and shoot A and B to be X, and the middle stake, top of the stake to be X.
Okay, now
So
we got
all
three
three of the
stakes in the
stakes.
ground. We got three
Yep.
stakes in the ground, and they all form a straight line on the top, and we haven't
Now
moved our
move
tool
your
yet.
tool. Move your tool in any direction. Right? In any, it doesn't matter what direction you move it into. But if we're going to extend the straight line segment straight, move it to a point where you can shoot back that's within 200 feet of that you know, middle stake. Shoot the middle stake and the end one closer to you, and make sure those two measurements are the same. They're both X. Got it? Now, just for shits and giggles, go shoot back to A, and if it's not, if it's a good enough day, you got all X.
Here's the problem. Here's the problem.
No problem so far.
You know, the 200 feet, you've got like, I think it's like 20 thousandths or 10 thousandths of an inch of curve in that distance. You will never see that in that distance.
I have what? I have curve. Why would I have curve in a
according to our model? According to our model, you would not be able to detect it.
We're not according to our model. We're talking about a method of creating.
Oh yes, we are. Yeah, we are. We're talking about the two models.
You won't even let me get to step B. This is how incensed you are.
Yeah, you've already sort of made a false statement with respect to our model that you would be able to see curvature if it was there at 200 feet.
About your model in the first place. Yeah. I'm talking about establishing a straight line segment and extending it. So shoot back to A without interruption from a glober. I mean, at this point they have to interrupt. You know why? Because this is the devastating part. You can move your tool in any direction. You don't even have to move it far enough away, right? You just move it to the other side and shoot them. They're still X, right? Move them a little bit further. They're still X. You can move them, and as long as they're X, it means that you're not, the top of the stake is the same elevation as the first one. It doesn't care what's under you.
Okay, listen,
and if you continue to do that for a mile, Rakia, you could look back at your point A and it'll be below your crosshairs.
You don't even have to do that. You can put an A and B a mile away in the beginning, and you're going to get different. Sometimes they're going to be above the crosshair.
Yeah,
that's why you don't do it a mile. Yeah,
that is a good point.
That's why you don't do it a mile. Yeah.
Yes, it might be above it. It might be above it left.
Yeah, it might be above it. Yeah.
Yeah, I mean, if you're down in the murk, yes, it can be. I agree.
Yeah, okay. So then we throw that out. That's why we do it a short distance and make sure that the measurements that you're doing are very accurate, the most accurate you can be without deviating up or down. X is X,
okay.
Not
think
below
of it this way. Left lane, think of it this way, right? What you're doing with these small segments that you're kind of piggybacking and overlapping over and over and over again is you're reducing any type of optical effects that may be experienced over long distance, right? So that's the point of doing it in these small increments.
Yeah,
so say you did what Rakia is talking about in like 6-inch segments, but you did that for 6 miles. Would you then disagree with that line being straight that whole entire distance?
No.
So every time you mark the pencil mark with the ruler, you're biased down?
No, I explained it to you. The curve is hidden. The curve is hidden in 200 feet.
You act like I haven't heard you say what you said at the very exact time that I'm saying what I say like 100 times. It's amazing that a glober breaks in at that very point every time and tells me the same thing like I didn't hear it the first 100 times.
All right. Look, listen.
Well, we have an audience. Go ahead, Jeremy.
We'll never get to the end of it. And go ahead.
I just going to say we do have an audience, so it's called rebuttal, and we say these things for the sake of the audience that in 200 feet you can't detect the curvature because it's hidden by the reticle in your instrument that you're looking at your story pole with. But if you extend that line a mile, then you would see the drop, which could be altered by atmospheric conditions and refraction. But we can go further than that if we want to.
For the audience, at the 200 feet mark, we're not measuring curve. We're making sure our straight line segment isn't curving.
That's a
Hey,
good
okay.
point. We can establish horizontals on the surface. It's no problem. I don't see what the issue is.
Okay. So when you extend that straight line segment, the horizontal that you just agreed is possible of doing over a mile, then you would measure the 8 inches drop of the water from that horizontal. Right, left lane?
Sure.
Okay, so now everybody agrees that it can be done. Now all we got to do is go do it.
Hold on,
Yeah.
hold on. I might have missed a crucial part. My wife started talking to me. We got 3 stakes. We haven't moved our theodolite, and we got 3 stakes in the ground. And we went 200 feet. We need to extend that farther. Now what?
You can shoot back to the beginning, the middle, the end, and then go one step further. Extend it out. That's what extending means. Like the ruler, just go 6 more inches. In this case, it might be 100 more feet or 200 more feet or whatever you can do on that day's accurate. What I tell you is when you
Hold on, my
set up.
AirPod died. What do we are we moving the auto level?
What do you say? Why?
No, I said are we moving the auto level?
You can. You don't. Some days
We
you
got
don't
to
have
extend this line. We got to extend
Right.
this line. 200 feet's not long enough.
Right, but you're referencing the line. If you move your auto level, you shoot back to the line that's already established to be horizontal and make sure that you're extending that horizontal out by referencing all the points that you've made on that line to be the same measurement. If you're off, like if you get 3 feet on the end and 3.3 in the middle, it means you made a mistake. Start over.
Okay, so we got the 3 stakes in the ground. Hold on.
Yeah.
We got 3 stakes in the ground. Now we're gonna move our auto level or whatever, like outside of in between these stakes, and move it like 50 or 100 feet or whatever, however far we can go down past to the right or something, and then look back at all 3 of the stakes and make sure they're all lined up on top.
Sure.
That's what I was talking about doing before, and you said it was a bad idea.
I didn't say it was a bad idea as long as you reference that straight line segment. They say it's a bad idea. But if you're...
No, you were telling me.
Oh, my God.
My bad. Go ahead. Go ahead, bro.
I don't know how to say it. I'm only going to say it one more time because now I'm wasting my time. If you set up a year from now at a different level, using a different transit at a different height, and you reshoot your horizontal plane and they're all the same measurement, that plane is horizontal and you can extend it.
All right, let's just take it one.
If you can't understand that, I can't help you, man.
I understand it. Let's take it one step at a time. Left lane. We got our 3 stakes in the ground. That's all a straight line, right? We didn't move our auto level or anything. We just put 3 stakes in the ground at whatever, 50, 100, and 200 feet away from us. We got a straight line there. You would agree?
Yes, sir.
Okay, now if we go to the right, picture an orthographic view of this, and now we go to the right, 50 feet past the last stake. And then we look back and we sighted all our shit up. You would agree that that's still the where the crosshairs are as part of the straight line segment?
Well, that's the part that's ambiguous because you won't see the curvature in that because it's so small.
We're not talking about the curvature. Go ahead. What's it?
Oh, well, I wanted to tie this into something else. So good. I want to. They're going to keep on saying the same thing. You know
Tie
that.
it in. Tie it in for us. Go ahead.
Okay. So left lane. If it's just such a small segment, just 200 feet, you're not going to see the curvature of the Earth. What about like a canal? Would I have to account for the curvature of the Earth whenever I build a canal?
I would say if you continued that method, that what I call daisy chaining, that may not be the right term, but shooting horizontals and then scooting down and shooting horizontals. You what you would do with that is, in our model, is follow the curvature of the Earth. Each of those planes would be a segmented curve, so to speak, and you could build a canal that way.
Okay. So if we just completely ignore the Earth being a globe, it will perfectly work out to build a canal on the globe?
Yes.
Wow. So if we just build the canal like it's flat, so we don't have to account for Earth's curvature when we build canals?
As long as you're maintaining an elevation, and see, we say that curve, the elevation is following the curve. And on a flat Earth, you say that elevation follows a flat line. And I mean, so you could build the canal without regard to the shape of the earth and come up with a good canal.
Yeah.
So we have a canal that's 10 miles long, left lane, right? How do you envision the water? We have point A at one side where the locks are, point B in the middle, point C at the end of this 10-mile canal. How do you envision the water?
If you, how long is it?
10 miles.
10 miles.
Yep.
Yeah, you would see, I'm not sure on the numbers, but if you shot a sight from A to C, from the beginning to the end, point B would be significantly higher than your sight line of sight.
Point B, in other words, the middle part of the canal at a 5-mile mark would be higher.
Yes, sir.
So the other two ends in respect, point A and C would be lower with respect of the middle.
Yes, if you got at point B and shot back at point C or A, those points would be below your line of sight.
Okay, one other question. With respect to point A and C, so when I'm at point A, does the water start to drop or rise in order for point B to be higher? What happens there?
Well, I mean, as we say, level being curved, and the water's just going to stay right where it's at.
No, it's not. That's not what y'all say. It drops from
Wait.
But
okay.
Yeah, the point here is.
Good.
Well, yeah, that Rukia's on it because in their model, the water drops from every point all around you.
Yeah, from point A it drops, not rises. And also, if you moved your auto level, you wouldn't shoot the middle to be higher. You would shoot it to be lower because you're on Earth curve. You're dropping. So you double speak even when you explain it to us.
No,
Yeah, the
if
canal.
you shoot from A to C, if you shoot a line of sight from A to C, B will be higher. That's your sagitta.
Yeah, but if you move your auto level from A to the midpoint, you're saying the midpoint is now higher.
Nope.
Not
Same
lower.
elevation. Same elevation
Oh
from point B. From point B, A and C will drop away.
Okay, now build another 10-mile canal at the end of it and start it another 10 miles away. So point A, B, and C of the first canal, the center would be higher than C. Now start A at the C that doesn't connect, a different canal. And now A is at that C mark, which is lower than B. And then the next B is going to be higher than A and C. It's ridiculous, bro. That's not basketball.
It's not. You just made it ridiculous because that's not how it works.
Dude, you have to trap them, man. How do we not know? Are we going to talk to them about it for 5 hours pretending we don't know what they're going to do? You have to trap them. You have to trap them. They're a girlfriend cheating on you that's going to lie about it until you prove that you know she's cheating on you. You have to trap them. There's not going to be some epiphany.
He just got trapped.
Yeah, well, is that method you...
All right.
Go ahead.
All right. I'm just trying to make one quick point, okay? So, left lane, whenever the Globers say that we do have to account for Earth's curvature when we build bridges, what's the difference between the canal and the bridge that we have to account for the curvature of the Earth on the bridge but not the canal?
On your suspension bridges, your columns or your pillars, supports, have to be vertical because you don't end up with any like radial or leaning forces. That bridge is going to pull the columns straight down. So it's important that they're perfect. And so for it to work out, they have to be on a sphere. They would be leaning away from each other.
Okay, yeah, you didn't actually even really answer, but anyway, so I was going to say, so this is one of the biggest flat Earth proofs. Long distance canals are built completely horizontal, completely neglecting any notion of the Earth being a globe. And actually, some of the oldest canals were extremely long and didn't account for the Earth's curvature whatsoever. So, in fact, the Chinese civilization built a canal in like 770 BC that was over 1,100 They did in no way account for the Earth being a ball ever. And in fact, they specifically state they did the opposite. And then when someone came to tell them that the Earth was a ball, and they were asked about whether or not they accounted for the curvature when they looked through the blueprint, they laughed and said, of course not. We built the canal like the Earth was flat. So in 770 BC, the Chinese built an 1,100-mile long canal, completely neglecting Earth's curvature. So apparently, engineering works perfectly on a flat Earth, especially when you don't know that people think it's a ball. So we have real physical, tangible evidence, everything that we do in reality, engineering, in everything that we do in actual reality, we do it as if the Earth is flat. And you guys just tiptoe around and then claim, actually, you can treat it exactly like it's flat when you build long distance canals over 1,000 miles, but actually it's curving, I promise. You'll just never be able to tell. Just build it like it's flat and it'll work perfect.
Well, the thing is, you just made a big long speech about ancient technologies and blah, blah, blah. And then you called it actual tangible evidence, which all you said was words. I didn't see any evidence.
What, you don't think that a physical canal is tangible?
Well, I mean, yeah, we've got water, we got the lakes. It's all tangible evidence. We just have to go analyze it.
So why'd you deny that it was tangible evidence then?
You didn't present anything tangible. You just said words.
Wait, are you saying that the Chinese accounted for Earth's curvature when they built their canal in 770 BC?
I couldn't say whether they did or they didn't.
You know damn well they didn't.
Then why did you?
No, I didn't. No, I don't. I don't know damn well anything about it.
Did the Chinese think the Earth was a ball in 770 BC?
Could you present that data that where
I'm
maybe
right.
documented or
just look it up?
Please hand him something physical through your phone screen or computer screen. That's what he's looking for.
That's why I'm trying to figure.
He's been doing is
yeah, that's the thing. We just don't need to be claiming tangibility where there is none.
Okay,
you just need to
physical canal is tangibility. This is what is so funny about
Senate Glover.
The stupid talk. I'm trying to get this out because I have to walk into the store, but it's like they will say that we have no evidence. Okay, now this is reality, right? We have tons of physical, empirical evidence because whenever you fly a plane and you assume that the Earth's a flat, stationary plane, right? That is physical evidence. Every time the plane works, it's physical evidence of the Earth being stationary and being a plane. When you build long distance bridges and long distance canals, assuming that the Earth is flat and you can build it effectively, that is physical evidence because it's a physical use case that is working and effective. That means that it's physical evidence. Every time you fly a helicopter or a plane, or we use electromagnetic propagation or radio propagation or build bridges or build canals, that is literally, by definition, physical evidence for the Earth being a plane. So you can say that we don't have any evidence, but we actually do have all the evidence. The globe model tries to take that physical evidence and claim that it's actually a globe anyway. Okay, you guys need to really understand that.
Hold on,
I'd like to
Rocky.
ask Left Lane when he did the 10-mile observation over, just theoretical with words. That wasn't tangible evidence. Now that he's saying that, but when he does that A, B to C, and he sees that B is higher, sees it, right? Is he measuring the water curving or how we see curving? And can he show us tangible physical evidence, because that's what he requires now, that the water is actually curving up, like higher than A and C?
But see, I did describe a procedure and represent the way that I think it would be, but I never said, and now we have physical, tangible evidence, and you lose. That's not what I said.
Oh, okay. So A, B, and C with B being higher, can you provide physical evidence that B on a 10-mile long canal is higher than A and C? That's what you stated.
I could demonstrate that with a circle on a piece of paper, but to actually provide the physical evidence, I would have to go take instruments and get on the water and do the survey of the surface of the water. And that I would be able to present as tangible physical evidence.
So no, that's a no. You can't provide it.
No, I could. I'm just a truck driver, though. I'm not.
Do you guys not understand that a physical canal, an actual physical canal in the physical world, is tangible physical evidence? You actually understand?
Yeah, but you say it's flat and I say it's curved. Now there is the crux. We got to go figure it out.
We built it like it's flat though. So what are you not understanding?
That's your claim.
Hey, how about
That's your
this?
claim.
See if you can answer this then. Okay. So if the earth really were flat, how would we have built a canal different?
I don't know. That's we were talking about if you daisy chained it and maintained elevation, it would work out on either model, I think.
And a 10
I may
mile
be wrong
canal on a
about
flat
that.
earth, would it look like you described? Would it
No, the 10
appear?
mile on a flat earth, you would be able to sight one end to the other, and you would be able to set a theodolite on one end and a theodolite on the other, and they would
Why do
look
you
at each
say
other's
that?
eyeballs.
Why do you say that? I can show you things not that you can't see in like 4 miles. That hasn't
I
any earth there.
understand refraction, but the physicality, of it would be such
No,
that
you're sighting it. From
sighting it,
A
yes.
to B, you're looking through an optic, sighting it.
Yeah.
Like
So,
Witz
yeah.
like Witz said, this is a cheating girlfriend. They're gonna say they were at the mall, they were at lunch with their girlfriend. We have to actually catch them in the act. Like nothing that's been done before is gonna matter because they can always talk their way out of it. They've ad
I
hoc
don't
everything.
really.
Well, no, this is
I
not. But
can't.
this is the thing,
I'm
though.
not
Like
like anybody else.
what you do is you go find a girl that loves you for you and is loyal and is going to tell you the truth.
We gotta catch them
Okay,
cheating.
that's what you do. That what you do is you realize that this girl is going to lie about where she was until she dies, and if you stay with her, she's just going to keep lying. So you just
I,
go get with a girl that's not going to lie, meaning you
Like
present
me.
the evidence
That's
to
you
the
get a girl like
open-minded people.
me.
we get it. I'm not with left lane. I'm trying to hook up with the girl in the audience that listens to both of us and goes, "Wow, this guy makes sense. I can go out and prove this myself."
I know.
Yeah, when I look through an
You just
optic
want
10
the one
miles
girl that can just drop
over
her
a flat.
pants on demand. That's all you want, Rakia.
Yeah, another Glober, just bullshitting, right?
Well,
No,
let
I'm
me
telling
run
you
through
the
this
truth.
with Zanuck real
I
quick.
agree with you, bro. Obviously, that's why I do the debates I do. Like on modern day debates, I'm just explaining that, like, when it comes to like real like evidence like this is for the honest girlfriend. That's all I'm saying.
I want
All
left
right,
lane to
so
say
hold
B
on.
is higher than A and C. I want him to say the water on a 10-mile canal in the middle at 5 miles looks higher, appears higher. I want him to say all that shit.
Why would it be higher?
Depends on where you're looking at it
Yeah,
from.
ask left lane.
Why would it be higher? Look higher, maybe?
But this isn't going to get us anywhere. Rocky, that thing you were talking about where we do A, B, and C with the stakes, then we go 50 feet or 100 feet on the other side of the stakes, then look back and line them all up. Is that called double rotting?
Well, you can do it. It depends on what tool you're using too, because you can use a theodolite and shoot A and B and then flip it over, and it gives you the same horizontal plane in the opposite direction. So there's
Yeah, but
different
is that
methods you can
method?
use.
Is that
Well,
what's okay?
you can double ride. That's not exactly leapfrogging. You can use a auto level to do that, but theodolite you can actually flip the scope over.
Yeah, let me ask
That's
Zanuck
true.
this real quick. All right, Zanuck,
You actually have
we
to.
got an auto level or theodolite or whatever set up. We make level. We put 3 stakes out in the distance at 50, 100, and 200 feet, right? And that's
Okay.
a straight line. We now have a straight line. Would you agree? The top of the stakes.
If you force those stakes to be equal to the horizontal line in the theodolite, yes, they would all be. That would be a straight line.
Okay, and now we take our auto level or our theodolite or whatever, and we move 50 feet on the other side. Like pretend you're looking at this orthographically, and now we move 50 feet to the right of all the stakes, and then we look back, and we got them all lined up. They're all still lined up on the X. Would you say that the crosshairs of the theodolite are now part of that straight line segment?
That'd be a flat plane triangle.
Sorry, say that again.
That would be a flat line triangle. Flat
line
plane
triangle.
Flat plane. Yeah, you have 3 points, 50, 100, and 200 feet. And you step over to the right or left, and you make another sighting of those 3.
It's a straight
posts.
line, Zanuck.
We're just going in a straight line. Yeah, there's no triangle.
Well,
we're just going in a straight line.
You'll make a straight line to the end if the line. It will be a straight line if it lines up with the last post.
Yeah, we have the crosshair. We're on the other side of the line now, 50 or 100 feet or whatever. We look back, and The crosshairs are all on all our spots that we already agreed was a straight line.
I didn't
are the
understand looking
crosshairs
back. It sounded like you went down three. You have 3 points all lined up. All of them are in line with the theodolite. Then you step to the side 100 feet and look at the last one, or what are you doing?
So we got 3 points in a
reverse.
straight
Look
line. We got 3 points in a straight line. We got 3 points in a straight line. We've looked through our auto
50.
level.
Janik, stop talking, man. Let him explain it to you.
We've looked through the auto level. We've lined up 3 stakes in a straight line. They're all lined up with the crosshairs, right? We got a little X on them. All the X's are lined up with the crosshairs, right? This is now in a straight line. Gotcha. We're going to go past that. We're going to go 50 feet past the last stake and then look back. And then we're going to line them all up with the crosshair again.
I'm stopping you because I'm just, it doesn't make a lot of sense. You have these 3 points, then you're going to go to the last point and go 50 feet past it. You're not being clear.
We're gonna go to the last point. You know what we're gonna do? We're gonna go to the last point.
Are we walking there? Are we walking to the last point?
We're gonna take an ATV. Who cares how we get there?
I don't know. Your words
it's
are
200
you're not going to turn this into a shit show, I promise you.
SE, I'm trying to say what he's saying. Please, you're making it worse.
Mic check.
Jeremy, you need the chalk on the sidewalk.
Hey, Zanuck, do you agree that we always build long distance bridges and canals? We have to build the long distance canals like the earth is flat.
All right, mic check. We're good now. Can you hear me?
We're good now.
We're good. We got 3 points. We got our auto level, and 50 feet ahead in front of us, we make a stake. We would have X on it. 150 feet past that, and 100 feet past that. We now have 3 stakes in a straight line in front of us with an X on it. They all line up. You agree that's a straight line,
right? And we're standing there looking at all 3 of those posts, and they all are right dead wrecking centered on that horizontal line on the theodolite.
So we got post A, B, and C. We're going to go to C now. We're going to look back at A and B, and we're going to line those. And we're going to line those X's up.
Right.
We're going to get them all lined up, and the X on the third post. Yep, the X on the third post where we're at is right at the same height as the crosshair. We look back. We're lined up on the other 2 X's. If I now turn the theodolite 180 degrees and put a stake in the ground to match up with the crosshairs, have I now extended that? Now we have A, B, C, D, all a straight line, right?
Yes.
And I can just keep doing that forever.
Correct.
All right, cool. Then this should be easy. Why have none of our surveyor guys done this yet?
They have done it. In fact, main surveyor had done it, and that showed that doesn't work because instead of having them line up and be on the crosshairs, we've done the opposite. They did the inverse of what you're talking about. They actually made sure that the stakes were the same height, put them out at a distance over water, which should be level everywhere on that surface, and found that is not lining up with the crosshairs. So we
post that video.
Post the video, yeah. Post it up.
Video of it.
Did he record it?
We have pictures in the data of the test, but we don't have the.
Basically, in summary, we do everything as if the Earth is flat, but it's a ball.
What do you mean by that?
Everything that we build, we build like the Earth is flat.
Well, how do you think they?
Hey, don't even try it with it. I've been through this kind of stuff, talking about the canals and the properties of water and the topographical scans made by NASA showing a flat Earth. They don't care. They're complete ignorance. They're fools. There's most of these people. There's no. Yeah, but there's literally we're just wasting time with these people. They're absolutely gone.
That's why I summarized it, which is that the actual globe model's position, no matter what the zealots in here say, is that you build canals and bridges and everything as if the Earth is flat, but this is their position, but it's actually curving. It's actually curving, but you can just neglect it. And if the Earth were flat, we wouldn't build it any different. Why? You can just neglect the curvature and build it like it's flat, and it's actually a globe. And you can fly planes like the Earth is flat. You can fly planes like the Earth is stationary. The military documents, the military equipment, the technology, line of sight technology. We do all of this like the Earth is flat, but actually it's curving. we don't really need you guys to say anything because that's your position.
Okay, Whitson, I have a quick question for you. I would agree. Well, first of all, can we get terms straight? Would you tell me the difference between level and flat?
Oh my God.
No,
level is equidistant above the ground.
What's that?
Or whatever it is whatever the reference is.
What is that?
Equal distance above.
What is that word? What are you defining?
Level.
Oh, level. Level is equal distance above the ground?
Or above whatever you're referencing, yeah.
Okay, so I could have a curved line that is level over a
That's
sphere.
what you think. Yeah. If you want to play word games.
I just want to make so I'm gonna that tells me that you understand. So I want to be able to tell you the answer. So yes, when they build things, structures on the earth, especially canals and things, they're building things level. Now you're saying
they're building them horizontal.
Flat. No, it's not horizontal. Level's not horizontal.
Yeah, well, that's how they build them.
No, they don't actually.
Yeah, they do actually. They don't account for.
The only thing they've ever built in the world. Hold on. The only thing they've ever built in the world, horizontal, was the SLAC facility and LIGO and a couple other facilities like them. Those are the only facilities that are built horizontal.
No, actually. Do we build them like?
You made a claim. Back it up.
Okay, 770 BC, the Chinese built an 1,100 mile long canal, and they were flat earthers.
Not horizontal.
Yeah, horizontal. Yeah, that's
it was not horizontal. Yeah. It was level.
Oh, but they just built it like it was flat.
Yes, no, built it like it was level.
Oh, they built it. No, did they account for Earth's curvature?
They don't have to because they're building it level. It already automatically does that.
So would they build it any differently if the Earth was flat?
No, they wouldn't.
Okay, so we build it like the Earth's flat.
Yes, they fly planes like it's flat too. You're making
right,
all these. There's a hold on. There's a logical fallacy here. I don't know the name of it.
All the physical and empirical evidence shows that the default position is actually a stationary topographical plane. And then you guys come along and say, oh, well, even though that's the default position built upon all empirical evidence, it's actually not true.
That's not true at all either.
Yeah, that's your
position. So you're making I can't remember the name of the logical fallacy. It's a good one though. You're making a good argument.
No, you don't know the name.
Hold on. What? Well, it's false. No,
this has nothing to do with logical fallacies.
Whitson, it makes me sound like I'm talking over you and you keep on blabbing out things when I'm trying to say something. So just
I'm like walking around and you have terrible timing.
Is it possible? No.
Okay, as long as you can acknowledge that the default empirical position based on all the evidence that the Earth is a stationary plane and that you have the burden of proof to substantiate the antithesis of that is actually the case.
Yes, I can do that. Okay. So no, cool. They don't make any false assumptions. There's no false equivalence here. There's none of this going on. All we do is we say yes. We fly planes, we fly as if it's flat and stationary. When we build canals, we build it as if it was flat. It's equivalent to building if it's flat and stationary, if it is round, because we're building it level. All these things make sense. They all go hand in hand. Now you're saying there's no empirical evidence. Well, absolutely there is, because I can go down to the equator and weigh less. That shows that we're spinning. If we're spinning, that means we're on a ball. Yeah, it does. If we're on an airplane and I fly west versus east, when I fly east, I'm actually lighter. That's been measured as well. The empirical evidence. Again, hold on. You can't just jump in and keep on saying no. Like you accuse me of doing that. Now you're doing the exact same thing. So no, there is
you're just scattergunning.
I'm not scattergunning. I'm giving you evidence. I'm stacking up evidence that is not scattergunning because they're all on target. If it's scattergunning, they'd be unrelated. They're very related. Now when we shoot rockets up into orbit, we generally will go east, because we'll take advantage of the Earth spin as well. More empirical evidence. And not to mention main surveyors' information regarding the theodolites and the equal height posts over a waterway. Now you can keep on saying it's refraction or it's an anomaly or it's this. Go ahead. Find one surveyor that's done that measurement and seen anything other than what main surveyor has seen.
Dude, I destroyed main surveyor in a debate for thousands.
No, you didn't. I listened to it. It was pretty bad. You were pretty bad.
Actually, just shut up, bro. You're annoying, bro. So, your argument is that we do everything in the world like the Earth is a stationary plane, and that all the technology wouldn't work if we treated it like a ball that spins. But actually, it's a ball that spins. We don't need to talk forever about it. That's your position. You guys are boring.
Can someone clip that part where Zanuck said they would have built a kilometer-long canal system
like it was flat, and then he said that's how we fly planes, like it's flat. Someone clipped that because that was a
Dude,
perfect.
1,100 miles. Dude. You guys should look at that. Yeah, 1,100 miles. You guys should look at that book.
Perfectly level.
You guys should look at that book.
Like it's flat.
Breaks down the canals. He breaks down the canals and all civilizations that built the canals when they were flat earthers. And actually, sometimes they went and asked the people that built it about like accounting for Earth's curvature, and they like laughed at them, like, what a ridiculous question. Like,
I totally agree with you. It's it. They built it like it's flat because it doesn't matter if you're building it level. It doesn't matter whether it's flat or round.
Someone sound
they build it. We know that. We know they build it. We fly planes like it's flat.
He just said they built it like it was flat.
Right.
Yeah. Hey, if the Earth was a smaller
that's
ball,
not an argument for your advantage.
Hey, if the Earth was a smaller ball, would we have to account for the curvature?
No. Why?
So there's not a ball that can be small enough that we have to account for the curvature.
You fly planes level. You build things level. There's no need to worry about whether it's flat or round. You just build it to level. It'll take care of itself. You fly a plane. Can I make one more statement?
That level was flat.
Can I make level's not flat? I didn't say that. You build it as if it was flat. There's no difference.
Built it like it was flat.
No, I build it as if it was flat, not like it was flat.
You said quote unquote.
You know what I mean. I don't care. You want to wordsmith me on.
They built a 1,100-mile canal system as if it was flat. That was your words, Nick.
Why would you mute me? Why would you mute me? I'm not going to talk over you. I promise. They built it as if it was flat because there's no difference between building something as if it was flat or building something as if it was round because of the equipotential directions. When we fly planes are flying level. We don't. Real quick. We fly
there's
planes.
A problem with that claim because when you build something on a ball, it has a different. Balls have a different geometry from flat planes. They're geometrically defined as being two different things in practical and reality and mathematically.
Totally
but the procedures by which we accomplish these things can be demonstrated and explained why we say what we do about build it as it's flat, fly as if it's flat.
Oh, really? Show me where you demonstrated it. Show me where you demonstrated
flat.
It.
So fly.
Oh, begging the question.
You have a center of gravity on a plane. It has a direction down on that center of gravity. And as you fly, if the surface and its equipotential is constantly changing, the plumb line, in other words, is changing, then you would fly as if it was flat. Because as you fly, you're flying through a curved atmosphere. And the plane will naturally curve because it's following its CG. You'll never have to adjust for anything. All you do is fly at level, and that will follow a curve. Now, you'll never know the difference until you make some measurements. That's how this transformation between the circular and flat path is done. It's a transformation. It's spherical geometry and planar geometry.
This is beautiful, and the thing is to let the audience hear this, right? Yes. When they say that water, what?
Racky has got a stereo on in his car.
Sorry about
that. That's cool. But like I said, this is great. They need to hear that. I know there's no way we're gonna convince these guys, right? But people need to hear, like before when I asked them, you have a canal 10 miles long, A at one point, B in the middle, C at the other point, and they have to say that the midpoint, the water rises. There's a hump of water. The audience needs to hear that, no matter how many times we've been through it. I've been talking about this for years now, and using the girlfriend thing as well.
Yeah.
We're never gonna get through to them.
See, there will easily, and I
not
agree
you, Xanax. Never gonna get through to you.
Well, no, you can, and you said
Xanax cool.
You can do something. Go show me any experience you talk about. Show me a horizon above level. Show me these theodolites that show posts that are the same.
No.
On the
Go
same
back
line.
to where
Racky,
you
I don't need you jumping in when I'm talking to SC real quick. Just real quick.
I know, but SC doesn't want to hear that. He just told
I promise.
you
I won't be very long. I promise. Thank you. So SC, if you show me those things, I will be definitely a believer. You just have to show it to me, SC.
Show you water that's not curving? I can show you right now.
You know what?
In my front yard.
You know what? Racky,
That's what you
I'll say
for.
something. Can I respond to you? I agree. Racky, here's the truth of the matter. You can find spots on the earth where you'll find flat water. And no one's ever said that before, I think, except till now.
What are you
Where
talking
do you
about?
find water?
You can go to the
Every
Indian
water.
Hold on. You can go to the Indian Ocean, and I bet you'll find seriously 50, 60 mile perfectly flat water. I guarantee.
Wait, how
it.
can you tell the difference? How can you tell
What?
the difference between the part that's actually flat and that's just looks like it's flat but just level relative to the curve? How do we tell the difference?
You see water
Well,
not go
there's
down a
really no
drain.
way,
Please let
actually,
him
unless
answer the question.
unless
you
it's
get
all
a
about
drain. Hold on.
differential, differential calculus,
No,
right? Differential
no, you
measurements.
shut up for a minute, Zanuck.
Oh my
You get a
DMOC, is
drain
this the
like a
time for
funnel.
you, really? So he asked me a question, DMOC, and you're gonna
And
jump in.
bulldozed over like 3 people already.
No, I
You
didn't.
need
I
to
responded to
I could
Rakia, and
ask
then
him a
he asked me a
question.
question.
Yes, you did. I was here listening the entire time. So it's not time for you to say no, you didn't. It's time for you to fucking take some constructive criticism for once. After
Okay,
you
thank you.
bulldozed, after you
Thank you.
should get the mic up at least once.
I'm just saying thank you for the criticism. I appreciate that. I'll try to behave.
How do we tell the difference between the actually flat parts and then the parts that are just look flat but are actually flat but are actually curving? How do we tell the difference?
I'll answer you like I did before, and then hopefully DMOC won't interrupt me. You can't. It's unless you have a differential measurements, and differential measurements will be something where, let's say I'm in the Indian Ocean, I've got 50 miles. That's perfectly flat, 1,000 miles square area. And you measure it everywhere you go. With theodolites, auto levels everywhere, flat. How would you know that it's around it is curved? Well, then you have to go to a bigger section and even larger. Pretty soon you have to be out in space looking at this object to see if the overall object is spherical or if it's overall flat. So yeah, you can't.
That's a cool
You're
story, Zanuck.
Well, I know it's a story. It's a cool story.
You said you can't
I'm
tell the
being
difference.
honest. I'm being honest that you can measure areas on the Earth that are going to be flat. You
From
will get them.
space.
I knew the wait a second. Is Zanuck the same person who posts pictures of balls disappearing over a curve?
That's
I
really
think
good evidence.
and buildings disappearing over a curve. Isn't it like the same Zanuck, or am I tripping right now?
No, if you didn't see those buildings, I would say that's not the really evidence that the Earth is flat. You would have strong evidence that the distance between you and why would you have a him and ha in the middle of a sentence? That's not really too
the consistency.
So if you had a building that was not hidden, I'd say you'd probably have a flat section of Earth there. I would agree with you.
From space.
Dude, this
Doesn't mean
is
the entire
prime
Earth is flat.
time entertainment, you know.
Here's the funny thing.
I'm trying to give you a dose of reality. You're not taking
No,
it's like
no,
cough
you're
medicine
not.
for you. You just keep on
Here's
spitting it out like
reality.
a baby.
Reality is you have a drain in your room.
Zanuck.
Show us where the water doesn't go down the drain, Zanuck. Show us where the water fights against the drain and stays with gravity and follows the higher portion of the floor and not the lower portion like you claim every day of your life.
You don't have to defend your mental illness in front of us, Zanuck. We're trying to help you across the street.
I appreciate that.
So, a floor that has a drain in it that's made to drain the water, Zanuck. Can you show your globe floor that doesn't drain the water? Your magic one? Your magical gravity physics? That stops the water from going down the drain?
You guys need a globe dexicon on your arm. Those things that, you know.
So you don't have that.
Well, I guess the question would be, how many locally flat areas does it take to make up a sphere?
Right. That's, yeah.
Well, that answer would be infinite. Could be infinite.
Well, a sphere that blocks the bottoms of the boats 4 miles away, like how many locally flat areas does it take to make a sphere that will visually obstruct the bottoms of boats as they go away from you?
Oh, unlimited
that
flat.
Be flat. That'd be curved.
Can't wait for the next explanation.
It's so flat it obstructs the bottoms of boats.
Flat doesn't obstruct bottom of boats.
It's so you can't see the curve because it's so perfectly flat.
Inferior miraging.
So mirages do, so not earth curve.
Inferior
so all the
miraging
times that
and
you say, look at this building, 20 miles away over water and waves, and not give the viewer height, not do anything. Look at it; it's obstructed. The bottom's
Did you say
missing.
waves?
So
did you say waves?
Earth curve. Did you say earth curve?
Yes, earth curve or miraging, inferior miraging.
Okay, so you're now going to say that it's so flat in local areas, let's say 15, 20 miles, that it obstructs bottoms of buildings.
If it was flat, it wouldn't be obstructing the bottom of the
Does
building.
your earth curve look
Why
like a
would it?
stair?
Why would it be obstructing the bottom of the building?
Because nothing's obstructing. That's why. It's not a circular reasoning or logic.
Why
It is
can't
actually
you
the
see
answer
the
you're
bottom
looking
of the
for.
building? You think it might be an
Nothing will
optical
obstruct
effect?
the bottom of the building unless something is obstructing the bottom of the building.
Like a visual effect, like an optical effect.
Like what's an optical? Like inferior miraging will obstruct it. Yes.
Okay, so that would obstruct it.
Yes.
Okay.
I said the two qualifications: earth curve or inferior miraging.
Well, how would you know the difference?
You can make some measurements. Look at angular position with change of altitude or elevation.
What do you
That'll give
compare
the
them
answer you
to?
need.
Or would you
Differential
say that if
calculus
it
is very
changes,
useful. We use this every day in science and
or
physics.
would you say if it changes due to conditions that it's probably an optical effect?
I wouldn't say it's probably that at all. No.
Okay, so on one day you stand at a beach and you see a boat disappear and it's halfway cut off, and the next day you see the bottom of the boat. What would you call that?
I would say the earth curve based on the fact, unless you did a measurement where the position changed with elevation angle or elevation measuring distances.
What about a side view?
Dictate that it is earth curve or not.
So when it's below the crosshair or line of sight,
the movement of the object in your field of view will determine whether it is curve or not.
Yeah, but every time that it's below the horizontal, the line of sight, basically, that's earth curve. But when it's above or even or obstructed or whatever, that's optical illusion.
Only if the entire object from bottom to top that you can see has moved upward in your field of view. If that angular change has been positive, then that would have been refraction. That'd be bending of light.
That's not how we see those, Zanuck. If the object is in the background and the foreground moved up, then what then?
That doesn't happen.
That doesn't happen?
No.
I got proof of it right now. I got proof right now it happens. I know it happens.
Show me some proof of that happening.
You've seen it a million times.
The foreground goes up, but the background doesn't.
Yeah.
Okay.
Bro,
okay. Now what? You believe in a white sun now too, Zanuck? You know what a white sun is now? How many things do I have to teach you?
Yeah, you're the teacher, Rakia.
Do you know what a white sun is?
He gave us a way to make a horizontal line. I think all the Globers and everyone on our side would agree to that. I mean, I know we do, and Zanuck does, and
I've been saying that same very thing for years.
Yeah, so we should go do that though.
Well, when you tell me what happened in the parking lot of the Marriott, Rakia, I'll start listening to you. So when 100 feet or 200 feet of a building's missing, and its angular position is exactly where it should be for its distance, and the curvature of the Earth, if you have an explanation for that, I will be all ears. But until this point happens, you're pretty much just pissing in the wind here.
When water climbs back out of the drain, Zanuck, we'll be on a globe, okay? We'll be good to go. Gravity, yeah, it'll be climbing up around the ball. Yeah, it'll be awesome. Yeah, it's so helpful to watch physical stuff.
So, I mean, that sounds like a relatively easy way. I mean, I don't want to say easy, but like do compared to the other shit we've talked about making a straight line. This way actually seems doable.
I like all these, check, double check, reverse.
Hell yeah, check the water.
Nothing wrong with
see
that.
The water. Gotta see if the water
we've had some crazy
cockamamie
ideas, and this seems like the most feasible one. If everyone agrees that would be a straight line, that method of when you can.
No, I got a better one.
I agree. Water pours down a drain. It never comes up from the drain.
Someone should go do this. Do like a Bedford level type of experiment, and the one like Jeremy's talking about, where you're actually forcing it to be lined up, and then see if those posts are equal height.
We should you do the post. You do the post, and then you see if and then you level or water or whatever under it, so you can see if it's deviating.
You measure from the top of the post down to the water. Bedford lever was a sighting over 6 miles. That's visual.
Right.
Hello.
Yeah,
that's fine.
We're not doing that, Rocky. That was silly.
That's why I said do the opposite of that. Do the inverse of that. That's what Jeremy wants to do.
I just posted a picture. It's not coming up yet.
Hold on. This is optical also, by the way.
Zanuck posted Soundly's picture.
I can't hear you.
Yeah. Can you explain that?
Yeah, what you're posting of Soundly's over Lake Pine.
Yeah,
I can.
How is it 200 feet of a building missing?
That's an illusion. It's
so where's
not
the building
missing.
Go? That's not the same thing. That is a mirage right there.
See the picture that I posted? That's the same building up here. Yeah, you won't let me speak. That's the same building above, like where it's like it's floating in the sky. They're both visual optical illusions over 24 miles of the marine layer.
Okay, here's an intelligence question for you, Rakia. All you have to do is tell me.
Please don't
if you were
use
to
tactics
pixel,
against
if you were
me.
to count pixel, Rakia, we can see a couple of the floors there. You know where that mirage starts. If you can tell me that where the water level will be, or where that bottom of the building should be in your field of view, and it's still above the mirage water, you might have something to go on here. But until that happens, all you're showing me is something that is probably hidden by earth curve as well as miraging. And maybe it's not earth curve. Maybe you're closer and you could see the entire building. It's a lousy picture. Why do you find pictures that are horrible to make your case, rather than find pictures that are good to make your case? If I give you a picture, it's going to be clear.
It's Soundly's picture, and not all pictures are clear, especially if mirages.
Look at the. I mean, come on, it doesn't take a genius to figure. Hey, Knucklehead.
What are you doing, bro? Why are you attacking
me? I got a physicist here in the room. He's gonna look at his picture. Hey, where do you think the rest of this building is right here? What? That building. That's all you see is the top of the building. That's a 200-foot tall building, right?
Who cares about his
We know
that
there's all. Yeah, we know that there's all kinds of optical effects going on. We know that there's all kinds of optical effects going on.
Okay, so
maybe Zanik, you just go outside with them, have some fun in nature, and look at reality for what it is. Maybe water, for example.
Yeah, you're clear, Jeremy.
You guys hear Jeremy trying to speak? If not, please leave and come back.
Wait, why would you?
I'd like to ask because I just posted a picture of a shrimp boat that's less than 4 miles away. The viewer height, which, oh, by the way, is me, is about 8 to 9 feet above the water. I would like the physicist to tell me if that's earth curve or not. I love how you say I got a physicist in the room, like that matters.
Yeah. How much of
that?
What's
the physicist going to say? What's the physicist going to say when we show him the horizon above horizontal?
That light bends downward?
No. Oh.
Yeah, no.
Why would the
horizon... have mercy, please.
What would cause a horizon to be...
So real quick.
Clay.
Real quick. So Rakia's picture is basically showing more hump than should be on a globe Earth geometry is what I'm understanding is that.
Well,
it's actually too close for that much hump to be seen on a globe.
Have you guys ever thought about like, say flat Earth like really gets out here soon, like just think about like Xanax and stuff like that being flat earthers. Like, have you guys ever considered that maybe it's a good thing in a way that this is like that sweet moment where we should kind of like cherish it and enjoy it?
This is the sweet moment before Zanuck completely changes to flat Earth and then pretends as if he was the flat earther the whole time and tries to school us.
Yeah, he was teaching us that the Earth's flat the whole time.
Yeah, he's gonna be like, yeah, no, I've always been saying it's flat. See, go back to my recordings. I'm saying they built the Chinese canals as if it was flat. Like,
why wouldn't
bro?
they?
Like, no, you know I've been flat the whole
time. The process builds something that is curved naturally. It can be built as if it's flat and follow the curve. It's just being built level.
I can't imagine basing my view of reality based on how somebody acts.
Definition of double speak right there. Congratulations on it.
What? No one said anything about doing that, Left Lane. I'm saying, like, it's going to get out there. It's going to get out there. It's already starting to get out there. And I'm just telling the flat earthers, like, kind of cherish and enjoy this moment where it's going to kind of get, like, flooded down. It's going to suck in a way because we're going to have a bunch of lame people now claiming to be flat earthers. We already have enough.
That was just a non-point because all the time in every interaction you've had throughout your life, you base your fucking opinion and ideas off of how other human beings behave. It's impossible.
No, I don't.
Yeah, it's literally impossible. You're speaking English right now. You got English from other people. All the ideas in your head were spoken into your head by someone else that fucking came up with them. All the experiments you did, someone else came up with it. Everything you do as a human being is socially influenced. There's no way around it. You can't not
Left Lane, you're not original. You're gonna have to cry about it.
That's a crazy claim. You can't possibly not be socially influenced as a human being. Impossible. It's like
That's
saying
what I'm talking about. It's not a matter of social influence.
I'm a
Dude,
crocodile.
yes, it is, Left Lane. That's why you think the Earth's a globe. The reason every single person in this room thought the Earth was a globe when they were 7 is because someone told them that, and their mom said, "Listen to the teacher." Okay,
The
that's the
reason I think
reality.
it
That's
is
100%
now.
why you.
I mean, there are lots of Globers that don't act in a way that I appreciate, but it doesn't change my view of the physicality of the world.
Yeah, but you believe other people to tell you that the Earth's a globe.
No,
real quick,
I see it for myself.
Wait, real
No,
quick.
you don't.
Left Lane, do you believe in the Apollo missions?
Yes.
Okay, so there's nothing in physicality that you have that can actually confer that. All you have is the behavior of organizations and human beings and what film they release to base your belief off of.
I've watched it take off the Cape Canaveral. I've watched it.
I just don't think that it's technologically beyond our ability to do so.
Okay, that's not the point, dude. What's that?
It is the point.
No, it's not. Like, is it? Maybe it's not technologically beyond our capability to put Iron Man in a suit and go to the bottom of the ocean and fight gigantic whales. Like, who cares what you? Who cares what you think is possibly possible? Like, who cares about? Like, this is the point, bro. Is the only image in your head that you have that you think the Earth looks like? What you think the Earth looks like from the outside is literally just an image that you have to solely rely on other people telling you that's what it looks like.
No, if I fly a plane, I'm at 30,000 feet. I see a horizon drop. That is my number one proof in my mind.
Dude,
logically,
so
as an intelligent individual that is educated in the field to a certain extent, that is the conclusion I make. Hold on, you can't help yourself. I know. That's the conclusion I make based on that information and my knowledge.
Do you know what?
Sexy girl, sexy girl.
Real quick. I have a
She's
5-second
my
point.
sexy girl.
All right, I'm gonna mute.
Who's doing that?
Clearly funny muting. Real quick, what Zanuck said. Oh, what I see it, and then I interpret it because I'm educated. You do understand the word educated means someone else told you something, and you're basing your opinion off another human being.
That's not what education means.
Disagreeing with Left Lane. Thank you.
That is not what
and
education means.
what's even funnier is I was talking about,
you want
like,
to argue about that
the
or not?
image. No, we want you to shut up. Like, the image of the Earth being a ball was placed in your head by a claim from someone else. And then he said no. Then he said that he is an expert in the field. He's educated in the field. You're expert in what field, dude? Pictures of the Earth from space? What field, dude? That's the goofiest thing I've heard all day.
Engineering allows us to have the tools and the knowledge and the education. The education is not just reading a book and say, here's the equation for drag and you better trust it. I go into a wind tunnel. I put the spring scales on it. I measure the fact that I have a drag coefficient and a frontal area and an air velocity that gives me the drag that we calculate, and it matches.
Hey,
Wright brothers
would you have
did
all
this
that
as
on
well.
a flat Earth?
Hold on.
Would you have all that
So
on a flat
when I
Earth?
understand these things, let me finish. So when I understand these things through education, which is not just being told, and then I go up in a plane and I see the horizon drop with altitude, I connect the dots and realize that the surface of this object that I'm flying over is curved.
Well, yeah, you're not very right though. So, like, if
I'm
you
not
were
very
to
bright.
engineer,
I just told you something I learned, and I
buddy,
used
stop
my brain
interrupting
as a
so
human
much,
being.
man. Why are you interrupting so much? So, if you just brought up how you engineered a plane. So, okay, would you engineer the plane any differently if the Earth was flat?
No.
Would you engineer any differently if the Earth was stationary?
No.
Would you fly the plane differently if it was flat and stationary?
No.
Oh, okay. So that whole nonsense rambling on about.
Can I make it? Can I correct myself? I have to correct myself a little bit, please. Let me add the one thing to add. So you fly it differently. Yes, you would be flying it differently if it was round versus flat.
No, you wouldn't. You're going to end up
Yes,
bringing up that you're
are
going to go back
things-
to the horizon drop nonsense, and that's not how you fly a plane.
No,
you don't fly a plane
you're
based
right.
on what the
I'm not-
horizon looks like.
Why are you giving me a not? First of all, that's a straw man. I'm not talking about how it fly versus the horizon. I'm talking directionally, navigationally. You will fly it differently if it is flat versus round. You have natural tendencies. You have natural tendencies for the plane to veer to the right. off course over time over a round surface. You
To
don't
the
have
right.
that. Okay, so you're just gonna, it's funny. You ask me questions, I try to honestly tell you them, and you just talk over me and then say I'm wrong.
It's funny that you just said planes veer to the right, like as if that's evidence of a globe. They veer to the right. So if I go north, they veer to the right. If I go south, they veer to the right. Like, just to say something like planes veer to the right is
In the
just
northern hemisphere.
incredibly ignorant.
In the northern hemisphere.
Yeah. Okay.
And south, they veer to the left then?
Yes.
So wait, real quick. If I'm in the south and I'm going north versus I'm in the south hemisphere and I'm going south, you're saying in either situation I'm going to veer in the same direction?
Right.
You veer to the left. Well, going north is a slightly different variation of that. I'm going west or east. If you're traveling west or east on the southern hemisphere or the northern hemisphere, you will veer to the right in the northern hemisphere and veer to the left in the southern hemisphere.
So
and
if
that's
I'm
not
in
even true, right? Like,
real quick. So he said in the southern hemisphere you veer left. So you're saying if I'm in the southern hemisphere going directly south, I'm going to veer left, and if I'm in the southern hemisphere and I'm going directly north, I'm going to still veer left. Is that what you're saying?
Now, if you're going west, for example,
it's
on the
yes
northern
or
hemisphere,
no questions,
you will veer to the right. You will veer south. You will veer south. You ask me a question, you talk over me. Why would you do that? Noah, come on, man.
Let's just not interrupt. Let's not interrupt. Zenik, let's not interrupt. But Zenik, if you could just like answer the question, you do realize that a lot of people get frustrated because they ask you a question and you never just answer the question.
Yeah, he's a liar. He's not answering my question.
Well,
he's monologuing.
Wait, I got to point this out real fast. This is so funny, okay? Because New Perspective just like basically like almost abused you, right? When he was talking to you about this plane thing. I felt bad for you. And you were like, all the Glovers are like, well, no, you don't have to worry about it because when you adjust for the wind, that's way more of an adjustment than anything that would happen regarding the Earth spinning. And then some of them said that the atmosphere moves with the Earth in lockstep. Never mind, not lockstep, but basically lockstep. But it's negligible, but it's not in lockstep, but it's like lockstep. And all this nonsense. And then someone like, oh, well, no, it would affect the plane, but you would adjust for the wind and the wind. Now you're saying that you veer right. Now you're saying that the plane physically veers relative to the Earth being a globe that spins after you previously said that adjustments for wind alone would be way greater than any effect on the plane of the Earth being a ball that spins.
Well, that's true.
So you just come back the next day and double speak?
No, I was trying to be hyper technical, precise. If there wasn't for wind, if wind wasn't blowing, we would have to adjust. You talked about navigating a plane, flying the plane differently, flat versus round. If there is no wind and we're flying due west, yes, we're going to have to adjust the plane northward because we will start diverting to the south if we're flying.
See, now you're changing it because what you said was when I fly a plane, it just veers right. That's what you said. And now you're saying you meant a hypothetical situation that doesn't happen in reality. So you literally said that when you fly a plane, it veers right. Then when called out for your double speak, now you were actually talking about it doesn't truly veer right. I was doing a thought experiment of an Earth with no atmosphere.
You're right. We got to start talking in terms of what happens in reality or what happens mathematically.
Oh, so math's not reality.
But nothing else. So the other questions you asked me were all true. You would never fly the plane as if it was curved or flat. You wouldn't care. You would just fly it as it's flat. I agree. But then I correct myself only about navigationally because I started thinking about some of the rules of navigation that when we do fly westward, we will veer to the south. If the winds are can be far in excess of that particular deviation, just like if we fly to the west, to the east, we fly southward, veer southward. If we fly to the west, we will start veering southward as well.
Okay.
Which is actually left. No, I was incorrect about that. I misspoke.
Okay, if we're flying from Alaska to Hawaii, we're going to be 30 miles off if we don't adjust for the Coriolis effect, right? Give or take.
Which way does Coriolis affect us when we're going westward?
He's asking you the question.
Yeah.
Don't
so
answer him, Jeremy.
We veer to the right if we're due to Coriolis. We veer to the left with the Earth curve.
Yeah, don't answer his question. Answer his question, Zenik. My God.
I'm answering it. Due to Coriolis, there is a deviation to the right as we go westward.
Okay, and you'd be about if we just went straight and there was no wind, we would be about what 30 miles off from where we thought Hawaii was in the first place.
Depends how fast you're going.
Plane speed. We're flying.
500 miles an hour.
Sure.
Okay. I'll have to, I don't want to give you an answer because you're going to call me out and make me hyper precise.
We're doing a hypothetical of a plane flying without air.
If there's no wind, I can tell you how far we're going to be off.
Okay,
no wind. Just naturally, if you're flying,
we're going to be 100 yards off.
If you're flying due west and you don't fly
right.
heading, okay.
You said 100 yards.
If you're 26 miles, over
So we're
26
flying
miles,
from
if you don't
Alaska
correct for Coriolis, you'll be about 100 yards off.
We're flying from Alaska to Hawaii.
Alaska to Hawaii, okay?
Yeah, Alaska to Hawaii. We're in Alaska. We're flying to Hawaii. How many miles will we be off if we don't adjust for the Coriolis effect?
Well, I'll figure it's about
Great Meridian flights debunk the globe.
What debunks the globe?
Great Meridian. Don't get distracted.
No, you're the one that's distracting us. Let's talk about Great Meridian flights.
Out there while you're
Great
supposed to be doing your
just
math.
a datum.
Buddy, you're in the flat Earth school, buddy. You're the student. Okay, so stop getting out of line before we send you to the principal's office.
Right.
Man, I'm about to mop the floor with you.
Dude, raise your hand, Zanuck.
Okay, I'm raising my hand.
And I want to see you after class.
Okay, we have a homework assignment, so you're.
So why is there a deviation for Coriolis?
Why are you asking questions? You're the student.
What?
Zanuck. You have a homework assignment. He did ask the question.
How much are we going to be off?
Right?
No, there's already a question to you. This is a pop quiz.
Well, you got
if we fly from Alaska, relax, dude, relax. If we fly from Alaska to Hawaii, don't adjust for Coriolis, and there's no wind, how much are we going to be off by?
Okay, I have to go through the calculator. How far is the distance? Is it 4,000
Anchorage to Honolulu. Anchorage to Honolulu. We're going to put you on mute until you have an answer.
Well,
dude, wait, time out. I just think this is so funny. Like, everyone gets that he tried to say, like, oh no, when I fly the plane in real life, it veers to the right. And then when I called him out, he tried to act like he wasn't saying that. Like, oh, when I fly the plane in real life, it'll veer to the right.
You don't care about it. You're right. You don't care about it.
Yeah, you got to express.
I was being hyper specific about things. When you fly a plane, mathematically in your head, you have to think about these are happening, but you don't actually deal with those when you're flying because the winds and everything else is far in excess of those issues. So no, you don't. So let me go. You know what? I shouldn't even went there. You're right. What's it? You're right. Every time you fly the plane, you fly as flat and stationary. You don't have to worry about anything else as far as the shape of the air. That's the answer.
You design the airplane, you don't have to take in globe Earth. When you fly it, you don't have to take in globe Earth. When you do any details about it, you don't take in globe Earth. You were honest.
You're right. You're right. I agree with you.
Rakia, last time I got on a plane, the most recent time I boarded a plane, the pilot literally said to me, he saw my hoodie that says the Earth is flat, and he was like, "Oh, you believe in that?" And I was like, "Yeah." I was like, "Oh yeah." He said, "Oh yeah, my friend brought it up to me a few weeks ago, and then I started thinking about it. I think you're right." And I'm like, "Oh yeah."
Oh my God!
The pilots are definitely thinking about it.
We have so many, Zanuck, we have so many videos of pilots already agreeing. You know, I think the best one is actually the best. One second, let me finish. I think the best one is actually the CRJ 700 pilots.
Crazy.
From the CRJ 700 pilots from Australia that say, haha, yeah, flat as a pancake, mate. And the Australian, I feel that's like one of the best videos because they know the CRJ 700 can fly up to flight level 41,000 or 40, I think even 45. I'm not 100% sure, but they can fly pretty high. So I get why they're so funky about it. I mean, I just feel the vibe.
Delusional. These pilots are joking.
Hey, Zanuck, Mr. You're so delusional. How about you look into vertical situation displays and how they work, and then you come back? You know, it has a lot of
Dude, Zanuck just tried to say that. Zanuck just tried to tell me that the pilot was trolling me.
Yes.
When I lived my life and physically walked in front of the pilot and had a conversation with them, Zanuck is telling me what actually happened.
Because pilots at 30,000 feet know that 200-mile away airport that they're aiming for is far below
Zach.
where it should be angularly. They know this.
No,
Why do you
they
guys not
don't.
listen to me? They know
He
that. They know,
specifically told
dude.
me
If
he
they
thinks
say
the
it's
Earth is flat.
pilots do not think the Earth is flat.
He
all
just,
right?
yes, he did. Yes, he did. I know
Then
many
he should be
pilots that think
fired.
the Earth
What's
is
his name? I'll
flat.
get him fired. I'll get him fired.
See, and that's
Ooh,
the
there we
problem.
go. There's a telling
Wow.
right
Because
there.
he's
Hold
a
on, guys.
danger to
Hold
the
on,
world.
everybody, for the
Look
audience.
at this
Hold on.
zealot.
Hold on. For the audience, he said, I will get him fired. Okay? That's a Glober saying he'll get someone fired for thinking the Earth is
That's
flat.
not a Glober saying that. That's
You
Zanuck
shut
saying
up.
that.
You shut up, you
That's a
fat
No,
Glober.
old and
you
worthless
should
person.
have. You should have.
You fat,
Guys,
old, and worthless.
guys,
Shut up.
please, guys.
Dude, it's
Come on,
crazy that
guys.
Glober
Yo,
do
this
that.
is
Like,
so
why?
funny.
Like, why do you guys do that? It's just like when I said I know a flatter seismologist, and now Blue is spamming me
Flatter
incessantly.
seismologist.
They're spamming me incessantly, asking for their name and where they went, or maybe it's not Blue, it's the other guy. I get them all mixed up. Earth is Science or whatever.
B-ball.
Yeah, dude. Like, what's his name? Because they're gonna go harass him and mock him and ridicule him and call
Exactly.
his employers and try to get him fired. Like, what a joke, dude! What an
Imagine how
absolute joke.
desperate. How desperate does a
Yeah,
human being
so,
need to be to make someone
yeah, don't give it. Go ahead,
lose their
man.
job? To make someone lose a job because they're flying their airplane over a plane, because in Zenek's vain fantasies it needs to be a globe, a sphere, 360 degrees around you, curving in every direction. How silly are you, Zenek? You're not a
This is the
man.
Glober. This is the Glober problem, right? Like they think that they can speak for everyone, so they're like, "Oh, there's no pilots that think this. Those pilots were joking." Like, no, I've talked to many pilots. I say, "Is
Me,
it flat up there?" They say yes every
same.
single time.
Get one
When I
on here.
say,
Get one on the
"Shut
show.
up,"
Same with it.
shut
Same
up.
with it.
When I say, "Hey, do you have to? Even the Glober pilot I talked to, I'm like, so, but you have to fly the plane like it's stationary and flat." And he's like, yeah. So I'm like, what you're saying is, so the Earth is spinning and curving, but you fly the plane like it's flat and stationary. He said, yes. I said, so maybe it's flat and stationary. And that was the only Glober, like just blatantly a Glober one. The rest of them were like, yeah, it's definitely flat up there. The last one I got on the plane, he literally said that he started looking into flat Earth because his female friend told him about it, and that he thinks it's right. And it was a serious conversation. He brought it up to me because of my hoodie. I was listening to music. And this is now a Glober on here saying no pilots think that, and he was trolling. So it's like, what can you do with people like that?
You can't do anything with them. You can't.
Well, you asked the question. Let me
He's
answer the
completely
question. Is it
lost his
rhetorical?
mind.
Can I answer the question? The question.
Zanuck, you're the
Can
troll
you
here.
please?
Stop pretending.
Yo, guys,
Can you
don't call
please have
names.
one of these pilots on the show?
No name calling,
Let's
please.
talk about him.
Zanuck.
Okay, I retract.
Have
Why,
one on the
so you
show.
can get his name, Zanuck, and you can get him fired? Is
So
that why?
you know what?
You
I take
can
it back.
say
I would
you're
never
gonna
have
have
him
him
fired because
fired
I know
because
you
he
can
changed
still
it.
fly the plane
You need to
Guys,
take it
everyone
perfectly
settle
well. I
down.
would
We
not
gotta
do
go
that
one at a
because he's
time.
probably either he's joking or it doesn't really matter. You know,
What
like,
about all these crazy
but I do
people
want
we
to have
got
a
on
pilot on the.
Hold on, I'm just temp muting everyone. Guys, we gotta go one at a time, please. It's getting crazy. All right. Just when somebody's don't start talking until the last person is done talking, please.
Yeah, Zanuck. So you want to have him on the show so that you can figure out who he is, so that, like you said
No,
previously, you
I
can
don't
get
want to
him
get him fired.
fired because
Take it
you're
back.
a creep.
Doing
I take
exactly
it
what I
back.
asked you to
You,
not do. Hold on.
I know you might say that you take it back, but it was literally like your knee-jerk reaction, which is typically going to be somebody's like subconscious coming up, boiling up, and doing what they would inherently do. So your first reaction to Witsit talking to a pilot and the pilot actually initiating the conversation and wanting to talk about flat Earth, you want to know that person's name so that you can get them fired. That's creepy. Super creepy.
It's degenerate. But there's no such
People,
thing as
people
No,
like
I don't.
Zanuck.
Can I
People like
respond,
Zanuck
please?
just give me
Can
the
I respond?
motivation to be a pilot. You know,
I was
like
muted.
thanks
Can I
for the
respond?
motivation, man.
Zanuck, what is there to respond to? You said it.
No,
You
I want to.
literally, you
I want
literally
to
said, "Let
clarify.
me know." You said, "Let me know who it is, so I can get him fired."
No,
That's
no,
what
I
you
was
said.
partially unjust in thinking about it. I wouldn't want to get him fired. I think the reason I said that is because I think
You're rescinding because you
you're a
realize
any pilot
that's
degenerate.
I know.
sociopathic.
Gio, let me respond, please. What I want to say is this. Now, the knee-jerk reaction is, yeah, I mean, because I think no pilot would ever think the Earth is flat. Now, if there is one, no, I wouldn't go too far as just want to get him fired. I would like to talk to him, but I don't want to get him fired. That's just the honest. my honest answer.
All right, so you rescind your
that, yes. Because I don't believe any pilot could ever think the Earth is flat.
How can
ever.
anybody trust you to be honest if you're double speaking all the time?
No,
seriously.
You can make
we can't take you
my
seriously
reaction.
because you don't
It was a
present
knee-jerk
yourself.
reaction
You
based
don't
on me
present
assuming that
yourself
there's no
as a
pilots
genuine article.
Okay, forget it. I can't talk.
Why won't they send anybody else but you and Kosho to come in and defend the globe?
The evidence speaks for itself. Anyway,
Zenik is as consistent as the astronauts talking about stars in space.
Okay,
yeah, but you know
I'll
what?
say it one more time. There's a reason why I said that. My knee-jerk reaction is all
you're gonna make
pilots.
excuses for yourself
Elijah,
one more time?
Can I say something to you without him talking over me?
Yeah, hold on, Elijah. You can go next if you want.
So, but the knee-jerk reaction was, I assume all pilots think the Earth is round, and so it's kind of like a joke or injustice. Like if that pilot thought the Earth is, I'd get him fired. But no, in actuality, there might be, but no, I would not get them fired because you do fly the plane as if it's flat and stationary. Even the training is flat and stationary, so it probably wouldn't be a problem. If I was talking to a pilot in a captain and he was flying my plane and I'm a pilot, I look at him and go, "You think the Earth is flat?" He goes, "Yep." Really? Yep. I still wouldn't want to get him fired. I think it'd be really weird, but I wouldn't get him fired. So I'm recanting it. I'm not double speaking. I just told you before it was a knee-jerk reaction, and let's move forward. Okay.
Did your backman told you to put it back?
You don't expect us to believe you, do
no
you?
backman.
Anyway, it's my turn, isn't it? So, with respect to pilots, there isn't actually globe Earth pilots. There's only globe Earth passengers. Because when they're actually flying, they're flat and stationary.
Okay, whatever you say.
Of course.
Doesn't it concern you, Zanuck, that your knee-jerk reaction... Hold on. Doesn't it concern you that your knee-jerk reaction, Zanuck, was to punish somebody for their beliefs? That kind of concerning.
No, it's strictly about safety. I'm all about safety.
Hey, Zanuck, can I give you a high recommendation? Look into the system that Boeing invented, which is called vertical situation display. It literally will give the pilot a vertical situation of the topographical plane underneath him while he is flying in a straight line with no curve being depicted over a plane, no matter the altitude. It shows him the depiction of the topographical properties of mountains and valleys and so forth right underneath him perfectly, debunking this whole notion of a curved surface underneath the airplane. Thank you.
Do you think that the pilot, Zanuck,
Can I respond to that, please?
No.
Can I respond to that?
Think that it wasn't a question, but
Can I respond
my
to it?
question is: do you think the pilot's safety, ability to keep the audience safe, the passengers safe? Do you think that has anything to do with his beliefs, how he flies the plane?
Yes, and I'll give you a situation.
Are you
where it would be
fucking
a
kidding
problem.
me? No.
Can I give you?
Dude,
you ask me a question,
love
then you
peanut
talk
butter
over
and jelly
me.
sandwiches.
You
and still
ask
fly
me
the
a question,
plane
and then you
fine.
talk over me. Can I respond? Now, if I'm flying with a plane and there's an emergency situation, not a normal situation, an emergency situation where all your navigational aids are gone. This happens occasionally, by the way. And you're flying in Colorado and you have mountains, 10,000, 15,000 foot mountaintops. If you don't understand that the Earth is round, you will, and you set your sights to fly over the top of it.
you can't
Can I
say
finish?
that.
I can't even finish the
Say
sentence,
that.
can I? I'm
You
giving you a
can't say
situation
that.
where it's unsafe.
You're saying if.
I'm giving you, yes, I'm giving you a
You
situation where
can't
it's
use a
unsafe.
hypothetical,
If
dude.
that
No one's
pilot was flying
imagining
me
this with you.
and he was a flat earther
Hold on,
and he was
Sensei, let him
lining
finish.
himself up with a mountain, we would crash the plane in that mountain if he didn't understand the Earth was round. I'm just saying.
Whoa. He's keep
I
on
have a
like
response. I'd like
repeating
to
these
respond
wrong
directly to
and
that.
Thanks for
false
talking over me the
assumptions.
entire time.
No one
Guys.
talked over you. You
Too
have
many people
finished.
talking right now, my man. Can you
Yeah.
hear me?
Can I quickly say this? No one in the world pilots a plane like Zanuck just explained. That's retarded.
Wait, Zanuck. So hold on. You say how pilots fly the Earth as if it's stationary and flat. You don't need to account for anything. And now you're saying that if they don't know it's a globe, they're going to run into mountains.
Yes, if your navigation, because when you fly a plane, you're using your altimeter, using your navigational aids to fly the plane. If you don't have those to your aid, and you're looking at a mountain that is 10,000 feet, and you're flying at 10,000 feet, you may say, okay, that mountain.
Wrong, Zanuck.
Hold on, you can't help yourself, can you?
I can't
Yeah,
wait.
Let me give you a
it's
scenario.
wrong.
Let
I
him
will give you a
finish. I
scenario
can't
where
wait
it's
for him
very
to fall down the
dangerous.
stairs.
Guys, please.
The level position of a mountain in front of you may be at level, and you're at 10,000 feet. You're assuming that mountain is at 10,000 feet. In actuality, it could be 14,000 feet. Now, You can't help yourself, can you?
Because
you just
it's
can't.
so stupid what you're saying. It
It's
has
not
nothing to do with.
You're flying a plane. You sight a mountain that's level, that seems to be at the same altitude that you're at. But in actuality, it's not. You will fly into that mountain if you don't adjust your altitude. Now, as you approach it, you can say, well, oh my God, I got to climb. But if you're in a
Nobody's in
piston
a
engine
plane
airplane,
flying right
you may
now.
not. God damn it!
You're so long-winded.
You may
Too
not have
long-winded,
the
Zach.
power to.
First time
You
as
may
well.
not have
I
the
want to
power.
respond directly to this.
Gio, can I respond or not?
No, because you're just repeating yourself.
No. If you don't have the power
you
to
are.
climb 4,000
We
feet
heard you the
over
first
that,
time.
Gio, why are you allowing him to do this? If you don't have the power to climb 4,000 feet for that 14,000 foot mountain that you thought was 10,000 feet, you will crash into it, especially if there's surrounding mountains that don't allow you to make a turn. So yes, it can be very dangerous if you don't know the earth is round and you don't have the navigational aids. You don't have the navigational aids that you normally would have in the electronics of the airplane. Thank you.
Are you done?
So left lane, is that how you were trained when you did your recent pilot training, that you have to have the knowledge of the globe? Because you've said the exact opposite. So since you just did the pilot training, I just wanted to hear your thoughts. Maybe he's not in. Oh, no,
I want him to. I want nothing to say fucking hell. I love when he says that. Oh, fucking hell.
That is his classic.
It makes my day when he says that.
That's his motto.
I have a direct response. I have a direct response to what he said 3 times that we didn't hear him the first time. So Zanik, can you go and prove that in court?
Yes, absolutely.
Sure. Okay. Have fun.
I want everybody to know Zanik is a pilot.
Best pilot monkey.
Yeah, he's a pilot. He's a pilot. He is a space shuttle pilot. He's probably like everything you can imagine.
No, he's not just a pilot. He
I don't know
trains
about the other stuff, but he is a pilot. He's not claimed the other stuff.
Hey, Zanik, have you ever used charts in your life to to navigate your plane?
No, he's a pilot instructor.
So what does these charts show you about what the topic you just talked about? What is so important about the charts? What do they show you? Why do pilots always use them, and why do they do their briefing? Because actually before they step into their airplane, and completely debunks what you just said. Because every pilot does briefing, so what you say will never happen except with a pilot that is stupid when it comes to briefing his flight.
So
okay?
this isn't an answer you want. You want me to answer it or not?
Yeah. So answer it.
So, well, let me finish. Let me answer. I mean, not finish. Let me answer.
I'm waiting.
Yes, the charts for one major thing that stands out in my mind is I can determine the heights of certain obstacles in the distance. That's what the charts tell me.
Right, and the charts have nothing to do with curvature. It says, hey, in the distance, this is this high. It's over here this way. So higher than this.
Zanik, guess what? Can I quickly respond to this? One second. So Zanik, guess what? If the charts tell you the mountain is such and such height, and you're gonna create your routing through briefing, you're gonna set a specific altitude of cruising that will 100% make sure that you pass that mountain. And even on the chart, it will tell you what the safe passing altitude is. Once you're on that safe passing altitude, the pilot that doesn't care at all what is underneath him.
Correct.
Okay, so what you say is just absolutely ridiculous. No pilot flies like this.
What if you don't? What if you can't recognize those mountains? What if you don't know where you're at? You lost navigation.
You fly around the mountain,
you're in Colorado. You're surrounded by 10 to 15 to 16,000 foot peaks, and you also have valleys and rivers and streams. You have no place to land.
Zanik,
how do you know if you're going to be able to clear that mountain if you don't have the?
How does anyone get into such a situation?
VFR. I'm talking about VFR and chart. He's saying charts.
Zanik,
use an instrument. You're not VFR now, are you, pilot Zanik?
No, of course you're using instruments when you're VFR.
You can VFR.
You don't think you use your altimeter when you're VFR?
What happened? Yes, you do. I didn't. Now you're.
And by the way, you're going to bury yourself with this one, Rakia.
You're being ridiculous.
No, if you are VFR,
I've been through trial training. And
you guys
will
just
tell you different. Left lane has been through pilot training now. I guarantee he thinks you're being ridiculous.
Can I ask
There's no way you're a pilot, dude. No way.
No, he is not a pilot.
Just
if you're flying a plane and you're approaching a mountain range and you don't know how high they are, and you're going off a visual VFR, You're not going to clear them. This is why most junior pilots have problems.
Hold on, Zanuck. Listen, you said your piece. Let Zanuck respond. I don't know. We got to go one at a time, please, guys.
Yeah. If you're flying a plane and you get VFI rules, you're still using your instruments. You're still keeping an altitude. You're still keeping the plane level. You still know what kind of banking and turn radiuses you're making. If you see a mountain range, you're flying in Colorado where it can be very dangerous, and you don't know how high those mountains are. You don't have your maps handy. Now, as Sensei said, if you have maps, yeah, you could plot your course and go right around them and know exactly how high you need to be. But if you're surrounded and you don't have your map and you want to get over that mountain and you look at it and it's level, it may be 14,000 feet. You're flying at 10,000 feet. You may not be able to climb high enough to get over that mountain. That'd be a problem.
Zanuck, which responsible pilot that has made his license, okay, with all he has been teach, who is so responsible regarding his own life that he will ever get in such a situation? If not, he is a maniac.
I would like to point out there are pilots that have done that, but they're all dead.
That's right. Those are all dead.
Yeah, they crashed.
There's no old pilots and there's old pilots. There's no old pilots.
No one else gets to respond.
Right,
yeah, let Rakia go. All right, go ahead, Rakia.
They're all dead because they're flat earthers. Sorry.
This guy. Go ahead, Rakia.
Pilots crash all the time. Not because they're thinking they're flying over a flat level plane and they're flying over a sphere or vice versa. It's because they make mistakes. No pilot is going to fly through the mountains and not plot a course and have charts. That's how I know Zanuck making up this story.
No, my God, that's not true.
And he cuts me off right
Zanuck.
at the end.
I know, Rakia. Hold on.
I'll finish up. Zanuck, are you a pilot? Do you have your license?
I don't know. Maybe somebody muted him. Hold on.
Zanuck.
Yeah, I muted him because he interrupted you, but then you quickly asked a question.
That's fine. I'll ask him. This is my last question. I'll get off. Zanuck, are you a pilot? Do you have your license?
Not current anymore. Not current anymore. No.
Not current. They stay current. What are you
I haven't
talking
flown
about?
officially in years.
You had a PPL, and it's not current.
Nope.
I didn't think that was possible, but maybe it is.
If you don't stay checked off, you lose your endorsement.
You lose your license?
You lose your endorsement.
That's not what I said. I said you don't lose your
current again. I can get current again, but I don't have the desire to do it.
Yikes! When were you last current?
I'm doing barrel rolls over Mount Anderson or Lake Anderson in 1985.
So the last time you were current, you were doing barrel rolls. That's why you said that. Like
95. Barrel rolls in an arrow start. Yeah, over
dude, what the
hell?
Anderson.
Listen.
I have video of it too if you want to see it.
All right. Zanuck's not a pilot. Even if his girl shaved her shit into a landing strip, he'd crash his dick.
Yeah, let me ask a question to the room now that it's calm.
Should I make a Cessna joke or no? All right.
If you want. But the question is, what about if you're flying a drone or just an RC plane and you don't have any of that equipment? You're just flying it by sight.
Yeah, I have RC planes too.
Since when in any of that, right? Even those nice fancy ones with direct cameras, these nutters do with they wear like VR goggles and do crazy races with the droning and all of that. When in all of that, do they ever have to account for the curvature or the Coriolis or any of that?
Never.
Oh, okay. See, that's my point.
Yeah. The point about these people getting, Sensei made a point about the
I appreciate it. You can leave it there. It's okay.
Flying without a flight plan. There's plenty of times you don't fly with a flight plan. You can be in a mountain, so you can fly to the Sierras from the Bay Area, and you have a general idea where you're going to go and where the peaks are. But you're doing a lot of it visually along the way, especially on a clear day if you're VFR. You can get yourself into trouble. The plane could have a engine problem, and suddenly you gotta do your hand pump to get the engine rolling because your fuel pump went out. And then you get it rolling. Now suddenly you're lower than you think. Now you're not looking at maps anymore. Now you're just looking at visual cues around you. And you want to see, how can I get out of this ravine? Left lane will back this up. He's gone through training. He's been flying. This is something we talk about all the time. Where you're going to land this thing, how you're going to get out of this thing. If you use your visual cues, you are taught in aviation training that if you're looking at mountains that are in distances, that they may be higher than they appear. That I can find a quote for that if you'd like. And that's based on Earth curvature. In other words.
No, it's not.
No, it's not.
That's so
Hand
not
wave.
true, man. That's
No,
so
it's
not
not.
true.
No,
So
I've never
tell me
broken it,
what.
but I know.
Hey, Zanik, what is the casual
It's not.
procedure if a pilot cannot determine the height of its front obstacle? What is the train procedure you need to do? No,
let me
left
answer.
lane, no, not you. I'm asking to Zanik. What do you do? What do you have learned in flight school?
If you can't determine it, you go around it. But go ahead, left lane. Let's hear your response.
No, the reason that
You never had a
mountains
license,
out in
man.
the distance may be higher than they appear is because they're below your level. They're over the curve.
Zanik, did you ever figure out how many miles off you'd be from Anchorage to Honolulu if you didn't adjust for
500
Coriolis?
miles. 500 miles.
That's not
So
right.
What happens when your horizontal, when the horizon is above your horizontal optically? Is that because the Earth is concave?
How can the horizon be above horizontal?
I've never seen that.
No one's ever seen it.
We got so many measurements of the horizon above horizontal. Are you
Only
talking about
on the water in Santa Barbara, looking at oil rigs on a fracted day.
Well, George did it. Jesse did it. Lots of people did it. All
Zanik,
your guys.
I gave you a PDF by the FFA. You can read that, okay? Maybe you know some more about mountain flying then.
It's called the FAA, knucklehead.
Yeah, sorry, FAA. My fault.
Don't call me.
What are you showing me there, Clay? Do I have to really look at that? I can pull out mountains of information if you'd like. I have flight manuals for the Boeing 727.
Yeah, I hear that, but you're just saying I'll fly around.
I got my pilot training books. I got every Jeppesen navigational tools. What do you want me to look at here?
Okay, I just
no one buys that you're a pilot, man. No one buys it, okay?
I'll show you a video of me flying. You want to see video of me flying?
Well, I can also sit right next to someone and get the controls.
Do y'all want to hear what he said?
I'm flying. If you think I'm not flying, you can see me holding the controls and doing a barrel roll.
Does anyone want to hear what
a lazy eight?
I can also sit next to someone.
I want to hear what Rucky is.
People arguing with
what do you want? You want any of this
not
video?
a pilot.
Yeah. Provide these videos of you being alone in the aircraft. Thank you.
Rucky, what you got, Rucky?
I asked a pilot. A pilot just called me. That's where I went. I asked him. I said, "Do you fly VFR or IFR?" He says, "I'm qualified for both." I said, "Okay. Do you file a flight plan?" He said, "Yes. Every flight, even if I'm going to fly in great weather with no clouds, like not even one cloud, and I'm going to VFR. I don't file
What's your point, Racky? We all file flight plans before we take off.
But I always.
Why are you barreling through him, Zanik?
He's not making. I can't hear him. He's just kind
of log in. I thought with our hours, blah blah blah. Actually, it's in our group or that we talked to. He taught some, blogs and whatever. He said that don't fly flight plans because it's like when you go on a long trip or out on the ocean. You want people to know where you are, where you're headed, what you're doing, and he says it's not hard. We go on our computer, check the weather, and file flight plans. This is what people do these days. He said in the olden days, people would just hop in their planes. There wasn't that many planes, and they would just go fly around. He said that's very unusual these days.
I agree with you. We always fly out some kind of flight plan. Sometimes you just say we're in a general area where you're going. But what's the point there? I mean, there's no argument at all.
So they would know where the mountains.
No, but if you're flying from the Bay Area to, or I'm using mountains, you don't know this area, but if you're flying from the Bay Area to Tahoe, you're going to go over a lot of mountains. Or if you're flying over Yosemite, that area, you're going to have a flight plan. You're going to look at these peaks and say, this is kind of the direction I want to go, so I don't hit these major peaks, and you stay to it. But sometimes there'll be weather. There might be a cloudy. Your VFR, you see weather moving in. You can't go that direction. Now you got to alter your plan. And sometimes you don't have time to look at the maps. You do things visually. You say, "Oh, I see. There's a path here I can go."
And you assume I don't know the region, right?
No, you have weather coming in. The weather will deviate. Left lane. Will you take over because he doesn't want to listen to me?
Been there, back, fly from Sacramento into Lake Tahoe and the border of California and Tahoe all the time.
And weather's moving in, and you can't stay on that flight plan. You've got a general flight plan for a direction. It doesn't say you stay on it directly, like within a mile or something. It says, hey, this is the direction I'm going. Because if you crashed, you just suddenly you didn't arrive, they say, where did he go? They would say, what's his flight plan say? Well, he's going from Sacramento to Lake Tahoe, South Lake Tahoe Airport. So they're going to do a search party along the way.
Okay,
but
when you fly vertically, when you file a flight plan, what's your deviation you can go vertically?
Vertically?
How many
Usually
thousands of feet?
There's an odd or even altitudes, several thousand feet.
Has it changed?
Has it changed since when? Since I was flying? Since back in the day? You're roboting really bad. You're deviating from the topic.
Yeah, hold on.
If I file a flight plan, I can deviate if weather is a problem, and I can go around. I can deviate laterally.
Hold on a second. Rocky, you're roboting very bad. Okay, but carry on.
Anyway, we can deviate off the flight plan if we have to because of weather, especially if you're a VFR pilot.
Yeah, you're in communication with some center somewhere that's monitoring you, following you. It's called flight following, and you're in communication with them. And then you can say, "Hey, I'm at 5,500 feet, and I need to deviate due to weather." And then they'll say, "Okay, climb to 6,500 feet and fly heading of this." And they're with you, and they're watching you. They've got you on their radar. You're squawking a code that they can see, and it's just, I mean, it's just kind of, I mean, it's not a big deal. I don't understand what the argument is about.
Right, exactly, Left Lane. Thank you for mentioning it. Left Lane just brought the point. What does that have to do with the pilot thinking he's flying over a spherical Earth, curving 360 degrees around him? Nothing. Thanks. Good game, Zanik.
All right, so Zanik, you think if we fly from Anchorage to Honolulu, and we don't adjust for Coriolis, we would end up being 500 miles off?
That would be my educated guess.
Okay, now do you think it's fat? Oh my! Hold on. Can you hear me now?
Yeah.
I hear.
All right. So do you think it would be less of a distance for the plane if the plane were to fly where Honolulu is going to be, or to keep chasing it the whole time?
Oh, if you can anticipate it, it'd be a shorter path.
It'd be a shorter path if you could anticipate it. Yes.
They do
so
that.
we can do. So okay, good. So we can do the math for where it would be, and we could anticipate it if we wanted to, right?
Mm-hmm.
Yes. So it'd be short.
The Earth will be spinning underneath you as you fly toward Hawaii.
All right. So don't you think all these airlines would want to fly a shorter distance?
They all do that. They all fly the shortest distance possible.
So you're telling me when they take off from Anchorage, they're not heading towards Honolulu. Their heading is towards where it's going to be.
Actually, they're following the winds, the winds that'll best aid their path. That's more of an important factor than Coriolis.
Okay, forget about the winds. They're going to have to adjust for winds regardless.
If I have a 200, if you're flying against a 200 knot jet stream, you're going to want to be able to, and you know that's going to take you eastward or westward, where the jet stream's flowing. You better take that into account. That's a crosswind. You actually adjust your flight path based on the crosswinds, just like you would with Coriolis.
Okay, so you're telling me these planes don't fly in a straight line?
No.
Well, let's bring up a flight path then, because I don't know. RC's made tons of claims about how he flies in straight lines, and all these flights are straight lines, and they all prove a globe because of
you're flying like from VOR, you're doing all these checkpoints along the path, and it's basically triangulating your position along the path. You're flying a straight path from going from from San Francisco to Sacramento. It's a straight path to it. You fly right directly.
Yeah, I mean, yeah. You like if I want to fly to say Nashville, I just touch it on my GPS, and it draws a straight line, and you can fly that line. But if you're not paying attention, and there's some winds that you're not compensating for, you can see that it's blowing you off, and you have to change your heading to correct for that to stay on that line.
Yes, you do micromanagement. You micromanage you micromanage your plane all along its path to make sure you stay on that straight line, which is headed towards Honolulu when you take off. But if you adjust it for Coriolis, and you weren't flying and your heading wasn't at Honolulu, it was where Honolulu is going to be, you would fly less of a distance and use less fuel.
That's not necessarily true.
It's like
what do you mean? You
separating
said it was
reference
less of a
frames, though.
distance. You said it was a less of a distance that the plane would have to fly if they flew where Honolulu was going to be. You just told me that.
Well, you don't want to waste time going in a direction that you're not truly going.
What do you mean waste time? It's less.
Well, think about going across a stream, a moving stream. Do you aim? Do you fly around the place you're trying to go to? Or are you trying to angle into it? You, like in a plane, you'd have a yaw, or you just dip the wings, and you would turn or in a boat you'd have the rudder, and you would actually be angled the entire way across. There's no shorter path to go. And so fighting and having you're not going to be able to dispel that energy any other way than just fight against it, use the thrust of the direction of the thrust of the boat to fight against the current. And you would go straight across the river with the boat angled, and then the path would be a straight line. That's similar to what happens in aviation.
Okay, so you told me it would be less of it. The plane would fly less of a distance.
Coriolis, though, is different.
If we were to,
because you're not fighting a wind.
Jeremy, the shortest distance is always a segment of a great circle. It's always going to be the shortest distance, no matter what.
No, we're talking about if it's a distance shorter. If I fly from Anchorage to Honolulu, is it a shorter distance if I don't adjust for Coriolis and just keep chasing? Or sorry, if I do adjust for Coriolis throughout the course of the whole trip and keep having to adjust for Coriolis, or do I just fly where the Honolulu is going to be by the time I get there in a straight line?
No, what you do is maintain a heading or whatever it takes to stay over the ground track that represents a segment of a great circle. That's the shortest distance. It's always going to be.
Well, Zanuck told me the shortest distance would be to fly where Honolulu is going to be.
That would still be a great circle.
Get that worked out. We're not even arguing about if it's a great circle or a horizontal line or whatever. That's not even an issue right now. We're just talking about which one would be the shorter distance for the plane.
Yeah, but Skylane's creating an issue where there isn't one. He's trying to say a great circle. Well, still a great circle route if you do it where it's going to be.
Yeah, Blue's absolutely correct. You fly that generally to point to point. But what I'm saying is, if you want to be hyper specific and technical, that would be a curve path. Coriolis would be a curve path to that object. And if you want to have a straight path, then you would have to anticipate and to straighten out that path. But that's not done because there's other factors that are far in excess of the forces of Coriolis on your path in your travel from one point to another point, traveling north or south to north.
Something that would cause you to veer off 500 miles or more?
Over 5 hours? Over 5 hours or 10 hours?
Yeah, I'm asking. Is that what you're saying?
Yes.
Okay.
We're talking about a crosswind equivalence of about 1.5 miles per hour per minute. Not that much. It's hardly anything. And that over 10 hours will have you off of 500 or 1,000 miles.
Oh man, hey Zanuck, didn't you tell me you wanted me to change your name? Someone changed your name back. I thought you wanted me to change your name. Did I mishear you?
I don't look at my name. I've not.
I thought do you not prefer your name to be Panic Zanuck?
Like my name right there, a little bit of a physics lesson is nice. Someone might benefit from that.
You do seem to consistently be in a panic, though, right?
I'm not in a panic. Do I sound like I'm in panic right now?
No, this is a rare moment that you don't seem like you're panicking.
I'm never in a panic.
But anyway, okay, I just thought you wanted that to be your name, so sorry.
Panic Zanuck puts him way too close to my name in the list, so you can keep it at just Zanuck, so he's far, far away from my name in the list.
We'll just put Panic after his name. Zanuck Panics.
Witsy, I think you're pronouncing manic wrong.
Oh, Zanuck the Manic Panics. All right, but I do got a question for you, Zanuck. Why do you come in, right, day to day, and then just like blatantly contradict things you've previously stated until called out on it?
Because he's a highly educated person, and his most in-depth education, he actually has a master's and a PhD in double speak.
Oh wow, touche. I'm just saying, it's just weird, right? It's like,
well,
no, it's like you heard how it sounded loud when you were like, yeah. Well, of course you fly the plane like it's flat and stationary, and if the Earth was flat and stationary, you wouldn't fly it any differently. Because
well,
first you were talking about all your qualifications.
Wait,
and
you asked me a question. Can I answer it?
I'm talking actually. How you talked about all your qualifications and expertise, and then you're like, yeah. I know how to make the plane and account for drag, and I know that this stuff is real, as if somehow that was like exclusive to a globe. And I'm like, wait, wouldn't you have to account for all that if the Earth was flat? Wouldn't you do the same? And then you said yes, right? So you lead the audience to believe that you're making a point that's exclusive to the globe until called out, and then you went on to say, and you acknowledged that it was flat and stationary, but then you jumped into actually, never mind, I'm going to change that. And then you tried to say that when you fly a plane, it drifts to the right. And then I called you out, and you're like, oh, well, actually, I didn't mean when I fly the plane, it drags to the right, like I literally said, after saying I had to correct myself to say I do have to account for the Earth being a ball. But actually, what I meant was a hypothetical thought experiment about there being no atmosphere, which means you couldn't fly a plane anyway. I'm just curious, what goes through your mind when you do.
Now you're straw manning me completely. So the reason I came back, and I agree with you all up to that point, when I really thought of one point where I'd be, you know what, in thinking about it, there are some things that you really, in flying the plane, navigationally, you kind of have to know the Earth is round in a couple of these small situations. So I walked that one back. As far as the drifting to the right or the left due to Coriolis or due to other types of factors that are in aviation, they're not substantial enough to really have to worry about it that much. Other than go ahead.
Yeah, just like what you're saying. Imagine doing a flight plan from Sydney, Australia to Santiago, Chile.
Yeah, dude. Oh my God, I've never heard that before.
I don't know, but it's serious.
Did you just come up with that?
It doesn't work on the flat Earth the way they do it, though.
Can you draw a circle on a flat Earth?
What's the mileage and how fast are you going?
Draw a circle on a flat Earth.
Yeah, a big long one.
So can you fly in a circle over a plane?
You still have to match the distances in the time of flight.
Yeah, the time of flight is hours different from one direction to the next.
Maybe a couple.
No, even up to 4. Up to 4 hour difference.
I wouldn't say that would be impossible, but it depends on the wind.
Also, the distance can be shorter than you think it is.
Okay.
You can't even verify the distance.
But that's an example of how navigationally you would run into a discrepancy between the two models.
No, I just exposed though that's not true. You can't actually even verify the distance, and they catch jet streams, which causes the plane to go faster. It can go up over 850 miles an hour easy.
I got to check into load here.
Say you're flying 600 miles per hour and you're in a 250 mile per hour jet stream. You're going 850 miles per hour, but you would think you're going 500 miles per hour in the plane because you wouldn't even be able to tell a difference. So yeah, anyway, and of course the distance is actually shorter. You can't even verify the distance, and you can't even verify the ground speed. So you can't even make the claim they're not going 850, 900 miles per hour or whatever it is, because you can't even verify the ground speed, and the distance could be shorter, and that doesn't matter at all. This is one of the most rare flights in the entire world. And none of you guys have flown anything like that, and you couldn't verify even if you did fly. And that's not really even the point of any of this. So whatever. Hey, I do got a question for you real fast, though, Zen. So all the Globers were making fun of me for this earlier. So let's see if you can get it right. So they were talking about sonar waves, right? And of course, I was like, I'm like, well, technically those are electromagnetic. And like they were saying, no, there's different, because I was like, it's similar to like radar. I mean, they're both electromagnetic, but they are different. But technically, they're both electromagnetic. And they were saying no. So then we covered it. And well, of course, sound is an acoustic vibration, an oscillation or perturbation of the medium, right? So you could sense sonar through water, or you can sense sound through air. And that's actually the air vibrating or the water vibrating, right? That's what it is. So if it is the medium itself that's waving, and the medium is electromagnetic, then it would technically be an electromagnetic wave, right?
That was an enormous stretch, but because I agree with what you're saying. Like it's elastic collisions in a material, it's like a solid material. It has it involves electromagnetic. It involves the electromagnetic force. However, I wouldn't. I would only claim that as it's technically does involve, but I still think it's kind of
different. Yeah, it's definitely. Well, it's different. That's why I said it's different. But so because the Globers were saying that water's not. They went as far as to say water's not electromagnetic. Like what the. So then I brought up the weak electro or the electro weak interaction, right? So like, of course, what actually holds all the molecules together, not just the molecules being held together to another molecule, but what actually holds everything inside the molecule together, all the way to the smallest scale, is all electromagnetic. That's what the electro-weak interaction is. It's a unification under electromagnetism, right? It's a unification of the forces. So what actually holds the whole medium together to even have a medium in the first place is electromagnetic. So the medium is electromagnetic. And if you start waving it, that wave would have to also be electromagnetic. There is a distinction between what we call, EM waves, but technically speaking, that is a waving medium that's electromagnetic. So do you agree? Do you agree that water is electromagnetic?
I have to be very technical. I have to be very specific when I say this because I think that what you're doing is how do you say it? Like I said, and so depending on the context, certainly everything, everything has electromagnetic components, just like everything has like the strong force involved with it. But I think it's, I guess it's just misleading to say that. Because I can't disagree with you that water is electromagnetic. It's got electromagnetic components for sure. It's put together by electromagnetic forces. It's what makes molecules. But like I said, it's just kind of I could see why people were disagreeing. I think it's just because it seems like it's
but I get it, right? Because they have a different interpretation of it. I get that, but that's why once we got into the heart of the issue, where I'm specifying exactly what I meant, which is why I told SC, technically it's different, and I get that the interpretation of electromagnetism is different, but I'm being hyper specific, and it's not misleading. It's actually increasing accuracy of what we're denoting as electromagnetic. It's actually improperly defined. It's improperly defined, just like the electro-weak interaction was initially opposed, and people said that it wasn't true, and now it's been integrated into the standard particle physics model, right? Initially by Stanford.
I think it could be worded maybe a little bit differently. In other words, sound is a kinetic wave that maybe propagates through electromagnetic substance. Maybe that would be a better.
Well, the only problem with that, SC, is now you're basically denoting the wave as something independent of the medium, as if the wave is some other thing. There's a kinetic wave that moves through the medium, but in fact, it's really just the medium itself that's moving.
It's agreed. But what's causing the movement is the sound.
No. Yeah, the sound is vibration, which is electromagnetic. So like,
wait. You said vibration is electromagnetic? No, sound's not electromagnetic.
Yes, it is, because sound is just the medium, the perturbation of a medium, and every medium is electromagnetic.
No, the molecules move out of the way. Medium. I pushed the air out of the way. That propagates through the air. That is the sound. The sound is that pressure waves of the medium that is being perturbed by the original pushing, the exchange of energy, the exchange of momentum that happened at the source. So when you have a speaker that moves, the drum of that speaker moves, that moves the air. And that air moves just like waves in the water, moves through the medium. And that is the sound. It's not electromagnetic in any way.
Oh my gosh. Waves don't move through water, dude. Waves are the water moving. Sound waves is the air
it is moving. The water moving. I agree. No, now we're getting semantic. Yes, the water is moving. It is the waves is the movement, the kinetic exchange of kinetic energy along its path in the medium.
So the wave is a verb. Wave is a
actually,
verb.
yeah.
So wave is a verb.
It's getting all screwed up.
No, just because you guys want to keep on talking about archaic remedial
if I push you,
you
move. If I push you, you move, right? Same thing.
No, you guys want to keep on regurgitating like seventh grade dumbed down terms. That's the problem, right? Stop,
it's not
dude.
electromagnetic.
Just like you guys want to talk about mass attracting mass. Dude, we teach kids that mass attracts mass to simplify gravity. It's not actually accurate. It's just a simplified, dumbed down version. Whenever you guys talk about waves and moving through okay, if that makes it easier for you to understand it, but it's actually incorrect. Everything's electromagnetic. The wave is a verb. Wave is a verb. It's not a noun. It's a movement. It's a type of movement of the medium. You can't have a wave without the medium. It's just the medium moving. That's all it is. And everything is electromagnetic. That's what I'm saying. And even the strong force is electromagnetic, and they will 100% end up coming out with that as well. Just like everyone denied that the weak force was actually electromagnetic in nature, now they acknowledge that it is. They're going to do the same thing with the strong force, right? We have a unification of forces under electromagnetism clearly on the horizon. And so that's why I bring it up. It's not to be semantic or to divert or anything like that. No, it's to point out this important distinction that needs to be understood that's being swept under the rug. And people want to teach us these like seventh grade dumbed down lessons as if the archaic remedial representation of the phenomena is the accurate one, when actually it's not. It's like the layman term, explanation.
Can I ask Yannick a question very quickly? I gotta say, I was arguing with people in here last night. So instead of disagreeing on this other thing real quick, which will drive us down a different path, I want to ask Zanik a question, and it's only because I want to see how you're thinking about this, Zanik, to see if there's something in. Well, just go along with me, Zanik. But like how sound propagates through like a solid material.
Yes.
Is that from the elastic? Like, what do you call that? But I forget. There's something. There's like a name for like the tensile strength. There's like elastic. I don't know if you know what I'm talking about. But there's like a name for the way, like to what decides how it moves through the material.
It's natural.
Isn't it have something to do with like the elastic?
Every object has a natural frequency.
Elastic collision.
You're right.
That's electromagnetic.
No, it's not. It's not.
Was that somebody spoke up and said elastic collisions or something, or
no? There's no collision. It's a solid object.
Dude, wait. How are you guys saying it's not electromagnetic, dude? If I scream through a wall and the sound somehow reaches the person on the other side of the wall, and the sound goes through that material, then what's happening? There's an oscillation within the material.
You already said it before. You said it's a material that's actually moving. When I have a bat, when I hit a ball, baseball, hold on. Every object has a natural frequency. Would you agree?
That's supporting my point.
That frequency, every object is a spring. This is a spring mass system. The spring mass system will vibrate. Will have an oscillation, and that oscillation is called its natural frequency. And if I actually have a velocity of something, an impact that equals that natural frequency, it'll excite it even more, and it'll have more vibration. And have more
sound. Let Coach get back in.
In a vacuum, you won't hear it.
Yeah,
but it still will have a natural.
That was just.
Wood has.
That was just to be on the same page.
He thinks that.
What did you just?
Zanik,
what did you just call it? What did you just call it? You said.
Just let him finish.
Zanik, about this natural frequency, and I just want to sort of speak on the same terms as what you're saying, because I'm trying to think of an example. Like I agree.
Think of a spring.
I agree with what you're saying, Zanik. No. Trust me. I understand what you're saying, and I understand how sound moves through solid materials. I just want to speak on the same terms as you. And I understand.
Yes, it is.
I know, but hold on. Hold on. I understand. Hold on. I understand what Witz is saying. I want to get to a point here, because I think what Witz is saying, and it is true that by virtue of those being particles, they're held together, they're electromagnetic. So, that there is, so it does exhibit that in every case, except for I was going to ask in a let's say like an exotic material. I was just wondering how you think like a neutron star, how sound would behave in like or a collection of
I know you're not asking me
neutrons
about
or
a
something
neutron
like that.
stars.
No. I want to see how Zinx about this is to make sure it's consistent. Because if it is, then yeah, you're saying, the sound moving through a neutron star, I guess, like it would be the same sort of vibration from before. But like I said, I don't know. I've never thought about that before, like how sound would move through something like that. But I'm just curious how you think about it, Zanik.
Well, I think sound will have to can move through an object, and I think that's where he's talking about probably the interaction of the atoms and the molecules of the substance. Is that what Witz is talking about? So
he was asking you a question.
Yeah. I'm asking you a question because I understand how sound works. I understand how sound works. Like I understand how if you push a million-mile rod, it takes the speed of sound for that rod to move to the other, like on the other end, because it actually has to communicate through the material.
That's what I thought you were
system
going.
or whatever
Okay.
you said. No, but that's what I'm asking. Those is how would that effect be consistent?
Well, there's two things that happen. You can tap on this metal bar, and listen at the other end, and there could be this, referring to this electromagnetic propagation of sound through the material, which is actually these molecules communicating with, probably having to do with the electromagnetic things. But I'm talking about things that when the vibration hears your ear, you hear it. Listen, you're not putting it on the bar. You're in the same room as this bar. You hear it kink. That noise you hear is the movement of the bar that moves the air, and the other air molecule all the way to your ear, which hits your ear. You're receiving that pressure wave, the actual air that's been.
Okay, let's break this down, guys. Janek, you're going on and on, bro. Let's break this down, right? Let's start with a tuning fork.
Thought I just did.
Hold on, Zanik. Let's start with a tuning fork. We strike the tuning fork. What kind of action is that? Let's break it down step by step.
Well,
is that a kinetic action or an electromagnetic action?
Why are those two different things?
Both. He asked me. So that's the example I was trying to initially. You have the movement of the tuning fork, which is a spring mass system, which has a vibration, a natural frequency, and that natural frequency is moving air molecules, which that pressure wave hits your ear and you hear it. That's a sound wave. Then there's also these electromagnetic.
You're going on and on again, bro. One step at a time, bro.
I said there's one type, and I elaborated on how it actually gets to your ear. Now we talk about what's happening inside the tuning fork's material. That's what Whitsitt, I think, is speaking about. How these.
That's what causes the sound.
Whitsitt is talking about the medium it travels
that's not what causes the sound. It causes the vibration. It causes the movement of the tuning fork. The fact that it moves based on the bond. Okay, forget it. Never mind. I thought you want to talk about it. Sorry, I thought we could have an intelligent conversation.
Well, you keep on saying, I think this is what Whitsitt's saying, and then you just keep going on and on and on. I'm right here. So I'll tell you what I'm saying. So the material itself that vibrates is what causes sound, because it causes a perturbation or disturbance in the medium. The medium is electromagnetic. The disturbance is caused by the material's vibrational resonance, which is also electromagnetic. The exchange of information or interaction between the molecules inside the material that causes the vibration, that causes the sound, is electromagnetic. The exchange of information, the interaction between those molecules, is an electromagnetic interaction. On the smaller scale beyond that, beyond the molecules, it's all electromagnetic as well. So everything in this entire equation is electromagnetic.
Well, yeah, if you want to go down to the quantum level, yeah, whatever. Yeah, that's everything is electromagnetic. But I'm trying to distinguish between a kinetic striking of the tuning fork and it traveling through the medium that you say is electromagnetic.
Okay, please let me respond. Now, Whitsitt gave his explanation. Let me correct what he had said, because he made a lot of errors there. The motion of the tuning fork, when you strike it, there is movement. That movement, you can say, is happening at the atomic and the molecular level. The sound you hear is not that. The sound you hear is the motion of the vibrating fork. and they're hitting molecules of air. And those molecules of air are hitting other molecules of air, and that becomes the waveform in the medium, not electromagnetic. When those molecules hit your eardrum, it pushes on it. There's an exchange of momentum. That exchange of momentum moves at a mechanical device, which translates that signal into your brain as sound.
Hey, what's the mechanism that exchanges the momentum?
That you just described it. You just said what it is. Exchange of momentum. Mass.
What's the mechanism?
The mechanism is the change of momentum is mass changing velocity. That's the mechanism. When mass changes velocity, there's a force. That force is being heard by a eardrum, which responds to a force. All along the way, like dominoes. You push the domino, the next domino's hit, so on, all the way to the end. That's exchange of momentum along the way. And when the final domino falls, it hits your eardrum, you hear the sound. We're not talking about what's happening on the impact. The vibrating, hold on, real quick. The vibrating tuning fork, the steel that is vibrating, there is something going on inside there. You're not hearing that. That's not the sound. The sound is the vibration of the waves that have been propagated through the air.
Oh my God, the vibration is what causes the waving. So yes. I'm not advocating, shut up. I'm not advocating for us to do away with the word like kinetic, okay? Like we understand that it's motion. It's beneficial to be able to denote the different characteristics of what's happening. Okay, cool, whatever. Yeah, motion, momentum, we can call it kinetic. Okay, but if you're going to actually exchange energy, right? That's what the sound is. When you hit the tuning fork, it's exchanging energy to the air that causes the sound, okay? And the sound is the air being perturbed or disturbed because of what? Because of an exchange of energy. So that's why I asked you, what's the mechanism that exchanges the energy?
One molecule bumping into another.
Okay.
The medium, guys. Come on. The medium.
When it bumps into the other molecule, it exchanges energy.
Energy.
And that is that's an electromagnetic interaction.
No, it's a physical interaction. Mechanical.
Yeah, it's a physical interaction, and everything physical is electromagnetic. So yes, it's different. It's different. I don't disagree with the distinction that it's different, but my point is that you guys don't seem to understand that everything's electromagnetic, which is why I jumped in to bring it up in the first place. It's not to be semantic. I get why Kosho says it's misleading because there is a difference. And you should distinguish between the two, right? Like simply an electromagnetic interaction or what you call kinetic. But technically speaking, the mechanism for kinetic exchange is intrinsically electromagnetic. The only thing that gives that molecule the capability to exchange momentum or information to the other molecule is an electromagnetic carrier. That's what it is. So if you actually understand this, and the reason I brought this up is, again, not to just be random or semantic or diverse, it's because, just like Tesla said, light can be nothing more than a sound wave in the ether. Okay? So the truth is that they're both intrinsically the same phenomena. It's oscillation.
That's the old school. That's the old school thinking, though.
Dude, no, the new school thinking doesn't even have an answer.
That's back when he thought that light needed a medium to propagate.
No, light is the medium.
What takes place in the new school idea is that these particles touch one another and exchange the ability to do work. It has absolutely nothing to do with anything electrostatic, or anything. They are simply passing from one another the ability to do work.
Yeah, exactly. Like they had a baby and they passed on their genetics. They passed on the ability to do something. Like Aaliyah's going to have the ability to understand electrostatics. So I passed it on to her, the ability. See, it's dumb. And that's why I brought it up, because when you said that that's the old school, what's so funny, Left Lane, is that you won't rebut this, which is that I just now invoked just the last day a 2022 article from the top levels of your paradigm actually saying that light is the background medium that permeates all of space, becoming excited. So it's not just me saying it. Apparently now the top level of your own paradigm is saying it. I don't think that 2022 PhD in atomic physics and a master's in quantum physics is actually old school. I would say that's top tier cutting edge of your own paradigm. Yeah.
Okay, what's it real quick? If I push you and you fall over, is that electromagnetic action?
Yeah, everything involved in that interaction is electromagnetic, but you can make the distinction between what you call electromagnetic and kinetic. That's why I am fine with making the distinction. I've said that 5 times. But I'm saying the reason that it's important to point it out, and it gets lost in the weeds when you don't point it out, is because then you don't properly understand the phenomena is intrinsically unified as electromagnetic, and that is effects.
Okay, Zanuck, I'm you never. Okay, so just real quick.
I want to answer your question too.
Yeah, no, I'm not trying to hijack. I was actually gonna. I'm gonna change the person I'm asking. But go ahead, Zanuck. You finish. Follow up with what you're gonna say. But then,
I already said it, but just really clearly, what's it? When the tuning fork moves, whatever the reason why it's vibrating, and you can say it has electromagnetic, intrinsic electromagnetic reactions inside the material itself. Why it's vibrating? How is it vibrating and not breaking apart? These could be considered these bonds, coulombic bonds, or whatever kind of bonds are holding the sort of the substance together. I get that, but the fact that it's moving is moving air molecule. These are things with mass, and they hit other things with mass, and that exchange of momentum just propagates, because that's how what happens, because things in motion will stay in motion until acted upon by the force. These are Newtonian laws, and eventually that molecule that hits your ear will push on your ear, and it's heard. There is no electromagnetic radiation, electromagnetic forces, or aspects of that whatsoever. That's purely physical. It's purely a physical force with mass. There's energy in the form of kinetic energy in this object that hits another object, that exchanges energy and so on, and hits your ear, which is an object in itself. There's nothing electromagnetic there at all.
That's a cool story, but of course, what gives it the ability to exchange this interaction? Like, what is the mechanism? When I asked you what's the mechanism, you just said exchanging momentum. I said, what's the mechanism that exchanges the momentum? And you said exchanging momentum. And you're pretending that you're pretending that you're teaching people.
No, I'm thinking. No, you're not teaching me. I'm trying to understand what you're saying. So, are you saying that the molecule hitting another molecule and having this elastic collision is electromagnetic in it? Is that maybe
of course it is. Of course it is.
That's what I thought. Okay, that's what I thought. Okay, so that's interesting. That the fact that something can hit something else and not go through it is in its very foundation is some type of electromagnetic reaction.
Correct.
Okay, yes. I'll go with that. You remember, we're talking past this because you're talking things at almost quantum level, and we're talking things in a more Newtonian physical.
Yeah, but don't you agree that the level that you're talking at is archaic? And I'm talking about, yes, it is. It's archaic, and I'm talking about quantum mechanics is clearly the most cutting edge comprehension of physics that we currently have. It is no, it's not. Everything else is comprised of the quantum level.
How useful is it for us to understand things at the quantum level for an object to hit another object and to move?
That's why I said if you want to teach a 7-year-old, then these dumbed down archaic terms are very beneficial so they can grasp the concept. If you want to actually understand what's happening in terms of physics, these dumbed down concepts are useless. In fact, they're detrimental. That's why we have a bunch of adults on the internet defending the globe every day saying mass attracts mass. Because they keep regurgitating this 7th grade dumbed down explanation so that people can understand the concept. Mass does not attract mass in your own paradigm. It simply doesn't.
It appears to.
So wait, hold on a second.
That's why you need to reread my paper. Go ahead.
Well, no, it appears to. But we understand that the reason for that is.
Hold on. In the globe paradigm, all atoms apparently are 99% empty space, right? And they're vibrating at a certain rate. Yeah?
That's what they say.
Yes.
Yeah, that's what they say.
Yeah, so you do believe what Whitsit's saying, right?
That this interaction of an elastic collision between two molecules
because
has
solid
electromagnetic Can you let me answer your question? And so you're saying that
the things that are solid.
Hey, you hear me talking? I'm responding to you. Why do you feel compelled to talk over? I'm responding to you. I'm doing that favor. So you're saying that when a molecule hits another molecule, there is an electromagnetic reaction, because otherwise one molecule would just fly through another molecule, or one atom would just fly through another atom. So there has to be some type of electromagnetic resistance that allows you to have an elastic collision.
Right.
Okay, that was easy. I'm in total agreement. Now, when you're looking at a collision of a car running into another car, are we going to have to look at things at the atomic level to explain this electromagnetic radiation? Is it useful? How is it useful for us to look at something at that level when we can look at things at a much more broader scope, that we have mass that has a force, it's applied, and there's not an elastic collision, it's inelastic. We have energy that's been released in sound and in heat and in deformation, which also could be electromagnetic if you how these atoms. Yeah, we're not inventing anything new here. We're not learning anything.
Okay, actually, Zanuck, you never answered my question. I don't. At least maybe you did, and I didn't hear it.
Sorry about that.
It's okay, Zanuck. It's okay, because I went and explored the answer myself, and what I've come across is troubling, because I was convinced that because like I said, even though I personally think it's a stretch how which it's suggesting that, because technically one could make the same argument and just say gravity for whatever reason, because there's masses and energies involved, or one could say the strong force, because the strong force puts those particles together. But at the same time, it still is true about the electromagnetic force. But then I was curious about like neutrons, like a neutron star. And then like I want to make it more realistic, and I was thinking about like a nuclear fission bomb or fission reaction. But then even like a more concrete example would be two neutrons colliding. So like if you just had a field of neutrons, and they were colliding into each other, would they collide in the same way that you'd expect electrons to repel each other? So they're gonna push each other, or they're gonna have this elastic collision. So I was just curious about that. And actually it looks like I got two different, cause I'm looking at like on Stack Exchange, like physics Stack Exchange,
right.
And there's two different answers, like two opposite answers, because one person says that the collision between two neutrons would be electromagnetic in nature because of their magnetic moment. But then somebody else says that there would be no electromagnetic relationship, because it would just be the strong force that would determine their
but the strong force
scattering.
is electromagnetic, dude. Right. So that's what I'm saying, dude. Your paradigm is about to say the stuff that I'm saying to you. Okay? So instead of just fighting it because a flat earther says it, because Witsit says it, why don't you just go look into it and accept it? Okay? Go look at the evidence that's saying that you're gonna have to unify all the forces, including the strong force, under electromagnetism, and see why are they saying that. And see, well, what do they call anti-gravity? What are they calling antiparticles? What are they calling the positron? What is all this stuff that they're talking about? What exactly is it? What is this all permeating field that they're discussing? What it actually is the nuclear force. And then you start to see there's a conjugate expression of everything. That's why they have gravity and anti-gravity. That's why they have all of these matter and antimatter, right? Because you have a conjugate expression. You have a reciprocation, the inverse of all things. All energy reciprocates. All energy reciprocates. It's that simple. So pressure mediation and energy reciprocation is two phrases that summarize all of physics. And your paradigm is reluctantly acknowledging this right now. And the only thing still holding them back is trying to integrate gravity into the unification.
But hold on a second. Yeah, I know, but what you said right there, you had to. I mean, I'm not sure if you're making a claim about the strong force, or if you're making a prediction about it. But it's not yet been. It's not yet encompassed into electromagnetism. Like it's got a different charge. It's like the color charge.
Don't worry, Coach.
It's different than the. I know it's fine. It's fine. I just want to make it clear if he's claiming that, or if he's just sort of predicting that, because I mean I could be wrong. I think that it's not yet encompassed in electromagnetism. It's a totally different kind of charge with the strong.
Well, there are people trying to do it, but the mainstream consensus as of now is that it's different. Yeah, they try to say it's different, but there are many physicists already trying to unify it. So I can cite some for you when I get back to the house.
No, that's fair. I just wanted to make it clear. I just wanted to, because I wasn't sure if what was happening there. I wasn't sure if you were claiming that's already been done, or if that's just like you were making basically a prediction. And it's probably a fair prediction, but it's I just wanted to make sure it's kind of like it wasn't like an assertion.
It's not the current consensus, but this is one thing that gets lost in translation in these rooms as well. There isn't some like board of consensus that like once they give their stamp of approval, now it's the new rhetoric. Like that's not how science works. That's kind of how the Globers in here talk, which is why they're always so behind. Because in reality, what happens is that the real answer is proposed long before it hits mainstream articles, right? Long before textbooks are updated. You know what I mean? There's not like some like board of arbiters that are like, oh, today we've agreed that the new consensus is the unification. Like, let's use the electroweak force, for example. Like, that was proposed, and then eventually Stanford integrated it into their particle physics model after so many different physicists continued to push it. So once Stanford integrated into their particle physics model, that began to cascade into other universities, and then eventually we all accept it now. That's how it works. So what I'm saying is there are quite a few physicists that are talking about this, that are already proposing it, and I don't really care about their theories. I'm just talking about the evidence. The evidence is that when you look at the quantum vacuum, you see that all of these interactions have a reciprocation, right? So when you look at the strong and weak force, and you understand that all of this has like a reciprocation or a conjugate expression, then all of a sudden it begins to click and make sense. And you can easily, there's a simple road to the unification. But
look, even in their
model, with gravity. Go ahead.
I was going to say, even in their model, they can't disagree with it, because even in their model, everything is electromagnetic. They even say now that you're sitting on the chair, you're not actually sitting on the chair. It's the molecules, and all that stuff, right? So even in their own model, they cannot argue with that. So there's no discussion here. Yeah. The only thing I wanted to say was the kinetic part of it. Yeah, that's it. There's no argument here. Yeah.
Yeah, except other than they'll say neutrinos, and like a lot of people will, they could cite all kinds of stuff right now saying that the strong force is not electromagnetic, because that's the outdated, archaic mainstream idea that's still accepted right now when it comes to accepted as in it's like taught in textbooks, and it's like, but it's wrong. Everyone knows it's wrong. People that have actually really looked into it.
They say the strong force is responsible for keeping everything together, right? That's the explanation. Whereas the weak is responsible for decay, if I'm not mistaken.
Yes, that's correct. Yeah, that's correct.
Okay. Yeah. So at that level, yeah, I mean, that's a whole different ball game. Yeah.
So like kind of like how they still teach gravity's mass attracting mass at school until you kind of get to university.
Yeah, they have four forces, right? They have the strong nuclear, the weak nuclear. The strong nuclear is responsible for keeping everything together. The weak nuclear is responsible for decay, right?
Well, in really crude terms, yeah.
And really crude terms, yeah. Then you have the electromagnetic force, the third one, and then you have gravity.
There you go. Yeah, that's the four fundamental forces. Yeah.
Yeah.
Yeah, but like I said, what's it called? Strong force is only in reference to keeping together the baryonic matter.
Yeah,
so it's
which is like what we call matter. Yeah.
Yeah.
Well, no, but I mean, like, if it's really just protons and neutrons and mesons and I don't know,
which make up matter
stuff. Well, they do make up matter, but they're not the only things that make. They're not even the most important things that make up matter. I mean, the electrons.
Yeah, exactly. Like that's why see, he's not wrong, because right now they distinguish between the strong nuclear force and then like the electromagnetic bonds and stuff that hold everything together. And so they've integrated the weak force into.
Oh, sorry, I thought you were done.
They've integrated the weak force into electromagnetism, right? And so they're reluctant because they're not trying to integrate the strong force into electromagnetism until they can also do gravity, basically, because they kind of play off of each other. But like, that's a them problem, like they're going to do it. And that's why it's so funny when you have people in here that say stuff like, if the electron doesn't exist, how do TVs work? It's so stupid. It's like, dude, just step back, bro, and don't just disagree because it comes from a flat earther, because it's just ignorance. You know, like, I promise you that many of the top level physicists from your own paradigm are trying to unify all the forces under electromagnetism, and everyone that can be honest can see that's clearly the only route forward. It's the only way that we can possibly explain it. And that's when you're going to get into the metaphysical realm. You're going to start talking about stuff like the reciprocation of all of these things. That's why they're talking about antiparticles, positrons, anti-gravity, because that's actually just the reciprocation. And this is what it would have to be. It would have to be happening in a field that permeates space. You have space, like spatial extension, Cartesian space, right? Like what we perceive. And then there's the reciprocation of that, or more so the inverse of that. And so anyway, long story short, like, it's basically just saying the ether without the ether. It's acknowledging the interaction in the ether, the other side of what we see that happens in the ether. Okay. And this is not just me saying it. This isn't just a flat earther just saying the word ether. This is like your own paradigm, top level physicists trying to answer the unanswered questions. And I just wish that people would like, well, you need to step back, bruh. I think the reason flat earthers put the pieces together so much faster is because we don't look at science as some type of like cult that has priests that we must obey. We don't care about that. We don't believe that we have to regurgitate our 7th grade understanding until we die. You know, and that's what's holding you guys back, whether the earth's a ball or not.
Would you agree though that that the same, like the same validity you have for, I guess, I don't know, I wasn't here for the whole argument, but for making a claim about electromagnetism and sound, and, you know, like I said, I'm not sure exactly how it was worded, but would you agree that the validity that you are using to say that can be shared by anybody who did the same thing with gravity or even strong force, based on the, you know, like if somebody said, well, it's all related to gravity, because if you have a sound, it's there's mass moving and there's a medium, and, you know, mass is always going to distort space-time, and so it's like, you know, it's always involved in the process. Like, would that be just as valid?
Well, see, this is where it gets complicated with gravity. It's like you have the quantum and the cosmological scale that are so far away from each other. Like, no one can really explain this idea of gravity extended into the cosmological scale, because, like, on the quantum scale, obviously everything's dominated by electromagnetism. But in reality, what we call gravity is an effect of electromagnetism. It's a collapsing effect based on the pressure mediation of electromagnetism. So, like, until you can accept that, you're not going to be able to explain gravity. And I guess, to answer your question, no, it wouldn't be quite the same, because you guys have this other really big question mark that you're throwing on top of it of modern cosmology. And that's where it gets complicated. I don't know if that's actually what you're asking. I'm saying I don't consider them entirely the same. Yeah, they're connected in the way, they're the same in the sense that they're connected, but because like what they're going to end up saying is, of course, that these are just different versions or modalities of electromagnetism, just like they did with the electroweak force. They just say that, you know, the electromagnetic phenomena changes, and that's not wrong. So yeah, they're the same in that sense, but the fundamental difference is, when you take that understanding, if you map out quantum where it can be fully explained, when you try to take that, including gravity, and then throw it out into space, it gets way trickier. Cosmology complicates the pursuit, right? And that's where I don't have that problem. I don't, you know, that's just where we differ. That's why we're at a standstill, in my opinion. Because I've read many papers that specifically say that like the unification is actually not that hard to do, except when you get to gravitation. Gravitation is the one tricky part of the unified field theories.
Yeah, that makes sense. And also, I mean, like I said, also they don't understand dark energy, so it's like, you already know my opinion about it, but yeah, I think it's kind of funny though, because anytime you hear about the Big Bang, or anybody who's telling you like, you know, I've read both Neil deGrasse Tyson's like a brief, no, what's it called? Whatever his book's called, and then A Brief History of Time by Stephen Hawking, and they both describe, you know, the early, like the ideas of the early universe, how it came to be, and what the forces existed as, like in the very beginning. And I suppose it's just a hypothesis, even though it's part of that theory, but because they you know, the claim is, I'm not sure how substantiated it is, but the claim is that like at some point in the past, like the energies and temperatures were high enough that most recently the weak and the electric magnetic force were one and the same, or were two parts of the same force, and then you go back a little bit further and the strong force was combined with them, and then at the very beginning gravity was combined with all of them. I guess it's just, I don't know if that's just an assumption or how that comes, or how that comes about, but obviously it's not. It can't
That can be
because
true,
they haven't
Kosho,
confirmed it.
because that can be true because they would integrate gravity very easily. That's the number one thorn that's sticking out. That's the nail they can't get in. So, no,
Like I say, yeah, I don't understand what validity they have to say that, or where they get that from, and then it could be the case that there's some evidence for that suggestion, or it's maybe just a rule, like it's kind of like how the energies kind of force that to be the case, like the high temperatures and energies that would exist there. But like I said, I have no idea why that.
you know why
claim
they
has been
can't
made.
incorporate it? Bro, I'll tell you why. Because gravity is not a force. That's why. Gravity is the bending of the curvature of space-time in their world. So how are you going to incorporate that? How?
Well, you know, I mean,
they're changing that though, right? Like that's why the paper that I keep dropping in there is so important. It's not really about the fact that just one dude's theory. It's just that that's where you're going to have to go, somewhere in that area, to answer these questions. You're going to have to change gravity, and they're going to have to say gravity is not a universal constant, and they're going to have to say they're going to have to integrate dark energy being what they call like repulsion or negative pressure. It's just actually it's the reciprocation of what we call gravity, right? It's the other side of the coin. You have the collapse and the expand.
It's kind of hard when you have smooth space versus bumpy space, right? And apparently gravity is built on smooth space entirely, and quantum mechanics is bumpy space.
I think you had that the right around. Isn't gravity built on bumpy space?
No, smooth space only for gravity, Bo.
Why do you say that?
Because that's what the problem is that quantum predicts that the space is not smooth while gravity does. So they have major conflict there.
I know, because general relativity explains the space as being curved and warped, especially when there's a
smooth and curved. You're right, but it's not bumpy. It's smooth.
Well, I mean, it's got the like wherever there's a large enough amount, like whatever the mass energy density of that region is going to determine how warped it is at that region. So,
but the space isn't smooth though. Space isn't smooth according to quantum.
I know, but I wouldn't think that was smooth though. That doesn't seem smooth.
That's what gravity needs. Gravity needs smooth space. Quantum mechanics does not work in smooth space.
I guess I'd have to understand what distinction you're making, because
at the micro level, it's bumpy. Gravity does not predict that it's bumpy, but quantum field theory does. So they conflict each other as far as how the field space works, whether it's smooth or bumpy. They conflict each other in theory.
I've never heard that before, but maybe it's correct.
Go type it in. Gravity is smooth space. Quantum field theory is bumpy space. They contradict. They do not work together.
You made me forget what I was going to say, Data. Because that was so left field. But what was said right before you said that?
It was parking lot. Kosho, that wasn't left field. That was out in the parking
lot. I'll Google that while I'm waiting to remember what I was going to say.
Major conflict. Smooth space versus bumpy space. Big conflict in physics.
Oh, I think it's not very important. What's the noise?
It's a major problem, dude, with formulations predictions.
Okay, yeah, I was going to say something not that important, so that's probably why I forgot it. But I was going to say that just this is my personal, the way I personally, define these things. But what do you call that? Inertial forces or fictitious forces, in my opinion, are technically a subset of forces. So even though gravity is not claimed to be a force in every reference frame, I still consider it a force in that regard. As long as I understood it's an inertial force or a frame dependent force. Yeah, I still consider those forces because technically they are forces. They just have stipulation. So what did you say again though? Data, you said gravity is a bumpy space, I think. Right.
So gravity is smooth space. Quantum field theory is bumpy space. They do not agree with as far as the micro of the world is, or how they predict it, or how the formulas. I don't use their formulas. I just read it in a physics magazine, but apparently it's a big issue. So I'm just going to keep reading and find a little bit more about it. But that's what physics addresses a major problem with quantum field theory and gravity. Is the way they predict space. Gravity predicts it's smooth. Quantum field theory predicts it's bumpy.
That wasn't in. You weren't reading Hustler or something like that, were you? Do you guys get Hustler?
No, bro. It's scientific. I don't look at porn at all. Porn disgusts me.
Hustler, it's not really porn.
Any of that shit disgusts me, dude. All magazines, any of that stuff disgusts me.
Dude, these people in the chat, man, just nonstop lying, bro. Like Chucky's like, I applaud Austin for scamming all these people out of their money. I wonder how many people weren't able to pay their bills because of this con artist scamming them out of their money. And then I'm like, shut up. He's like, I was complimenting you. And then the other guy's like, yeah, look at his summit. It was $150. Then they have the coupon and it's 100% profit. They don't have to do anything. It's genius. It's like, oh, actually, yeah, well, it's $100, 50% off guarantee. It's actually just $50. And we had to pay for the Zoom webinar package, which is incredibly expensive. And then you have to pay for the speaker fees and the website and the app. And we pay each speaker individually. Plus, we give the proceeds to them. When someone picks their name at the time they check out, they get the money. Oh, but yeah, it's 100% profit. It's a scam. Yeah, it's like everything. You guys just suck. Yeah, I don't know what other word to describe you people other than degenerates. Degenerate people. But anyway, it just sucks that they're allowed to just constantly personally attack and lie about people's personal lives. Like, yeah, what does a con artist? He knows the Earth's a globe, but he's just stealing everyone's money, scamming out of the money. Yeah, it's like just everything you guys say is a lie. You guys suck. You're over here defending like 1920 physics, pretending you're teaching us every day, and then lying.
Bro, I got him on his. Let me
sorry to bring the negative thing into the chat. It's just
try to ignore him. No, I try to ignore that text chat. If you don't say it in VC, it don't even count. But yo, Kojo, if I were to fly a plane, Zanuck already gave us his answer. If we were to fly a plane from Anchorage, Alaska to Honolulu, Hawaii, and would it be less of a distance for the plane to travel if the plane were to fly where Honolulu is going to be?
It's funny. I think this didn't we go over this like 2 years ago, like almost a
dude. Yes or no?
I gotta think about what the answer was 2 years ago. Hold on. In the meantime,
the answer 5 minutes ago.
Don't tell me his answer. Don't tell me. Don't tell me his answer. Don't want any hints. But hey, I was watching this video last night, dude, for Neuralink. Elon Musk's company, and my friend has one eye. Right, she's got one eye, and anyways, there's a thing that allows you to sign up for the testing of be on a registry, and they'll contact you and shit like that if you want to be part of the trials. I was wondering if you would sign up for that, just like she did.
Yeah, is that where they implant something in your brain?
Well, first of all, because she's got one eye, you got one eye. I honestly think that the trials, because they just got disapproved from the FDA for initial trials. So I think when they start trialing on humans, when they start doing human trials, I honestly think for blind people, it'll probably be people who have eyes but can't see that'll be tested on first before they test on people who don't even have eyes and like put an eye in there. But yeah, that's
why?
That's
Why
what
would
they do.
you want to mess? I would never do that. That's some shit you need to try and straight up blind people that can't see at all. I'm not risking anything with my eyeballs at this point. That's
You
fucking
wouldn't do
dumb.
it?
You need to try that
happened to your eye,
with people
Jerry?
that can't see. Period, dude.
What
What do they have to
What
look?
happened to your eye?
No, we just need like a 4K camera, cram it in me.
Oh yeah, that's exactly what's up, dude. If they put like a really high tech camera in there that I can see like infrared. You can like see Wi-Fi. You like read like Wi-Fi in the air.
To be able to see like a predator. That'd be
Yeah.
dope.
Better than Predator, dude.
Make that little sound. Dope.
He's just got infrared.
Yeah, they won't fuck with your good eye, Jeremy.
They wouldn't fuck with it at all.
Dude, I'm not doing any eyeball shit until that shit's tried and true. If they had done it thousands of times and they were like, yo, this shit works, it's fire, I'd be like, okay, let's do it up. I'm not about to be the first person to let them go tinker around and inside mess with my eyeballs when I only got one eyeball left.
You're not going to mess with your eyeball, dude.
Kosho's mom lets me implant things into her red eye.
Goodness gracious, dude.
Just saying,
They're not gonna. They got no reason to fuck with your good eye, dude.
But what if it's a freemium thing and then they start giving them ads?
Yeah, bro, I'm not doing no eyeball shit until it's tried and true, dude. I'm not about to be the lab rat where they just test this shit on. That's something they need to try on people that can't see at all. That way, there's no, there's not really risking much.
Well, that's what I already said, but I think yours would be riskier, dude, because for a blind person, like they put these little electrodes in there that just like have electrical connections, and they already have an eye, so they would just kind of, probably just use the electrical connections that would reach in the eye and then just reach the brain and connect it. But they would have to put.
This is how like a Tales from the Dark Side episode starts off,
or like Mirror or Black Mirror or something. But they would have to put an actual eye in your head and then connect that to your brain.
What if they gave you a fisheye lens and then the world looked like it was round all of a sudden?
Yeah.
And then your good eye was conflicted with your fucking robot eye. You were just spiraling.
Yeah, if they did it on blind people, thousands, at least hundreds, or at least thousands of times, I'd be like, all right, this shit works, it's good. I'd go get a bionic eye or whatever. That shit sounds dope. But I'm not going to be the first one to let them go start messing with my eyeballs and my retinas, whatever the fuck they do. I don't know how the eyeball works, but whatever they're going to do in there, I'm not going to be the one. I'm not their lab rat.
Are you panhandling right now? Somebody sounds like they're panhandling.
I'm stacking chairs up in a cafeteria. I'll go on mute.
You're fine, man. It's just I hear traffic. That's why. Nothing wrong with panhandling, by the way. Those guys.
Xana gave us his answer. He was wrong on the
All
amount
right, dude.
But Xana
Listen,
gave us his
I remember.
answer.
I remember this question. Because we went on this for way too long, and I remember thinking about it. And actually, I think the answer is and was and still is. That's right. Yeah, that's right. The answer is if you have a powered flight and you make you travel towards the like I said, wherever you're going. Doesn't matter if it's Honolulu, wherever you're going. You traveled there, like you aim there, and then you correct for your flight as it deviates from that path that you have aimed for there. As you do this, that will end up being the same as if you were to aim for where it's going to be. Like those two, doing those two things would result in the same thing.
Okay, so I have three different answers from three different ballers. Bacon said it would be longer to fly. The plane would travel longer if you flew where Honolulu was going to be. Xanax said the plane would fly a shorter distance if you were to fly where Honolulu would be. And you say it's the same.
No, I'm saying that I gave a very specific stipulation. I said if you drew a path from Honolulu to Alaska, whatever, and if you followed that path, and if as you deviated from that path, you made perfect corrections, so that you never deviated from it too long, then what you'd end up traveling, that path that you end up traveling would be identical to the path as if you were aiming to where it was going to be, where you know, at that time. It's like it's the same exact thing. The same things would occur.
Yeah, so same distance. So Xanax says longer, Bacon says shorter. You say the same distance. Got it.
Like I said, that based on the stipulations, because I don't want you to fucking later say, oh, because you always you don't listen. You never listen, so you always fucking will just say your own words as if I say them. So I have to say perfectly.
Yeah, what were you saying? I wasn't listening.
Exactly, dude. Just don't even use me, okay? Don't even use me. I didn't give an answer, okay? As far as you're concerned.
I heard you.
No, we got your answer. It's too late. Same distance. Got it.
Yeah, just don't share it with anybody then. It's just between
everyone's. Everyone. No, everyone's here. We shared it with everyone. Same distance. Got it.
Yeah, because you're gonna leave out.
I'm
shit
writing
that I
it
said.
down right now. I'm writing it down. Show 2023. Same distance.
But don't you remember asking this question a year or two ago, and we were on this like
yeah, and I was not satisfied.
Brendan's.
I'm not satisfied.
I don't care if you're satisfied.
I'm not satisfied now.
You know, I mean, you know what they tell mules? They tell mules they're as stubborn as you.
Bro, I'm like your girl after sex. I'm just not satisfied.
Okay. Yeah. I told your wife not to tell you about that, but okay. So what? I'm inadequate. No big deal.
Oh, you missed it earlier. Zanuck tried claiming he was a pilot. But I told him that even if his girl shaved her shit into a landing strip, he crashed his dick.
Okay, all right, dude. I'm pretty sure. Yeah,
I like our left lane, who is actually the pilot, Maria pilot, and I 100% believe him. Concluded the whole conversation in just under 10 seconds and explained the whole thing, how repilot would do, which Zanuck was not able in even 10 minutes. So good job, left lane. I appreciate that.
We all know left lane. He's a paragon of what's that word? I'm just gonna make up a word. Succinctity. Okay.
Hey,
what's that called?
Hey, Kosho, what do you think about this? So, like, say that someone comes up with they discover evidence or whatever where it's inevitable that everything has to be unified under electromagnetism, and people explain how it all works. And there's a theory that just it has to be accepted, and all the physicists see it. It's experimentally validated. Blah blah blah. How long do you think it would be before, like, say, the people in this room, right, updated their rhetoric? Like, what I'm asking is, like, what do you like? Have you ever thought about like what's the process of the rhetoric being updated, and like how long? Like, what's the fastest you think it can happen?
Okay. Well, first of all, the people in this community are very unique. They're not very good, like, you know, survey of the population, because there's very intelligent people in this community, and also people who are, you know, like, there's a lot. So basically, what I would say is that it could go all directions, because there's people who I think, depending on the veracity of what was shown, like if it was like tested and verified and basically confirmed beyond, you know, any more testing, like there's no more testing needs to be done, it's been confirmed. There's certainly people who would agree with it and accept it, you know, as soon as that was the case. There'd be people who either stubbornly, you know, dug their heels in just because they believe something else, and there's obviously people who, based on the arguments, aren't going to accept it just because you know, just because of the nature of the argument in this community, that, you know, they'd have to admit that, you know, because they're already engaged in an argument about that thing. So I don't know if they would accept it right away. But that would probably
what I'm
be
saying is, yeah. But what I'm saying is, like, have you ever thought about, like, what is the process of update, right? Like, for example, everyone's still talking about relativity this, relativity that. Relativity is the most experimentally validated and verified theory ever, and relativity is true, blah, blah, blah. Okay, it's been known for really like a century, but it's been like really known, like experimentally verified and demonstrated beyond any doubt for like almost 20 years easily now. And for like the last 10 years, it's been insanely demonstrated, but people still say it. So what I'm saying is, like, have you ever thought about it? Like, let's say that tomorrow there's this huge discovery that's just inevitable. Then it gets replicated for the next few months over and over and over, and it's consistent. You know, like the relativity cannot be true. Here we verified for sure that everything's electromagnetic and everything has to be unified that way. Whatever it is. So, or even someone comes up with a theory that clearly is the right answer and it actually works, right? Whatever it is. It's like, have you ever just sat back and thought, like, how long would it take to actually trickle down to, like, the public? Not just this community, but the public. This community just yells about the current archaic consensus as if it's so definitive that anyone that dares question it is stupid. Yeah, they're rare in that sense. But, like, have you ever really thought about, like, how far behind the mainstream rhetoric is from the actual scientific paradigm?
I mean, we see things differently because me personally, I agree just like, everybody knows that gravity is, very most likely going to be superseded by a more robust, description of what's happening. But it will have to encompass general relativity, surely. And so it's like it goes back to that crossword puzzle thing that we talked about, like the example of the crossword puzzle, because it depends on how much of general relativity was overturned in this like new paradigm shift. Like if it was just everything in general relativity, but was shown to have a relationship with the other forces, I think people might accept that fairly fairly quickly. I don't know if they would probably be skeptical at first, but I think definitely if there was something that overturned general relativity and took out a lot of what was claimed to be happening and exchanged it for something that was electromagnetic, I think people would be much more skeptical and probably I mean personally, it'd probably be like 50-50. Like people would be up in the air like with whether or not they believe it or not.
Yeah, but you see, like,
it's hard to answer.
There's one part that has to be pointed out here, right? Like, relativity addresses a lot of stuff that isn't exclusive to relativity, right? Stuff that was known long before relativity, phenomena that's been verified entirely independent of relativity. It's not like relativity is just because it explains, it integrates certain phenomena and explanations of it. It isn't like exclusive to relativity. It's not like we need relativity to show that linked contraction exists within electric wires. That existed with all of our heavy side before relativity. We don't need relativity for that, right? So there's so much phenomena that relativity gets applied to that people falsely attribute to relativity, meaning like they need relativity to explain it when it's not the case. So much of the phenomena can still be explained completely doing away with relativity. But when relativity, say, makes a prediction, and then the exact opposite of that is demonstrated to be true experimentally, relativity no longer works. It has to be gone. It's gone. Or I'd say if you demonstrated for sure that there is an invariant speed of light, well then like relativity is automatically wrong no matter what. You can't say, oh, it's just going to be encompassed and update. No, it's wrong. Its base postulate's wrong, right? Like relativity will just be done away with. It just sounds better to say it'll be encompassed and updated. It's incomplete. It sounds better. But quantum's already shown there's no way relativity can actually explain like the reciprocation of the quantum vacuum, stuff like that. It has to be entirely updated and revised. But my point is like when you said that people would be hesitant, right? It's like, yeah, that's kind of my point. They would be hesitant or skeptical, and it would take, in my assessment, like at least a decade. It would take so long for the average person to update their rhetoric, right? People still say mass attracting mass. People still talk about Newtonian gravity, and it's been superseded for over a century. So, like, I guess my point is that we wouldn't live to see the day in here. Like, the people that do that, the certain Globers that do that in here, it's such a safe bet. I'm almost done. It's such a safe bet because they will not live to have to humble themselves. They'll never have to come in here and be like, damn, now the new consensus is this. Because by the time that the quote unquote consensus trickles out to the mainstream, it's like a decade or more behind the discovery. So like it's such a safe bet to just be super arrogant and mock and scoff and talk about the archaic system because they'll never have to live to see the day like in here where they have to admit they were wrong. You see my point? Like there's such a delay that like it's always a safe position of the time to just keep screaming the old archaic disproven system long after it's been disproven. That's kind of what I'm saying. It's like it's weird that people don't see that.
When pop
Let me let Elijah
culture
get in.
when pop culture wants to explain things to the masses, dropping a mic to the ground and calling that gravity will be probably around for the next 100 years, because it's such an easy, convincing, for the paradigm, it's a very convincing concept to have things fall and then attribute it to a sphere because of it. I don't think you'll be able to escape this claim of things falling.
You're talking about the argument
just give
that
an
was made
example.
on.
Just give an example. A science educator by the name of Neil deGrasse Tyson drops a mic. It's science.
Comedy Central at Comedy Central at 10:30.
Therefore, he drops a mic. Therefore, science. Therefore, science equals gravity. So when we stop appealing to pop culture consensus, then maybe you guys can move forward in actual, science accuracy.
Like I said, the argument doesn't really hold up because it was on a comedy show. That's not how gravity is shown to be true.
The point is that's what it's done for pop culture. Pop culture is dropping things, therefore gravity, therefore sphere, therefore paradigm, earth settled. I live in a spinning space testicle.
So was he joking about the gravity then?
Yeah, that was a joke. He wasn't joking about gravity. He was joking about the feud between him and the rapper B.O.B. That that's what he went on the comedy show to express it like that. He wasn't like actually calling out B.O.B. and like trying to do like a.
But he still thinks dropping a mic is gravity, caused by gravity. The mic falls to the ground because of gravity. What are you trying to say? Because it sounds like you're saying that he doesn't think that.
I'm trying to say he was on a stage on a comedy show, 10:30 at night on Comedy Central, and that was part of the act. That was part of the the act that he's putting on. He's putting on a show for the people in the audience and at the home. I mean, it's just not a good example.
My question still stands. This representative of science, is he doing comedy, or is he telling people this is gravity when he drops the mic to the ground?
Those aren't mutually exclusive.
It actually kind of reminds me of Nazi Germany. When they hold their arm up, the old salute thing. That's kind of what
that's y'all's salute.
I don't do that.
Can't even knock the Nazi salute, man.
Neil deGrasse holding up the mic and he's doing his little authority, bow to my authority, and putting his arm out and dropping his mic. It's the same shit.
That's not. Obama did the same thing at his last
Dude, you're making
press.
Excuses.
No, I'm not making excuses. I'm telling you what it is.
Do you know how many people in here that claim to be Globers say that's gravity, and now you're saying it's not? It's just a joke. But
they say that's gravity and drop their mic. Nobody does that.
Yeah, dropping a dude. Left Lane said dropping a pencil yesterday was gravity.
That's fine. Yeah, that's him giving an example. I'm saying what Neil deGrasse Tyson was doing was doing a show, doing a presentation. I mean, if someone were to say, things falling to the ground, that's gravity. That's not incorrect. That's not comedy, though. Them saying that. I know, but that's what I'm trying to tell you. Is what Data was just saying was that presentation, showing that presentation was what should substantiate what gravity is. That wasn't the point of what he was doing. He was putting on a show.
You could take all that out, all the comedy bullshit and everything you just tried to make an excuse for, and have him just say, here's the mic falling. I'm going to drop this mic. This is gravity. And that's what y'all think.
So basically what he's saying is we shouldn't take scientists seriously.
No, what I'm telling you is that you can take the same person, the exact same person, and you can take an example of when he's actually trying to describe gravity to people and show what it is. And you can take what he did on the Comedy Central on the nightly show, and you can see that they're vastly different things.
Bullshit.
He doesn't when he's explaining what gravity is. He doesn't do that comedy act.
You hand him a mic and say, "Show me gravity." What do you think he's gonna do?
I think that he also hosted the Cosmos, in which he explicitly described it. So the argument.
Wait, Coach. So when he was asked what gravity is, he literally said, "I don't know."
I don't know. Yeah. That wasn't on a comedy show.
It was on a science. It was on a science show. And he literally said, "Well, what is it? I don't know."
But I think that's making.
It's also out of context too.
we shouldn't listen to what he's saying.
Everything's out of
context. That's of course out of context. If he's also explained it, what gravity was, like, if you can find examples of him explaining what gravity is.
Hey, Kosho, what's gravity? Kosho, what's gravity?
How explicit do you want the description to be?
Kosho, what's gravity? You're Neil deGrasse Tyson.
Did you hear the question? Did you hear what I asked you?
Gravity.
Data. Did you
gravity?
Hear Daddy, if you're not going to participate in a conversation, there's no way I can participate with you.
What's gravity?
I just asked you a question.
What's gravity? What's gravity?
Data. Yeah, no, I asked you how explicit do you want me to give you the description?
What's gravity?
That's a fair question, dude.
It's your choice.
What's gravity, Kosho?
Yeah, just explain it, Kosho.
It's your choice how you answer it.
It's my choice. All right. Well, okay, but remember that you said that it's my choice.
He's waiting for chat.
It's my choice.
To load.
It's my choice.
Bullshit now because you're trying to get out of
it. No, if it's my choice, it's my choice. Then you're not worried about the explicit.
All right. While Kosho,
I'm waiting for you guys to shut up. I'm not delaying. I'm just waiting for you guys to stop talking.
Delaying. While you waffle,
I'm waiting for you guys to stop speaking. If you guys stop speaking immediately, I will fucking give you the answer.
Whatever.
Right?
Show what's gravity. 90% of the time, it's not how you act.
Data, you just asked that question again.
What's gravity?
Data, for the love of God. Yeah, what's gravity, you ask? Gravity, I'm going to use the words of John Wheeler, okay? John Wheeler says that space-time grips mass and tells it how to move, and mass grips space-time and tells it how to curve. And that's a succinct way of explaining Einstein's description of what gravity is.
Cool. So you said
so how come Neil deGrasse Tyson says he doesn't know? Michio Kaku says there's no mechanism for it, but yet you are describing space-time and inferring that gravity is space-time.
Both those guys have explained what gravity is. You're just taking them out of context.
No, so I've listened to them explain
I have examples. I have examples of both of them explaining gravity.
Show, you're interrupting. I've listened to them explain it. They, the only person that explained it the way that you described it was not Vsauce, but the other guy there. The little short guy that does the space-time videos.
I've literally heard Neil deGrasse Tyson explain it this way. He used these exact words.
He described it as you said, is that space-time tells matter how to move, and matter tells space-time how to bend. As you described it, this came from not Vsauce, but Veritas, not Veritas. What's the guy that does all the physics videos? The little short guy. Veritasium. He did a video on it. He did a video on that describing exactly what you stated. But again, this overall gravity is not a universal effect on all items. Hence why quantum field theory, and why at the subatomic level there is no gravitational forces, nothing. So when you claim that it's space-time, but yet at a subatomic level there is no gravitational forces, then how is space-time not affected, or how is space-time a viable field if at a subatomic level there's no effects due to gravitational forces?
I'm confused. Space-time curving or bending or whatever is why my pencil falls when I lift it?
Yep.
You got it.
Allegedly. I just wanted to touch on the point that you made earlier, Data, when you brought up Neil deGrasse Tyson dropping that microphone and said, this is what the thought process is going to be for the next 100 years, right? This is going to be kind of like the idea of gravity for the next 100 years, regardless. And that's kind of a good point. And I took it as like the overarching common masses association of what they think gravity is, regardless of what the cutting edge of science and or any alternatives to science are talking about what gravity actually is. The average person in not just the United States, but the world, their association of what gravity is as simple as dropping an object, period, end of discussion. And that's going to be their conception and their idea of it for a very long time, until somebody comes along and can explain something that's a little more complicated in a simplistic way.
Yeah, see, this is the problem with the connotation of, well, I'll give you an example. Roblox is teaching children the reason why they're stuck to Earth is because of gravity. Gravity is holding you to the center of the Earth. So that's being taught right now still in schools. So you're going to have all these.
I mean, in here over the past couple of days, responses to the talks of electrostatics and magnetism being similar to gravity, and the similarities between Coulomb's law and the universal law of gravitation. There's still responses, Left Lane being one of them, that are as simplistic as without gravity we'd float away.
That's what they're teaching kids, right? So this is what I'm saying. Until we as a group start changing the cartoons and start getting kids to think about why things are, as opposed to telling them how to think or what to think, giving them the tools to deduce it on their own, to gather the information on their own. I don't think we'll get there as a society, because it's all about control fundamentally. And if you control the youth and you control their minds, then you're going to control the future. And I don't think I don't know, why is this flat Earth thing popping up here? Is it being the antithesis to all this teaching? So how I'm just trying to say, how are we gonna compete against it? Because I think that they have it so fine tuned that it's that easy as you described to call something gravity. That connotation with that something dropping encompasses a whole model of thought, a whole idea of philosophy. So I don't know how you can compete against it.
It's a tough row to hoe, right? Because there is so much programming that takes place from a very young age all the way through adulthood, and then you still have the visual propaganda reinforcement of that as well throughout one's entire lifetime. And yes, if you try to say that you have an alternate explanation as to the effects that we see on Earth that we relate to this term gravity, if you claim that you have an alternative explanation as to why we have this downward vector and things move towards the surface of the Earth due to various different reasons, and or move directly upward, right? So you density, buoyancy, all these things, right? And you claim that the causal nature of that is something other than what the mainstream is. The average person literally just looks at you and says, "So you don't think gravity's real?" And then holds their car keys out and drops them and go, "You're stupid." It happens all the time in the real world when you
Magic. Oh yeah, magic still, dude. I got into a discussion with a guy a month ago or so, and that's all it is these quick little affirming tests that they claim to be tests or science in their mind, just reaffirms their belief. And I'm like, no, dude, you got to understand how you think and why you think that way to begin with. And it's really hard. It's a real hard spell to break. But haven't you thought about why the spell was broken for you, or why other people like Whitsid or Rakia, the spell was broken? How is the spell broken for us in the sense that we can see the problem, but not for them, where they do not see the problem? It can't be an intellectual aptitude, or it can't be just based on intelligence.
Well, you just have to be willing to hold different ideas within your head and give them serious contemplation without necessarily adopting them, and use discernment, right? But you have to be willing to allow that information into your brain to give it consideration in the first place. And I don't think a lot of people are, or they just don't have the time, nor do they ever come across the information that's presented in a way that makes sense to them. I fortunately enough have found throughout the years various things that have been explained to me very simply, in ways that I understand and comprehend, and I can paint the visual picture in my brain. I can run that through my discernment and see whether or not it makes sense, and either decide to adopt that, continue to look further into it, discard what I had previously learned, or reanalyze what I previously learned, weigh it against the new information I've taken in. But the problem, I think, is usually with most people, it's step one, allowing new information to even roll around in their brain for a little bit.
I think sometimes it's also beneficial to try and be the spectator, and because often the problem is people identify with these things, and that's what makes it so hard to let go of things. It becomes a part of their identity.
Yeah, I agree.
Well, frankly, they're able to wrap their mind around it, so then they just can't let it go once they think they understand it.
Well, here's the thing. here's the thing
But
with
it's like
I've
being a
tried this.
Yankee fan or a United fan or
I've tried
right.
this with water, using physical properties of water just in small scale demonstrations on just average people, like friends I've known that not familiar with the debate, the conversation. They cannot seem to even grasp the physical properties of water large scale, even though you can show various scales at a small scale, or let's say a lake, 3-4 mile lake, you can use the comparison small scale. Even that concept on the physical properties of water, how it takes the shape of containment, and then the hydrostatic pressure is subjected to, levels off, and it gives it a horizontal balance. I can present that information for a short period for them, and a short period of time they can understand the principle of it, like how water works at their local scale. But then they, for some reason, they can't continue on at a larger scale, equating water properties to maintain itself. And I find that absolutely, like, that's just mind blowing, because you can look at a lake that's 5-6 miles, 6 miles. You can see across it. You can demonstrate a small scale version of this lake just to 1-to-1, scale down 1 to 1,000, 1 to 100,000, whatever. You can scale it down, and it would maintain the same physical properties that you see. When you appeal to the logical reasoning, that form of logical reasoning in their mind, they get it for a brief period of time, like a minute or two. You can see the lights on in there, but for some reason they cannot cross the boundary where now they look at water as a whole across the entire earth to maintain those properties. They cannot get there.
They already have in their mind the shape of the earth, right? So then once they expand that outward, then that shape that they've been taught comes into their brain, cognition kicks in, and they have a hard time associating what you've just logically explained to them on a larger scale, because the larger scale does not comport to what they've been taught. So that's when cognition.
I don't think it's cognition. I think it's just contradiction. It's not cognition.
Well,
you're trying to say that what they understand, you have to understand what they understand the world to be, and the ocean's curved with the shape of the earth, and you're saying it's flat, is a contradiction. It's not cognition.
No, what I'm showing them is the physical. I'm not saying the shape of the earth, okay? The shape of the earth is irrelevant. We're talking about the physical properties of water. They can relate and they can see, okay, yes, I see the physical properties of water take the shape of containment. When it's undisturbed, it levels out, it's horizontal. Yes, we use it in buildings. So they can acknowledge all of the practicalities that come along with the properties of waters and how it is displayed and how it's used. I can even use large bodies of water, whether it's the lake in Russia that's 300 and 400 miles long, or lakes out here that are 6-7 miles wide and long, right? They take on the same properties. So they agree. They go, yeah, I agree with that. Yeah, a lake is like that. Oh, hold on. A lake is like that. Yeah, I can see the physical properties. So then they get it. They can register it. And then I say, well, at what scale now in your mind does water change its properties? And they cannot answer.
There's no change in properties, Data. It's not a change in properties.
It has to be changing properties.
No, if it was flat, it would be flat. If it's curved, it'll be curved. And the discernment of those two shapes over a long distance is the problem.
Water has sphericity in it anyway. Okay, that's why we have the surface tension. It's got a sphericity to it anyway, right? But we're not talking about that. We're talking about its properties in general, what it does. They all of a sudden contort their mind that the physical properties of waters no longer take the shape of containment, but are adhered to a surface due to gravity. So it's a different application of thought. When they're looking at water settling and taking shape of containment and leveling off, they're not equating that to be gravity, but they equate gravity to the sphericity of water attached to the earth. So there's a switch there in their mind that they have to suspend disbelief, change the physical properties of water, and call gravity. Gravity is causing it. And that's the leap in logic that they do to justify how water at a local scale can display properties here, but at larger scale display different properties. In reality, it doesn't display different properties in scale. How? It's because we can vary.
It's not displaying different properties, though.
We can vary. Listen, we can vary scale. We can vary scale in size of containment, and water adheres to all of those properties in each of those scales. So yes, it might be affirming the consequent that even at a larger scale, it operates the same way. That would be obviously a good deduction. You're not inferring that to be the case. You're deducing it from smaller scale objects, even up to 6 mile, 7 mile lakes, even up to 400 mile lakes. the surface of the water is horizontal. So that means it takes the shape of containment. Hydrostatics kicks in, it levels off undisturbed, and you've got a lake. So again, to have their minds switch between local scale and large scale.
Nobody argues that, Data. Nobody's arguing the properties of water, that water takes the shape
have
of
a
its
conversation with I know, but have a conversation with a layman, and not somebody who's familiarized with this debate, familiarized with the rhetoric, familiarized with the rebuttals, somebody who's just an honest observer that has no attachment, no gate, no dog in the fight. They answer, you can see it on their face. You can see the reaction. You can see whether they're angered, upset, confused instantly. You can see it by questioning their minds. Now, I'm granted a lot of people that I've asked know me, so they're not going to be offended or aggressive towards me. Where I've asked other people, they get aggressive and upset.
Hey,
so
Bendy
there's no
Light.
reason.
Oh, I didn't want to interrupt. I just wanted to say something when you're finished.
Hard home.
When I talk to real people out there, not the anti-flat earthers, when I talk about water, what real people actually do most of the time? They do this. Wait, yeah, that's interesting. You're right. I've never thought about that.
Well,
yeah,
that's correct. You're right. They do acknowledge it for the first minute or two, but then they'll jump back and go back to justifying how it is at large scale. This is it's like endless.
Not
like
they
will literally have a moment. Well, so far, most of the people, they will have a moment of real life. If they're honest, really laid back, cool, and they're generally open to things, then they'll kind of have a surprised or like an epiphany, if you will. But I'm not them. But then they might have that. They might have that epiphany, but then they go right back to believing what they did.
It is easy with the ones who already know stuff like 9/11 and Corona and all the other things, like someone who doesn't buy into the news, doesn't buy into everything they have been taught and so forth, right? These people are like even more easier to comprehend what reality depicts, right? That's the people I talk about. Like, these people are sit on the table and they were actually, the funny thing is, coincidentally, there was one more guy on the table. He said, I just began researching flat Earth. Like, he actually, this guy has like, he's like a wine maker, he has like a lot of, like I live in a wine region, and he literally works every day, right? Like all the time for his wine. But still he said me, still finds time, after his day, like in the late afternoon, to just look at some flat Earth stuff. And he was already totally into it, He was actually helping me in a conversation with the other people. And, some people just laughed because of insecurity, but no one was really like, no, you're stupid, or no, blah, 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 this, blah, 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 that, Some actually just said, oh, yeah, that's interesting, So I'm just happy that in reality, we don't have to deal with people like we do here in Discord, That's a good thing.
Well, you should record these interactions. That would give you some good content for a YouTube channel.
Yeah, so I've done all that left lane. I just don't want to be that kind of guy because, again, going out and getting confrontation, asking people in the regular day, it's almost like you're a pest in a way, right? So I did it in the beginning of Flat Earth. It's an unpleasant feeling. I got enough information out of it to know that even optometrists don't even know of the convergence, the optical illusion of the vanishing point. They haven't thought about it before. I've already done that. I've asked pilots how they fly the plane. Do they navigate it flat Earth? I've got 3 pilots on a camera claiming the Earth's flat and operate when you pragmatically operate over it. So I've done all that stuff already, left lane. I don't need the clicks or the likes. I don't give a shit to have a YouTube video and have followers. I don't give any shit about any of that stuff.
Hey, Data, do you have the names and the employer names of those pilots so that Zanuck can get them fired?
Yeah, right. Yeah. No, I took the videos down because I did have the one guy's face on camera, and I edited it so they didn't have. I just didn't put their faces up because I knew that People, when they just ask face value that they're honest and genuine, they have no no mission here, no agenda. They're just straight up tell you exactly what flat earthers think and see for reality. But even though they mention that, still inside their mind, they still think it's a sphere. So this is what I find really interesting is they will agree along the lines with what flat earthers essentially agree with, but then when it pushed further, they still think there's a sphere. So I find that really intriguing.
Or once
So
they
you
find
did have
out,
the evidence.
once they find out about flat Earth, and then they hear what flat earthers say, they then update and start just perpetually being dishonest about the basic stuff, and they'll just deny anything that comes from a flat Earth. The reason that all the Globers fight me so hard on the fact that what they're calling gravity is actually electromagnetic is because they've heard me extend it out to how it debunks their model, right? And how electromagnetism couldn't properly describe or explain the planetary orbits at immense distances through a vacuum with these immense masses and blah, blah, blah. They've heard me use it to take away their paradigm. So therefore, in their mind, they must deny that gravity is electromagnetic until they die. To such an extent that I've dropped top level people in their paradigm now coming out in the last year saying the exact things I say, saying that light is actually an excitation
I need
or
evidence with
oscillation
it.
of. Hey, buddy, I'm almost done. So I've now dropped top tier people in their own paradigm that know way more about it than these people in here who still think mass attracts mass, saying the exact things that I say, that light is actually the oscillation or excitation of the background 0-point field that permeates all of space, which I've told you that ether is light's just ether excited and illuminated. And then he says that gravity is electromagnetic in nature. I told you guys that. Whenever he says that you can naturally see this by looking at Coulomb's law and the law of gravitation, I told you guys that. Whenever he says that gravity is not a universal constant, I told you guys that. And you guys have to now deny it to such an extent where all the Globers were saying this guy was made up. He didn't really exist. He's a wackadoo. His credentials must be fake. That's not a good journal. He doesn't have any legitimate published papers. And then, of course, you look into it. The dude's incredibly credentialed, been published by Cornell University and Harvard University. He's got a PhD in atomic physics, and he's the leader of all these different institutes and boards. So all that to say, it's just because flat earthers say something and they think it may give them their point some credibility, they're going to fight it until the death. That's all there. That's just it. So it is cognus, Leftland. It's the definition of cognus.
No, here's the thing with it, and I'll make the statement. You can argue this for if you don't come up with a way to demonstrate and objectively demonstrate, prove, show here's what I'm going to do that, show cause and effect type relationships and how it's working with the measurements and whatnot. You're 10 years from now, you're going to be just saying the same thing without making progress.
Yeah, but you've never done anything, right? That's the ironic.
I don't know. That's just it's irregardless. I'm not claiming to have done anything. Which
no, you're claiming to know what gravity is. So basically, you're saying if I comment on it, now this is what's so funny. If you say you empirically prove it with experiment, if you took that same standard and applied it to what you believe, then it would fall flat on its face. Because if I now go do the Cavendish and I show that once I manipulate electrostatics, it makes the Cavendish move different magnitudes, you'll say, "Oh, that doesn't count." And whenever I change something, you would say it doesn't count. And when I change something's weight, you will say that it doesn't matter. And when I make something float on the Level documentary, when Sean gets here in a couple of days and I literally make things float, you'll say, "Oh, that doesn't count." So I already have demonstrated it. That's the point.
Yeah. I mean, if you did take the Cavendish and you did input electrostatics, it would have an effect, and it would be due to the input of the electrostatics.
But are you willing
but
to?
It was already there.
In the first part of that.
I'm saying it's already there. Wait. Let me say one more thing. Leftland, what if I don't do anything to it and I see it moving, okay? And then I ground it and it stops moving as much. What does that prove?
There might have been electrostatics involved in it, and you isolated that variable, and now you're left with mass attracting mass.
No, see what I'm saying? You just see what you did? So first,
that's
when I
logical.
said no, it's not. First, what I said was that I would introduce electrostatics and make it move more, and you said you just added it. And I said, okay, well, then what if I don't do anything to it, and then I ground it, and it stops moving as much? Then you say, oh, that actually proves mass attracting mass too. Do you not see what you do? Do you not see what
you don't have to use? You don't have to use Cavendish to prove electrostatics. You just rub your head on a balloon and stick it to the wall. I mean, that's all you got to do to prove electrostatics.
No, but you're claiming Cavendish proves mass attracting mass, even though that's the dumbed down phrase taught to 7-year-olds. It's not even what your model claims anymore. Okay,
It's still
and
utilized. They still use it.
no. And if I explain to you, well, my question is though, the reason I brought up Cavendish is because you said that I need to actually prove it. I need to do an experiment to prove it. So what experiment do you have to prove gravity?
Oh, we got Cavendish is done in classrooms all around the world every day in physics classes. And then you get into Einstein. I don't know enough about Einstein to speak to any proofs with regard to that. And I say proofs colloquially, right? But
So you got nothing. So you only have Cavendish. And so if I do, that's why I brought up Cavendish, because that's all you guys have. And if I bring up Cavendish and I show that I can make it move more when I introduce electrostatic, I can add nothing to it and it's moving, and then I ground it and then it stops moving as much. That shows you that what's moving it is electrostatics. And when I ground it, you don't eliminate electrostatics. In fact, what it's doing is taking the surface charge that's constantly in flux and constantly accumulating and discharging it into the ground. It's constantly dissipating into the ground because there's constantly accumulation of charge. It's constantly in flux. There is no getting rid of it. And so whenever you dissipate it into the ground, it moves less. That shows that the actual cause of the effect is electrostatics. You're claiming there's something else there and you haven't supported it at all.
Where would the electrostatics be coming from? Once you ground it, you bleed off the electrostatics into the ground, and then where would any more electrostatics come from?
Well, why do you think that whenever when we stop grounding it, it becomes electrostatic again? Where does it come from then?
I don't know. I would think
Okay,
you probably have to
air.
do something to it to make it good.
It comes from the surrounding medium.
Yeah, wind maybe could do it. I don't know.
No, not wind, just air. You could be in a shed. You could be in a vacuum chamber and it would do it, because it's been proven there's electromagnetic fluctuation inside of a vacuum. So the point you're asking, like, it just bleeds off. So where would it come from? Well, if I stop grounding it, all of a sudden it becomes electrostatic again. Just like whenever I used to have to fuel planes, I had to ground them. But if it wasn't grounded, we could blow up, right? That was the whole point. Like, as soon as I removed the ground, I was in danger, right? There's nothing. It doesn't just eternally disappear. You have to keep it grounded to keep it at a minimum, because it's constantly accumulating. There's constant electrostatic transference and inductance from the medium. And even within the molecules that hold the matter together and on the surface, it's constantly in flux. It's never at zero. So this is the point. The point is that variable can be scientifically proven, and we can show a direct relationship with the effect of it moving. And you guys claim that doesn't have anything to do with it. It's actually something that you can't isolate, can't manipulate, and can't prove.
Well, you see, you can show, and that's what you need. That's what I'm saying. That's my point. You need to show the work.
Okay, but do you not see the double standard, though? That's what I'm trying to point out to you, man.
Well, if these things you say are indeed true, then yes, we got a problem. Houston, we got a problem.
And do you actually think, Left Lane, like, I know you're smart in this, do you actually think that this guy with the PhD in atomic physics and the lead institute of the Nuclear Physics Institute, the lead guy, the director of this other physics board, do you like masters, bachelors, PhD, quantum physics, atomic physics, nuclear physics? Do you really think that this guy is so stupid that he put forth a theory? He's so ignorant. He put forth a theory about gravity being electromagnetic and actually the law of gravitation being intrinsically tied to Coulomb's law, that he's so ignorant that he couldn't come in here and discuss his theory with some anti-flat earther that says mass attracting mass in Cavendish. You think that is that what you think?
No, he just needs to bring his evidence with him.
Well, he put it in the paper.
No,
right,
well, I mean, he said some things, but I haven't seen any of the experiments or any of that stuff associated with that paper. So
yeah, but you can just look it up. It's something called the Casimir effect. Like, it's like, I guess what he's doing is he's writing the paper for people that he knows that people already know this stuff. When he talks about the fact there's dielectric permittivity and magnetic permeability in a vacuum, he doesn't have to come argue with anti-flat earthers to prove it. Everyone knows it. There's something called the Casimir effect, and we measure electromagnetic fluctuations in a vacuum for decades now. So, like, he doesn't have to put in the paper, here's how you prove there's dielectric permittivity in a vacuum, because everyone knows it. It's only in this room, in this realm, where it's denied. It's your own paradigm knows it, but you guys have revisionist science. You guys make up a new version of science that's tailored to go with the flat earther, which is the whole reason I jumped in to point out that's what's going on with what Dad is talking about. You guys have a revisionist physics that's tailored and engineered specifically to go against the flat earthers.
No, that's not. It's got some theories, and you keep on bringing up things like the Kashmir. These are things, and he even mentioned things specifically talking about things. That's why I use the word quantum level, very, very small levels. Kashmir effect is something that's observed and known about at the very, very smallest levels. You would agree, right? We're not seeing the
The
Kashmir
smallest
effect on the
levels make
larger
up the
scale.
big levels.
If that's what you're saying, and that's the goal for a lot of physicists, to unify these theories. Unfortunately, there's so many concerns. The one that you just mentioned earlier, the fact that it's a natural progression, gravity to follow Coulomb's law. It's not. It's not a natural relationship at all. The reason it's not natural, quite simply, is because Coulomb's law talks about attraction and repulsion. Gravity has never been seen to have a repulsive character.
You know, he addresses that in the paper, so I guess you still haven't
I
read
know,
it.
I've read the paper.
Well, he actually specifically addresses
I think
it.
you're confusing
So
him.
wait, are you
Someone who's
denying
had
within your own paradigm the phenomenon of anti-gravity?
What is anti-gravity?
So you don't even know what it is. So are you
I do
denying
know
dark
what
energy?
do you mean? You know,
You said you do know
ask
what it
me-
is, but you asked
let
me
me
what it
say,
is.
I've proven electrostatics is a cause for things to fall because I can make things float by using you add
No,
forces.
you just said you knew what
that-
anti-gravity is. What
a
is it?
butterfly is okay, we can't talk over each other. Would you say
Well, I mean, if you're gonna talk about the repulsive effect, you have to bring into it the antimatter half of it, because that's where they talk about gravitational repulsion.
Why are you trying to save
is
him? Why are you
between
saving?
matter
Why are
and
you saving?
antimatter.
That's true. That is true.
And you guys are like in a cult, right? So you had to jump in and save Zanuck because Zanuck
No,
tried to act like he knew about it, but then I said, so then what do you know about anti-gravity then? Because that's what's in the paper. He's saying that it's never been shown to have any repulsion. He said it's never been. He said it's never been shown to have any repulsion characteristics, but in the paper it specifically invokes a specific phenomena in your own paradigm that's acknowledged to explain that, and that's why I brought up anti-gravity. And then his response was, "What's anti-gravity?"
No,
And
no.
then he
What do
pretended
you
that
mean?
he knows all
What do you
about it,
mean?
and now
Because
and,
you talk
and
about
now
sorry, but you talk about this in many of your discussions about how something levitates, therefore it disproves gravity. So I assume when you talk about anti-gravity, you're talking about other forces that counteract the force of this attraction we call gravity, or the cause of the bending warping of space-time, something following a geodesic path.
You have to believe that. You have to believe in that.
I don't have to believe anything.
No, you have to believe in that.
No, I don't.
Okay, well then you don't even believe in the heliocentric model. Then you don't even believe in current cosmology. You don't even believe in your current model then.
Why do you say that?
See, again, this is where I have to teach you again, then you're going to pretend you're teaching
what
me.
don't I believe? You can't make a
so
statement.
if you don't believe in anti-gravity and antimatter, you can't believe in your own cosmology.
Antimatter, dark matter, dark energy, all very small sections of our model. They're very, very small. They're things that apply
they're 96%
usually at
of
the
the model.
galactic level. At the local
96.
level, well,
Wrong again.
Just like instantaneity applies to gravity at the local level, instantaneity doesn't apply at the greater size.
You're wrong again. You're wrong again, right? So
why do you
actually,
keep on saying I'm wrong, but you don't
it's
have
not
anything
just-
to back it up?
Yeah,
You
it's
notice
not
that,
just
don't
the galactic level. It's what's called dark energy is observed on the quantum level.
Oh, really?
You didn't know that?
Show me an experiment.
You didn't know?
I don't. No, I didn't know that.
Oh my God, bro.
Oh yeah. So tell me about the Kashmir effect on a large scale. Has there been any
look what you did.
experiments
You see
with
what you
Kashmir
just did?
effect in a vacuum? I have two plates attracting themselves with no air in between, a vacuum that shows an attraction.
Okay, so you see what you did? First, you said that it's only observed on the galactic scale, right? And then I corrected you, and then you switched to say, "Show me the Casimir effect on the large scale," right?
Well, as an
And
example of there's no. Show me dark energy.
But your own cosmology acknowledges that
Give me an example.
there has to be some type of negative pressure or anti-gravity or
Negative
repulsion
pressure
involved within space-time. Your own paradigm acknowledges it because it can't explain the expansion rate being 10 times faster than the prediction of the model and having to go way faster than the speed of light without some other additional energy that basically counteracts gravity that acts as a repulsion. But please keep saying mass attracting mass from 1600 and then pretend you're teaching the flat earther. This is why I said you guys have revisionist science tailored at the flat earther.
Mass attracting mass is what apparently it does. We don't think and cannot even imagine, as Einstein himself or Newton has written, we can't imagine that there's some type of magical force that attracts these masses. Yet we see an attraction. We have an apparent attraction. Later, Einstein then realized that this was not an attraction. This is just objects following a geodesic path.
You just you say some catchphrase that has nothing to do with the specifics of the conversation, but you say it as if you're teaching me. This is you guys are boring at this point.
What does that mean?
Admit you were wrong. Admit you're wrong. Address what I just said about dark energy.
I don't know. I don't know how that personally. I don't know how that would apply to things in the quantum.
Okay, can you acknowledge what I said about dark energy, please?
You said a bunch of things. Just when you ramble on, we can't ever follow this disconjointed flow of words.
Does your paradigm require some type of repulsion?
How does dark energy fit in my paradigm?
Does your paradigm require some type of repulsion characteristic? Yes or no?
At what level?
So just the cosmological level.
At the cosmological level.
Oh, so physics is different on the big level than the small level.
Very different. Yes.
Really? Yeah. So is the big level made of the small level?
Yes.
Oh, so the big scale that's completely comprised of the small scale has nothing to do with the small scale?
No, it's comprised of the small scale, but doesn't have the same characteristics of the small scale. This is like basic logic. Now, if you're going to make a logical fallacy here, and I'll forget the name of that one, but it's a very good one as well. You say that just because something is made up of something that has these particular characteristics, that the overall larger product of the addition of these smaller characteristics should also be attributes larger. That is a logical fallacy in itself.
You're going to talk to me about logical fallacies right now when your entire model is a lological fallacy? Catch up, bro. So, first of all, dark energy has never actually been observed, of course, right? The point is that one of the only things that people have been able to come up with to try to explain dark energy that actually existing is stuff that we've seen on the quantum scale. Can we get it? Do you understand that?
Yes.
Okay, so it is connected to the quantum scale. And when we start looking at the quantum scale, every physicist worth their weight in anything knows that they're going to have to create a theory that can explain the phenomena on the small scale all the way up to the big scale, because the big scale is comprised of the small scale. That's how physics works.
That's the problem. That's the paradox. It's not.
That's your paradox because you're in a religion that doesn't work.
They all desire, they yearn to unify these theories, but they can't. And they don't know why.
Okay, so is there an energy density observed? Is there a background energy density observed on the quantum scale?
Energy density.
Yeah. See, you don't even know any. You don't.
No, I'm trying. Man, I'm repeating your question because I don't know of any energy observed at the quantum scale other than that's in between atoms. The energy that's actually is possessed by in the atomic structures.
Yeah, okay, so you don't know about 90% of modern quantum physics then?
I'm sure you don't either. But no,
there you go.
I'm not a physicist that specializes at the.
So why are you correcting me though?
Because you don't know either.
Yeah, I do. I'm sitting here saying specifics.
What's is now a quantum physicist?
It has nothing to do with that.
Yes, it does.
Do you know what the credentials fallacy? Hey, do you know what the credentials fallacy is? Can you define it?
Yes.
Define it.
Validity and give weight to someone's opinion based on certifications that they have achieved studies.
That's not what the credentials fallacy is.
Yes, it is.
No, it's not.
Yes.
Try again.
You're given argument.
I would say someone is absolutely right just because they have credentials would be a credentials fallacy. However,
no, that's an appeal to authority.
If you're going to cite something that somebody's worked on, it would give them some validity if they were a PhD in their field.
Yeah, okay. Fair enough. But that's called an appeal to authority. So credentials fallacy is different. Credentials fallacy is different. So I'll help you guys out here. Credentials fallacy is when you say someone's argument can't be right because they don't have the proper credentials.
Oh, okay. I don't know. I don't know if I like that or not.
appeal to
Right.
authority was when you appeal
Based
to
on
the
the
wrong
credentials.
authority.
But you were right. But you were
No,
right.
no, that's one version of appeal to authority. If you say that this argument must be true because authority says so, that's an appeal to authority.
Yeah.
All right.
Credential authority is slightly different than authority.
Okay, anyway, moving on. My point is that you are committing a credentials fallacy. It doesn't matter if I'm a quantum physicist. I'm talking about specific evidence that can be verified outside of any piece of paper, okay?
You
And
haven't
you're
done the experiments. You haven't done any of these. You're reading them and regret. Like that guy, he might not even be real. We don't even know. You don't know.
Dude, see, and now Zanuck is full-blown conspiracy theorist, where a guy that's been published by Cornell University and Harvard University and has his degrees that you can go check from all these different universities, and the guy that's in charge of the Nuclear Institute of Physics, the guy that's on another physics board, and the masters at all these different universities he actually doesn't exist.
He's not
Actually, his credentials that come from all these different universities.
He doesn't have any credentials in.
Yeah, what he doesn't have any credentials. He specifically has a degree in quantum physics, Zanuck.
That's not astrophysics.
Dude, he's talking
claims about gravitational equivalence to Coulomb's laws at the galactic scale, unifying gravity and electromagnetic principles. This isn't going to be done by him. He has no experience in that area, especially since he's not even a part of it.
But you know what you're talking about, though. So in reality, what he's saying is that the only feasible way forward is that we're going to have some type of unification of the forces. You disagree?
Surely they've been talking about bridging the small and the big for ages. So what field of science is that?
Yeah, exactly.
Well, both, right? If you're going to bridge the gaps, you better talk to both sides and find a common ground, because right now, astrophysicists and quantum physicists don't agree on very much.
Okay. So obviously something is going wrong here then, huh?
Why is it? No, that's a logical fallacy in itself.
Oh my God, dude. So and this is what you just don't seem to understand. This is what you don't seem to understand.
You find it
buddy, stop.
To extrapolate something small to large. That is absolutely incorrect logic.
Okay, so you don't understand any of this.
This
is why you have to. This is why you have to.
So why? So that's
like. Hey, hold on, Zanuck. Hold on, buddy. You're getting into this thing where all you do is you overtalk people, and you're not allowing them the space to answer the questions that you're asking them. Okay, so chill out, unless you want a freaking warning, because it's ridiculous that you can't allow somebody you're having a conversation with to fully finish their thought. Go ahead, Whitsit.
It was reciprocated, but thank you.
Yeah, so like this is the truth, right? On both the quantum and cosmological scale, there are tons of things that are still currently unanswered, right? And there has to be major updates to the framework. The difference is that quantum is obviously hands-on and experimental. So we're discovering all kinds of evidence, all kinds of experiments are showing us all kinds of phenomena that can actually be verified, replicated, and done over and over and over. Okay, and so when we look at the current cosmological model, the lambda cold dark matter, whatever, right? It's completely off. It doesn't work. There's huge gaps. They need a ton of energy to make the universe expand that wasn't previously predicted in relativity, meaning something has to counter the prediction of gravity in order to explain the current model. Something has to be countering it, repulsion. Okay, and then you have a lack of mass. There has to be some type of substantive quality of like basically matter or mass that's there that would even explain how much gravity is there. So there's too much gravity and there's too much anti-gravity in space for the current model. When we looked at the quantum scale, what we discovered was there actually was energy where it previously was thought not to be. That there is like a energy density inside of a vacuum. That there's some type of background field that permeates space that holds energy. Okay, go ahead.
So you said a lot there. We should have stopped.
You should have to pay me tuition.
Yes, I do agree that the universe is expanding in a much greater way and can be forecasted by the amount of matter and theories we have gravity, depending on warping of space-time. I do agree that most galaxies also have dark matter, things that should be acting like matter to make them spin the way they do, be distributed the way they do. I also agree, and like you said this many times, that 95% of this matter that we know is out there, we can't even see, right? So there's many things that are unanswered. We fill the voids with something we call dark matter. So what? That's our placeholder right now because we don't understand it. But it doesn't mean that we go back to the quantum level and say, well, we see something like the Kashmir effect between these two objects in a vacuum, and there is an attraction or some type of force. We can't explain it, so we're going to call that some type of ether field or something where the energy is electromagnetism or electrostatics is somehow in the actual vacuum. That's a stretch, and that's also a theory. There could be some other principle of gravity that we haven't quite we don't understand. We haven't discovered yet. I don't know. You don't know either, by the way.
Oh, I know that your theory is completely trash. And
one more point though. Sorry, just to go one quick. To take this logical fallacy of something that is small that builds something large, that the large should replicate or be similar to the small is a logical fallacy itself. It's like saying because ants can lift 1,000 times their weight, we should be able to lift 1,000 times their weight.
Not analogous at all.
That's a good point.
And levers.
No, it's not. Are we made of ants, Left Lane? Hey, are we made of ants, Left Lane?
Okay, now you're talking over me. There's reasons that
because you're just monologuing and not being specific at all.
1 sentence. You talked for 5 minutes. I said 1 sentence about.
I was being hyper specific though.
I wasn't. I gave an analogy of ants to people. Why do they lift thousands of times?
Okay, the reason that doesn't work as an analogy is because
for logical reasons. Thank you.
The reason that doesn't work as an analogy is we're not made of a bunch of little ants.
We're all made of cells, similar in size.
Okay, that is, dude. The point is that and just like everything else that's alive, we're alive. But the point is that for you to say, well, ants can lift 100 times. Ants can lift 100 times their weight. Well, if we were comprised of tons of ants or something, like everything that's big is comprised of the small. Everything that's big, dude, please stop. Everything that's comprised is everything as big is comprised of the small. And by the way, quantum isn't just talking about what's on the really small scale. It's talking about what's in the space around it. Okay, it's discovering that there is energy outside the air in the material world, that there is a background energy that would apply everywhere. Do you understand?
We know that energy can flow through a vacuum. That's not in question here. No one's arguing that. You're saying that the actual medium itself contains is energetic, and that's a fallacious argument. Number two, these ants, even if we're built of ants, we wouldn't be able to lift 100 times our weight. That's not how it works because the physics doesn't support that logic. Some things in physics don't scale. Aerodynamics, for example, does scale fairly well, not perfectly, fairly well. Other things don't scale. There's no unification of many theories that you're assuming there should be, just because it's
no. You're so lost. You're so lost. Like you tried to say that we know energy can go through a vacuum. You tried to say we know energy can go through a vacuum as if the energy that we observe in the background in the vacuum is actually just from outside of it and it's going through it. No, dude. Energy density is the background energy observed in a vacuum, void of matter or radiation.
Charge.
Okay?
No charge. Two objects with no charge. That's what you're saying, right?
It's void of matter or radiation. There's not energy radiating through the vacuum from the outside. Okay? That's not what it is.
A theory. That's what's not accepted. Most physicists do not agree to that.
Wait, you're saying that most physicists think that the vacuum doesn't have energy? Wait, time out.
What?
You think that you think most physicists, quantum physicists, don't acknowledge that the vacuum there's background energy? Then you have no idea what you're talking about. You must not know what the Higgs field is. You must not know. Every single quantum physicist effectively says that the energy actually becomes manifest based on the excitations of fields in the background. It's called the Higgs field.
Higgs field is caused by the objects in that environment.
What is the Higgs field in the material world? Is the Higgs field like in the vacuum?
It's in the vacuum, yes.
Okay, so there's something outside of the air that's in the vacuum, and all the energy comes from that?
No, it's coming from whatever's in that environment.
Oh my God. So wait, where does the energy come from?
The boson.
Okay, where does the boson come from?
Matter. Subatomic.
Oh, So it doesn't come from the Higgs field.
Energy.
What's the Higgs field?
Well, isn't that they saw this field of energy, but they didn't see the thing, and then they finally did see the particle that was responsible for the Higgs field?
No, what they're doing is they're seeing quote unquote particles. They're seeing energy pop into existence, quote unquote. So there has to be something that is housing it prior to it becoming manifest.
Energy can manifest itself into matter.
You're trying to cram such an archaic. You're trying to cram this archaic remedial idea onto us as if you're teaching us. You are regurgitating a 7th grade understanding of 1950 physics. Dude,
so
it's so goofy, dude.
This Higgs field's new, right? It's a standard model in particle physics.
Buddy,
I mean, come on.
Buddy, you need to pay attention, okay? So we know that there's a background energy.
Talk about the generation of mass from particles.
There's a background energy density in a vacuum.
It's a yes or no question.
I didn't hear you. There was a motorcycle.
Does the Higgs field describe a mechanism that explains how subatomic particles become mass?
Yeah, how they get their mass. That's right.
No, how they can become mass.
Where they get their mass from? Yeah. So where does that exist?
Near matter.
Yeah. Basically, what Xanix's trying to do is act like he's teaching the room physics by claiming that the vacuum is. Please stop interrupting me every single time I speak, dude. Xanix's trying to pretend he's teaching the room physics by explaining to us that the vacuum is actually Newtonian emptiness. What a joke. You are literally pretending to teach us by saying the most archaic, outdated, incompetent, ignorant take on the vacuum. Please teach us more.
Okay, so is the boson particle, is that real? Is it something they actually know about? In the last 20, 30 years, have they discovered that this existence of this mass-giving field was confirmed?
Well, they observed the phenomena and they have a theory as to where it comes from.
They confirmed it. It was discovered.
They did not confirm it.
CERN, CERN, experiments at CERN did discover it. I mean, it did confirm it.
Even if that was true, that would only make my point stronger. That's what you don't get. It's so funny. You're goofy, dude. You're laughing. Hey, is a vacuum empty? Is a vacuum empty? Is a vacuum empty? Is a vacuum empty? Is a vacuum empty?
Yes.
See, so you are like decades behind physics, and you're in here trying to pretend that you're teaching me, dude.
Look, a vacuum can have fields in it. We know that vacuums can be vacuum just means no pressure. Absolute vacuum is no pressure. There can be fields that are in vacuum. No problem whatsoever. I can totally agree with you. There can be fields inside of a vacuum. Where do those fields come from? What generates them? These subatomic particles are known and have been proven and show strong evidence to produce these characteristics of mass.
This is what's so funny too. Jason's in here pretending that he's teaching too. Let's read what Jason. LOL, the fields exist in an internal space within our regular space. Wow. That's so profound and intelligent and competent. It exists in an internal space within our regular space, related by a double angle relationship. Wow. That's the dumbest. Dude, here's the facts, okay?
Is that like a dream within a dream?
We know that there's a background energy density within quantum physics. They've already acknowledged it. And in fact, they're trying to use this phenomena to see if they can explain the dark energy problem on the cosmological scale. And then you get into things like anti-gravity, antimatter, right? And so there has to be some type of repulsion mechanism related to gravity, right?
Why?
Some type of negative pressure.
No, not right.
Because of your own cosmological problems.
It's not because of those cosmological understanding or laws. No. We don't know what is causing these galaxies to form where they do and have the spacing and the spin that they do. We need more mass to do, from what we understand what mass does and how gravity works, we need more mass. So we think there's a dark matter of present that can do this. And most of that dark matter is in the outer 95% of the area of a galaxy. You can say, oh, you're just confused, you're making shit. Fine. They're making shit up. That's what they need to make those things do. We don't know what it is. What's it? And neither do you.
How about I just read this so I can school you with your own belief? So,
Oh, dude, you
in
can't school
quantum
anybody.
mechanics,
Google. You're a Google searcher.
this isn't Google. In quantum mechanics, the concept of background energy density refers to the energy that exists in a vacuum or empty space, even in the absence of any matter or radiation. This energy is sometimes referred to as a vacuum energy or zero-point energy. The existence of vacuum energy was first predicted by quantum mechanics in the 1920s. So you're just, I don't know, a century behind. And it has been confirmed through a number of experimental observations. One of the most famous experiments that demonstrated the existence of vacuum energy is the Casimir effect. The Casimir effect is a quantum mechanical phenomenon that arises when two parallel metal plates are placed very close together in a vacuum. According to quantum mechanics, the vacuum between the plates contains virtual particles that are constantly popping in and out of existence. When the plates are placed close together, some of these virtual particles are unable to fit between the plates. And as a result, there is a slightly lower energy density between the plates than outside them. This difference in energy density creates a force that pushes the plates towards each other. The Casimir effect has been observed and measured in numerous experiments, providing strong evidence for the existence of vacuum energy. Other experiments such as measurements of the Lamb shift and atomic spectra also support the idea of vacuum energy. The existence of vacuum energy has important implications for cosmology, as it is thought to be responsible for the accelerated expansion of the universe. However, the actual amount of vacuum energy predicted by quantum mechanics is many orders of magnitude larger than what is observed, which is known as the cosmological constant problem. This remains an open question in physics and is an active area of research.
Are you reading from Mice? Is this Mice's paper?
What? No.
Is that Mice? Who are you reading that from? Is that Mice's paper?
Doesn't matter. Hey, respond to what we just said. Respond to what we just said.
That's his opinion. That's his idea and theory about how we can possibly unify.
That's not him. That's not him. You said that you read that paper, so you obviously haven't.
Well, there's three papers I read. I don't remember. It was very long. I don't remember. The paragraph sound familiar? It sounds like his writing.
It was very long. It was yesterday.
No, I read 3 of them, but I'm saying what you read to me sounds like it was in that paper.
No, it doesn't. Not at all. Not how he writes at all. Not even close.
So it wasn't him.
Wait, can you address any of the actual stuff said? You're saying it's just an opinion. It's all wrong. Is that your rebuttal?
When they can judge whether it's all wrong or not. It's a theory. You said we already talked about what the Casimir effect. We talked about these particles. We talked about the fact that you said that it was a repulsion that attracts these two plates, which make a lot of sense, but maybe you misread that. Or did I miss something?
Okay, so I guess you don't have an intelligible response.
It creates a force that pulls the plates together. That's not how I understand the Casimir effect.
Wait, so do you what do you think about particle-antiparticle pairs?
What do I think about it? I don't think.
Yeah. Okay. But please teach us more about how you know I'm wrong.
No, the Casimir effect. Those two plates you mentioned. We're talking about what's there's no charge between them in theory, right? That's the idea, and they're very, very close together. I mean, we're talking about submicron geometries here, and there's actually a force that's attracting these. Right? There's actually a force, but they're not being attracted by gravity. They're attracted by the interaction of these particles that are in that field between them. That's the Casimir effect, and somehow that the field itself makes an attractive force happen between these two plates. I don't know if about it, just saying in general, but I don't know why it had a very, very small. Now to extrapolate that to the galactic scale is kind of silly, because none of these things are in existence or in common with those plates. Just as Coulomb's law is not similar to gravity.
Oh, now you're just going on and on. Okay, shut up.
Forget it.
He's gone.
Okay, so you didn't even answer the question. Yeah, his panic Xanic, man. So, again, we have all kinds of different things within your own paradigm, right? So you guys claim that antimatter is produced with cosmic rays. That's what you guys claim. That's what your paradigm claims. Your paradigm predicts that there's a symmetry in particle-antiparticle pairs, right?
Yes.
You guys claim, your paradigm claims that it predicts that antiparticles have the opposite charge. So you have the positron. Wait,
you know what that means?
You have the electron and the positron, which is like the anti-electron, and it has the opposite charge. So now that's where you get into anti-gravity. What would be the opposite of anti-gravity?
Gravity.
Okay. So what would be the opposite of gravity?
Anti-gravity.
Okay, so what would it do? If it's the opposite of gravity, what would it do?
Well, something works opposite, the opposite direction. The vector would be opposite to
So
gravity.
what would it do? What would it do?
Means you'd have like a negatively charged particle or a negatively charged field. Negatively with a positive charged field have repulsive. Either attraction.
So gravity is positively charged?
Two similar charges will repulse, and a positive and a negative will attract.
Oh, now we're talking about electromagnetism. What the fuck are you doing?
But there are things in electromagnetism where they follow the inverse cube law, whereas gravity always follows the inverse square law. So how do you rectify that?
Hey, you're gonna walk, buddy. You're gonna walk this out through its conclusion. You know,
I was talking. Instantaneity follows gravity. It doesn't follow electromagnetism.
Hey, buddy, listen. Okay. Hey. So I asked you. Are you saying that gravity is a positively charged field?
No, God, no.
Well, you just said that. I said, okay, what's the opposite? I said, what's the opposite of gravity? What's the opposite of gravity? You said anti-gravity. I said, okay, well then what would it do then? And you said do the opposite. I'm like, yeah, what would it do? You said, well, it would be negatively charged. You have gravity and be positively charged. You would have negatively charged. That's what you said. That's what you said.
That'd be a positive. That'd be a positive attraction as well. Be an attraction. A repulsion is where you have two similarly charged particles.
Okay, so what would be the opposite of the effect of gravity? What does gravity do in layman's terms?
Like anti-gravity boots or anti-gravity skateboard, that's just gravity, but then forces are adding to it to counteract gravity. Not that the forces are actually anti-gravity. Hold on, I'm almost done. Not that is anti-gravity.
Now he's an anti-gravity expert.
Oh my God, I can't even finish a sentence.
Because you interrupted me.
It's just working. Okay, go ahead. Take the field.
Yeah, you don't know what you're talking about. So
I do know what I'm talking about. I'm telling you, you just can't get an opposite force and call it anti-gravity and have it related to gravity because it's working against it. That's not how it works.
No, you don't understand it. So I'm going to walk you through it. So calm down. I'm going to walk you through it, but you need to just answer the questions. It's just one word answer. So don't monologue. Okay. So if I see mountains, because you don't seem to know the word I'm looking for. I'm like, what does gravity do? What's the opposite of it? What does it do? You can't seem to answer.
Attraction.
Oh, there you go. Attraction. So what's the opposite of that?
Attraction, yes.
What's the opposite?
And Coulomb's law involves attraction and repulsive, which is not a characteristic.
What's the opposite of attraction?
Repulsion.
Okay, so gravity is attraction. So what would anti-gravity be?
It'd be repulsion. Play your game.
Check him out. You're getting there.
That's pretty silly. And you're saying what is the opposite of gravity? Will it be repulsion? Is there such a thing? No. There's no anti-gravity. Gravity works.
Do you know how they? Good.
Show me an example of anti-gravity. A butterfly flying, an airplane flying.
Wait, I don't believe it. You do realize that I don't actually believe in your paradigm. I'm pointing out that your paradigm necessitates this, and you don't.
Explain.
No, I know your paradigm is dumb and wrong.
Accelerate and be in free fall.
There you go. See what you did? You just immediately divert away to where you think that you're desperately trying to find some situation where you can pretend to have the upper hand. That's all you're doing.
I do have the upper hand because I have the entire world and hundreds of years of physics behind me. You have nothing but a couple of Google searches and a couple of outlying scientists published in suspect sources.
Okay, so that's a cool story.
So that has more validity than all the scientists in the world.
Do you believe in antimatter? No, I'm invoking your scientists, and you're arguing against them.
I do believe in antimatter. Yes.
Okay, so you believe in antimatter.
Mm-hmm.
So we have electrons, and then we have positrons, right?
Okay.
Okay, we have particles and antiparticle pairs in your paradigm, right? We have matter and antimatter in your paradigm, right?
So you're saying antimatter will have repulsive characteristics? What you're saying?
No, hey, buddy, chill out, buddy. Stop getting so. So we have gravity. So why would gravity not have the reciprocation as well?
Because you're confusing Newtonian and Einsteinian characteristics of gravity. So how do you have a geodesic that follows a
would be your confusion?
the geodesic? Not you're saying basically not following the geodesic by antimatter. That's not what they mean when talking about antimatter. They don't mean that it suddenly has it's inversely warping space-time. It makes time go backward. Time can't go backward.
No, see, you're just all over the place.
You're using
hey, buddy. When you don't comprehend your own paradigm, don't pretend you're going to teach me about how I misunderstand what you're ignorant about. That's so stupid and see-through. Okay, so I'm pointing out that you have actual necessitations within your own paradigm that you're sitting here arguing against from this archaic position. You don't seem to understand it, right?
Archaic.
That's your problem.
How many physicists in the world
because he hasn't had his firmware
understand
update yet.
or think that way? You are, what you've read by a couple outliers. The definition of outlier is not that many of them, right? So we know that these people are thinking outside the box, trying to figure something out, but nobody thinks it makes any sense. They read it, it's interesting, but no, there's no experimentation that can back up the things that they are claiming, and that's the point about science. You make these theories, and then you try to do some tests using your archaic scientific methodology and see if you can give some inkling of hope that maybe they're onto something. But right now, this unification is far outside of our reach.
You've got that backwards. You don't do the experimentation after the theory. The theory comes from the experimentation.
The hypothesis.
No.
The theories.
Now you have to retrace your words. I'm just correcting you, and you have to say no.
No, you can have a theory without the experiment. It just doesn't have any validity.
No, but
you mean your
theory? My theory is that there is antimatter creating anti-gravity. Okay, there's a theory. What's the hypothesis? Then you start talking about the detailed story about what you're talking about. Then you start doing experimentation to back it. Then that can validate your theory.
You're not understanding
don't get too semantical about your criticism of what I just said.
Well, why don't you pay attention to what you say then?
I do pay attention. I can't help it if you interpret things incorrectly, take things out of context.
Who's interpreting anything? If you're going to use a word, then use it correctly.
I said theory. You can make a theory without having any hypothesis.
No, you're trying to interchange the word theory and hypothesis and try and get away with it.
I'm not at all. Why would you say it? Why you mind?
You are at all. That's exactly what you just did. You did that.
No, I said you can have a theory. I can have a theory. Everything's fake. God is real. My theory is that there's God and everything's under God. Now I can develop a hypothesis.
Theory. That's just a statement.
Okay, fuck you. You're interrupting bastard.
Okay, bye then. What kind of a childish response is that?
Dude, you do it every time. It just takes Geo to stop you so I can talk. I'm not going to interact with you if you're going to be this obnoxious.
I do anything all the time? I'm the one who's trying to get you to address what I'm saying while you speak through me.
If I start talking, you're going to jump in and start talking over. If you don't, I'll be very surprised.
You still haven't
See, like you're doing right now. That's why I can't deal with you.
I'm surprised we're having to talk about what a hypothesis and a theory is.
I'm surprised that you guys don't even understand that your own paradigm is frantically trying to shift around and figure out what's going on. You guys are still talking about 1950 archaic 5-year-old understandings of it and pretending you're teaching us.
I can answer that, Witsit. Why do you think you have to have an opposite to every notion that they bring up? Because it equates to nothing. That way, what they brought up doesn't have any validity or any significance because they have negative. When you put that,
why do you think?
I'm not talking to you. Stop being a hypocrite. So, Witsit, when you put that just in basic equations, when you put one on the other side, they cancel each other out. That's why they do this. It's blatant to the people who can comprehend what they're doing. But that's why they have the electron and the anti-electron.
I think it's a legitimate question that Witsit asked, where you have electrical charge, why positive and negative attract, positive one thing, negative the other. And why is there, if there's a gravitational attraction, why is there not a repulsion? That's a good question, but I don't know. We haven't seen it.
Well, this is what's so crazy, actually. You kind of have seen it, right? You have seen it in your cosmology. You've seen it because there's an accelerative expansion going out, overcoming gravity at an incredible speed, faster than the speed of light. According to you, there's gravity all throughout space. And when they look out in space, they see that the universe is actually expanding faster than the speed of light, overcoming gravity, moving out away from it. So that's my whole point. That's what I'm trying to like. That's why your paradigm's trying to tie quantum with the cosmology, and they're trying to use this this energy density to try to integrate it into dark energy.
But do you think about things deeply? Like we talked about the Kashmir effect. You know how big a micron is, right? We're talking about micron, like these are geometries and chips. And plates that you mentioned, these plates are 1 micron apart. And they say normally you'd have a gravitational attraction, but we all know that the gravitational effects at these scales are immeasurable, that aren't a factor. Yet there is an attractive force. And so now they're talking about what this field between them. So if you logically look at what physics has discovered and analyzed to date, it makes a lot of sense. You're going one step further, actually many steps, saying, no, it's not this Kashmir effect. It's something completely different. It's antimatter, anti-gravity. I mean, I don't know what you're talking about, actually. Either do I know what these other scientists and physicists are talking about.
What did you just say? What's the meaning? What are we supposed to take from what you just said?
That we understand that these objects have some type of particle interaction, which manifests itself in a attraction where there shouldn't be an attraction, because we know the gravitational effects, mass that small, plus all the other overwhelming force of gravity and bending warping of space-time won't affect these two plates that are that close. Yet we do measure a slight force, and we think it's because of certain interactions of the particles between them. Not
Wait,
that
do you know what mass charge? Do you know what mass charge equivalence is?
Generally, why don't you tell me?
Oh, let's hear it. What is it?
I don't
Just
remember.
Say no. Just say no. It's okay. Okay.
General. I said no. It means generally. Mass charge
no,
equivalent. Yes, you have certain particles. All these particles. This is what we talked about this earlier. That these can actually be given properties of mass in the presence of a Higgs field. It will actually turn these particles into massive.
No.
Oh no.
No.
Okay.
Mass charge equivalence. It's kind of in the name. Okay. So anyway, it's about the mass of a particle being related to its charge and magnetic moment. Okay, and specifically, its magnetic moment in the electromagnetic quantum vacuum, right? Which is the ground state of the electromagnetic fields. The ground state of the EM field, right? The quantum vacuum, the electromagnetic quantum vacuum. And there's a magnetic moment.
Nice's paper.
I'm not quoting his paper. Listen, man.
This is.
Do you think that he's the only one that acknowledges the phenomena of the ground state of the vacuum?
No,
so can you stop?
I didn't say that.
The mass charge equivalence is the idea that mass is not like it's not like a fundamental property of the particle itself, but like it's
a mass equivalent. It gives it. It's kilograms.
Buddy. But that mass is actually just comes from the interaction of the particle with the EM field itself.
Yes,
mass charge equivalence.
That given particle. As we said, I said in the beginning, you're saying it again. So what?
Yeah, okay, but this is what's so funny, dude. Like I've been telling you guys for years now. I've been telling you guys for years now. I've been telling you guys for years now that you're like, why don't things fall at different rates? And you keep on bringing up mass, and I'm like, what? I'm like, how do you quantify mass anyway? You have your charge to mass ratio. You just say resistance to acceleration, which is a property. That's not a definition. And I'm like, dude, mass. The reason that things fall, everything's intrinsically electrostatic. Time out. I've been saying for years.
We can't follow. We can't talk.
I'm almost done. I've been saying for years. I've been saying for years to you guys in response to your stupid questions, acting like you're debunking my electrostatic gravity. And I've explained what, dude, density, mass, and weight are all intrinsically electrostatic. It's all based on charge. I've been telling you there's a mass charge equivalence.
No. You can't have the instantaneity of gravity weighted to Coulomb's law or electromagnetic attraction or electrostatics. It doesn't work because it's not instant. It's instant with fictitious forces. It's not instant with charges. You can protect it. You can actually change the charges. And like you said, if you reverse the charges, it should levitate, and it doesn't.
All right, here's the main point.
You get
Okay, you
objects
don't know
that
what
are
you're talking
paramagnetic.
about. No, you don't know what you're talking about.
It's
But
almost
here's I
impossible.
want to make the main point here. This is the main point. I've been explaining to you guys that like gravity is actually electromagnetic, right? And that your side is going to have to attempt to unify the four fundamental forces: the weak nuclear force, the strong nuclear force, the electromagnetic force, and gravitation. They're going to have to unify it all under electromagnetism, right? They're going to have to actually unify all these forces. And they're going to end up acknowledging that gravity is electromagnetic, but they're going to have to find a way to be able to translate data over to the cosmos to explain the orbits, because it's going to be a serious problem for them. They're going to have to change the medium, change the distributions and the masses and all kinds of things. But it's going to be the only way that you can ever make a progress, or you're going to sit here with your dark matter and dark energy problem for another 100 years. Okay, and I've been explaining to you that actually
matter. It'll sound more official
because you'll just keep interrupting me if I don't say it all.
I'm letting you talk. You're just going forever, even though you're talking fast.
Because I'm actually talking about something profound that's new, talking about the actual issues, and you're not. And I'm gonna try to make the bigger. I've been trying to tell you guys, right, that you actually have like that gravity is actually intrinsically electric, and that you have like this mass charge equivalence, and that weight is nothing more than a product of that relationship. And you guys have mocked me and scoffed at me, and I'm so stupid. I'm so stupid that you can just use like a 5-year-old retort about things should flow, and that's how easy it is to debunk me on just some stupid flat earth. And the truth is, there are tons of different physicists with all kinds of credentials that have been studying this for decades that you guys would normally appeal to the authority of, that say the exact same things. So basically, in summary, what you guys are saying is that those physicists that experiment with it for decades, that know all about your paradigm and are desperately trying to fix the holes in it, if they came in here, Left Lane would slam dunk on them with a 1-sentence remark about how things should float. You guys are so exposed, dude. It's such a joke.
Exposed. Okay, I keep on bringing this thing up. You keep on hand waving it. I don't know if it ever sunk in. We can't see things accelerate, which we know is, of course, whether they be electromagnetic or not. But when they are falling, there are no forces acting. You can measure; they can be measurable. No forces acting on these objects when they were in free fall. If you make something, force something to accelerate at 9.8 meters per second squared to the Earth, it will be in free fall. There'll be no forces acting on it. But you're forcing it to accelerate. That's a paradox that your electromagnetism or electrostatics is not going to be able to rectify.
There is no paradox. You just assert that every time, but there is no paradox.
Very helpful.
That's what you do. You just say the same. You don't respond to anything the other guy said. Nothing you said had anything to do with the end, or the middle, or the beginning of its dialogue.
It will be in free fall. That is a paradox, and it doesn't follow in any way, shape, or form electromagnetism.
Do you have Elijah turned down, Zanuck? Hold on, Elijah. Do you have Elisha turned down, Zanuck, or do you intentionally pause and wait for him to start to speak to then speak over him?
Yeah, he was quiet. I'll turn him up a little.
Yeah, he's coming in kind of low though.
Perhaps, but the point is, Zanuck, why don't you relate what you just said to what Whitsitt said, rather than just asserting something for no other reason than because you want to speak?
That is a good point. Zanuck tends to want to interject every time someone speaks.
Because it would be fine if he actually related any of his dialogue in response to what the other person said. Because then, even if he says a bunch of stupid stuff, at least, or even breaking the rules kind of stuff, at least it's a continuous conversation with natural flow. If he's not going to even do that, why do you think people interrupt you? So perhaps, if you can hear me now, why don't you go back, remember, or ask Whitsitt to repeat, and actually respond in kind?
I did. So we talked about the mass charge ratio.
That's exactly the point. You can't even acknowledge.
I can't even answer you because if I start talking immediately. Thanks for
actually, we don't want you to respond, right? Because instead of picking out a term that you're going to pretend to teach us about, like, oh, like a basic understanding of what you think mass charge ratio is, so you're going to monologue, act like you're teaching it. No, I want you to acknowledge my actual point, okay? And Lefty, I'm not trying to pick on you. I'm just making a point, okay? I'm just using you as an example because you do this to me a lot. Basically, according to the narrative that you guys push, right? All the stuff that I've been saying about gravity, right, is so easily debunked. Every single flat globe earther in here, from bottom to the top, name them all. Name them all. NASA page, Chill, Lel, Kosho, Bacon, Left Lane, Xanic, all of them. Every Slickwid, the random anonymous text troll chat, every single one of them. Mandalore set,
Make
all
your
of them.
point.
Right? Listen. No, all of them are so intellectually superior to me that they can just stomp all over my idea of gravity. I'm such a remedial idiot that it's so easy to debunk it. Things would float. Thousands of people regurgitating this from FTFB and MC Tune and ridiculing me, right? But so what that means is if your little narrative that you psychopathic zealots keep on pushing against me for like 4 years now, if it was true, then what you're saying is that if we brought these physicists in here that have been working in the fields and have all kinds of PhDs and they're the heads of all kinds of nuclear physics institutes and stuff like that, drowning in credentials, revered in your paradigm, if we brought them in here to propose their theory of gravity that fixes
Get to the
problems
point, for fuck's sake.
No, you hate when I build it up and make the point like this.
No, you don't.
So
You
shut
said
up.
all the
I'm
flat
making
earthers.
my
Then you have to name
Zenix,
every globe.
Stop interrupting me. If I brought these physicists in here that have to explain their theory of gravity that they've been working on for years with tons of experiments and observations, tons of understandings of all the specifics. If I brought them in here to explain their theory of gravity to try to fix the problems that the current understanding of gravity automatically has, and everyone knows it, you guys are so much smarter and more informed about gravity than them that you could mock them, scoff at them, and ridicule them, expose and refute their entire concept of gravity with one stupid sentence of, well, why wouldn't things float if I change the charge? Is that what you think?
I've made a couple of simple observations of your ideas, why they're incorrect, giving you the tools you need to answer the questions you have, but you hand wave it and turn the other way. All I'm saying to you is to look at some of these paradoxes, look at some of the characteristics we do know of gravity, and understand our model, the theory, and see if it fits this electrostatic, electrodynamic, electromagnetic idea that you've conjured up over the past few years. It doesn't. It has holes bigger than the fucking window I'm looking at the fucking hailstorm.
Okay, so you can't answer the question. So the question is if the way you guys have been treating me about my gravity ideas this entire time are it's been so easily debunked that like someone can just jump off me and say, why don't things float if you change the charge? You know, like a caveman with their little clipboard. But yeah, exactly. So then what you're saying is if I bring these physicists in here, just like Jace is so arrogantly talking about it, 100% the physicist that wrote this paper would just absolutely destroy Jace in a debate about it.
It's not his field, by the way.
Thoroughly embarrass him about it. But look how cocky and arrogant and derogatory he is in the chat. And this is my point. My point is that do you think that if that physicist came in here and explained his theory of gravity being electromagnetic in nature, that every single anti-flat earther in here could just completely expose how stupid he was with one sentence of exactly.
Not at all. No. I'm saying we could do it because we could stay at the fundamental level. He's got a stretch going there. I sent that paper. Remember I told you last night I was going my and I sent him the paper last night. In fact, I sent to his father also.
Actually, you lied about it yesterday and said that he had already read it yesterday. So thank you for admitting
he read one of them. I said the other article and everything that supported in his because he wanted to know who is this guy. So I sent the qualifications, all from France. He's got these journals he's published in, and all these reference sites that are basically a social media for physicists. By the way, they're not very credible, but not trying to poison the well or anything.
Dude, he's been published at Cornell University.
Hold on. Let me Journal Physics. Yeah, a lot of things have been published.
Cornell University and Harvard.
Yes, everything that he has his credentials, I sent to him, and I asked
he's
him,
been published by Cornell University.
Hold on. He. Let me finish. You're doing the exact same thing you me of doing. So I'm giving you exactly what I did last time. We talked about. He said that's all bullshit. I'll read it. But why should? Is this guy real? Yeah, he seems like he's credible. But give me the evidence. Give him all the evidence. So now he's got the information. He's gonna respond back to me. Now here's someone that not my field really. He's a particle physicist. It's still not his field. It's a very specific type of physicist that can actually, navigate through all the technology and the math and the physics of this particular idea that you're espousing to know so much about, Whitsitt. This unification of gravity and electromagnetic, electrodynamic theory is not easy, and it's been thought of and talked about by many. In fact, I think even Jace put paper in this done by a real credentialed, known, well-known, legitimate physicist. This guy is a nuclear physicist. He's got a good resume, but this is not his specialty.
He's an atomic and quantum physicist.
Yeah, that's not what we're talking about here. Unification of astrophysics.
Oh, but Jace is an expert in everything, though, and Zendik is an expert in everything.
He's a great generalist. He knows. He studies a lot about things, and so does my nephew. They don't just only do their own shit. When a paper comes across their desk, they read it. It could be about something completely obscure or obtuse. These physicists are like that. They're like sponges. They like to learn. Some know more than others. Some know very little about other fields. Like that woman astrophysicist that didn't know why butterflies flew. She thought it was due to buoyancy. I mean, some of them are brain dead stupid at anything other than it depends on the person, depends on their education, depends on their interest. So what I'm telling you is that I have passed it to who I think is very well-rounded, youthful, then world-renowned in the area of nuclear physics and particle physics. So let's see what he says. This guy, I don't know whether he could be completely right. We don't know. You don't know. You just like it because he uses a lot of fancy terms that looks like gobbledygook, and it kind of matches some of the divergence, electrodynamics, dielectrics that you talk about.
It has nothing to do with that. I don't even fully agree. I don't even fully agree with this theory. So it has nothing to do with that.
Okay.
But the point is that I invoked the paper. I invoked the paper to expose you guys because you want to pretend that I'm stupid because I've actually investigated the depth of a lot of this stuff that's unanswered. And I've used my own brain. Stop interrupting. I've used my own brain to try to piece together the phenomena and make it coherent and unified and explanatory. And you guys are incapable of independent critical assessment. You can only regurgitate remedial understanding of the current consensus. So in order to try to convince yourself that you're superior to me, you mock me, you scoff me for years, how stupid I am that I dare even think I have the audacity to come up with a theory to explain it. And then these people that I find, and by the way, there are dozens of them, and I've only released one of them so far, and you guys have squirmed, tried to discredit them. It's hilarious, right? Hilarious. I got Nobel Prize winning people that I'm about to pull out. Nobel Prize winning physicists, and you guys are going to pretend that just admit that the whole talking point and the narrative pushed by these anti-flat earthers that I'm so retarded for even daring suggest the idea that gravity is electromagnetic in nature, that they're wrong and that they're full of it. Admit
it. They're not saying what you're saying, but they're still wrong as far as I'm concerned. But you're way wrong because the things you're doing are using terms and concepts that are not real, that are made up by Ken Wheeler. You latch onto them like it's freaking the Bible, and it's a religious type of thing. Elijah, do you hear me fucking talking? Elijah,
yeah, I can hear
you. I know you heard me talking. You don't need to jump in. I'm talking to
point.
So I have one thing, Whitsitt. I respect the fact that I love the fact that you're into this. I really do, by the way. I think it's cool that you are so into reading, looking at these theories, trying to understand as much as you can. I think it's very admirable. My question to you, if you're really going to critically think about it, go back, and I don't want to be like a broken record, but give me the explanation of the paradox. Why can something free fall, yet visually watch it accelerate? If you can rectify that and coherently, cohesively, and cogently explain that to me, I would be very impressed. Don't just hand wave it, because it's a real problem.
No, because as soon as I tell you my understanding of it, you're just going to ridicule it because it's outside of your little confined.
I won't. I promise you that.
There's an energy source that's pressing down through this background medium that permeates space. It's pressing down on it. It puts it under stress, and this creates the bias that transfers into the material world in the form of electrostatics. It creates the intrinsic bias.
Can I stop for a second? One second. I would like to do this where you say a couple sentences and I get to kind of give a little bit, like either a question or say, so is that bias? You're saying, so obviously implied by the word bias, you're saying it has directionality and so it's downward?
Yes.
Some type of downward? Okay. And that's because of the potential between the ground and maybe cosmos or this above
Well,
us.
that would actually just be a byproduct of it. It would be the etheric background outside the material world.
Why is it pressing down in other directions? Why is it attracting?
There's energy coming from above the Earth.
But why is it going down? Why does it want to go down?
It's above the Earth. Where else is it going to go if it radiates?
Why couldn't it just go in all directions? Why can't it be scalar?
If it goes in all directions, if it's above the Earth, where's it going to interact with the Earth from?
So the direction that it's facing, the downward direction that it's biased.
If it's just above us, then we're going to get an interaction of the radiated energy down. So it ripples down.
Comes from everywhere?
Well, that's a good question. No, there's a central source of energy.
All right. So okay. So we have this energy that's biased. It's pushing down on us in the form of what? What are there massless particles that are or mass or
what? I don't believe in massless particles. I don't know what that means.
How can something be pushing on something if it's
it's just radiating downward pressure. It's a life-giving force. It's like
an energetic
true coherent force.
So it's like a positron, and we're also positively charged, so it's pushing on us.
What?
Down to the Earth.
Oh, dude, this is what I'm saying. It doesn't really matter, right? Like the idea that things free fall and accelerate, not some type of like slam dunk paradigm that we need space and time to bend and warp. That just makes no sense.
You kind of do. I mean,
how does it orient? I mean, how does it orient?
Definitely, and you hear me trying to get in, didn't you?
Well, yeah, I was trying to get in too. I didn't think we were at the same time.
All right. Well, I was just going to implore a analogy, right? Not a direct analogy, but an analogy that might kind of clear up either where Zanuck has a misunderstanding or illustrate for the greater audience kind of what's taking place. So if you think of a stream or a river flowing, right? And if you have a grate at the end of the stream, that if it was not a grate, it would be like a dam, right? But instead of a dam, we have a very large grate. Now the stream would be representing kind of like this energetic flow. So in Zanuck's example, if we were standing on the grate, right, and our head is facing towards the opposite direction of the flow of the stream, right? We could stand there. There would be this pressure that would keep us attached to the grate, and we could move around left or right. We could even push off of the grate, but we'd be pushed back down by the flow of the stream. Now, Zanuck's free fall example is like going upstream, jumping in the water, and flowing with the stream, being free fall. And then somehow saying, well, how can we have no forces acting on us when we're flowing through this stream? And then when we get to the grate, we have forces. So if you think of this stream as being an energetic flow that comes downward and the grate being the surface of the earth, it's a very similar example as to if you're going with the flow, you're not necessarily experiencing the same forces you would if you're standing in an area that is not moving and the flow is coming around you. Does that make sense?
No. Here's why. You have objects that are being pressed down by this flow, energetic, and you're saying that that's what's causing them to accelerate. So it's putting a force on that object. Either it's interacting physically or maybe just electronically or electrically, magnetically, whatever you're doing. Magnetic interactions we understand very well. And so even in a magnetic interaction, when you have an attraction, if I have a magnetic, say I have two magnets, and I one's hollowed out and I have something inside, a glass marble inside the magnet. And I have these two magnets and I'm holding them apart. You can tell so I can measure it with a spring. And I remove the spring and the magnet goes to attract the other magnet and impact it. Inside that magnet, if I had a window, I can see what's going on. That ball will exhibit a fictitious force. It can be pressed against one side of the ball as it accelerates. We don't see that in reality. Something is dropped off a building. We don't see a fictitious force. We see in free fall, a true free fall experience for that object. That doesn't compare with that idea that this is a magnetic or electrostatic or electromagnetic attraction at all.
Dude, it's a fact that what's called gravity is just electromagnetic in nature. Any person that's not actually moving progressively towards the path of unifying the four fundamental forces under electromagnetism and acknowledging that gravity is actually an expansion and contraction conjugate geometric expression that is electromagnetic in nature, it will never, ever fix the problems in your paradigm. And it still won't, because you're going to have to change the medium of space. You're never going to answer the questions. You're never going to answer the paradoxes of what light is, of what space is, of what anything is, of what quantum mechanics is. Nothing. And that's just a fact. Okay? And you guys can deny it. You can call me stupid. You can just try to pretend that I'm going to rely on the misunderstanding of consensus. And Austin can't be right. He doesn't have a degree. Austin can't be right because he's a flat earther. You can spin it however you want to. What I'm saying is just a fact. And there is a reason I'm so confident in it, because I've seen it. I put the pieces together. I know there's no viable way around it. Sure, you can say I'm overly confident. I don't care. You guys have for 4 years not been able to rebut any of it. It's just a fact. You can't acknowledge it. And you can tell me how I'm wrong, but then I'm like, oh, well, then how do you explain it? And then you got nothing. You got no answers. But that's science. You poo-pooing on someone poo-pooing on someone solving the problem is actually science whenever you say you don't know. Hilarious. And what happens? What happens when I write a paper, right? Because all the Globers are like, why don't you write a paper, get your Nobel Prize? Okay, I'll write a paper and it won't get published anywhere. It won't be accepted anywhere. Not because it's wrong, not because the math doesn't work, not because it doesn't solve the problems, but because I am not in the approved paradigm of physics. I don't have the approved piece of paper that says I'm special. That's it. That's it. So when I write a paper, just like whenever I wrote my paper to the court, not one single Glober had shit to say. You guys mocked me. You still mock me about the court, but no one can rebut my paper. No one can even read my paper and tell me what's wrong with it. No one can rebut my core document. But I'm so stupid. It'll be just like this whenever I write a paper. And that's what I did. No, it just hit me. I'm going to write a paper about what gravity actually is. I'm sure it will take me a handful of weeks, right? And then once I release it, no one will respond with specificity. You guys will all just wait for McToon to say it's stupid.
I will.
Whatever.
And
okay, so I'm automatically doing more for the pursuit of the truth in physics than you guys are. Just the mere fact I'm trying to figure out the answers,
true.
right?
That you know what? All the things you said, Whitsitt, and you've said a lot. That is the truest and most obvious thing so far that you've said.
Yeah. Okay. Look at that.
None of us is progressive.
You guys are relying on flat earthers.
None of right. Well, not really. There's other people that have ideas, and I guess, and like Jace posted, there is a paper written by a renowned physicist that has ideas about the unification of these theories and using real math and real words and real ideas because of his training. I don't believe Mice is equipped, even though he's got some good ideas there. I think he's very much fringe. Now he could be right. I don't know enough about it, and neither do you. But based on what I know about some of the things he said, just at a high level, it seems like there's a lot of inconsistencies.
Why do you comment on it?
The question to you, Whitsitt, is thanks for interrupting. The question to you is, you might come up with your theories.
Use the same as an interruption.
The way I read the paper, I see the inconsistencies. I see things like it's a natural progression from gravity to Coulomb's law relations. No, they're not. These are just statements. They're just statements he's saying because he believes and he has a theory to how things can be unified. And he understands we have cosmological issues, how the universe is expanding greater than the speed of light. All these things that we don't really know. We have ideas, but we don't know. He wants answers, and he thinks we need to break things down, quantum level, understand these other things, and then we'll have our answers. And that may or may not be true. But my point to you is break it down to the simple, like why things in free fall are accelerating. That paradox right there, you should focus on. Until you have an answer. What I'm saying.
You think that you can ask that guy that question?
You see, you're doing it. You're interacting. You don't like what I said, and I challenge you, and you immediately think you should take over.
You're not. My point is that you're acting like you can just ask him that question and it refutes his whole theory. It's so stupid. You guys can only get away with this in this censored paradigm. That's it.
It doesn't even make any sense because it doesn't fall within the definition of what a paradox is.
Do you know that
he
it
asserts
absolutely
it
does?
every
It is.
other day.
Elijah, you don't know what a paradox is. That's
3
fine. I
times a
understand.
day,
You don't know.
sometimes
That
as
is a
many,
paradox. How
sometimes
can
as many
something
times as
accelerate
3
yet be in
times in
free
a
fall?
sentence. What is a paradox, Zanek? Define a paradox.
Paradox when two things that are true can't coexist. That is the definition of a paradox.
Are you sure?
I'm positive. When you have something in free fall with no force
sure?
acting on it, how can it accelerate, which requires a force? That's a paradox by definition. Wake up.
No.
You don't even know what
I
a word.
don't
You
think
don't
you
even
understand.
understand what words mean. I mean, it's just crazy. Why even bother?
No, that's not paradox.
I like where Witzit was going earlier, and now you're making it a shit show. I wanted to hear his theories.
You're
Talk
the one
about
who
it back
keeps
and forth because they're
invoking a
interesting.
word,
But you're
and
just
then
making
when
it
asked to
nonsense. Okay,
define it,
I'm
you
out.
define it
Sorry.
incorrectly. Paradox, a statement that seems to go against common sense, but may still be true. A false statement that at first seems true. A person or a thing having qualities that seem to be opposites. Paradoxical. That's not what you said, and that's not what you're presenting.
I just qualified for the last definition. Things that are true that appear to be opposite. Something accelerating required a force, yet it's in free fall, having no forces acting on it. Stop being an idiot.
Who said?
I'm going to
But
back
who
out.
said it has no
You're
forces
giving me a
acting
headache.
on it?
I have other things I have to do that are more
Zanek.
nonsense.
Zanek, who says, and by what metric are you determining that this thing in freefall has no forces acting on it?
By the definition of the word free fall.
You can't measure any forces on it.
Says who? How would you measure the forces of something in freefall? How would you eliminate any of the quote known forces, let alone the unknown forces that you like to invoke in different conversations? How would you eliminate that? You're trying to prove a null. It doesn't make any sense.
That's why I tried to give the example of the stream, right? So if there's a bobber in the water and it's floating down the stream, what are the forces that are causing it to go downstream, that are acting upon the bobber itself? It's really just sitting in something that is already accelerating.
And I agree with where you're going with this, from the point of view of someone who wants to engage and understand. But even still, is it napalm?
Yeah.
Even still, napalm. How the flip did the thing get in the position in the first place to freefall?
Yeah, that's the thing. It has to be dislodged from where it was initially at what we would consider its equilibrium, or at its rest.
And
right?
then, what is the definition of a force? At least in the Newtonian perspective, or the equation.
I don't know what their proper definition of a force would be. I know that the calculation is mass times
Basic
acceleration.
equation, right? It's force is mass times acceleration.
Right.
So, what is the issue when there is a force, when there is a mass that's accelerating? Then there is a force. They're trying to do. I think Witzit actually mentioned this. I'm not sure if he's gonna.
It's kind of like a double speak, right? Like there's an acceleration without a force.
I haven't finished. Can I
ahead.
just? Yeah. Because I think Witzit mentioned this in his terminology about maybe an hour or two ago, how they're applying noun to a verb. This kind of thing, right? They're trying to. I would like in common parlance or whatever, try and say they're trying to make something real that isn't. It's the result. The force is the result. So their painting is that, there's no forces acting on it, even if that were true, which, I mean, they can't prove that, so okay. But then you have the whole equation satisfied. You have the mass and it's accelerating, so you have a force. What's the big deal? That's why I fight against it. Perhaps I don't need to be so belligerent, but when he keeps asserting paradox, when it doesn't even fall within the definition of paradox, it doesn't explain why they make statements, which is just an assertion in that whole statement of, there's no forces. We've measured it.
The thing about free fall, there's something moving that apparently doesn't have any force on measure. You can't measure a force acting on it.
Because you're looking at it backwards. You're intentionally or unintentionally putting yourself in a wrong perspective to try and justify a point.
You have a mass, it's accelerating. Is that agreed, yes or no?
I would agree, yes.
Okay, so you have a force, by definition. What's the problem?
What is that force?
That's a different question. What's the problem?
Oh, that's a good question. What is that force?
Yeah, I can address that after, but for now, what is the problem with what was just said?
You know, it is a good question. That how would you measure a force acting on something in free fall?
But we can go on there. I'm not trying to obfuscate the point that you're trying to raise.
You accelerate something without a force. Can you guys hear me?
Yeah, I got you.
Can you accelerate something without a force?
I would say
no. I mean, by definition, the acceleration of a mass is a force to begin with. I think that's what Elisha's trying to illustrate or illuminate.
Yes, the equation, the moment you move one needle, assuming one of them remains constant, the mass, the moment one is moved, the other one is moved. That in itself raises some questions about the nature of creation, but that's another discussion, and that's the kind of discussion that Witsit wants to have, which is the whole point. And I know, Napalm, you wanted to respond because I hadn't really finished my point, but that's it. And I think even in your response, Left Lane, there isn't a problem with what I just presented. So why does there have to be a paradox? It doesn't have to be one because there isn't.
Yeah, I have trouble identifying free fall as a paradox.
Is something accelerating in free fall?
Well, it accelerates into it. Well, no, actually.
Okay, something's accelerating in free fall. Hold on, real quick. I only got 2 seconds. If something's accelerating in free fall, and you need a force to have acceleration, how can you say it's not? There's no force acting on it. That doesn't make sense.
No,
in your own paradigm, you have to have a force. You just told me.
I agree.
This is where Isaac Newton was 400 years ago. This is exactly why. This is exactly how he derived the force universal law of gravitation, is by making the assumptions we're making right now, and they were fair assumptions because it perfectly described what that force was, the value of it at least. But it's only our interpretation now that different, than a normal force. Like an inertial force, like I said earlier, I consider it a force, but it's not a force in the same sense as it's not a force in every reference frame in every sense of the word, like we use it otherwise. But otherwise, I mean, we can identify what it was, and like I said, if we try to do that, we would just end up the observed force, the observed acceleration, and use his equations to derive what the force was.
Yeah.
I think the better question would be, okay, well, you have this happening. By what mechanism is it happening? Right. And just to clarify, I think it is a little necessary. It's not the most necessary, but in the case of freefall, unless it starts at freefall, which doesn't really happen, assuming it starts from a static position, it has to accelerate all the way up to freefall first, and then after that, it's not accelerating necessarily. It's just traveling at a constant speed. So again,
dude, we got them, bro. They said there's no forces acting on something free falling. When something's free falling, it's accelerating. In order to have something accelerating, there has to be a force acting on it. You're just double speak.
No, what about in the case of Coriolis? About in the case of centrifugal force? No, it's an honest question. Honest question. In the case of centrifugal acceleration, what's the force?
Oh, so acceleration doesn't require force? That's not an axiom of physics?
No, these are inertial forces. They're fictitious forces. Centrifugal force. How?
Oh, just 2 days ago, Xanax said I was stupid for saying inertial force. He said I was stupid. That doesn't exist.
Yeah, but what does it matter what Xanax says? Come on.
I know. I just think it's funny. It's just funny. They get it's funny. They act like they have a unified front, and they constantly contradict themselves.
Not contradicting ourselves. It's me saying something that Xanax said something different. But we're not the same person. But
Yeah,
regardless,
no, but you
inertial
guys
force is
present it like you have a unified front.
inertial way of saying fictitious force. It's just another. It's a term I use because it's less controversial, but it means the same thing.
Hey, but when we do engineering and we have we have an actual body moving around another body, so we're moving around the fixed central point of the other body, moving around in a circle. Is there a real centrifugal force?
There's a centrifugal force.
Oh, so there's not a centrifugal force on the object that's going to be countering the internal direction of the rotation?
No, it'll experience from that frame. It'll experience a centrifugal force, a centrifugal acceleration, but the actual force that's holding it, or going towards the center, that's a centripetal force. That is a real centripetal force. Is a real force, but
Okay, and that's going towards the center. So what about the
force
force that's countering that?
Well, I mean, it's not that frame. On the outside frame, there's not a centripetal acceleration or centrifugal acceleration. Yeah, but that's not experienced in the outside frame.
Well, this is what you guys have to kind of say this because your paradigm has anomalous physics, like I always say. Here's a paradigm anomalous physics. So you have to say this for orbital mechanics. You have to claim that you don't account for the centrifugal force. So the centrifugal force would exist in your orbital mechanics, but you guys just ignore it.
The centripetal force or centrifugal force?
I think you could be more general.
Which one did you say? Yeah.
What are you talking to me? I'm not.
I didn't hear it. Which one did you say? Which one was the one that we had to ignore? I didn't hear which one you said.
Centrifugal force.
Centripetal or centrifugal? I'm sorry. I'm just like people say it fast and I can't tell which one.
Centrifugal. Centrifugal.
I got you.
The force, it's very simple. If I draw a circle, then I draw a big circle around it. And there's an object going in that big circle around the circle in the center. It's going to be, of course, aimed towards the internal fixed central frame of the smaller circle. As it's moving in a bigger circle around it, it's going to have a force that is countering the direction up to the center. It's going to be going out, away from the circle.
Because it's in equilibrium.
So it's going to be centrifugal force. Like I can draw a picture, but anyway, this is just ignored. This is just ignored in orbital mechanics.
I think there's an easier way to summarize it without necessarily those specific terms. You have in systems of equilibrium, you have that there, right? We witnessed this. You just gave an example, but then for whatever reason, and this is where your question comes in. When you look into the cosmos under their paradigm, the equilibrium isn't there, and they're just like, no, don't worry, it doesn't matter. Everything's just chaotic.
No, I mean, it's I stated before in the outside frame. In the outside frame, the centrifugal force isn't observed as that. It's observed as acceleration and a linear acceleration or a linear velocity. That's why if you stop the centripetal force or the centripetal acceleration, they're not going to fly outward. They fly in a straight line.
When you drop them, do they got to spin?
Huh?
If you drop something, does it have to spin?
I'll drop pictures.
Not really.
So when you drop things, they don't have to spin. So in the space where there's nothing doing anything, like why would anything start spinning anyway? Well, it's dropping.
All right, you guys see that picture right there? Do you see the green arrow?
Yeah.
Okay, this is centrifugal inertial force. Okay. This is what Xanax was stupid for a couple of days ago, saying inertial force, but you know how that goes. So anyway, you have the directional bias towards the center. It's moving around the center, right? So you have the centripetal force, but then you also have the centrifugal force.
No, the inertial forces are not different than a non-inertial force. Inertial force is real. It was the way he was using the word. He was incorrect.
No, when I said inertial force, you said, "What's that? That's dumb."
What
So
do you
anyway,
mean by that?
No, you said that it didn't exist, and so here we are. Look, just be quiet, man. This is how we engineer things in reality. In reality, when we engineer things, in reality, we account for that centrifugal force right there. That's depicted because as it's moving out around the center, it's going to also have an inertial force that causes it to move against the motion towards the center. It's going to move out away from it. It's going to have a slight bias around it. That's actually going to push back and put a load onto the object. It's going to counter the centripetal force. Right. This is reality. This is what happens in reality. It can be tested a million ways. So
a sling. David did this with Goliath. It's not that hard. It's like very basics.
Now, here's what you guys say for orbital mechanics.
We say no equilibrium anymore.
You just deny it. You just completely ignore the centrifugal and inertial force. It's completely ignored.
You know what it must be? There must be some make-believe line that once you leave Earth,
gravity's ignored.
All rules go out the window. All balance is lost. Everything
like literally
in the universe
just ignored.
Yeah, everything in the universe is unbalanced except Earth, is what they're saying.
And in the Glober's mind, they're like, oh, well, whatever. It must work because we know it happens because we have satellites in space. You would never be able to put a satellite in space free falling around the ball if you didn't figure this problem out. So then what they say, because they have a catchphrase, you know how they have a few catchphrases like refraction, gravity, right? They have another catchphrase that they love to say to get out of all the paradoxes and issues within their paradigm. And the catchphrase they use for this one, and it's one of their favorites. It's probably in third place behind refraction and gravity. I would go gravity, refraction. This is third place. Can anyone guess what their attempted get out of jail card is? Their little catchphrase they just say. They think it just solves the problem by just saying this catchphrase.
I don't know.
Conservation.
Reference frame. Reference frame. Yeah. Oh yeah.
Which is just another nod back to relativity, right?
Yeah, but it doesn't even within relativity. I mean, it doesn't even help.
Reference frames,
Yeah, but that's not the reference.
They tried using the reference frame thing when we were going over the train thing.
It's their get out of jail card.
That was a couple of days.
It didn't save them though.
No, you can't do reference time. Time's its own reference.
And you got to admit, it's funny how flat earthers are depicted into the mainstream like we're just like so stupid. We don't understand basics. No, we're pointing out glaring fundamental flaws that defy physics in the foundations of your belief system, including orbital mechanics. Far from stupid when we're pointing out that you're ignoring the physical inevitability of a centrifugal inertial force countering the centripetal force. You don't account for it in your orbital mechanics. That's not stupid.
That doesn't. I think it needs to be made clear. Like I said, the centrifugal force doesn't exist in all frames. That's why it's a problem.
That's exactly what he just.
Well, I mean, how about this? You can laugh at it. I won't make fun of you. But if you don't understand it and you're laughing at something that you don't understand, that doesn't make me look foolish. It's probably just worth it just to look into it and just look into what the centrifugal force is. It's not a force in every reference frame. There's no way to square that circle.
Give me a real physically verifiable example. Give me a real physically verifiable example.
You slamming into your windshield when I slam on the without your seat. There's an inertial.
What the? Dude, I said give me a real physically verifiable example of centrifugal force not existing in this way.
Yeah, no, it doesn't exist in every frame, is what I said. And the example that Andy just gave, when you take a left turn and the centrifugal force flings you against the side of the car, the actual thing that's happening is you're traveling a straight line in the inert frame, in the frame that is not the accelerated one, and there's no forces acting on you. It's just the other frame is accelerating, and that's causing you to experience a force. But it's not a force in the other frame. There's no force. There's no force acting. Yeah.
You're riding the horse.
It's kind of funny, but I mean, it's not really that funny. It's just how it's described. That's what inertial force is.
How it's described. That's correct.
That's why they say these fictitious forces are forces without sources, and they're reference frame dependent. Centrifugal force is a reference frame dependent force.
There's that word.
So do they have an antipode to time then, like negative time or whatever, to justify that answer?
No. No, they don't make any damn sense.
If
They
you
can't demonstrate it.
have the warping of space and time, what's the opposite of space and time?
I don't know. I thought space and time was buoyancy,
What keeps it in balance?
resistance.
What keeps what in balance?
Don't chase it, Zanuck. I think it's supposed
Space
to be
buoyancy.
Right.
When air rises up in space, like it does on your Earth,
The reason I
it
said
doesn't fall down. It rides up away from the Earth.
The hell?
For the love of God.
What the hell?
Is that
Did I mute the wrong
Stop
person?
doing sighting live.
Kosho, man. I muted someone else.
My
I
mic
thought it was them.
turned off. For some reason, my mic didn't turn off, dude. It's not my fault. I just won't open it again.
We'll forgive you. It's okay.
I'll put you on time out for that, Coach.
Well, it's still I don't know what to do. So
when he was talking about
I'll be back.
the reason I brought that up, Whit said inertial force, which is true. In his writings he starts about a non-inertial reference frame and compares that with a non-inertial. That's nonsensical. Non-inertial.
No, we weren't even talking about him when you said.
I know, but I'm just clarifying what I said before. But yes, you're right today. The centrifugal force is inertial.
No, back then we weren't even talking about him. Like when you said that it was goofy, you said I was wrong and the inertial force doesn't exist. We weren't even talking about him yet.
I
You
would
didn't
never
even know
say
anything
inertial
about him.
force didn't exist ever. That's something I would.
Yeah,
never
you
say.
did.
I was talking. He brought up non-inertial. I'll bring up his article. He says about the inertial force, and he talks about related to non-inertial force. He's confusing reference frame descriptions with forces description, and these are inertial forces is a pseudo force. Inertial force, Lambert force, fictitious force. Those are inertial forces. That I've been touting that for years. You know that. It's only in reference to him throwing non-inertial in, which is a conflating of a different term. His argument. That's when I know he was smoking crack.
Hey, Coach, Xanet, do you agree that if you have enough charge, that something won't fall at the same rate?
It has to be charged with respect to something else. Something.
Okay, the ground. What about the ground in the air?
Ground in the air. Well, the distance will be very critical in the amount of force or attraction that or repulsion that it will.
So we can make things fall at different rates.
Of course.
We can make things fall at different rates with electrostatics.
Yes. Of course.
Okay, well, how come in the chat they're saying that charged and non-charged objects all fall at the same rate?
Why? Because they don't understand what they're talking about, obviously.
Why would you with the
Yeah, Mr. NASA employee, what's up?
with no, if you have a charged object, if you have two charged objects, right, they're gonna have a electrostatic force applied to one another. We're talking about if you have a charge, and then it's in an area with no other charges, right? Then
where's that area at? Where's that at? Narnia?
Put it in.
That doesn't make any sense.
Put it in.
Where's the area with no charges? Narnia? Where's the area with no charges?
Faraday cage. They can eliminate the
Faraday cage has charge.
Nope. According to the.
You want to bet money? You want to bet $5,000?
It will eliminate 99.999, like trailing 9% of the.
Oh wow! So it does have charge, and actually, can you verify the 99.9999 claim? You just made that number up.
What you?
And that's not even the purpose of the Faraday cage, anyway. What's he talking about?
I haven't heard what he's saying yet.
I can't hear him at all.
He's not saying anything. You're not saying anything.
So if you put something in a container, what do you do to anything it has any type of potential of charge? You increase.
So yeah, if you put in a Faraday cage, what you're doing is you're constantly grounding and dispersing the charge as quick as possible. That's what you're doing. So if an object is more dense in the air, right, then it's going to go down. It's going to have a buoyant force. That buoyant force is intrinsically electrostatic. So you'd have to manipulate the electrostatic induction between the two, the relationship between the object and the medium, to change either its trajectory or its downward acceleration, right? That's a fact. You can't have mass, weight, or density or buoyancy without electrostatics. You can't have any of those things without it.
You can have
okay. Name one time you can have those things without it. Name one time you can have any of those things without electrostatics.
You can
the more you ground it, the more it has to try to pull from another system to equal out that ground that you tried to take, that you took from it. So whenever they say Faraday cage and this other shit, none of that, man. You're never getting rid of electricity.
Neutrons,
no, of course not.
Neutral, and they have mass.
Yeah, whoever's talking right now, I can barely hear you. Your mic's super low.
Okay.
He's like, are you new to the flat Earth conversation? You haven't heard me just absolutely destroy the globers with that claim. Neutrons are mass and they're neutrally charged. Neutrinos. You haven't heard me destroy that claim before, or like you just ignored it? Like, okay, first of all, there's a difference in net charge and charge. Do you agree?
Yes, the neutron is made up of charged quarks.
Okay, so can you ever fully attain exactly zero net charge?
Exactly zero in real life? Probably not.
Right, because it's in constant flux. So it's impossible to get a zero. So neutrinos aren't completely neutral.
I didn't talk about neutrinos.
Our neutrons aren't completely neutral.
Neutrons? They balance.
Yeah, there's no way to get...
Their charges balance each other out.
But not to perfectly zero.
You know what?
Within whatever margin of error, like within tolerance, right? Like we're talking like the absolute tiniest force that's not even going to move anything. That's not going to...
But the tiniest force of electrostatics is 10 to the 36 power stronger than gravity's claimed to be.
Okay, but if we're talking about even smaller than that, like the electric distribution, the electric field distribution would be smaller than that. We're talking about quarks which are packed so tightly together, right, that everything appreciably outside of the neutron is going to be a lot closer to zero and a lot less than the gravitational field.
It's not a lot less than gravity. Cite it. You just made that up.
We can easily.
Please cite that the smallest amount of charge on the smallest scale is going to be weaker than gravity on that scale. Cite it.
Of course it is.
That's not what I said.
Cite it, Zenik.
Sure.
I'll say it because we can measure the force of an object that has weight. Weight is that force. And then we can also measure the force of any kind of electrostatic charge that you can impart on that particular object, and it'll be very weak. Now, it's not considered...
Really? How much weight does a neutron have?
It's its mass times
measurable.
9.8.
Just get destroyed every day. It's like insane that you just keep coming back.
It's not being destroyed. Dude, you don't understand that thing. It's almost as dumb as people saying, well, if gravity is so strong or so weak, it's why so strong, then how do the oceans, not off into the atmosphere?
Non sequitur.
It is not.
Yeah, you mean how do physics physically do your claim?
It has that strength, but you don't have that strength inside of an atom. The atomic force is not going to be as strong. So even though gravitational force is considered a weak force, it still can do very strong things. For example, it can lift.
Wow.
It can.
Let's get our crayons out. Let's get our coloring books and crayons out. No, stop. Dude, look at this. The anti-flat earthers on Discord. Wait. Dude, this is a startling discovery.
The more the mass, the greater the force.
Wait, Zanik, time out. The anti-flat earthers on Discord have discovered gravity on the subatomic scale. Holy shit. We need to get this immediately to your leader so you can get your Nobel Prize. You discovered gravity on the subatomic scale? Oh my God.
Xanax for the win of nonsense. Imaginary stuff.
About the last 5 minutes has been nonsense. I don't even know what.
Said. What about a demonstration, Left Lane?
Oh wait, Left Lane. Hey, Left Lane. Is him claiming that he has gravity on the subatomic scale whenever the top level of physicists in your own paradigm knows they can't in any way isolate gravity on the subatomic scale? So which one would be nonsense? The person pretending that they're teaching us about gravity on the subatomic scale when their own paradigm says that doesn't exist and it can't be isolated? Would that be? Would that be the person?
I don't know that that's what was said though.
Oh, it is. They're literally trying to tell me how gravity can't be electrostatic, and they had to bring up neutrons They had to bring up neutrons, dude, to somehow present
Gravity
that
is
we
not
need
electrostatic.
gravity.
Gravity is not electrostatic because you know what? It lacks instantaneity. It does not
How do
have
you demonstrate
instantaneity.
gravity doing stuff?
For that reason alone, it is not due to electrostatics.
How do you levitate stuff? How do you orbit stuff?
I hope
Show
you
us,
heard that,
Dennis, with
Witsit, because
gravity.
that's one of the defining differences between electrostatics,
We'll define
electrodynamics,
it.
electromagnetism, and gravity.
You haven't
Instantaneity.
defined anything. You're saying a lot of words without doing anything physical. Can you use gravity and not magnetism or electricity to levitate and make orbits?
If gravity is so weak, then how does it hold billions and billions and trillions of
It
pounds
doesn't
of ocean,
exist.
pound forces of ocean,
Gravity doesn't exist.
to
It's
the
really
floor of the
simple.
ocean? But it is a weak force. Why?
It
Because
doesn't exist.
comparatively, on the same scale, it's weak. But it
Is
can be
Xander
very
talking to
strong,
a personal
much
guy in the
stronger
background
than
that he knows or
electromagnetism or electrostatics.
Zanuck, are you got a student in the background? Are you teaching some little kid that doesn't know anything or something? Like, who are you talking to? Does anybody know who Zanuck is talking to?
He's just trying to
He always
convince
has to pretend that we're dumb, yeah.
It sounds like he's talking to a mirror at his house.
Yeah, he needs to make
Zanuck,
sure
are
that
you
he can
talking to
keep
yourself?
believing the story.
I don't have to pretend. You guys do that all on your own.
Dude, you constantly deny and defy your own paradigm. It's hilarious.
Okay.
It's hilarious that you guys think
Paradox.
This goes back to
In
the
the
point I
paradox.
made a second ago. I'm like, oh yeah. The anti-flat earthers could shut down all of these quantum physicists and atomic physicists that have been researching this for years, that wrote intricate, detailed papers about
All based
gravity being
on
electromagnetic in
untruths.
nature. You always have to interrupt it because you know it sounds so bad when I get to say it. That all these anti-flat earthers in here we could bring that physicist in here and they would just completely destroy him with one stupid comment about how charged objects and non-charged objects fall at the same rate. And they would float if it was actually electromagnetic. You would just destroy all those physicists by saying that stupid little phrase, wouldn't you?
No, I would say 3 words, 3 terms to shut him down. And he wouldn't be able to have anything to respond to other than making up. Because nobody can explain paradox. I won't repeat that you know what it is. And you can't either. You've tried.
What, the one that you just
said there was a
debunked like
pressure.
10 minutes ago? Okay.
You tried to say that it couldn't be instant. You said it has no instantaneity, but of course, electromagnetic effects can quote unquote can travel at the quote unquote speed of light.
That's not instant.
Oh, I know that's what you say, but in
Fictitious
fact,
forces don't travel faster than
light is already there, just like electromagnetism is already there.
Okay.
It just becomes physically manifest. So
But
thanks
then
for
how do
playing.
you remove it? How do you
Hey,
remove
how
the
do you
field?
measure? How do you measure how fast gravity is?
No, it's an instant concept.
Oh, just because you say so? So you get to
No,
make up
hold on.
concepts
No.
and it becomes
That's right.
reality. But when I have real physical scientific
obvious.
experiments, it doesn't matter.
When you remove something, remove the force that's the proper force that's holding this weight, which is a fictitious force, its weight. When you remove that force, it will move instantly, no delay.
Oh, really? Can
gotta
you
understand,
wait? Can you remove the
Get
force?
back to the
What?
basics are this.
No. Can you cite it?
Can't even
Cite it. Give me an
explain-
experiment. Give me an experiment.
I will. But first,
Do it right now. No, you made it up. Give me an experiment.
First,
Just say it off the top of
you
your head.
We've talked it. You have not yet explained because you were interrupted. Both of us were interrupted. Everybody else.
What experiment do you have that you can remove?
Wait, listen to me very carefully. I like the interaction we had where you were giving me pressure, the universe or the energy pushing down on things, and talking about those forces and how it acts on certain objects, giving them weight and the directionality of those forces. We have a problem though, the fact that if I have forces, you have acceleration, that you can measure those forces on those objects, but in reality, these objects that are free falling have no forces on them, and we do that very easily.
Stop.
So
You made
how
a
do you
claim.
rectify?
You made a claim.
Hold on.
Dude,
How do
no,
you
dude.
rectify
You made a
no
claim.
force?
Okay. You made a claim that we know that gravity is instant. That's why it can't be electromagnetic. I pointed out actually electromagnetic would propagate at the quote-unquote speed of light, which actually is instant. And you just say, nuh-uh. And then I said, how do you know that gravity is instant? And you say, because we can remove it and it instantly affects the other object. I said, okay, provide an experimental piece of evidence to support that claim. You just want to go on with all kinds of non sequiturs. Answer the question, please.
I'll have to find an experiment that actually.
So you made it up. You made it up.
I didn't make it up.
You did make it up.
Forces are defined as such.
Okay, so just because someone
show me
said
experiment
so.
that shows it's not instantaneous.
Wait, so if you make a claim, I have to prove a negative, or it's automatically true. Wow.
Right. You gotta prove. You gotta come up with imaginary stuff,
True until it's
like Santa.
It's true until it's okay. Santa Claus exists.
That's how science works.
Prove Santa Claus doesn't exist.
Zanuck, it's the speed of light. Gravity travels at the speed of light.
Oh, look at that! Isn't that funny? How we've come full circle to gravity being electromagnetic again.
Santa Claus proves our claim. Prove he doesn't exist, guys. Globers.
Hey, who's the guy really low?
Probably the homie.
Okay, have you read the paper? Will you read this paper?
Yeah,
it's in the
that's
chat.
Paper where they get G wrong.
Wait, have you? So you read the paper?
Yeah, and they have a bunch of fundamental constants that they say equals G, and it doesn't.
Well, no, but it shows the experimental evidence to support it. So can you rebut with specificity instead of just saying
G is wrong.
Right. So really, what's the mathematical component of it that's wrong?
Have him turn his mic
The
up.
value of G they get is literally wrong.
Okay, cite it specifically and show where the math is and what the value is and why it's wrong.
Sure, 1 moment.
Yeah. And then I want you to show me exactly why you couldn't take this concept and apply it to what we know about the world. You can't. This is what I'm saying. Anti-flat earthers act like they can come in here and they can just shut down these intricate papers with specifics by saying stupid things.
Also, this is by Scrib. This is not a trustworthy source. But 1 moment.
Really? Well, what about all the papers this guy wrote that was published by Cornell University and Stanford and Harvard?
Well, that's wonderful, but this one he got the value wrong. So
those were completely unrelated fields.
No, they weren't. It was literally about the 0-point density of a quantum
those
vacuum.
are not related to this paper at all.
Yes, it was. It was about the electromagnetic vacuum.
Danik, hold on.
Not that paper. All his other publications were not had to do with his.
The other publication is about the electromagnetic characteristics of the vacuum that was published by Harvard.
Okay, Witsit, you asked me a question. Under section 3.3, this is the value. They say this is how you calculate G, right? And you can go up further in the paper and it'll give you the value for all the constants or like the vacuum permittivity, all that. You can find that online. Really easy to do. You do this operation and you get like 6.67. Is it really that low? Hold on. I'll finish this and then when Witsit's talking, I'll turn my volume up.
Yeah, the mass charge equivalence and the electromagnetic nature of the gravitation constant G imply the equivalence of Newton's gravitation law to Coulomb's electrostatic law. So if you actually do the math right, it is exactly.
This value is wrong. When you actually multiply and divide all that out, the value is not what is measured in reality.
Even though you just said out loud, oh wow, is it really that small? You don't even know the value. So can you show us where you did the math? Can you just take a picture? Just take a picture of where you did the math.
Sure, I actually did. I did on MATLAB.
Do a 1 minute TikTok.
I sent this to you. I literally sent this to you.
I don't check my DMs from weird anti-flat earthers. I would be here all day.
Check your it wasn't your DM. It was in this chat.
Okay.
I sent this to you. Hold on, I'll just.
Is it possible for you to turn your mic up? Because I'm really struggling to hear you, dude. Dahomey Don, that is.
It says considering Planck's length of 1.616 times 10 to the negative 35 meters, which is the shorter possible wavelength for a single photon beyond which the electromagnetic energy density transforms to a quote-unquote black hole. The gravitational constant big G is expressed exactly through the elementary charge E and the electromagnetic vacuum constants. And then it gives you the equation, and it says the mass charge equivalence and the electromagnetic nature of the gravitation constant big G imply the equivalence of Newton's gravitation law to Coulomb's electrostatic law. In fact, the well-known Newton's gravitational potential between two particles I and J with respective masses m to the I and m to J separated by a distance blank right, and then it actually shows you the correlation. It shows you the equivalence of Newton's gravitation and Coulomb's electrostatic law.
But again, they get the wrong value of G. Like they predict the wrong value for G. And as I said, I sent this to you, and I'm going to pull that up in just a moment. Is my voice better? Can you actually hear me now?
Yeah.
Okay, good. I sent this to you. Here we go. Here we go. So this is the message link. That is the message link. Let me just.
You didn't send anything.
No, I haven't. One moment.
Let's look through the whole thing.
Yeah, there.
It possibly did
That's
the because it says that it's 6.6728 10 to the negative 11th power compared to 6.674310.
Yeah, and the margin of error for the most recent measurements is smaller than this percent error here.
Wow. And you brought up Cavendish to explain that. That's hilarious. Yeah, actually, it shows that the predicted margin of error of Cavendish can be superseded by up to 10-fold. And I have
1.5% to 0.15% would be tenfold. He did 1.5% is pretty good.
Cavendish's error margin is off by 10-fold.
Yeah, 1.5 to 0.15 compared to modern margin of error. He was off by 1.5%. Modern, today can even get better than 0.15.
Today's most precise Cavendish has a prediction of like it's 40 parts per million off, and they have very precise controlled experiments showing up to 10-fold that, over 400 parts per million off.
Oh, and this is my point, right? We have very accurate measurements of G, and what they predict in the paper is outside of that measurement range. So this paper is wrong.
Proved you wrong, though. You brought up Cavendish.
What do you mean?
You say that
Cavendish is the first one. What I'm talking about is the modern one, right? I said even Cavendish did better than this paper, but the modern measurements are better than Cavendish, and the modern measurements are what I'm talking about.
What experiment exactly is it that I need to make sure I explain with this specific value?
What, the ones where they measured the value of G? Do you want me? I can post those if you want.
I want to know where you think you have some type of evidence that G has to be a very specific value. What experimental evidence do we have for that?
All the fundamental constants of nature they can't be a range. It can't be more than one number. What do you mean?
Oh, see? So that's
weird.
So you didn't even read the paper?
G has one value. I don't know.
No.
If these guys think that it doesn't, then it's wrong.
Okay.
A constant can't have one number.
Then it says specifically it's not a universal constant. You didn't even read the paper.
Wrong.
Oh, they're wrong because the random anonymous dude on Discord said so.
They're wrong
it's
because
not even
they
constant on Earth.
With G
it's not even
is
constant on Earth.
Jeremy, you're confusing
big G
and little G.
Gravitational anomalies on Earth where it's not constant.
Jeremy, that's little g. Little g is not constant. Big G is a constant. Two different things. One's the gravitational constant, one's the gravitational acceleration.
All right, how about this? Obviously, unless pure integers attract or repel each other, Newton's and Coulomb's law are phenomenological mathematical expressions describing how gravitation and electrostatic forces act, but without explaining physically why. In addition, it is worth to note that G in equation 21 is inversely proportionate to whatever these characters are, which may be understood as the square of the density of the vacuum states. Generalizing the expression, we may write, and it has a different equation, where whatever that symbol is the local Keenan mean density. Through this lens, G depends directly on the local density of the vacuum states and consequently may not be a universal constant.
Yeah, but their hypothesis is wrong. They got the wrong value for G. Like this paper predicts the value of G
maybe can't comprehend
all these things. No, what's it? I'm telling you, right? This paper has a hypothesis for what's going on in the universe. That's fine. They make a prediction. They think that G is based off of the vacuum, the vacuum energy, right? But we can go and we can take their prediction and compare it to reality. And in reality, G does not line up with their hypothesis. Therefore,
I asked you
their
already with the
hypothesis is wrong.
experiment that you're building that upon and telling me what reality is or not, and you didn't answer because you don't have an answer.
Dude, there's plenty of. Okay, I'll just start dropping values for G in the chat, I guess. Hold on. Here's another one. Value for G.
Can you actually rebut what it's saying, which is that? Can you actually rebut what it's saying, which is that G depends directly on the local density of the vacuum state and consequently may not be a universal constant? Can you rebut
that is a hypothesis.
Yeah, but what's wrong with it?
What's wrong with it? The prediction is wrong. That is exactly specifically what's wrong.
The prediction is that it's not a universal constant. You would have to know
the prediction is that it's
you would
G.
have to know the specific local density of the vacuum state. How can you tell me the prediction?
Wait. Of which vacuum permittivity? Epsilon or mu?
Dude, okay, do you not understand words? The local density. So
right. So which one of those variables?
Constant. So if you bring up an experiment, you need to know the local density of the vacuum state for that very specific area, and then you can compare it to the value you got for G. That's how you would test it. Not just you say "nuh-uh" on Discord while you still protect an archaic remedial idea of relativity that's been debunked.
No, what's it? Which of those variables represents the density of the vacuum state? Is it rho?
Are you saying that the density of the vacuum state's not rho?
I'm asking you which one of those variables that you just posted is the density of the vacuum state. Is it rho?
It's the P. It's the P little.
It's the rho.
Giant.
And which part of the paper is that in? What section is that under?
Section 27, 26,
section 20. Oh, okay.
It's all good, man. But you should read it and understand it first. So. And it even explains that it's using the plasma frequency corresponding to a collective oscillation frequency of the electron density, which is with a well-known expression. So what it's saying is that gravity is not a universal constant, and it's actually going to be directly relative to where you are locally. This is an experimentally testable hypothesis, that's for sure.
Right, and as I said, okay, so let me rephrase it then, right? Who has experimentally verified
that wasn't the point. Like, it hasn't been experimentally falsified or verified from my understanding. I'm still looking into all the specifics, but you're claiming to know it's wrong, but you didn't understand what the hypothesis actually was. And that is that gravity is not a universal constant and that it's directly relative to the local energy density of the vacuum. So that isn't just like, oh, it doesn't match my current value. He's saying that the value fluctuates and it's relative to the vacuum density of the local area.
Right, but is there any evidence in reality that G fluctuates? Like, has anybody ever measured G fluctuating?
Well, I just now told you what it is that he's basing it upon.
Right. That's his hypothesis, which is fine. He can hypothesize whatever he wants. But has anybody actually measured G being different in different places?
We've never even measured G always being exactly the same ever.
Within the margin of error of tools, right? Margin of error is not a difference. It's just
the margin. Is it the margin of error based on an instrument?
Yeah, the margin of error based on an instrument.
Really? So what's that margin of error?
Vary, not the
it depends. It depends.
Or are you
on
measuring gravity?
It depends on the experiments. Some of them are torsion balance. Some of them are torsion balance experiments. Some of them are, well, actually, I'm not going to claim I know all the different ways G can be measured, but the torsion balance experiment would be the most popular, right? Yeah. So if you have different values of G all within the same margin of error, that's not a fluctuation. That's just differences in the instrument.
That's the Cavendish, right?
Cavendish would be a type of torsion balance, yes.
And that's really all they know about is Cavendish.
Well, there are others, like one where they took a vat of mercury and measured it with a load cell, right? Or gravimeters, right? That's not a...
All of that's electromagnetic.
Mercury is neutral.
Mercury is one of the most electrically conductive dielectric materials.
Yeah, if you put a charge through it,
it's intrinsically held together by charge.
But it doesn't produce, like if you sit a vat of mercury down, it doesn't produce an electric field unless you run a current.
That's a total non sequitur.
That is exactly what we're talking about. It is not a non sequitur.
Can you address what Winston said?
Yes. Hold on, Jeremy's glitching for me. Or not.
We don't really include Jeremy in any of this. It doesn't include a train.
Can I just chime in and say that I find it quite amusing that you're kind of arguing over big G, little g, and it sounds like a religion to me. So
we're talking about experiments.
How ripping
right.
How would
little pseudoscientific bodies? That's what I'm doing.
How would an experiment be religious? I've literally posted experiments in the
This
chat
is the
or
opposite. It's
measurements.
the opposite of
It was
religion.
the
No, actually,
irony
it's
of big
religious,
G,
Left Lane,
little
because the
g,
guy tried to
according
say
to
he
the
knew it was
Bible.
wrong before he
So
even understood what it was saying. That's the definition of religion.
Yeah.
He's immediately saying
Over
before you even know what you're
overviewing.
talking about. It's like someone saying, "Hey, I found a discrepancy in the Bible," and then you screaming at them that they're wrong because you know the Bible's real. It's just like a religion. That dude said he knows.
No,
he's wrong.
overviewing experiments and their results is not a fucking religion.
But he didn't do that. He said that he knew it was wrong before he even read and understood the hypothesis in the first place.
Nothing to do with religion.
That's religious.
I should clarify, right?
The
It would
red
be
herring-
better to say that we don't know this is right because nobody's tested it yet.
yeah, but
Never
it
claimed to
even
know it's
goes
right.
farther. Let me explain why I said religious or whatever, because yins were arguing over subatomic particles and its relation to gravity and everything else. And those can't be even seen under a microscope. So they're like invisible. They're hypotheses.
Yeah, but the phenomena is real. So like their subatomic particle nonsense is all fake pseudoscience and they make it all up, that's for sure. But that's just a quantified construct. The phenomena is real. Like the phenomena of the atom, quote unquote, it's real. It's a concentrated like spherical area of concentrated frequency. That's a real thing. With what they call the electron, yeah, it's not like some little particle of matter that we can never find that's always going everywhere and has no size or shape and all this nonsense. But it is a real phenomena. The electron is a real concentration of pressure mediated and giving you like an electrical phenomena. Like that's a real thing, right? We can utilize the real phenomena for technology. That's how we make computers and TV screens and all kinds of stuff. But what they say it is what the religion is. It's pseudoscientific. It's made up. It's never directly observed. Yeah.
Wait,
No,
how
we
is what
shoot
you said
electrons
different
that
from
are
whatever
long.
you just said? That's what quantum mechanics says about electrons. It's not a little ball whizzing around. It's
No, you guys claim
literally
it's
an
a
energy
particle of
fluctuation.
matter. You guys claim it's a particle of matter.
And a particle is an oscillation in an electric field.
That's
a particle
some
is a wave.
QFT understandings of it, and you guys claim electrons a particle of matter.
Yes, which is a oscillation, and QFT is the most successful quantum theory we have.
Yeah, except
right?
that it still doesn't explain tons of things.
Well, yeah, the current science. Nobody in science says that our models are perfect. They're getting better. That's why there are millions of scientists around the world. They're trying to get better. But QFT, our best currently, says that an electron is not like a little ball whizzing around. It's pretty much what you described it as. It's a localized area frequency.
Yeah,
for the electric field.
You guys denied that for decades, and if you guys were alive in the 1920s, you would have called me crazy for saying that because you just repeat whatever the current rhetoric is. And of course, the current rhetoric is still wrong. That's why you have a cloud distribution, a cloud probability distribution equation for the electron. You claim it's a point particle with no. You claim it's a point particle with no. You claim it's a point. You don't fire electrons if you don't even know where it is.
Measure the field.
Okay, you claim that it's a point particle with no known size or shape, and that it's a particle of matter. And now you're claiming that matter isn't actually matter; it's just a frequency.
Matter is made up of frequencies, right? So an electron is very similar to the way you described it, right? You have an electric field, and whenever you have an oscillation in that electric field, that is what we would on the macroscopic level identify as an electron.
You're getting closer to the truth of what it is finally after reluctantly ignoring it for decades now, right? You're just inching your way back to the fatherheads of electrical field theory who knew this over a century ago. You're also just inching your way back to the ether when you bring up stuff like the Higgs boson and 0-point energy, vacuum energy, quantum foam, electric permittivity, magnetic permeability of a vacuum, the Casimir effect. It goes on and on and on. You're just inching your way back to what we've already known. You guys aren't teaching us anything. We're sitting here like, wow, when are you crazy materialists finally going to realize your whole entire stupid little particle physics paradigm is stupid? But you're not going to realize it until daddy priest science tells you so. That's the reality, and I'm not trying to be derogatory. That's a fact, and you know it. You're not going to agree with anything I say until it's the mainstream consensus. Just like there's no unified theory yet, right? Just like you guys, you would have been making fun of me for saying that the weak nuclear force is actually electromagnetic. You would have been like, you're crazy, you're stupid. We know the weak nuclear force and the strong nuclear force are not electromagnetic. You're insane. What are you talking about? But now the electroweak force and interaction is integrated into the standard particle physics model. So now you do think that. And now if I told you the strong nuclear force is also electromagnetic, you would say that I'm wrong. But in about 2, 3, maybe 5 years, you'll be saying, of course it is. We all know that.
I mean, eventually we would like to unify all the forces. That would be the ultimate goal. Yeah, whatever we end up calling it. Maybe we'll end up calling everything the strong nuclear force, but like eventually the goal would be to unify all the forces. That is the ultimate
electromagnetic then, right?
And whatever we call it.
So your main thing isn't a force, but you can unify all the forces with a not force. That's really going to help you.
D-Mock, I'm very confused.
Wait, you're going to have to, wait, are you saying you're going to have to unify gravity and electromagnetism?
Eventually, it would be nice if we could unify all the forces. I'm not saying it's possible, but that would be the ultimate goal.
So your goal is to unify gravity and electromagnetism.
Yes, if they are the same, then like if they are fundamentally the same thing, that would be awesome.
Yeah.
If there is a way to describe it as the same thing. Currently, there isn't much evidence to suggest that they are.
Yeah,
but
because you're looking at the wrong medium, at the wrong background, and
exactly, you're looking wrong.
Yeah,
you're thinking wrong.
Or looking. How should I look then?
Well, that's where it's up to y'all, the scientists, to figure that out. But if you keep doing the same thing you're doing now, it's going to take you forever. You might not ever figure it out.
Yeah, you're looking at science and ignorance. You should look at physics and the physical attributes of physical things that you can do or not do. So if you can bring matter into fruition the way you think matter is, I'd love to see some matter grow in a lab. From gravity.
I don't understand.
This paper's written underneath the lens of cramming pseudoscientific materialism down, the natural world's throat. But it's still at least he has the balls to acknowledge the inevitably obvious. Like if I read this to you, you're not really going to be able to rebut it. Like the origin of gravitation,
can't rebut a hypothesis.
Origin of gravitation appears to lay on the modification of the electromagnetic quantum vacuum-filled fluctuations due to the presence of localized charges, i.e. mass, which reduce locally the presence of the vacuum states, that is, keenons. Thus, a flow of keenons from the surrounding space is induced towards the charge density or the mass, which consequently experiences in its frame a radiation pressure at the characteristic frequency. Variations to the quantum vacuum fluctuations may be also due to the presence of electromagnetic waves, also referred to as photons, which also reduce the presence of keenons since they are composed of keenons themselves, enhancing by this way the gravitational effect at short distance. For instance, the photospheres of stars increase the gravitational effect felt by the bodies moving closely, perihelion. By the same token, light rays should follow the path in the electromagnetic vacuum imposed by the charge densities in space, modifying locally the vacuum fluctuations of the refractive index. This dude is actually addressing major problems in your paradigm and your cosmology, and he's talking about the perihelion, which is still a problem in the solar system for you. He's talking about the fact that we know that there's actually a 0-point vacuum energy density inside of a vacuum, and there's electromagnetic fluctuation, and that he knows that the light's nothing more than the excitation of the background that's already there. Now, he's still wrong, because he's still trying to cram it into this stupid pseudoscientific heliocentric paradigm, but like, can you address, like, you have to admit that this guy is not just like some random flat earther saying electromagnetism. He's specifically explaining the phenomena from your own paradigm.
Yeah, so I mean, there's a lot to unpack there. And fundamentally, right, this is all a hypothesis, right? And I have no problems with people hypothesizing anything that they want. So the next step would be to find these keenons, like, oh, if this keenon is a type of particle, can it break down from other particles at high energies, right, inside of a particle collider? Or, oh, if we use really precise gravimeter, well, I guess gravimeter would be hard. You need to know the density distribution. Is there a way to measure the fine fluctuations in the value of G, either over time or, with distance, right? So making a hypothesis is fine, right? You can't rebut a hypothesis. It's an idea with a prediction.
Like
right? But until it's tested, well, relativity has been tested.
And it doesn't work.
There are plenty of times it does work.
There's plenty of times it doesn't work, though.
But it's still incredibly accurate when it does.
No, but it doesn't work 96% of the time.
And that is the best we have so far.
That's according to you.
Who's gotten better? Who's
this
done
guy right
better?
here has better. Maxwell had better. Oliver Heaviside had better. Nikola Tesla had better. Charles Proto Steinmetz had better. Henry Poincaré had better.
None of those
Lorentz
people
had
even
better.
knew galaxies existed. How could they have it better?
First of all, what? When
What's
do
a
you think
galaxy?
galaxies were discovered, my
What
guy?
are you talking about?
I guess
Is he
maybe
trying to be a meme?
That was a little troublesome. Maybe take that back. Take a mulligan.
When do you think
Okay,
that
well, the
galaxies were
mini. Okay, I
Just
will
take
take
a
that back.
mulligan,
I'm
man.
thinking.
Yeah,
I'm taking that back. I was thinking of the Hubble Deep Field, where they
Okay,
found a
mulligan.
ton and tons of galaxies. Right, the prevalence of galaxies wasn't known until the Hubble Deep Field.
in the 20s.
When
That was in the 1920s.
Hubble Deep Field,
Yeah,
the telescope,
Hubble.
I'm talking about the telescope, Hubble Deep Field.
Okay. Well,
That's the name of a picture.
Hubble's the one that discovered an immense amount of galaxies in the 20s.
Right. Which is why, as I said, I was thinking of the wrong thing, which is why I took it back.
Okay.
That's the problem.
But
with
yeah,
your thing?
no. They could not have predicted, like the whole dark matter thing comes from galaxies spinning too quickly. But galaxies spinning too quickly wasn't known back in Maxwell's day.
It was known in 1933.
Galaxies spinning too quickly.
Yeah, dark matter was
What
first
a year?
discovered in
1933.
1933. You don't even like Fritz Sawicki or whatever. He discovered that the mass distribution prediction for relativity was off by 99%. Then, when looking at the galaxy clusters,
99%.
Yeah, 99% off.
That's a lot.
Only 1% of the mass predicted was observed. This is
All
all
right, can you-
pseudoscience
can you-
anyway, by the way.
Can you send that to me?
The rest
Yeah,
of it
sure.
isn't
I've
going.
never heard of a galaxy 99% off.
Well, you're
They're
gonna learn
off, but
today.
not 99%.
You're gonna learn today, bro.
No offense, but you might be hanging out with the wrong circle, right? Like, you know what I'm saying? You get caught up in a certain circle that all agrees with each other and you don't hear the opposing view. You never go research it. You'll never learn anything new. That's what we were saying earlier.
You have to
You
ask
sound
more
smart
questions.
enough. You sound really smart. Like, you could do the research, get a hold of the papers and do your own study and make your own decisions, you know?
Dropping the citation.
Actually, I found one from the DOE, Fritz Zwicky, 1933. Would you look at that?
General principle is think less, ask more questions, and you'll be in a good position.
But
Well,
it's
what we're running
okay,
into
so we have
also, a lot of these studies and papers are being really suppressed, almost like a book burning. Like, it's like pulling teeth, finding stuff you even discovered like 2 or 3 years ago.
Yep.
You know what I'm saying? Like, you can't even find those papers anymore. It's actually strange. It's a modern day book burning where they can press a button and it goes off the internet.
Not just that, my guy. You know what they're doing? It's kind of unrelated to this topic, but they're doing it to popular culture. They're rewriting it. So they're rewriting fictional books to the end of their specific silly agenda. But this is another way. This is another way to suppress. So
I don't particularly care about.
Original copy. If you don't have an original copy of some
I
of these
understand the
papers
subject, guys.
hold on. If you don't have an original copy of some of these papers that are being referenced, you don't know if what you're looking at on the internet is a doctored version. And then someone comes and shows you the original or a copy of the original with a book that they had, and you go, "Hey, hold on, this doesn't match."
Well, Ruhif actually claimed that this morning, that some of the citations that Witsit is using are not actually citations; they're made up, which could be true, right? Like, so easy just to go in there and change it, post it, and blah blah blah.
Yeah, it would be really hard to determine which ones
what
are.
he's talking about is that I had one person send me certain papers. I had a list of different papers that I couldn't find. And then I kept trying to look them up. I couldn't find them. I ran them through ChatGPT with the name of the articles. It gave me links. I kept clicking the links, and it would take me to like random papers or to dead links. So what I did was I copy and pasted them all, sent them over to Brian Myers because he's a former professor, and I thought he might have access to certain databases that he could find them. What he did, because he's a little chamomile, is immediately take that, send it over to McToon, who made a video that was like bashing me about how I'm so stupid and I'm using all these stupid links. And now you have that dude Ruhif running around trying to like bring it up. Right. That's what happened. And it's just funny because like I reached out to what you would think is an intellectual that would want to know about the articles and what's happening to them. And instead, he's like, "What's it so stupid? These articles aren't what these links are." And then went and gave it to McToon immediately, who immediately made a video bashing me about it. That's such a great company that these guys keep.
Interesting.
And also, I sent it. Wait, one more thing. And I also sent Brian Myers this paper that we're discussing, and he responded with, "You don't get how that doesn't help you because it still makes a sphere." I'm like, wow. So you mocked me and scoffed at me for a year straight when I told you that gravity was electromagnetic. You said it was impossible. No one ever would ever think that. I sent you all kinds of papers. You called them all wackadoos, and they were all insane. And now I've sent you somebody just drowning in credentials, and instead of like defending the specifics of the argument, you say, "Oh, that still doesn't help you anyway." So once they're proven wrong for all their mocking and ridicule, they just shift over to like, Earth's still a ball. This guy thinks the Earth's a ball, right? So anyway,
Yeah, I'll say making definitive statements like that. I mean, there's 8 billion people in the world. I'm sure some of them also agree with, some sort of electron or, electric unification between gravity and
there are a lot of them though.
the electric views.
There's a lot of
no, I'm sure
trying to do that. Yeah.
I'm sure there's a group of, it's not mainstream scientists. I'm sure there's a group of people. It would be nice
when it should be 300 million or 5 billion or 7 billion. Our peer review is weak as hell, and our science is weak as fuck too when it can't match physics. Don't you think it's weird when physics outdoes science?
I don't even know how to answer that question, DMOC.
I know, because nobody likes physics, right? Globe physics that don't exist. When the physics outdo your science, like you can make up anything you want for science, but you can't for physics, because if you can't demonstrate it, then it's just made up. And you guys have like truckloads of shit, like trillions of tons of information, papers, math, artwork, and all this stuff it's unproducible in physics. So if your science could just match up with physics, it would be great.
I would say physics is a field within science. Is that not normally how it's defined?
Of globe physics, I'd love to see them. I want to study that one.
Physics in general, not even have to deal with any particular shape.
No, you're missing the point. If we live on a globe and the whole universe is gravity globe, the only physics we would have to demonstrate would be globe physics, which we don't have. We have flat physics. We don't have globe physics. This is my conundrum.
Interesting. Okay.
How you thought about it?
I got 60 something papers explaining all the problems with current cosmology and all the evidence supporting this guy's hypothesis
of gravity and electricity being.
Well, yeah, it's all of those things together. So like the problems with dark energy, the need for it, the redshift anomalies built upon that relative to the baryonic distribution of space and supernova acceleration, and all these different things that are falling apart in modern cosmology, combined with the quantum evidence for what's inside of the vacuum effectively. Yeah.
Right. So I don't think there are any, well, maybe there are some. Again, there's 8 billion people. I shouldn't make a definitive statement, but most, people who are doing astrophysics wouldn't say our cosmology is perfect, and it's still always being worked on. So, finding errors in the places in our cosmology would be the areas that are under active research. Like, yes, this is an issue, and we need to go find out how to rectify it.
107 all credentialed links. So.
Right. No, that's what I'm saying. There's definitely going to be issues.
Fundamental errors.
Right. No, I'm saying there's going to be issues, and that's where scientists come in and try to rectify them. Right. If there's a error, then a scientist would come and try to find out, okay, what's the more accurate model, and then when whoever comes up with a more accurate model, we go to that.
Yeah, but you keep saying the word model when it's really just an imagination. That, like when you just said you couldn't refute a claim that Whitsitt or someone else said because it was just like an arbitrary thing, right? Because it's something that, he's just discussing. It's just a discussion of an idea. Now, how can we, right? How do we fix ideas with physics? Like, if the physics and the ideas don't match, how do we fix? Where do we even see your idea happen?
Right. So with the model, we have testable predictions, right? A number typically.
Well, I mean, it
If the
depends
model's the
on.
same numbers,
Okay, well, never mind.
Come you gotta let
well,
him
I mean, what,
respond, my man.
I don't know if I should. I mean, I was just gonna say, the model makes a prediction, and then you measure whatever you were testing it in reality to see if the model aligns with the prediction, if they agree with each other, and if they do, congratulations. If they don't, you got more work to do.
If they don't, then your theory's wrong.
Right.
This is the
Well,
problem. They're not replacing it with a better hypothesis. They're just trying to rewrite it again and again and again instead of just accepting that the whole model is bunk from the
Not
offset.
even like, they won't even entertain that possibility. It's not even on the table. It's a religion.
It's like when someone doesn't like their face, they start doing editing with the surgery, and then they just become this unsustainable monster that makes no sense. That's an analogy to what your model has become.
It is refreshing to talk to someone like this, though.
I will say this, right? It is very possible that, in order to get a better model, that we need a completely new paradigm, right? There's no, I shouldn't make definitive statements about other people, so I won't. I will agree that could be a possibility, right? Having a hypothesis with a new paradigm is fine, but the current model will continue to be used until a new model can make better predictions.
Would you
right?
agree, though, it's hard to do the testing because you can't get the fun on something new like this that's so far away from the current paradigm? Like it's tough, right, to get even recognition, much less the funding that you need or the space at the universities or whatever,
Yeah, it's a bit of a, what is it, like a chicken and the egg? Is that what they call it? You need funding to do the measurements, but to do the measurements, you need funding, right? So I will say it's a bit of a chicken and egg issue. The best we could besides, I could look at it both ways, right? I actually do think that all ideas should be tested and tried, right? I wish we lived in a world where it was possible that anybody could come up with a hypothesis and the funding would be supplied to test it. Unfortunately, practically speaking, there's just not enough money to go around. And so
there's a select group that controls that, and they're I don't want to say biased, but they are biased, right? They've known this for so long. They're trying to make it work. They've invested all their time and energy and life into it. They went to school for it. They paid for that, and now they don't want they don't want to waste the money either. So they're trying to be careful and do the right thing, and it just puts us behind time.
Yeah, but that catch-22.
You can look at it that way, and the way I look at it isn't that much different. The way I see it is, you want to invest the money into the experiments that are probably going to produce the best result, and those experiments will probably. Yeah, exactly. As I said, we don't exactly. I don't quite come at it. I don't think of it as like malicious or even intentional quite as much. Just that, if I had to determine where money would go, I would send it to places I expected to, actually, advance science. And in that paradigm, sorry, go ahead.
Sorry, finish and I'll talk.
Yeah, no, I was gonna say, right, that's not the best thing to do. I think the only thing we can do, to what Whitsitt might have even been saying, right, is you have to, when you identify places where the current model doesn't work, right, where there are anomalies, that those are probably the places where we could come up with new paradigms. But until those new paradigms have been tested, they're just a hypothesis.
Yeah, I mean, I think what you said there is basically all more or less true, but I don't really think it's exactly addressing the issues. So someone mentioned about bias, and another person, I think, said vested interest, or maybe I heard vested interest. But of course, a lot of these scientific papers are published, like partially with funding from vested interest who want to see a certain result. Okay, I think we're all grown up and intelligent enough to understand that people funding things want something for their money a lot of the time. On top of that, let's just say that Bryant Myers, who came up in the conversation earlier, was in charge of the funding that gets distributed for testing of hypotheses. There's definitely someone or a group of people who are in that position, And the biases of those people will affect where that funding goes, as you just more or less said. But of course, those people are biased based on their own, what they think they know. And so effectively, what you're saying is that, effectively the situation you have is that people who already think they know things are throwing more money at the things they think they already know, which that's not going to give any funding to, quote unquote wacky ideas as they perceive them. So it's not that it's not even like there's a maliciousness, like necessarily, although I think some of them are malicious. I don't think that the maliciousness is even necessarily the issue.
And I can see your point and how these biases could be addressed. And on the other hand, there are also people who recognize the issues in the current model and know that, the money that needs to get sent out needs to go towards doing more measurements to break the model, right? So a lot of these, what's happening over in CERN, what's happening in a lot of, high-tech experiments all around the world, they're designed to hopefully find an anomaly in the model so that we can go and fix it.
Actually, they postulate stuff. They postulate stuff that
Well,
they
but
go
I mean,
and
it
look
happens,
for.
right? In reality, people go and find measurements, and they will find that there are anomalies, right? That happens in reality.
Yeah, but to what end? If it's run by the monopoly for the monopoly, why is it going to change the state of the monopoly?
From a monopoly's point of perspective, to make it themselves better, right? If this monopoly wants to improve science, then they would still have vested interest to improve science.
No, because that's not the vested interest. The vested interest is itself, the entity that has become the monopoly. So why would it? Why, even if things did come up to challenge it, why would that change anything?
To improve itself.
But why would
right?
it? It doesn't need to.
That's not the vested interest. The vested interest is just to continue.
Oh, okay. I think this is where the fundamental difference is, right? I do think that the vested interest is improving science, right? When you look at the way funding is distributed, it is to improve our understanding generally. And it works, right? Maybe slowly, but it does work.
I think that's a naive perspective on what's actually going on.
It's also.
But, in reality, it does work.
It's self-fulfilling.
It doesn't.
Like you're saying, I believe in this paradigm because the paradigm works because I believe in the paradigm.
Well, not just that. Like we've made over the past, however far back you want to go, advancements, right? Like those things have advances in science have happened in reality. We understand the world better than we did even 20 years ago.
Have any of those quote advancements challenged the monopoly for what it stands, as it stands?
If you mean quantum mechanics and general relativity, well, for general relativity, yes, dark matter certainly does.
No, remember what we were talking about, vested interests, right?
Right, I'm putting names to these vested interests, right? The people who advocate for quantum mechanics.
It's a consistent vested interest. That's why I've said monopoly, and you haven't even argued with that, right? So over that time period that you've denoted, right, and the advancements that you've alluded to, have they actually challenged the status quo in any way? Fundamentally, not from a an insular advancement perspective, but fundamentally, has there been any challenge? Has there been any overturning, any change of direction?
If they include the people who support GR, then there are a number of scientists who believe that GR needs to be modified, that Einstein's general relativity is wrong and that it needs to be modified. Would that answer the question?
No, I don't. Did you understand the question?
I don't understand who they is. I feel like it's pretty vague to just say they. That's why I'm trying to give a name to they.
But it's not about that. It's about the consistent vested interest that you could over generalize and simplify as a monopolistic ideal. Nothing in the advancements that you mentioned that you could bring up a few examples of has actually changed that.
Okay, right. So if one of
That's
the
still been trugging along. The main thrust of who's controlling the, even what you alluded to earlier, which is a distortment of the term, right? Mainstream science. That's a distortment of the term science, because that's not what science should be. It shouldn't be what the mainstream has to say about it. It just should be what the results are, right? And my
okay,
point is, in any of the things that you think are advancements, which might be advancements within, a myopic, insular point of view, have any of them at all ever challenged the status quo? The answer, I think, should be no, or I don't know.
well, and that's why I'm trying to give like an example for this vested interest, right? So, for example, general relativity would be have a position, right? And the vested interest would be to maintain general relativity, right? Would that be a good example of a vested interest?
You're thinking too insular and too myopic.
Okay, so then how should I be thinking? Can you give me an
Well,
example?
I'm not going to tell you how you should be thinking, but with respect to the question, I think it's pretty evident, but perhaps I'm not articulating it in a way that you're understanding. Is there anyone else here who gets what I'm saying?
Let me try. I've kind of been in these circles, right? So when you have an investor, let's say, someone who's going to donate a building, huge amounts of money to a university or whatever, usually the projects that get done in that particular university are things that he's interested in, right? Like, just making it simple. And not that they have control once they give the money to the department, but you better be damn sure, if you want to get money the next year for your budget from the same guy, you better provide him with some results that further his, whatever he wants to do, or their family's interest, or, whatever it may be. I mean, it's usually an ideology, right? Like, you can look into their background, and then they look a specific way, and that science department, if funded by that person, is usually going to go in that direction.
Right. And I think I understand what you're saying with this vested interest, right? The vested interest is trying to keep itself in power. But I'm trying to find an example of this vested interest in reality, which is why I'm bringing up general relativity as an
All of them.
example.
They want to be right? The people who support general relativity want to be right, so they throw huge amounts of money towards it. Even when proven wrong in so many areas, they only show them where they're right, and they're like, okay, here's another 5 billion, or 2 million, or here's this a piece of equipment or building or whatever it may be. Keep going.
Well, but if we're talking about general relativity, right? There are places in general relativity that have been shown to be incorrect, right? So that's what I'm talking. And yeah, so I'm saying, like, in reality, right, it seems as if whatever this vested interest is, it's interested in improving itself, because there are papers and experiments in reality that go against the ideology. Like, they do exist.
I mean, yeah, but when you're sitting in the board meeting, this is how it goes. They go, we've done this, and this, and man, you should see all this, and this is great. And and this was kind of, something that we frown upon. But let's move on to this. Let's stay positive. That's how it goes. Write the check.
Let me respond to something he said, though, because he said to improve itself, right? But that was my point earlier. The improvements have only been within its own specific paradigm, and it's a broad, wide paradigm that influences practically everything in our day-to-day lives, right? In terms of understanding. But but the paradigm itself hasn't been challenged, or any challenges that do come up are necessarily either occulted or suppressed or just ignored, or whatever the specific tactic to meet the ends of continuing its own existence. And I think a good parallel would be like Coca-Cola, right? It has a long history.
Mm-hmm.
It has a market share thing to deal with Pepsi and all these kind of things. I don't know the ratio, so forgive me if I'm a bit wrong here and there. But the point is that it's continued, and and the things that have maybe improved or challenged it, that it's accepted, have only been to increase its own ends. And that's what I'm trying to get you to express. Has anything that because we were talking about a challenging of the paradigm in terms of the glaring errors in the fundamental cosmological perspective or whatever, right? None of these have actually been successfully challenged to the end that this thing has been rejected for what it is, which is erroneous, and to go and look into something else that actually has validity. Do you see what I mean? Whether you agree or not, do you see what I mean?
Yes, and maybe I misspoke when I said improve. Maybe I should say change, right? Because there are, if we're taking general relativity as an example, or whatever other part of the mainstream science, I'm going to use that in air quotes. There are a lot of scientists out there that have, competing hypotheses for what is going on that directly challenge the quote unquote mainstream science.
And what
And
have been
those
the
voices don't get.
what have been the results thus far?
They don't get heard, right? They don't
Oh,
get
so
funded as much.
they do. Modified gravity.
Have they affected any change?
So far, there isn't enough evidence to support other hypotheses, right? So ultimately,
No. See that I would say that I would argue with, and I know most people here could argue with that, right? But has those things that are in direct opposition, have they actually affected any change? Because if the vested interest was, as you say, to get to the truth or whatever, then those things that have come up against them, they should have been entertained. But I would argue or present to you that actually no, that's not the case, and the things that do actually have validity have been unscrupulously and surreptitiously and blatantly just moved out of the way, suppressed, whatever you
Where's
want.
the evidence, though? What evidence are you talking about?
well, hold on, Left Lane,
Jesus,
because
man, everyday life.
because
Science
the
ain't no
thing,
different.
You know what?
well,
This is actually part of the point. This goes back to exactly what whoever I'm speaking with and Witsit were actually talking about. That would be the kind of evidence we're talking about. Things that actually challenge the fundamental of what one quite clearly monopolistic point of view is trying to uphold, and counters to that, which are pointing out the glaring errors in what they're doing. And there is evidence there.
right? And I would like to say that the answer to modern attempts to disrupt GR or quantum mechanics currently is no. Asterisk being the research isn't done yet, right? So we don't know if in the future if they will upset or overtake our current understanding because it's an active field of research, right? And they are getting funding, right? You can go and look up modified GR. I don't really know if there's an active anything going against quantum mechanics now. I don't know if there are any other competing models.
Can I ask?
Go
Sorry.
ahead.
I don't know if Witsit's still here. Witsit, you still here?
He's unmuted.
Oh, if he's not here, then I wanted to ask him a question.
He ran. He got scared.
Yeah. Well, when Witsit comes back, I'd like to ask him a question. But you guys carry on for now.
Yeah, okay.
But even you were saying modern GR, right? That's not opposing GR. That's just trying to update what they think they know or what they've learned over the years with all the incredible amounts of funding and a technology that's tried to be developed to improve it or make it work better or whatever. That's the whole point. Where's the funding? That no matter what, that takes away from the funding or the resources, the time that it takes in labs. That takes funding and the time especially.
Rakia? Oh, they got Rakia. The vested interest got Rakia.
Right, you fight for time just to go in and do any type of experiment in a lab using technologies that you can't afford yourself, right? So when that is put forth to modern GR, yeah, I don't know why you're mocking it. If you don't want to be a part, that's good. Just oppose the view. But I know this is a fact. I mean, this is not like something I'm just making up. I've dealt with it. I've been on boards. You don't have to be on a science board to know how these
You're breaking up, Rakia. You're breaking up. You can hear me.
Is the alternative reality. And there's nothing wrong with it. I mean, I think they're doing the right thing, right? With the funds.
Goodbye, Rakia. They got him, guys.
Well,
I think one of the glaring evidences of this type of discussion is the different people that Whitsitt mentioned. I can't remember all the names, but he was talking about Heaviside and Steinmetz and these kind of individuals. These people were around nearly a century ago, or at least some of the height of the research and active work they were doing was century, if not more ago. So it's not like these ideas haven't been there. If the agenda really was to further the understanding, then why is it that these things, if they are being done, are only being done now, when the proposals and the demonstrations, etc., were done that long ago? Because they're not uncovering anything. It's not like they're uncovering anything new.
Well, I mean, from a classical perspective, right? A lot of those, Maxwell and those guys, they founded classical electromechanics, right? QFT is more accurate than the things that Maxwell and those guys in Tesla were finding out.
Wait, what? What do you mean?
So, for example, right, if you go to, Maxwell's equations or, even like Coulomb's law, those are classical. That's classical electric mechanics compared to QFT, right? They are different theories. And normally on the macroscopic scale, you can use like Coulomb's law and, Maxwell's equations, and they'll work fine, but they will start to break down as you get smaller and smaller. And that's where QFT comes into play.
And QFT says what?
QFT says that reality is comprised of a bunch of fields, and that matter is oscillations in those fields.
And this is why it would be better if Whitsitt was here because of the nature of your discussion prior. But this is why I'm asking you this question. What you're talking about it's not new. It's not what you're talking about that's coming at QFT. The way you just described it, that's not something that these guys weren't aware of.
You're right. I'm sorry. I missed something very specific. They are quantized fields.
And doing action. These people were writing and doing actual demonstrations of this. I think I don't know when it was, but I was reading through one of the interesting things that Tesla was up to in his writings. And what I don't understand is where is the disconnect to the point where people are ignoring that that's the case, and not at least acknowledging that the vested interest is quite clearly opposed to it because it challenges their paradigm.
I did make a mistake, right? I didn't completely explain QFT, right? The Q quantum, quantized, is probably the most specific part and important part that I didn't explain, right? So these fields where things are oscillating, they can only oscillate in discrete chunks, right? So imagine we have a wave, and the amplitude of that wave is in reference to the energy of the wave, right? It can only go in steps of, say, 1, 2, 3, right? It can't go in between, right? That's the new part. That is the new part.
Wait, what new, like as in what?
The quantized part, the fact that these energy waves exist in discrete packets, right? You can only go by certain steps. You can't go in between. That is the new part. That's where the quantum comes
Can't
from.
go in between. You know, like the idea of like quantized packets aren't new. Like Nikola Tesla knew that.
And this is my point. Thanks, Whitsitt, for coming back.
When did
Tesla said that? That's he called them like basically like a condensate, the ether corpuscle.
Yeah, Wesley, now we're back. I want to ask you a question because it actually pertains to this conversation. There was a point during your Brian Myers debate where you were talking about, I think, deriving a value for G from Coulomb's law, and maybe you can expand on that. But I remember him saying you couldn't do that. So does this paper that you've just been talking about address that at all? And if so, what's the result?
Yeah, so this paper does say specifically that by using like basically the energy density value, but basically the electromagnetic energy inside of a vacuum, using that value, you can actually connect the two and show that they are they're equivalent. I think in the debate specifically, I was explaining that basically it hijacked Coulomb's relationship, and then they just claimed that gravity existed, and he said they were different. He was saying that they wouldn't work because it falls off with distance, but you know, there's actually no evidence that what they call gravity is not just electromagnetic that falls off with distance. And I tried to also tell him that you could do it with a kinematic equation. That was the specific equation I had to replace it for little g, that you don't need his idea of gravity to solve for little g. It's super easy. You can use a kinematic equation. But this paper does offer a specific one, like I had to connect the two ideas, which I had never come up with the equation myself, of course, to do that, because I think it simply hijacked it. But this paper is still trying to explain like their understanding of big G overall and what all it needs to do. So yeah, like I obviously I have a bit of a different position than the author of this paper based on that, but
yeah, for sure. But I just remember it being a point where he kind of was mocking you for it. It's like, you can't derive it from Coulomb's law. And I remember thinking, well, I don't know that, but it sounds to me like he's just going nah, but at like a scientific level. And I think this is the point that I was going to make to Dahomey Don or whatever is, I think a lot of these people are tied up in their own ego of what they think they know as well. And so when information that, say, even has like the same phenomena, but has a different explanation for the same phenomena, people will think that they know the first one and therefore the second one's impossible. I think this is an example of that. So he's already tied the phenomena in with what he thinks he knows about gravity. So he won't entertain that it could be something else, you know?
yeah.
Yeah, I can see the issue in that, but if there isn't any evidence for it, right? If the model isn't as good as the current one, then it could be an interesting field of research, but for what people are going to use now, they're going to go with the model that works the best.
Okay, the problem is with what you've just said, though, is that what I said happened entirely conceptually, right? So the phenomena exists independently of the concept. And so if you observe a phenomena and you say that conceptually you understand it, well, if you think you know that, then any quote-unquote evidence that's going to be produced against that is also going to be conceptual in nature.
Yeah, and like, what do you even talk like you can like what do you? I won't interrupt, but this is like I just like you just say like you guys say that stuff, man. It's like what?
Yeah, I don't know why we have to explain this stuff.
Yeah, and it's like if the test works, like your theory doesn't work. If you would even apply just a half of what you guys say to shut down opposition to what you currently hold to be true, it would save us so much time. But you guys just can't do it.
Yeah.
It's weird.
The model works the best. That is the more accurate
By what
way to say it.
metric? By what metric?
By the number of useful predictions it can make. Right? There's things that it cannot predict, but there's a lot of things it can predict.
It's like you didn't understand what I just.
No. I don't think it's hubris, but is there like an ignorant form of hubris, Crypto?
He's not distributing hubris. He's just making a statement that the current model works the best in making predictions about many things. Some things it doesn't predict. But
okay, name what's it predict?
Point.
What's it predict?
Accusing him of being hubristic, but it's like a Dunning-Kruger or something.
I would love to answer what's its question.
Okay, but Crypto's point kind of got it.
Yeah. Before we move on, Left Lane and Dahomey Don, whatever. My contention hasn't been addressed at all with either of your statements, and that's what's so frustrating.
Okay, maybe I don't understand your contention. I mean, I can understand if it feels as if people have an ego about this, right? And maybe it's true. You know, people are people. Some people have egos, and I can't help that part. But maybe I don't understand your contention.
Right. Okay. So I see a phenomena and you see a phenomena, right? That phenomena happened. We both agree that phenomena happened. We have different conceptual understandings of why that thing happened. Okay.
Okay.
That's all I'm saying. So when you say, well, what's the evidence for it? Well, the evidence is the same for both, but they're different conceptual understandings.
Okay, I think I see where you're coming from now. When we ask where's the evidence, what we're specifically talking about is, so you have an idea, I have an idea. We have to make a prediction, right? That in some, exactly how this prediction works, it's a bit more complicated, right? And the evidence is measuring to see if our prediction is correct. And it can't exactly be what we just observed. That would be circular.
Yeah, you guys do with downward acceleration.
But the problem is that if the phenomena is the same for multiple hypotheses, then you're just going to say, well, my hypotheses must have been correct.
Well, to one point or another, it is a little bit of affirming the consequent, right? Like the way the method works is a little bit of affirming the consequence. You can't say with certainty that any given hypothesis is correct because the prediction's correct. But the idea that produces the most valuable predictions and the most useful ones is the one you go with at the current time. And then once something is able to make a better prediction, you go with that.
Could I interject?
But then there's something self-affirming about that if you take in what Elijah said earlier, which is to do with the vested interests and the amount of funding. Of course, when you have vested interests who like a certain idea and they fund it, that is going to have the most quote-unquote evidence that's understood in that way because it's been funded, right? So then you have a self-reaffirming worldview that can't be disproven because of funding issues.
Also, in the way he framed it, that the thing itself is producing the prediction. That's not really how it goes down. A prediction is predicted to be usually because of the vested interest to be in line with what has already been conceptualized.
Yeah, exactly.
It's a sophisticated game of roundabout.
You see, and this is what I was saying earlier. This doesn't happen in reality, right? Because because anomalies exist, right? Mainstream science has found anomalies in mainstream science. That has happened in reality.
Yeah, and how do they address the glaring
No, they're actively being worked on. That is like the people in here. Here's the thing, right? I couldn't tell you how. This is the cutting edge of science. I don't know the cutting edge of quantum mechanics and general relativity. That's not my field of study. I don't know what's going on. Right? As for the frontier,
act like you know I'm wrong, for example. Like when I bring it up.
I'd propose something to you. What you have denoted as anomalies, depending on what you're specifically thinking about, I suppose that could be different. But these things that are conveniently termed anomalies are usually errors that point out, are things that are observations that point out not just minor errors, but glaring fundamental errors in the concepts that are trying to be upheld. And the logical unvested interest perspective and critical thinking approach would be, there is a fundamental error in the concept here. Let's wipe the concept clean and let's start again working with the new information. But that's not what actually happens. What actually happens is a continuation, and it's just pushing it under the carpet, naming it an anomaly. Aside from just accepting, this has completely removed my foundation. I'm now sitting on sand. I need to remix my situation.
Well, what about looking at current technology and where these principles are actually applied and have utility?
But this goes to what
does that got to do?
Yeah, this goes exactly to what Crypto was saying earlier. One is the agreed upon observation and the agreed upon phenomena and the results, and the other is the concept. Just because you put a concept on top of something that actually happens doesn't mean that the two are connected. That's called conflation.
Yeah.
No, I mean, they talk about computers work based on quantum physics.
Are you going to address what I said?
No, I don't think
I mean, what about what I said, where these concepts are actually applied and have utility? They must know something about it, or it wouldn't work.
That's not what's happening, though. That's the conflation that you're making.
Yeah, I think
I would say
I don't think you're really on board with what's being said, Left Lane. I'm not trying to be rude, but I don't really think you're understanding what's actually being said.
I would say that on the technology side, right? If we have a model and you design something before you actually physically build it, and you expect something to work in a certain way, right? And then you go and build it and it works in the way you expect, then it provides evidence that your original model was correct. It doesn't prove that your original model was correct, but it does provide evidence that, hey, if I design something based off of this model and this thing I designed works in reality, then maybe the model is good.
Well, let me give you an example, right? So let's just say that I believe in the Sky Fairy Elisha, right? Just for example. And I believe that everything I do in my life works because of the Sky Fairy Elisha. So I decide I'm going to go on eBay and I'm going to buy a bunch of computer parts. And then I put all the computer parts together. And then I say, if the Sky Fairy Elisha is real, then all these computer parts will come together and the computer will work. Fantastic. So I put the parts together, plug it in the wall, press go. Hallelujah. The computer works. Thank the Sky Fairy Elisha for my working computer. That's evidence for that, right?
No, because you would be missing out on a lot of details. In the prediction, but you'd want the prediction to be quantitative and not qualitative in nature, right? So this Elijah, right, would need to transmit a certain amount of energy to make the CPU work, and you need to be able to measure the energy coming from Elijah. Right? Like if it's just qualitative, then whatever, but quantitative is what we want.
Obviously, Elisha does that through the power cord.
Right. So we would need to measure, right, how whatever this mythical Elijah is doing, right? You'd want to make a prediction that you can quantify based off of something, right?
Right. But the thing is you already have
a answer.
The thing is, let me just finish this quickly. You already have a working computer. You already know what all of the measurements are, and then you can just say it's thanks to the Sky Fairy. And so then when someone says to you, oh, well, what is the output of that? You can say, oh, well, clearly the Sky Fairy Elisha is giving me 44 watts of power for this computer or whatever. Like, do you not understand that, like, you can take what you already know, apply it to something you think is true, and then you can just backwards engineer it?
Well, yeah, the problem you're talking about is affirming the consequent, right? And that's what I was talking about earlier. Yeah, what you're exactly talking about is affirming the consequent. And there is some of that at play. You cannot say because the experiment, the reality matches the prediction that it proves something to be true. All you can say is that there's evidence. And so you could have a bunch of hypotheses that talk about, this is how a computer works. But if there's one model that can do, computers and radio waves and a bunch of other things and has really crisp, clean ways to quantify and test it, then you go with that one because it's the most detailed and it's the most, useful predictively, right? And then eventually, hopefully something else will come along that's better and we'll switch to that.
Yeah, but this is completely
all right,
the problem.
Can I get in here real quick?
1 second. This is completely the issue with this predictive, it's really post-dictive, but this predictive way of approaching things. Because at no point have you isolated the concept that you're trying to prove or trying to affirm. You're just keep it's just a way. It's just a narrative. It's just a way to write a narrative. At no point are you actually isolating anything, concluding anything definitively in a manner that can be accepted as, oh, this is proof of cause.
Well, preferably it wouldn't be like a whole computer. You'd be looking at one quantity at a time. And then in the actual experiment, you do your best to, it's in reality, you can't perfectly isolate anything, but you do your best to try to account for, whatever you can. And then again, it won't be perfect.
It's only,
okay,
so it's only you guys do affirming the consequent. You can't manipulate any variables, right? So if you say, oh, there's weight change with latitude, and then you do the experiment and go measure the weight change with latitude as your experiment, that's affirming the consequent, right? Or is that science?
To be fair,
hold on. Here's
hold on, let him answer.
I can't answer. No, Jeremy has a point. There is an answer. The answer is if you say it proves, right, with 100% certainty, that is affirming the consequent. If you say it's evidence, right, that it suggests that the model is correct, then it is not affirming the consequent, right? And that's why science doesn't prove.
Okay, is that how you do science? You have an effect, and you say, oh, I think this is the cause. There's some cause of this effect, and then you measure the effect all over the place and say, haha, I've now done science.
No. The prediction needs to be different, right? That would be circular. It needs to be.
So if I told you that my experiment for weight change with latitude was I was going to go around and measure different weights at different latitudes, and there's the experiment, shows us Earth's rotating, would you be happy with that?
Not really. No.
Me neither.
It wouldn't be.
Me neither.
It wouldn't be great as a. It would be a first step as evidence, but it would not be great in and of itself. Right? You'd want to have a large collection of different experiments.
But just as a standalone experiment, are you satisfied with that experiment?
Well, I wouldn't be satisfied with any standalone experiment.
Really?
No. I mean, a standalone experiment would say, hey, maybe there's something to look at. But by itself, no.
Okay, real quick. Earlier, why were you talking about big G and then bringing up gravimeters and torsion tests?
And that was the whole thing, right? I brought up different ones, right? I wish I knew off the top of my head all the different ways. If it was just one type of experiment, that wouldn't be as good as all the various different methods that are used.
I'm just curious because earlier I was confused, but then afterwards it sounded like you were confused because you were talking about big G and torsion balance tests, and you were also talking about gravimeters in the same breath. Remember when I said they weren't? It was not constant. Remember when I said it's not constant?
Yeah. So gravimeters measure little g, right? And I guess I didn't fully explain it, but once you have, you're kind of working the math backwards. You find little g and you have your two known masses, or you use little g to find the force, and then you have your two known masses and the distance between them, and from that you get big G.
Yeah, but a gravimeter doesn't measure big G, right?
Well, nothing measures big G. There's no direct measurement of big G. You have to find the force. You have to find the force.
I just now gave an equation to find gravity that's completely derived equivalent to Coulomb's law. This whole
Jeremy and I were talking.
But I wanted to say this 10 minutes ago, and you all this nonsense. You made claims that there are predictions that only your model can make, and that's a joke. It's not. I asked, what are these predictions 10 minutes ago, and no one's gonna say them because you don't have them, and you keep up bringing up 9.8 meters.
We were having a different conversation, and then you interjected, and then you're wondering why I didn't answer you with it. Just like you did with Jeremy.
That was 10 minutes ago, actually.
No, when I was talking with Crypto and Elijah, right? We were talking, and then you asked me for examples, and I haven't gotten to that because we were in the middle of a conversation.
What? You said it predicts things, and he
Jeremy,
asked what predictions.
I'm just saying I dropped one equation super fast that you can use to replace this whole bullshit gravity. You can use electrostatics and perfectly map out any prediction you use for the little g number and the big G number. Thanks for playing.
Did you want to respond to that, or?
Well, I have to read it. I am not superhuman.
So but you agree that if I take big G and little g number away from you, then you don't have any predictive power? So like any type of predictive.
Why would you take big G and little g away?
I'm saying as in you don't have any predictive advantage.
I mean, if you just take away variables from my models, of course.
No. As in, I take it away, meaning you don't have it exclusively. As in, there's an alternative based on electrostatics that gives you those same values. Do you agree you have no predictive advantage with your model?
If that exists, then sure. Well, no. Hold on. I take that back. That would be one part of the model that you could say is equivalent to one another. And being equivalent isn't good enough. You'd have to be better.
Oh, so we have to stick with yours until you arbitrarily determine another one's better?
Not arbitrarily, objectively.
No, wait, why if they have equal predictive power, then why do we have to stick with yours whenever mine can be scientifically proven?
Well, they're the same thing.
No, but mine can be
if they
scientifically
make
proven.
If you have two models that make the same predictions and come up with the same answers, then they are effectively and practically the same.
No, they're not though.
They're not
one of
making
them is
any
built
new
upon
different
something that can be
predictions.
scientifically proven.
The scientific proof doesn't exist. We just went
Yeah,
over
it
the
does.
whole framing the consequent.
Wait, are you saying we haven't scientifically proven that electrostatics exists?
You can't. No.
Oh,
you can't.
we can't. There you go.
No, you can't.
Yep.
If you can show me, can you show me a? Oh no, because the scientific method cannot prove because of what Jeremy and I were just talking about. It's affirming the consequent if you say it's proving anything.
No, you can't prove
it's only affirming
singular cause. You can't prove the cause of an effect. You can prove a cause. This is what I need to answer this question. If you have two theories and they both have the same mathematical predictive capability, but one of the theories is based upon a phenomena that can be tangibly and directly manipulated and physically verified through a scientific experimentation, and then the other theory cannot be, which one's more valid?
Well, the second one has better predictive power because you can
See what I'm
actually
saying?
manipulate
This is how
it.
we know that you're just a zealot, because you can't
How am I
answer
a zealot?
basic rudimentary questions.
Did I not answer it? Did I not answer the question?
You said the second one has better predictive power. The second one that can't be physically verified is better than the
I'm sorry. The first one, I made a mistake there. The first
it's all
one,
good.
I got them mixed up. Sorry.
You're fine. I thought you were like jumping all the way ahead, saying you could tell
No.
I was doing, and you're okay.
No,
so then
I made a mistake.
Okay, so you see the point I'm making then, right? This is based upon electrostatics. That's a variable that can be tangibly and physically proven with scientific. Okay, you don't like the word proof. It doesn't matter. That's semantics. Okay, then we'll use a colloquial use. We can scientifically verify with experimentation that electrostatics can change the weight of an object, can change the vector of an object, can change the downward acceleration rate of an object, and everything's intrinsically electrostatic. I now have big G and little g predictive capability with the electrostatic phenomena. So that's all scientifically verified through experimentation. I can directly manipulate the variable electrostatics, make things float, etc. Now, the alternative is this idea of gravity. Now, it has the same exact predictive mathematical capability, right? But you can't scientifically verify the actual independent variable that you're claiming of the bending and warping of space-time. So which theory is more valid, which one's more valid?
I completely disagree with the premise, is my answer. You can change the mass of the objects and get different forces out of them. That's not changing the mass of an object or switching between objects of different mass is not very difficult.
That's like red herring non sequitur, isn't it?
Yeah, no. Gravity is the independent variable would be mass. It's literally right there in the.
It's literally right there in my
Newton's
equation.
law. No, I'm talking about I'm talking about for the one you said you can't test in reality for some reason. In Newton's law, the two independent variables are the mass and the distance.
Yeah,
and
I
you can
just
change
put it
the
right
mass
there
of
in
an
my
object
equation.
easily. Yeah, the mass of both of them. I know I haven't gotten to your equation yet. I'm talking about mine. You said that I couldn't change it.
No, you're claiming that by manipulating mass, you're indirectly manipulating your caused claim of gravity, which is the bending and warping of space-time. But with electrostatics, we're directly manipulating it. And with this equation right here, right, and this backing, manipulation of a mass directly affects the electrostatic interaction, thus the accelerative rates. So this is specific, and actually the accelerative rate doesn't. This is just to give you a constant, which I don't even believe is true. This is just to show you that I have a better way of explaining your own equations.
Hold on. Mass, the independent variable, causes the bending of space-time, the effect. The bending of space-time is the acceleration. And then acceleration times the mass is squared.
Gravity is the effect of the bending and warping of space-time.
Gravity is the bending and warping of space-time.
No, it's the effect.
Where is that
of it.
observed?
No, I mean, to our current understanding, right, with those asterisks, that is what it is, right? The acceleration is the bending of space-time.
So you're saying
do you understand the fundamental difference here? That one, the causal variable in one of the situations can be tangibly and directly manipulated and verified with scientific experimentation. On the other hand, the bending and warping of space-time can only be inferred and presupposed, which means that the first one is more valid.
No, what's it? So in yours, it's charge. In mine, it's mass. You can manipulate charge and you can manipulate mass.
I don't think he gets it.
He doesn't get it. It's totally
No,
different.
in my paradigm, mass causes the bending of space-time, right? The mass, the thing I can definitely control, causes the acceleration.
First of all, what you think causes acceleration is the bending and warping of space-time.
No, it's mass. The bending and warping of space-time is the acceleration.
Oh my
is the
God.
acceleration.
What a joke. You think that an object falling is space-time.
The acceleration from gravity, right? G, little g, is the bending of space-time.
Dude,
It's
gravity is the effect of, you don't even know the basics of your model. Gravity is the effect. Gravity is the effect of the bending and warping of space-time. It is an effect that is caused by the bending and warping of space-time, which causes a gravity well based on the amount of mass, which acts as basically a railroad track guiding the object down. It is the cause of the effect known as downward acceleration. It is not synonymous with it. You don't even understand.
Hold on. I'm not saying it's synonymous. I'm saying that an object that goes into a gravity well, right? It's following its shortest path, its normal straight line path, but it's following the geodesic. That geodesic arises from the bending and warping of space-time. So the bending and warping of space-time is making, that is the acceleration. That is where the acceleration is coming from.
You see, you almost slipped up and said it's making it fall, and that's what your actual model says, is that the geodesic path is created by the bending and warping of space-time, and then the object follows that geodesic path and then accelerates relative to that geodesic path. It is not synonymous with the geodesic path. Yeah, you don't even
that geodesic path is so in relativity, right? If we're in a just take 1D for right now, right? If you go into a gravity well, then that means the distance that is being traveled is changing as you move through it. So you're moving in a straight line at a constant rate, but the actual space, the distance between 1 meter is physically changing. And because your distance over time is changing, that is the acceleration, right? If that makes sense. The distance part of distance over time.
Gravity is the effect of the bending and warping of space-time. Bending and warping of space.
I have done an experiment on this myself. Okay, I filled the room with smoke, and I walked through it, and I bent space-time because I can never be in the same space again because the air has moved around me.
There's not what they.
And it's fascinating to see it happen. And it's not space-time. It's just space. It's just space.
They claim that the air fills the space, right? They claim
that would be air.
Well, the air
that
does
you're moving
fill
around.
the space if you actually fill it with if you and I'm saying light smoke, so you can see the air move, and it moves in circles and things like that. It moves in a different pattern than we would ever imagine that it would move. And I watched this, and I was fascinated by it because every time I moved, it spun the air different ways and everything else. And then I realized, oh, this is what they are explaining by this concept of space-time warping and all the other stuff. It's just, if you stand at your kitchen counter and wash dishes and you go back the next day, if you had this smoke and you could see the air move and everything else, you would know that you're not in the same space because everything's changed. So
I think we're using the word space differently. When I'm talking about space, I'm talking about the distance between objects, not like
this
the
is the
space in my
distance
room.
between. Yeah, but there's no changing the distance between the objects in your room. I mean, even within the smoke, I can measure from my sink to my kitchen chair, and it will be the same every day unless I move the chair.
Right. Yeah, that's no one would disagree with you on that. And what's it? So I'm finally getting around to your derivation, right? And maybe I'm missing something, right? So you say FG equals FE, and you have so you're trying to you're trying to balance Newton's law and Coulomb's law, right? Let's start there. You're trying to balance those two laws, right?
Yeah.
Okay, so you have, but you're dividing both. In order to go to the acceleration, you must be dividing both sides by m2, which is normal. And then you have gm1 over r squared equals kq squared over 4r squared. Where did this m1 come from?
Just a second, what's your question?
So you have so if you go back to 502 where you pasted this, right, you're trying to balance Newton's law and Coulomb's law, and it looks like you divide both sides by m2 to go from force to acceleration. But then on the left side, you have gm1 over r squared, and on the right side, you have k squared over 4r squared, but then an m1 as well. And I'm trying to figure out where this m1 comes from.
Okay, so now we can derive the acceleration due to gravity from Coulomb's law by considering the gravitational force between two masses at a distance.
Right, but no, I'm talking about that specific step. Where did this m1 come from?
What do you mean? Where did it come from? It's a theoretical example with two masses.
Okay, but like in Coulomb's law, Coulomb's law doesn't have mass in it.
Yeah, we integrated the the mass of basically like the distance between the edges of the proton.
Wait, you just added it to the equation. You just changed Coulomb's law. You have 4r squared over m1.
Dude, that's the whole point. It's drawing the equivalence.
So you're trying to use Coulomb's. So you have k squared over 4r squared. That is Coulomb's law, right? But then you also divide it by the mass, right? That gives you an acceleration, right? When you divide Coulomb's law by the mass, it gives you an acceleration, right?
Yeah, you have the point charge.
Okay, actually, I'm sorry. In this example, you divide by m1. That's how you get to acceleration. But on the left side, you still have m1 over here. You should have divided both sides by m1, right? To get to the acceleration.
Wait, which one were you at?
G equals, basically the line I'm on is G equals gm1. I'll just post it in the chat instead of saying it over and over again. This is the line I'm on at 502, right? I'm trying to follow your math here. And I'm not seeing how because you're balancing Newton's law and Coulomb's law, and you've divided something, but it's not equal on both sides. Those two functions are not equal on both sides. You've either added m1 on one side or forgot it on the other, or forgot m2 on the other, and I don't know which one happened here.
M2.
Yeah, because that's part of Newton's law.
Yeah,
you have m1 and m2, right?
Mm-hmm. Okay, so you have the point charge, right? That's being generated by the electrostatic force, right? So then you have a force between the 2 point charges, which is based on the magnitude of the charges and the distance between them, Coulomb's law, right?
Yes.
Okay. The charges do not have a mass themselves, right? In our current understanding, I mean, technically they would resist acceleration, though. So do you see this require basically a mass charge equivalence, which is actually correct?
With that, I'm specifically talking about the math, right? How did you get to this step using algebra? That is my question. Using algebra.
Which part?
What you have here is algebra.
Which part is that you're saying is wrong?
The part I put in chat, right? I mean, if I can put it up on my computer and we can walk through the algebra together. At least what I think is incorrect.
Okay, why can't you just say it again? You're saying something should have been divided on both sides. What are you saying?
Okay, so you have this step above and you have this step below, right? But that algebra does not work, right? On the left side, you have gm1 m2 over r squared. On the right side, you have q squared over 2r squared. And then on this next step, m2 on the left is gone and M1 on the right appears. And I'm trying to figure out what algebraic step you took to get from the step I posted to the step you have here, right at 520. I'm trying to find the algebra between these two steps. What is the? It's at 520. It's really recent, right? I copied the two steps that I'm confused about. I'm trying to find the two. I'm trying to find the algebra used to get from one place to another.
Is it because there's a usage of M1 on both sides because what you're trying to do is solve for the equivalent portion of Coulomb's law where you have two charges that are the same? Is that why M1 is being used on both sides and not M1 and M2 like you're trying to ask, Don?
Well, no. What I'm saying is, and it would be better. Maybe hold on. Let me just write it out, right? Because he has this. He has FG equals FE. So let me actually just write what that is, right? So that's G M1
there is no M2.
2 over R squared. On the left side there is. For FG, there's an M2. And then you have KQ squared divided by 2R squared, right? So this is the step, right? So that right there is the step, which is FG equals FE, right? These two statements, FG equals FE and what I just posted, they're equivalent, right? I'm just substituting the laws into each other, right? I'm trying to figure out how he got from 522 to this here. From 522 to 522, I guess. Right, what algebra? What is the algebraic step that Whitsitt took to go from there to there?
Wait just a second. Let me look at it. This is just pasted from notes. Okay, so you're asking basically why is the right side of the equation not divided by M2?
Well,
Okay.
not quite. I'm asking how you got from GM1, the equation I have at 522 to the one below Gleams, right? That's what I'm asking. What is the algebra used to get to that step? That's what I'm asking.
Wait, what? Well, I'm
Okay,
not seeing the problem.
Okay, I'll put it in chat, right? So I'm gonna paste the two equations in chat, right? Okay, so at 523, I have two equations here, right? We have, this is what you posted earlier. It is FG equals FE, right? There shouldn't be any contention about that. And then right below it, I'm trying to figure out what algebra you used to get from that first one to that second one, right? That is the exact question. I don't know how I can make it more specific.
I'm trying to get it all written out back to back. A second. Look at it. Because I hate the way it looks in these little jumbled up nonsense.
Yeah, if I could it would be better if I could write it out and share my screen somehow. I don't know if I have. I guess I could open Overleaf. Maybe it would look better on Overleaf. Or Paint. I don't know. I'm not very good with Paint and a mouse. It would look even worse, honestly. Oh, Symbol Lab. I can do it on Symbol Lab. Hold on. Symbol Lab looks nice. Oh, does Symbol Lab not have subscripts? Oh, that's unfortunate.
Here, I think I got it.
Okay.
I'm saying I think I have it in a different part of notes here.
Oh, okay. I'll keep doing this then. Just to do it in a prettier form. I agree. Doing it over text does look pretty ugly.
There it is in text again. So this is much more laid out here. Let's see.
Well, just wondering, would you be able to like just demonstrate the algebra?
You want me to share screen and write the algebra out?
Well, you don't have to share it. Your screen, you can write it in text. I know it looks ugly, but I would like to see the algebra.
The algebra is right there, written down in like step by step. So tell me what you think is wrong.
It doesn't work.
Why though? Like each step is explained right here. I don't see the problem.
You don't see how these two steps are not algebraically equivalent, right? What you do on one side, you have to do to the other. If you divide both sides by m1, then the left side should still have m2. If you divide both sides by m2, the right side wouldn't have m1. That's the issue, right? So on this step in the chat, you can do all sorts of algebraic things. You just have to make sure you do it on both sides. So I guess I'm asking, are you dividing both sides by m2 or by m1?
I'm pretty sure you do both. You end up doing both.
Okay, then m2 would be on the right side.
Okay, so m2, and this is why I obviously don't hold to this equation whatsoever, is talking about like the mass of the Earth. Okay, so you just have m2 like equaling m being the mass of the Earth. You have m1 being used as like the mass of protons, and you're going to make the equivalence between like the diameter of the proton and the mass, and you're going to use the charge equivalence with the point charge. So it's just like m2 equals m, which is like the mass of the Earth. So you substitute the value of m2 into the electrostatic force.
So you have an equation for m2. M2 equals something.
M.
Okay, but M2 equals M. That doesn't. Then you should have a M on the right side. You have an M1, not an M.
Okay, go to step 13 here. Oh, it's not numbered here. Substitute the value of M2 into the equation for electrostatic force. So right above that, you see cancel out the common factor of r squared from both sides. Solve for M2. M2 equals M. So the mass M2 in our original equation is equal to the mass of the Earth, M. Substitute the value of M2 into the equation for the electrostatic force, and that's where you're going to see the capital M divided by r squared. So then you rearrange that equation to solve for G.
Hold on, wait. This is a new thing, isn't it? Hold on. Yeah, so you have that. You have K. Yep, K Q squared over K times Q squared over R squared G and 1 and 2 squared. K, cancel out the common factor of R squared. That's fine. Then you have F equals G M. Okay, that's whatever. G equals M1 M1. Okay, that's kind of redundant, but that's fine. What? That's okay. M2 equals M. Could have just substituted that. That's fine. Rearrange the equation to solve for G.
I can think of several ass whippings I took in high school that is more fulfilling than what's going on right now.
Yeah, I don't believe in this equation because it assumes a mass of the Earth. I'm showing that you can easily just take electrostatics and replace their whole paradigm. The reason that it can't be done, though, is because at immense distances, it's well known electrostatics would never be strong enough to make a planet's orbit.
Where does it say that? So you're rearranging to solve for G from where? Right. What's man, I can't. It's not numbered. Where is it?
Yeah, let me take a screenshot.
Or it would be Christ. Where did it go? So okay, yeah. You have K. No, here. Rearrange. Yeah, here you have rearranged to solve for G, but little g. You don't have little g in the equation, though. But I mean, that is the definition of G, though. G equals, that is the definition.
Pretty sure these are both from the same thing. See, I'm not looking through all my papers. I'm just not going to look through all my papers to find it. This is someone else's electrostatic theory, though. I don't remember his name or anything. I have a paper about it, though. I have another thing pasted here, but I don't know.
Yeah, I'm just trying to
I don't
go
know if
through
this is the same paper.
I'm trying to go through the math here.
I'll paste one
And this
more.
is different. This is a different derivation. Than what
Sure
you
the
had
first one just
originally.
skip steps, though? Or is the first one skip steps, or you're saying it's different?
Well, no, because the first one didn't have the first one doesn't equal that, right? What I just posted, that does not equal the first what you had in the first derivation, where you had this. That's not equivalent. Those two are not the same. But for this one, you have. Wait, no, it's what in the world? Did you add another one? Okay, here. You don't need these values. Okay. This was in a paper.
Yep.
They do the algebra really weirdly here. I guess it's. Wait. These last steps here, I'm not following. Okay, so these are the last steps of, I think it was like the second one or whatever. Or maybe it's I don't know, you've posted multiple times. I think this is the second one. So you balance the two sides, right? FE equals FG. And then you define, it says rearrange here. I'm going to assume they mean define little g as that, which is normal. But M1 here would have to be the mass of the Earth and not M2 for that to be correct. And then you substitute the values of K, Q, R, M, and M1.
Doesn't really matter which one is which, right? Like, it doesn't matter.
Yeah, no, that's what I'm saying. It's fine. But you have substitute the. Okay, so they take out G M1 over R squared. So you still have little g times big M, and then you divide M, and you get they got a value for the gravitational acceleration.
Oh, look, there's
for
another one. Electrostatic solution for gravity
charge.
force and value of G. I don't know if this is where I got this equation, but Glean posted another one. See, I don't even care
how many?
I don't care because it assumes the mass of the Earth. The actual point is that there's not some exclusivity or advantageous position of the mathematical predictions of the current theories of gravity. That's a misnomer. There's Glean posting another one.
I have to go through each one individually. I am not.
I mean, is this gonna click for you though? Like, if you see any of these equations drawing an equivalence with electrostatics and gravity and actually working out, are you gonna understand the point?
If it works out, then I mean that I would definitely look into it more. But I can, like, the first one, the algebra is just straight up wrong. I was trying to ask how it works, but the algebra is wrong. The second one, I'm still trying to figure out what they did, and then I'd have to look at each one individually.
It's all
right?
good, man. Do it in your own time, bro. Like, I'll try and send you the papers. I can find them.
Okay.
I'm not gonna look right now though.
I can go through. I mean, I'm not just going to say it's wrong and not look at it, right? That would be pretty dumb to do. I don't mind looking at it, but it does. I'm not superhuman. Although, I mean, for your second one, right? I mean, they explicitly use big G, and then also Q. They use both to find the gravitational acceleration. Wait, why would they put big G there? Okay, no, maybe I'm not understanding the second thing you posted.
I'll get you the paper, dude.
Could you do the algebra?
Maybe, yeah, but I'm not about to. Not in this text form for sure. I'd have to like write it out. I'm not
Okay.
about to.
Because I can't. At first, I thought they were substituting little g back into that equivalence, but here they have big G in their calculation, which doesn't make much sense. Because, I mean, if you were to do what this paper is saying, it's, at least from what I'm getting from the steps you have here, you should do k times q squared equals little g. That should be what you're solving, according to the algebra.
There's a paper.
And then you should still have an m. You should still have a big M. Is that the same paper that Gleam posted, I wonder?
Yeah, it says Gleam's paper.
Oh, no, they're diff an electrostatic solution for gravity force. Okay, yeah, they are the same paper, aren't they? No, what?
Mhm.
What? No, they're not.
Are you sure? The same title.
They have the same title, but one has a figure, the other one doesn't. Maybe they just
Morton
didn't include
Spears.
the
I'm
figure.
pretty sure that's the one Gleam always posts. Morton Spears.
Morton Spears.
Yeah.
Oh, yeah, they are the same. Just one has a figure and the other one doesn't. Weird. Okay. Okay, yeah. Well, I don't mind looking through this and seeing how they try to derive G. Yeah. Out of curiosity, has anybody here gone through the paper and make sure that the numbers for G are equal to the measured value of G?
Yeah, it's like it's like 6.6656, 6.6685, 6.6725, 6.68, 6.71. So
Yeah. Those are the measured according to this paper here. I don't even know when this was written. Probably recent. No, 2010. Okay, that's recent.
Well, you have the difference in the currently accepted value in Spears electrostatic units being 6.67259 compared to 6.68541.
So we have so that's a GE here, right? 6.68541.
Yeah.
And then so if we do the percent error calculator, because I am too lazy to do percent error myself, we take the predicted value of 6.68541, and then the accepted value of, I don't know, what is the accepted value of G?
6.67.
Oh God. Google, I didn't want little g, I wanted big G. Plus or minus 0.0. Okay, I can even, actually it's right here. I don't even need to do the percent error. So that is the accepted value. Oh, times 10 to the negative 11. Sorry, I didn't grab that. I mean, but we all know it's time. And then this is, if you're saying this GE is the predicted value, then they got it wrong. See here? That's supposed to be a times. Right here, right? If that's GE, and this is measured, I'll just call that GM as measured, then GE is outside of GM, which means they got it wrong. That's not me like making it up, that's just numbers. Right? Am I missing anything?
Like, what's the plus or minus? Like, how much is it off? I'm just reading something else, dude, and I don't care about that.
I put it in the chat. It's 4 decimal places. No, wait, 3 decimal places, and then a 1.5. That's the current plus or minus. And of course, it's that margin of error times 10 to the negative 11. Of course. Right, but so they didn't get G. They got the wrong value.
You don't have enough decimal places on here to see it.
What do you mean? It's in scientific notation. They have what? It's 1, 2, 3, 4 after, and this is. I mean, but this is wrong on the second decimal place, right?
Yeah, but to really see how much it's quote unquote wrong, I mean, like if you actually look into the accepted value of G, right, and you actually look at how it's derived, anything that's extremely close to it is fine. In reality, in actual reality, when you look at experimental analysis of the accepted value. So, like, how you think that we're experimentally validating this? If you dare even utter the word Cavendish, then you're gonna absolutely blow this margin of error out of the water. It's not even going to be close.
I don't think they use Cavendish. I'm not exactly sure
That's
how
what I'm
this
trying to tell you, dude. That's why, like, you can't just look it up and be like, oh, this is the accepted value and the margin of error. The way that they do it, when you actually look at any experiment trying to get evidence for it, it's all around this number. It's outside this error of margin all the time. It's cherry picking out of 50 attempts and then being like, look, I got it. It doesn't mean anything. Which goes to show you that there's always a fluctuation. It's almost impossible to get the number that's right there, although it should always be exactly specific to the amount of mass, and it's not. Shows you that it's actually not universally constant.
You mean within well-controlled modern experiments, you're saying that they're getting values outside of that plus or minus
you'd have to be really
0.00015.
specific here if you're gonna, Like, well, I don't know. I mean, I don't know
Okay,
what
I'd have
systems
to.
you're gonna bring up. Like, say you want to bring up LIGO, not a good idea. Like, say you're gonna bring up Cavendish, not a good idea.
I wasn't using either of those. I mean, this
I'm just explaining that.
this margin of error comes from Britannica, right? And maybe we'd have to look it further into it. Maybe the margin of error is really wider than what Britannica is saying. But I guess we'd have to look into it more to see if Britannica has the right number. But I mean, from what I can, even so, right? I mean, it's 2 decimal places. GE is different from 2 decimal places. Is off 2 decimal places than the accepted value. That's not particular. I mean, that's good enough for like a high school experiment, but that's not particularly great.
Yeah, what I'm trying to explain to you is that, and you look in the real world, this value in any experiment changes relative to location. Okay, so it isn't constant. It isn't universally constant. It changes with location.
Do you have a paper to support that it changes with location?
Yeah. I mean, like, all gravity readings ever change with location.
That's little g. I'm talking about big G.
Okay, big G is calculative upon what?
The little g and the mass is in the distance. If there's more mass, no, listen, if there's more mass, then little g goes up. But if you have more mass and you have bigger little g, then g is going to remain constant, right? If the mass is going up and little g is going up, big G doesn't need to change.
Yeah, so you're saying that downward acceleration changes?
I'm saying little g can change without big G changing.
Yeah, if it's directly proportionate to mass, but I thought the downward acceleration was constant.
No. Little g change. I mean, that's acknowledged. That is acknowledged. Little g changing is acknowledged. It doesn't change much.
Is it acknowledged within like the realm of actually making the physical theory make sense? Like,
it's measured.
Does that happen? Yeah, but it's measured. But how does that happen? It'd have to be directly proportionate to mass.
Yeah, I mean, some places on Earth have lead underneath your feet. Some places on Earth
every time I do the test,
natural gas.
The same, right?
If different locations on Earth have heavier metals underneath your feet, and that's
so
going to change the value.
Location, dude, bro, I get it. Okay, you have different mass distribution at different locations. So if I go to one location and I stay there and I keep doing it, I should keep getting the same number. But we don't.
Well, that depends on the mass around you, right? If there's more mass moving around you, say it rains, or say, I don't know, if there's an explosion, not an explosion, an eruption, right? Little g can change. But little g can change and the mass can change, and big G can remain constant. But I've never seen any papers talk about big G changing with location. I'm aware little G does, but I haven't seen anything about big G changing.
Well, if little G changes at the same location, then big G would have to change, unless you try to find some excuse as to like mass changing around you, like you said.
And well, yeah, like rain.
Yeah, but what about wind?
I don't know if that would be strong enough. That's probably not going to introduce enough mass.
Right. Well,
in your
what
area.
mass would it introduce? Like a little bit of air? Is that what you're saying? Because it just moves the air around. Or
well, that's what I was talking about. Rain. Yeah, rain. If there's more accumulation of water,
but
in your area, that'll change the mass.
With wind, thunderstorms, lightning.
Well, I mean, in a thunderstorm, all of that seems analogous to, a lot of water being in your area, right? I don't know if you're talking about like a clear, windy day, but from the way you're talking, it sounds like it's in the middle of a thunderstorm, which God forbid that's not messing up your reading in the first place. And then, it's lightning, which means there's probably clouds around, unless I don't even know if it can lightning without clouds. If it's a thunderstorm, it's definitely clouds around, right? So you got a bunch of water, extra water in your area. So the mass does change. And how much is little G changing anyways? Like, it's got to be.
It's all relative.
Pretty small. I mean, yeah, but like in relation to what, like plus or minus, right? What is the plus or minus percentage that it changes?
For all these different experiments, man.
You got to be
the general standard of that you're asking.
Well, you said that little G changes with time. What is like the percent change? If it's absolutely minuscule, then I mean there could be a ton of reasons.
What is minuscule? You got 9.81. You can measure 9.73. Consider that minuscule? Just a second ago, that's not minuscule, right? So.
No. Hold on. For one thing, we can use a percent difference, right? And then we can be more objective, right? Anything more than, I don't know, 0.1 or 0.01% would be not minuscule, right? So anything below 0.01% change from the accepted normal value would be minuscule. That would be an objective way to define it. But we're talking about with time, right? With location, there could be all sorts of reasons why. We talked about that before. But with time, how much is little G changing in time at one location?
Like I said, it'll go down to like 9.73, 9.72, 9.
In time?
What do you mean?
What paper? So we're sitting at the same location, watching our gravimeter.
Yeah, they just
we're not moving it around.
About what's going on outside, or what they think there's some type of anomaly going on electrically with the device, or they have all kinds of excuses. That's not the point. The actual point is that you guys have stacked the deck. You stack the deck where when the measurements don't match, you just say there must be something else going on, and then you're given free reign to speculate as to why it didn't match.
Well, can you show me this paper that shows a gravimeter at one spot changing its value that large?
What does that large mean?
As I said, more than plus or minus 0.01%.
0.01%?
Yeah.
Okay, I'll see. What
so 9.72, 9.73 would be significantly greater than
definitely
that value.
Second.
In time, I know I have heard of it changing like so many decimal places down, but 9.72, 9.73, like, is this over the course of a day that this is happening?
Yeah, I already told you that they just come up with excuses.
Well, like, irregardless of the excuses, are these changes happening within the course of the day, of a single day, or like what's the time scale we're talking about? Days, months, weeks?
No, it can happen in one day, yeah, just based on something happening outside. Is what they normally claim.
Huh.
Even when it doesn't rain. Like when a thunderstorm passes overhead, but it doesn't rain. And actually, they show sometimes that the change is consistent whenever it's like lightly raining and when tons of rain falls. That the change will be the same amount.
The change will be the same amount.
Yeah, that doesn't
for
work.
Light rain and. Okay, yeah, I'd have to take a look at this paper.
You know why though, bro? Because gravity is just electric.
I mean, I would love to take a look at this paper before I'm drawing any conclusions.
Okay. Because like if you even go all the way back to the heart of the issue, like if you go all the way back to Cavendish, like well, when was Cavendish? Like the 1700s?
1700s, yeah. They didn't exactly have our level of precision back in his day.
And then you have like it's like Schalian or something like that experiment. You know what that is?
Yeah, the Hellenian experiment, the one with the really circular, conical, or symmetric mountain, right?
Yeah, like if you compare those values that them two got, there's like a 20% difference.
For between those two, when was the Schalian experiment conducted?
Similar time, a few years before, maybe a decade before it or something.
Schalian experiment.
Maybe 2 decades before it. I don't know.
Let me see. Okay, that's completely useless. 1774. I mean, the 1700s. They didn't exactly have precise measuring equipment.
20%, bro.
Yeah, with not precise measuring equipment. That's why I'm restricting it to like modern day measurement. You know, we've gotten a lot better with measuring in general. I wouldn't really expect measurements from the 1700s to be that good. Also, I mean, they were, for the Mount Schalian experiment anyways, they were estimating how much mass was in the mountain because it was really symmetric, but I mean, it's not perfectly symmetric anyway, so there could definitely be a source of error there. Where do they get? Okay, yeah. Yeah, no, I see it here. Schalian, 20%. Honestly, that doesn't surprise me. With 1700s equipment and the assumption that they made that the mountain was symmetric.
It's just funny though that Glover's bringing it up until I point that out. That's all I'm saying.
Oh, well, I mean, it's an interesting thing to point out qualitatively that the pendulum did swing towards the mountain, towards the, more massive object.
You mean towards the object in close proximity with electrostatic charge? Yeah.
I can't honestly for this. We couldn't say one way or another because this wasn't exactly well. Did not.
Neither was Cavendish. Cavendish didn't even account for electrostatics. He just ran away and then pulled out a telescope.
Which for precise measurements, that's why I've been restricting it to modern measurements.
The most modern precise Cavendish experiments show an observed discrepancy over 10-fold the predicted error margin.
You're going from 1.2% to 0.12%, and it's even less than 0.12%. Yeah, so it got 10 times better. That's great. I'm glad that over the course of 300 years, we got 10 times better.
I had a Scientific American article explaining that it's like the predicted error margin is like 40 parts per million. And when they do the experiments, they observe up to 10-fold that.
They are experiencing 400 parts per billion of error.
Yes, as opposed
that's not normally that's not normally how margin of error is recorded. That's a bit of a weird way.
Okay, well, I'll just
describe it
here. There's so much stuff to drop you. I'm trying to do something, but yeah, dude, it's just like in this arena, people pretend Cavendish always works real consistently. That isn't correct. That's patently false. And every single time an anti-flat earther does it and throws it on YouTube, they don't show you the measurements. They're not really precise measurements, or they intentionally leave out the times it didn't work. They didn't even get close. And they're like, oh, close enough. When you look into it, right, it's one of the most inconsistent experiments on the face of the earth.
Yeah, I would need to look at that because that's completely not consistent from what I found of the margin of error being plus or minus like 3 decimal places to 1/5 times 10 to the negative 11. That's pretty good in my book, but I'd have to look more into it. I know for the other fundamental constants, we have more decimal places, but I would say what we have measured right now that's pretty good. Certainly better than I could ever do. I don't have a device that can measure that accurately. This one's from the Royal Society. This one was talking about only 0.7% higher. And that was an issue. They were saying it's an issue that it was 0.7% higher. What 0.7% is. Let's see. What was the margin of error?
And of course, the funniest part of all this is that the predicted movement is so small, right? That it's so easy of a prediction. You just stack the deck. It's like the predicted movement's so small that it's like, oh, look, it barely moved. There you go. It's like, oh, it barely moved less than it barely moved. It's like, oh man, how fascinating.
I mean, from a qualitative perspective, sure, but if there are devices that can measure that accurately out there, then I mean that's like the whole point of like NIST and all these standards. Their whole job is to come up with more and more ways to measure values even more precisely.
Dude, I'm saying as soon as it goes the wrong way, they just throw it out. Just assume user error. Cavendish is the number one way to do Cavendish is to just automatically assume user error. Everyone knows that. You just it's such a precise and delicate experiment that you just automatically assume user error if you get anything that you're not supposed to get, pretty much.
Well, to your point, it is very delicate and precise. That's why I'm personally restricting it to the modern professional ones.
It's Texas sharpshooting fallacy. If you throw out every single thing that doesn't fit within your predicted outcome, then you throw it all out. That's Texas sharpshooter. Oh, it's just all user error. How so? What happened? I don't know.
Hold on. If you have conflating variables affecting your experiment, then you got to account for those, right? If you're just a college student in a classroom, then the air current could have been affecting your measurement, right? And you don't know if it is, but you have to write it down anyways because it could, right? That's not a fallacy. That's accounting for the fact that nothing is perfect in reality.
The story from the end of 22 and the beginning of 23 here in California. This Berkeley, California.
Left lane, you're killing me with the news, man. We don't listen to the news.
Oh, I'm sorry. Yeah, I'm not used to being on my phone. It picks up everything. Sorry.
It's all good. I was just like, you're shooting a weapon at me or something.
I wanted to know what was happening in California.
Dude, I wanted to immediately get him muted, dude. I felt sick.
I don't even know what world metrology is.
I'll be right back.
Okay, here we go. So this paper was sent to me, and they are quite thorough. I'm trying to look for where they get G in their uncertainty. I must divide 104 by a million. That must be what they mean by that. Okay, so this paper here is saying that they got 106 parts per million uncertainty, which I'm assuming when they say a parts per million, you just divide 106 by a million. Yeah, I mean, I know Witset's not gone, but I'd say that measurements are pretty good, a lot better than what was predicted by that one paper.
So back on that equation, what did we determine? Was it a bad equation or what?
So the first one was, I mean, maybe I was a little bit, prickly. I don't know how to describe it. The first one was just wrong. The algebra was wrong. If you go back and look, those two things can't equal each other. The algebra is just straight up wrong. The second one, I'd have to scroll back up. The second one, I'm not even sure how they. So it's this one in the chat. I don't even know how they made this leap in the algebra because they go from.
Yeah. Did it come from a paper or something?
What's it said this came from a paper? It's pretty shoddy algebra if it came from a paper.
That was my concern.
Yeah, it's pretty. The algebra is not good. I don't even know how they. Because apparently they're substituting G. I think they're substituting G back into the original equation. But if they are, they're supposed to be solving for little g. But they have big G in their calculation, even though it shouldn't be there. That just doesn't make any sense. Yeah, that algebra is wrong, or I'm missing something as well. And then the third one, the one that Gleam and Witsit sent, those just have the wrong value of G. Like GE that they have in the paper is just wrong.
Gotcha.
Wait, is Gleam in the voice chat? He seems to be responding like he is.
Mm-hmm. He said that's not the equation that he posted or something.
Oh, well, earlier y'all at least the authors were the same. I was wondering if it was the same paper because they one had a figure and the other didn't, which was a little weird, but they did have the same author. It was that guy who's starting with an M. So I'll go ahead and read this from Nature here. So, Gleam, what I'm gathering from this paper in Nature is that they're measuring the force between this thing they call a matter wave of like cold rubidium atoms to a tungsten cylinder, and using interferometry to actually. They also don't have any derivations or in here, but this doesn't look like anything to do with like an electric form of gravity. It looks like they just had a completely new method, which is pretty cool. I didn't know about it.
Why are they using parts per million? I don't know. Parts per million of what?
Yeah, that was weird to me as well, but I actually, in this paper by Nature, they have a conversion right here. So that's the conversion from parts per million to a percentage. I guess it's just a easier way to write it.
$15,000%.
Pretty good.
Pretty tight.
And interestingly enough, though, I mean, this is, I don't know when these two papers, well, this was written in 2014. This BIPM one was written in 2014 as well. Okay, so that makes sense. BIPM got to 106 parts per million. So it's coming down. Yeah, Gleam, they're just measuring the value of, that comes from the paper from Nature. They're not deriving anything new. Oh, but the one from G, yeah, so this is the one where, yeah, they get a value for GE. The value for GE that they get in this paper from, I don't even know what university. What is IA State? I don't know. Iowa? I don't know. This is wrong. This value that they predict is wrong. So this is what they predict in the IA State paper, and it's just incorrect. Well, I mean, you say that, but it seems as if maybe there was an odd timing, Gleam, because this Nature paper says that the uncertainty was 150 what was it, parts per million. But then this BIPM paper that also came out in 2014, they got 106 parts per million. So it seems as if maybe this Nature paper was unaware of the current research, because these were both released in the same year, and so maybe they just they didn't realize that there was a better. Okay, right. No, I'm saying, I'm saying the one from Iowa State, right? That one, irregardless of anything else, it's just wrong, right? That one's just wrong. The one from Nature is the one from Iowa State. They get the wrong value. Like the numbers aren't the. I don't know how much more objective you could get. The number is incorrect. The one from Iowa State. They give you the number, this number here. This is from the Iowa State paper. I can take a screenshot. That number is incorrect. I cannot possibly be more objective than looking at two numbers and saying these numbers aren't the same. or this number is not within this range. I can't get any more objective. I mean, I'm glad he tells us why, but that doesn't change the fact that it's wrong. So he tells us why it's wrong. That's wonderful. It's wrong. I'm glad he recognizes the reasons why it's incorrect. He has a figure. Are you saying that this GE number is not the actual number? Is there some other GE number we should be aware of? Because this is the GE. I can take a screenshot. I'm pulling this GE number directly from your source. Is there some other GE number? If it was correct, that would give, credence to the idea that he was correct. But so long as it's wrong, we can't do anything with it. It's wrong. I don't know how much more objective I could possibly be. Okay, well, I mean, I'm glad he had a hypothesis, but until we have a number, a predicted number that's within the range of the current measurement, which would be the closest I've seen is 106 parts per million, but that was back in 2014, which crazy enough, that's a decade ago. So that might be even better now. This is outside of that range. So until we see that number, we can't work with this. I'm expecting it to be within the range. So whatever G is plus or minus 106 parts per million. That's what I'm expecting. If it's correct, that should be the number. I mean, it could be. Maybe the way we see relativity is wrong. Maybe there is extra mass out there. We don't know either way yet. There's evidence on sides for both. Gleam, the current, I have it up here. This isn't even, so your Nature article, which actually is incorrect, the current measured value is this much. That's the margin of error. Anything outside that margin of error is wrong. And again, the one from BPIM, they got an even tighter margin of error than this value. Anything outside of that is just not correct. That I don't know of I couldn't possibly okay, I shouldn't say Nature's incorrect, right? So this article came out in June of 2014. Okay, I should say outdated, right? This article came out in June of 2014. So here, I'll put the two papers in. The Nature article came out in June of 2014. This Royal Society one came out in October. These are the two ones. These are the two papers, right? The Nature one says that the state of the art is 150 parts per million, but this Royal Society got it to within 106 parts per million. But again, it's because one came out pretending. I'm just reading off the numbers and the dates. What is there to know? I'm so confused. I'm looking at the dates, and you can click on them and see the dates, right? This shouldn't be surprising. Between June and October, there was a better measurement. Parts per million is different in every country. I don't know why country. They just have a more updated measurement, right? Time passed. It got better. That's the uncertainty. The uncertainty got better. The value of G didn't change. The uncertainty changed. It got better, as things tend to do with time. The uncertainty got better. This shouldn't be surprising. It's getting better with time. Again, this is a decade ago, right? If we look at modern experiments, I would not be surprised if the uncertainty got better. Yeah, that's what I'm saying, right? So these guys from the Royal Society did it better than the average. So good on them. Even then, we can work with 150 parts per million. When I compared it to GE, it's outside of that, right? If you want to use 150 parts per million, we can. It's outside of it. I don't know what else I could possibly say. And then the Royal Society found a better method as well. These two things can exist. They found one way using cold rubidium atoms. These guys didn't use cold rubidium atoms and still got a better way. So I am not wrong, you were. I don't see how this is a wrong and right thing. I'm just saying the guys from the Royal Society got a better measurement than the average. And if you take either uncertainty, it's still tighter than GE. Like fundamentally, that GE value is wrong, no matter which way you slice it. Okay, if you go from the paper in Nature, it's 150 parts per million. That is the uncertainty. It is still outside the uncertainty. I mean, you'd have to go up like a whole order of magnitude. Like you'd have to, the uncertainty would have to like widen by a whole order of magnitude to even get to that value. Like they're completely separate orders of magnitude. So what if I'm an order of magnitude? An order of magnitude's pretty bad. That's pretty bad. I've never heard anybody say so what to an order of magnitude. Yeah, so it's 106 in the one that came out in October, they got 106 parts per million. In June, they said it was 150 parts per million. So that's an improvement with time. That is the difference. Right? And at the average of 150 parts per million, it's still wrong. And in order for your value to be right, the uncertainty would have to be a whole nother magnitude off. Yes, so it'd have to be a whole other magnitude off, like 1,000 parts per million instead of 100. Yeah, no, I'm saying the uncertainty would have to be up to like 1,000 parts per million or like 10,000 parts per million instead of 100 or 150. That's way different. I don't know if you're claiming that, there's a modern one that was that off, but I certainly haven't seen any evidence for that. You'd have to show me that. I mean, it would be that. That's better. 47 parts per million is better. Gleam. Yeah, so it's getting better with time. That's a whole order of magnitude better. You're going in the wrong way. Yeah, of course. I mean, with time, the measurements are getting more accurate. I'm glad. That's exactly what should be happening. happening. And I will keep on to this because this is great. 47 parts per million. That's incredible. What would that be in percentage terms? I had it up. I had the conversion up here somewhere. That would be 0.0047%. Compared to 0.001. Yeah, no, I'm saying 47 parts per million. That's even better. That's 0.0047% instead of 0.015%. The uncertainty, the value didn't change. The uncertainty changed. The margin of error changed. The value isn't what's changing. Purely storytelling. I don't know what am I reading this wrong? This is saying the uncertainty is what changed. Is the uncertainty has gotten better with time. Is this surprising? I would be surprised if it was getting worse. Oh yeah, no. Yeah, I mentioned that earlier. The other ones are way better. This is true. All the other ones are much better. The certainty depends on how good your instrument setup is. What do you wait, Gleam? Like we're talking about numbers here, right? In June of 2014, it was 150. In October of 2014, it was 106. And then in 2020, okay, so maybe these people implement it and now it's gotten better because it went from 150 to 106 to 47. That's an improvement. It sounds like whatever issue they were having, they fixed it, and now it's just getting better with time.
Hey, man.
I mean, remember, the article you cited is like a decade old at this point.
I just gotta tell you, it's strange
because I was crazy to think about.
I was confused. I was like,
for 9 years.
I thought I couldn't hear Gleam or something, but you're talking to him in the text chat. I got a solution though, because it's weird to do that while he's typing and you're texting. Why don't I just read what he says? That way you can respond if you want.
Oh, okay, cool. So they stopped using Cavendish and they got better results. That doesn't change the fact they're getting better results.
Yeah,
it's getting even weirder.
Yeah, it's getting weirder by the minute. Can you hear Kosho?
Okay. He's. I think he's server muted.
You might have muted me. You might have muted me. Perhaps,
he has
I
a
don't know.
red thing across his microphone instead of a gray one.
What?
Who? Next to who?
Your whole point is that it's getting better. Okay, well that's my point too.
Like, did you say that Kosho has a red mic?
I think he has a red thing across, which means he has him muted. Personally, I think.
I think you got Kosho muted.
Damn, I wonder what happened. What did you do, Kosho?
Well, my mic was kind of fucked up earlier. Maybe that was it.
Oh.
I thought my computer's messed up, and I was like, you gotta do a whole bunch of crazy stuff. And then I realized that I had like 8 gigabytes in my recycle bin, so I just emptied my recycle bin.
Wow, 8 gigabytes, huh?
Yeah, it's just, hopefully that does the trick.
The recycle bin.
Now Don is deafened.
Don is deafened. What? What's going on?
I don't know.
That's some crazy shit. That's some crazy shit.
Yeah, some crazy shit been going on in here lately, dude.
Yeah.
I tell you.
Crazy fucking shit. It's crazy. It's fucking crazy, man.
Hey, Arm, let me ask you a question.
What's up?
And hear me out before you judge what I'm asking you, okay? But would you consider becoming a tranny in the future? When I say that, I don't mean a transsexual or transgender or something. I mean a transhuman.
Oh, a transhuman. So why don't you just word it that way?
Well, in the future, I think, you know, there's going to be it's not going to be a fine line. It's going to be, oh, you're a tranny? Oh, I slept with a tranny last night, and it was actually it's a transhuman.
I see. I think you just worded it that way because you wanted it to be funny. You wanted it to.
Well, Armin, don't dissect it. Sure. Just listen to me. Yeah, because I asked Jeremy earlier, and and actually he's on board. He actually is on board. But my friend signed up for what's it called? Neuralink last night because they have like you can just sign up for their trials even though they're not able to test it on people yet. But yeah, I'm just curious. I mean, I'm curious what people how they feel about that. I'm gonna be.
In which paper is that one from?
The weirdest part about this is Glean.
Oh
Glean's
yeah,
not even
that's
in
the
here.
COT data, 615 down to 47. Except this guy in 1998 did a shit job, or 1998 and 2002 they did shit jobs.
It might be
Especially the
easier
guy
if
in
you go.
1998. What the hell happened there?
Go to the YouTube page.
I don't
Go to
know.
the-
I think we're trying to. I don't know.
Yeah,
It goes
Don.
to
Look at Kosho and see if you've got Kosho muted.
He definitely does. Oh wait, oh God.
Yeah, it.
And now go to
There's the
Glean.
conductance.
Go to Gleam and see if Gleam's even in
Okay,
the
yeah.
room.
These, for one thing, what am I wrong about? The numbers are getting smaller.
Holy shit, Don, can you hear anybody? Don,
Yeah.
can you hear me?
I can't hear you, Napalm.
Okay, cool. Can you do me a favor? Can you go to Kosho's little picture and click on him and see if you have him muted?
Yeah, I did have him muted. It was my fault.
Okay.
Thank you.
Just making sure, because it seems like the room is talking to you, but you just keep talking to the text chat.
Oh, I didn't even realize that. Sorry.
No, he's
Yeah,
talking
go
to
to
the void.
Gleam's picture and see if he's even in the room right now. Spoiler alert.
Yeah, he's not. I was wondering.
Offering, I gave you a really good offer earlier, but I didn't know you could hear me.
Again.
Yeah, I was offering you to read for Gleam. That way, it actually it made sense because it's like you're talking to him. I don't think he's not even in here, but he must be listening on YouTube, I guess.
Yeah, but Kosho, when you do Gleam, they'll do like a voice though, right? Like do like a funny voice.
Nah. I got respect for Gleam. I got respect for Gleam, so I'm not. I don't want to.
What? I want to do it though. I want to do a funny.
Yeah,
voice.
he's got a cool accent. So.
Oh, I mean, we could make up we could just do like a made up voice like Mickey Mouse or something, or like Scooby.
Oh, come on. I bet you Snacks can do a good Gleam, but no, Gleam has this. He's got this fire flow he did a few years ago. It's about like the Globers in this community. And it's pretty funny.
What kind of accent does he have? I need to know.
Yeah.
Try to replicate it real fast.
He sounds like a black guy from Atlanta.
From Atlanta. I don't know what that sounds like.
No, dude, he's British, man.
It's British?
Yeah. Just ask him to come in here, dude. I mean, he's already in a conversation in here.
You're wrong to say that. Yeah, I don't know how to do British. If I do British, it's gonna come off it's gonna be like a weird Australian mix kind of thing. You know how like some people they be doing like the weird accent that's just sort of like Australia, British, and all that shit. It's all like one thing. I'm gonna be doing that kind of shit, so I'm not even gonna touch it. I'm not gonna try it.
I keep forgetting you're from New Jersey.
Yeah. Wait.
Yeah,
what did I say? Did I say something with like a New Jersey accent? What happened?
I mean, everything you say is with a New Jersey accent.
Oh.
Every single thing you say. But there's a lot of New Jersey dudes. We forget how. I mean, that's probably the biggest demographic in the server.
Oh wow.
People from New Jersey. So.
Well, I mean, I originally came from New York, specifically Staten Island, but I mean, that's already like New York, or, and New Jersey, they all, have a similar thing going on. But I guess.
Have you ever noticed that's the most boring borough?
What, Staten Island?
Yeah, nobody wants to tell people they're from Staten Island, dude.
Yeah, I know. Apparently, my broke is that same thing. Right? He's like, "Oh, I'm from Staten Island." They're like, "Okay, who cares or whatever."
Yeah, tell people you're from New York City, man. It's probably.
I mean, to be fair though, I think at this point I've lived longer in New Jersey than I have in Staten Island. If I had to, I think that sounds about right.
I'm from New York City as well, and I've lived in Texas longer than I've lived in New York City at this point. Probably 2/3. But I'm pretty good at accents, dude. And people don't believe this, but I'm probably 8 out of 10 when I hit or miss for this one. But I can even do I can even pick up which borough you're from. If I know you're from New York City, yeah. Although, like I said, I don't think I've ever guessed Staten Island before because I don't know the uniqueness of that accent. You ever notice that though? Somebody from Queens and somebody from Brooklyn and somebody from the Bronx, like, there's almost 3 different accents.
Maybe. I might have to BRB because my brother's cat is in my room
coming on
right
to
now.
you?
No, I mean, because I think literally like an hour ago I was like, "Hey, I'll play with you," and then an hour later I feel like he's giving me like. I mean, granted, I'm talking English and he's a fucking cat, so he shouldn't understand me. But I feel like he's sort of like hinting,
But
like,
there's
"Hey,
a chance, there's a chance he might have understood that, and he's never going to hold you to it." Yeah,
That's exactly.
And not only that, but he's got a great perception of time and can read clocks pretty well.
Yeah, because this is big eyes, Cat's got good eyes. They could see in the dark.
Ask him if the Earth is flat.
No, the cat.
Yeah.
Oh, I did already. He told me it was round because he's a smart cat,
Cats don't experience time dilation, you know that?
Cats experience time dilation?
No, they don't.
Oh, they don't experience time
unaffected by it. Yeah.
That's how they have 9 lives.
But real fast though, don't smaller creatures, smaller you are, the faster your perception is because you have a smaller brain and therefore the time between neurons is shorter?
That's an interesting idea. Did you make that up or you hear that somewhere?
No,
that
I mean
actually makes sense.
Yeah, it makes sense, but also like there was also that one movie where it was like everyone was like tiny and like bugs and shit, and everyone else was like slow motion. And I thought about it, I was like, wait, that kind of makes sense actually when you think about it.
Let's think about this. But what do you think the latency?
Sorry, go ahead.
No, just wondering what do you think the latency what's like okay, so the reaction time when you're in a car is like supposed to be a 1/5 of a second or like a fraction of by half a second. Like if you're in a car, like the second you realize something and you start to act on it. Yeah, so I guess you think it's faster for bugs and shit and smaller things?
Yeah, because with flies, I know their fucking reaction time is like fucking crazy. Like literally, that's why you can't fucking hit them because they have like a fucking quick ass. I mean, you can, but I mean, you have to be really, really fucking fast though, because otherwise they will like see your shit before you even like really process that you're about to hit them. You know what I'm saying? Like
but
they're fast.
There are other things than just the distance between the neurons, like their brains. I mean, they don't actually have like brains. They have like a very developed nervous system, central nervous system, and they're pretty much reactive. Like they're built for a reaction,
Well,
you guys are sick.
Well, I was gonna say is because I know there's like different types of reaction time. Like there's like to physical touch. There's sight. Like you react to different speed. Like there's different speeds for each one. Like also for sound and whatnot. So I mean, I don't know. Maybe flies are like an instant thing because it's like a touch.
There's something really interesting I saw about like how the brain has to synchronize the stimuli it's receiving to make sense out of things. Like when you touch your nose, the time it takes for the feeling of your nose, like the signals from your nose to reach your brain, is much smaller than the time it takes for the touch from your finger to reach your brain. So you would feel weird if you notice that difference in time.
Oh, yeah, okay.
Your brain kind of anticipates that, and you feel your nose, like you feel in your finger at the same time you feel in your nose. Like your brain anticipates how your fingers gonna feel like when your nose feels it. So it doesn't like so it keeps things making sense, you know.
You know, it'd be interesting. You know, it'd be interesting. Like, you know, we were talking about Neuralink a second ago, Bacon, and talking about. I was asking Arma if he thinks he'll ever be a trainee, and I told him I meant
What is a
transhuman. That transhuman.
What is it?
In the future, in the future they'll be called trainees as well. But I was thinking though, when you said that just now, wouldn't it be interesting if Neuralink, like, not only are they doing like the prosthetics and shit like that, but like what if they had like an interface with your brain where you had, well, no, not just that, but what if like, because there's so many subconscious you know, processes in your brain, stuff that you can only dream to have a control over, right? But what if like you actually could have access to like all that subconscious stimulus and processes?
Wow.
That'd be crazy if like you somehow got access to that.
Yeah, you'd be like, you'd be like a what do you call that?
It'd be
Like
fucking dangerous, dude.
It would be, but I mean, it would also be kind of crazy too. Like you'd be approaching like demigod status at that point, at least in terms of the mind. That'd be some crazy shit, you know?
Possibly, but I think you'd possibly do more damage than you thought. And then also, like, if you malfunctioned something and then you couldn't turn it back on, and you had to like remind yourself to breathe every time, all that kind of shit. Your heart to pump.
Well, that's why there'd be like a backup, like a backup, you know, like 3 backups. So that couldn't happen.
But yeah, there's some things though that would be interesting that you know, because like if you, like you said, the thing, because there's so many subconscious processes like that. Like I can't think of any other ones on the top of my head, but there's a lot of things that your brain automatically does to help you cope with you know.
You know what you could do? You could stop yourself from like sneezing. Like, you know, if you have to like really sneeze or something, because that's like isn't that like a, you know, like you could be like, don't fucking sneeze. I mean, you probably want to sneeze because you want to get that out your nose, but like, you know, just maybe you're just like tired of like sneezing a bajillion times, because sometimes it happens, you know.
Yeah, quickly get rid of your hiccups.
Or hiccups, yeah, you can stop hiccups, or I guess maybe. I mean, how does that work? Isn't that more of like a muscle?
That'd be like probably the easiest thing to, you know, if you had access to that. That's like, because that's definitely an automatic process.
No, but isn't that like a muscle though? Isn't that like a muscle like thingy? Like is that really?
Yeah, your muscles are controlled by your nerves.
Well, no, I get that, but I mean, like, okay, I guess. Okay, look, I don't really know too much about the whole muscle. I mean, you're right. You are right about that. I just didn't know that was like a whole brain thing though. Like, are you telling me like whenever you have hiccups, that's like your brain just kind of like not glitching per se, but just being stupid? Is that what's going on?
It's something to do with
I heard smart people never hiccup.
Yeah. Well, no, but you know who hiccups the most? People who have anxiety. And
really?
And yeah, like laughing in general. Like there's a lot of stuff. There's a lot of automatic processes with your diaphragm, and breathing, that like when you disturb that, like you get weird shit like hiccuping, laughing. Like these are all like disturbances with your automatic like flow of breathing.
Are muscle spasms controlled by the brain? I just thought maybe. Yeah, because isn't that what the hiccup is? It's just like a muscle. Like it's just like it's not supposed to be happening. It's just fucking up.
In the lungs, the lung muscle. What do you call it? The
diaphragm. Yeah, I think the diaphragm. Yeah, diaphragm. I think that one thingy.
Yeah, but I'm telling you, if you know, like, okay, so people, the reason why, like, if you get scared, it gets rid of it, or sometimes maybe causes it. It's like if you notice people who have anxiety, when they get anxiety real bad, they start to get hiccups. It's
yeah.
So
I get hiccups whenever I eat spicy food.
Yeah, you don't like spicy food?
I love spicy food, but I love it, but like I think maybe I overdid it when I was younger, so my body's like, you know what, stop, because like I love like really spicy food, but my body just can't do it anymore. Like I mean, I could eat it, but hiccups though, you know, I'll have to get hiccups, and that's the price. That's the price I have to pay. So
spicy food's good for you, man. I can't eat it if it's
not good for me.
I can't eat food if it's not good for you. You're Brazilian.
Yeah, but I can't eat spicy food. I love it, but I can't eat it. I have like if I eat spicy food, my stomach starts producing too much acid, and it hurts my both stomach and the thing that comes before
intestines.
the stomach.
Oh yeah, okay,
before,
yeah,
not after.
Yeah, I know what you're talking about.
We call it esophagus. Might be a
Esophagus.
similar word. Yeah.
Esophagus. Something like that.
Yeah, and I have another issue that my stomach doesn't close very well. So when there's too much acid, it easily goes back to the word you said is off.
Oh, the intestines.
No.
Esophagus. Yeah. Same word. Yeah.
Yeah. So I have to. There's some medicine that helps make like makes the acid of the stomach less acid, so it doesn't hurt.
I think my bro has that. My brother, because he also used to like eat spicy food, and now his stomach is all fucked up, and he can't eat spicy food. He can't eat a lot of shit. It's fucked.
Yeah, you should never eat a lot of shit.
Yeah. yeah, or any for that matter. But you know what? Then, Bacon, I think that you are probably going to be one of the people who are going to be on board with becoming a tranny, because I think in the future, transhuman.
What is a transhuman?
Transhuman is like it's like the transhumanism movement is like there's a lot of people in here who like talk about it in a bad way, but it's basically like the merging with technology. So it's like, you know, prosthetic limbs.
Cyborgs.
Yeah, I mean that would be down the line, I guess.
It just remind me of a story.
What's that?
Now that I remember the story, I'm not sure if it's a true story. There was this guy that had a surgery in his penis, so he had to replace it with a prosthetic. So he has like a cyborg penis, and then a bunch of girls wanted to have sex with him because of his different. You get it.
Yeah, I get it. Yeah.
The problem is that like he couldn't feel anything because it wasn't like a real penis. So he kind of entered in depression because he never had so many girls wanting to have sex with him, but he didn't feel anything. No, he wouldn't feel anything.
This sounds like a Brazilian wives' tale. This is like the kind of.
It might be a fake story. A long time.
No, I mean, I've heard it. I've heard it before too, though. But another weird story is the guy who got like a prosthetic penis, but it was grafted off the back of a mouse.
It was what?
Yeah, like they used a mouse to grow the organ, and the organ they were growing was a penis. So I don't know. There's pictures of it. Actually, you know what? That also might not be true. I know there's a picture of a rat with an ear on its back. They've grafted ears off mice's backs. I think they've also grafted penises, but
this might be like this picture is probably real, but this happens to people. Like there's a bunch of surgeries where like let's say your finger, you got your finger, like you lost your finger, fell from your hand or something. Yeah, it was chopped away from your hand. They might put that in some other part of your body just to keep it alive for a longer time, just to have they can. For example, there's a very weird surgery where, like, if a kid has cancer in the. Damn, I have no vocabulary. Just give me a second.
Lungs, heart.
No, the bone is the bone in your leg.
Oh, yeah. Femur.
Not the femur. The other one.
Fibula.
Yeah, the one between the feet and the knees. I don't know. Anyway, that one. So what they do is they cut off the feet of the person. But they don't like they leave the nerves in between the feet and the leg, and they remove all that part of the leg, and then they plug back the foot in the leg, in the rest of the leg. But they plug it upside down, like turn 180 degrees.
What?
Yeah.
Is this real? Like, what are you talking? So why is it backwards?
Because like if a kid had cancer in the knee, for example, okay, that was the other thing, the knee. So they remove the knee, but they leave the leg and the foot connected, and they plug it 180 degrees. So when the kids finish, it stops growing, like it gets the bones in the full length. They can use that knee. They can use the foot as a knee, because the foot is still controlled by the body. Still have the nerves controlling the foot, but the foot is in the direction of a knee. So you can use it as a knee. So you can plug a prosthetic leg in your upside down foot, and then you can control their leg using your foot as a knee.
What? That's
Yes, this actually happens.
Yeah, I'm
It's
sure
a real
it
thing.
makes sense. Yeah, it seems like a very clever solution, a problem-solving solution. It also seems like a stupid solution. It's like well, it's a pretty
Dude,
clever solution, but
medicine is full
yeah.
of it. Full of
Oh yeah,
these
sure.
workarounds. Like the
Yeah,
human
but
body is not like a machine where everything you can just like unplug this and plug there. It all has its
not.
like people have to be creative on how to fix the human body.
Yeah, and hope that they get it right. Yeah, it seems like you can fuck that up real easily. But
Yeah.
that's what I'm saying. Neuralink or the sort of transhumanism possibilities, I think are going to be, you know, it's going to be much better than that. Like they're not going to be deciding, oh, should we do we got to turn his foot around and make it a knee? Like they're going to actually be able to give you like a fucking superhuman knee, like a superhuman leg. I mean, that's why I think athletes in the future. This is why I said I'm not trying to jump around, but this is why I said that Oscar Pistorius, the guy who was running in the Olympics with like springs for legs, and then he's a South African dude, but he was running in the Olympics and he didn't have legs. He had these springs on his legs, and they let him run in the Olympics for some reason. But I was like, you might as well do that because what's the difference? It's like in the future, people are going to have all sorts of prosthetic limbs.
Why don't you give him a car to drive or a motorcycle?
Well, maybe, but think about it. Like people in the future, like you might have like a prosthetic arm, and like you're throwing, the quarterback's like throwing all the way across the field. You know what I mean? I mean, what's to stop that from happening? It's not.
We might as well just have robots playing.
Well, yeah.
Yeah, it is a slippery slope. Yeah.
Yeah, but where's the line? Like if they're, like I said, Oscar Pistorius wasn't on to do that, but like people taking drugs.
You couldn't take enough drugs to get that kind of advantage. The guy would be nothing without those. Like the whole idea of sprinting, and I know this, is all about the Achilles. The energy return system is the Achilles. If you can get something that returns energy, you're in business. And a mechanical apparatus made out of metals is infinitely better. That's why he could just kind of jog and be almost Olympic caliber.
Yeah,
and still
exactly.
didn't win, by the way.
Yeah, no, he didn't. No, he's the wrong kind of African. But what was it? No, but yeah, so that's what I'm saying though is that like a lot of people had to give up their medals because they got caught in like retrospect taking drugs or whatever, or in the case of like Lance Armstrong, he's just putting his own blood back in, But it's like I don't know. I feel like if people, there's not really a line between what you can and can't do because you can take nutrition shit. So it's like why not just be able to take whatever drug is available? I mean, I don't see what the problem is. I also don't see how you're going to be able to stop it.
You guys believe in hypnosis?
In what?
Hypnosis? Hypnosis?
Oh, hypnosis. Yeah, dude. I mean, I used to practice hypnotherapy. It's been a while since I've been allowed to do that, but yeah.
Yeah, I know it's everything because I've hypnotized 2 people, and the first one was actually not in purpose. I didn't even know that actually happened.
But you did. So you practice you practice hypnosis?
Yes, I hypnotized my cousin when we were the kids, but I didn't know there was hypnosis. I only realized that like many years after that when I started reading about it, and then I remembered like that experience, and this actually happened like, when I was a kid.
How did you do it by accident?
Because we were playing, like I was hypnotizing her, and I remember that she fell asleep. In my memory, she just fell asleep, and she dreamed everything that I told her to dream. She dreamed that. But what I did was exactly what you're supposed to do to hypnotize someone. So all she did was dream because actually it was like everything I was telling her was going on in her head. But I didn't use that for anything that you can use hypnosis for. I could have used, but I didn't know she was actually like hypnotized.
Yo, you should have developed. You should have honed the skill, dude.
No, I then learned like then after I realized that happened, and this is like a real thing. I learned a lot about it. Not a lot about it, but enough to do it. And I did with my girlfriend a couple of times.
Oh yeah. Well, you know what you can do. Some people don't believe it, but it's absolutely true. You can suggest an orgasm.
I know that's true.
Yeah, it's a very real thing. But that's cool, man. I mean, I practice hypnosis too, man. I feel like everything. I feel like you're trying to replace me, dude. You're trying to you're gonna take over my entire fucking existence, dude.
No, don't worry. I'm never gonna learn calculus.
Calculus?
Yeah.
You don't know calculus?
You're right. You should know calculus. I guess you know calculus, right?
Yeah.
I don't know calculus.
What? I guess they don't. Wait. They don't teach that
in computer science. But that's just the very basics, and I cheated too on calculus. So I didn't learn. I mean, recently I learned a little bit of derivatives, but that's it. All I can do is simple derivatives.
Calculus is basically memorizing rules. There's a bunch of rules you got to memorize.
Oh, the rules just simplify it, turn it into a systematic way to solve, right? But you should be able to do without them, right? It's just harder.
I guess. I mean, like when you take like the derivatives of certain functions, it's like there's like I only knew them by memorization. I didn't know there's a way to do that. You know who's good at math? Ruhif, supposedly. He said he beat the Australian. What was it? What did you say it was, Ruhif? Some competition. Smartest person in Australia.
The company that I worked for before I started Tigra had a barrier test, so that you get
your mic's a little bit bad.
Yeah, no, I'm in one side.
I hear you.
The barrier test was 3 maths tests, and the third maths test was the hardest. And as far as I know, I still hold the record for that. So,
really?
Yeah.
Interesting.
What kind of math is it though? Like a computer, like a general math, or is it like computer based?
It's not difficult. It's not difficult maths, but it was all about speed, and some of it was like sequences and what's the next number kind of shit. So it wasn't difficult, but it was a barrier test to weed out who is slow and bad at maths. That was it. And then they would interview people that passed it.
Nice.
Yes, it's hard to find computer science people, programmers who aren't good at math, or at least
who are or who aren't.
Said a lot aren't.
No, I'm asking.
I'm saying like basically like everybody I come across who's a programmer, they're at least decent at math.
Yeah.
Let alone have a passion, a very sick passion. Passion nobody else has.
I feel like I'm very slow in math. Like I can do stuff, but I'm very slow.
Jesus. That day that you talked me through the intersection of 2 circles on a sphere, that was pretty cool.
Thank you.
Yeah.
I get
that would
get
take me fucking weeks to do.
I gotta give Bacon props because when we were doing the celestial navigation thing, like I would look up the different formulas for Haversine, this and that, but he was literally doing everything from scratch just so he could like understand it. Like he wouldn't even allow me to give him the answer. I was like, dude, you just do this equation. He's like, no. It's like, no, I'm gonna just keep doing it until I get the right answer. Okay.
I think that's good exercise. I mean, I don't like.
Yeah, it is. Yeah.
I like to understand the things I'm dealing with. I don't like black boxes. And also, if you want to present something as an argument, and someone says, "Well, why did you use that equation?" and you say, "Well, I just Googled it," then that doesn't look good,
Yeah.
So, like, if you ever do everything from scratch, you can explain the whole thing. There's no think you're just accepting.
So you guys are a dynamic duo now, dude.
Yeah.
Basically fighting crime together.
Crime being Brian and Nathan Thompson?
Who knows? You guys will probably be fucking doing a world tour next.
Brian's very excited. He said he found a way to do cell nav in the AMAP.
Really?
Dude, I told you all the answer.
Yeah, but I don't think that's the answer he thinks he found. He said, let me see if I can find what he said.
Yeah, what were his exact words?
He created a way to do cell nav with an ephemeris and an AMAP easier and quicker than globe methods.
That's not true.
He's wrong. Okay.
Let's give him a chance.
Yeah, okay.
I mean, I also believe he's wrong, but I will give him a chance anyway.
I know a complicated way to do it. Because I wanted to see if there's a way to get McToon's money, just to see if it's possible. But if you take the azimuth, if you take your azimuth and you apply a function based on whatever your azimuth is, so it's like so to create the circle or the ellipse at your GP or whatever, you just have to got to make like a special ellipse that's based on the
the ellipse you get once you project the circle from the Earth. Yeah. So if you do that, you're gonna need like this different equation to get that shape, but you have to justify it according to the rules of the challenge.
Yeah.
Like you can't if you see it from that position in that angle in that direction, you have to justify how light is arriving at you from that direction, and you can't use unknown behavioral light. So that pretty much makes it impossible to be solved. Unless you figure out that actually that's how light works in the atmosphere and you find a way to prove that, then there's no way you can. Yeah.
Yeah, I thought about some like sort of brute forcing methods to take turns money, but I can't.
Oh, you really?
Yeah.
Yeah, I didn't even try. Like, because these rules, I know I just unsolvable.
Yeah.
I can barely prove the way light actually works. Imagine proving like light works like that. Oh, by the way, you know water business model? Like, there's a bunch of people saying that this might be how flat Earth works. Like, that would account for all the azimuths and elevation. Well, I was wondering if that would be distinguishable from a sphere. And if you try to navigate on water business model, even though you could arrive to the same places, the path would be different. You end up with a very, very different path. Even though all the azimuths and elevations are the same at each coordinate, the path wouldn't be the same because the true azimuths are different. So you end up with a wobbly path. And I created some simulations to see how those paths would look like, and they're very weird. Very interesting to me.
Whitsett and Shane were talking to someone the other day about that they kind of had this idea that the simple act of overlaying an Altaz grid onto the AEMAP somehow solved the problems, and they said that solved the problems rather than this stupid, weird, ad hoc, bendy light. It was such a bizarre conversation.
Yeah,
like the coordinate system itself just fixes the problems. What?
Yeah, I've been hearing this too, but every time I try to understand how this thing works, this supposed dome works, I get a different answer. And of course, I get no equation for how to correct for like what that there's no description of how it works that you can put numbers and try to make predictions with. It's just like words about it.
Yeah. Oh no, like Walter Bislin literally says, here are the altitude and azimuths for a globe, right? But my star is over here. What path does the light need to take to make that happen? And then he just does it. Like it's
Bezier
completely
curves, right?
ad hoc. Say again?
He used the Bezier curves, right?
Oh, probably, yeah. But then, applying, getting the atmospheric structure to have those Bezier curves, do what they do.
No, yeah, you can't.
It's completely ad hoc, yeah. completely ad hoc.
You can't for a simple reason. You have like the circles aren't circles, even if there were different. Like if you have some refractive property of the atmosphere, like a certain gradient that would cause that. The distance, like given the angle, you'd still get a distance from this angle. So the circles would still be circles. They would just be different sized circles, and that's not going to work. Because if you like, the only circles that are going to work are the ones you get if you project from a sphere, which aren't circles. They don't have all the same distance. The distance change based on the azimuth, which wouldn't happen with a gradient of. So you can't even solve like that.
Yeah. Anyway, let's see Brian do his cell nav.
Right.
That'd be funny.
Did you ever get to the bottom of those documents?
The navigation ones that Witzer gave me? Which one?
No, there was you were asking last night about MC Toon's video and
yeah, MC Toon is pretty certain that someone just asked ChatGPT, make me a list of citations about this topic. And I think ChatGPT just made them up. So if Witzer wants to, where is he? Is he in here?
He's here.
He's here, Stefan. Yeah.
Okay. All right. Well, anyway, if someone gets to talk to him today, I would love someone to ask him that question. Where did he get those citations from that he sent to Bryant Myers? Did he ask ChatGPT to make them up?
Well, I don't think he. I bet you he put. I wouldn't put it. Ask him who gets the best answer, but I'm just saying I don't assume that he asked it to make it up, but he might have asked it for. But that's what I kept trying to warn him is that it's not. There's no. It's got no. Need to tell you that. Yeah, it's got no need to tell you the truth.
Yeah, a language model can't control whether or not the answers are true or not. It's a language model. It's not a true model. A model of getting accurate answers. It's a model of answers that make sense as a language, not as a.
Yeah, it's like people use it and go, oh, ChatGPT says that you can't get a fucking elevation angle from a curved baseline or whatever. Like just that sort of shit, right? Who cares what an AI thinks?
Yeah, ChatGPT get things wrong all the time.
Yeah.
I mean, it can barely multiply two numbers.
People are using it wrong. But you can set it up with like Excel or Google Sheets, and you can get it to do all sorts of cool stuff with that. Like you like oh god, there's a lot of things. Like if you needed it to make like I don't know descriptions for YouTube videos or something, and you had like 1,000 YouTube videos, you just like type in all the different all the different titles of them, and then it'll come up with like a very same style description. But I mean any really anything though. That's just one example.
Yeah. Oh man. I'm at so you guys know I'm like at my daughter's school every day, right? She's autistic, and we're at this athletics carnival thing today, and she's losing her shit every time this fucking helicopter goes over. This helicopter, I think, is doing practice rescues or something.
But the other kids, some kids are excited, but yeah, that seems like that gives me PTSD from when I was in the Navy. Not real PTSD, but I used to live on the base, on the air base, and they used to have air shows, and it was like fuck, you can never sleep. I had to sleep during the day because I worked at night, and I can never sleep, dude.
Yeah. Does Brian Leakey want another debate about something?
Want to know what?
Does Brian want another debate about something?
I don't think so. I think he was just I don't know. He just wants to describe the thing he said he came up with.
Okay.
I'm curious.
Yeah, but he's still trying to do that. Yeah, his whole thing with the flat Earth or with the AE map. Yeah, I mean his solution is not very clever, but at the same time, because there's actually better ways to do it because it's too like arbitrary. You know what I mean? The reason to use the 69 miles per degree.
Oh, fucking the number of times I've explained to him the small angle approximation, and then he just goes, "Oh, but what about the large angle approximation?" I'm like, "What the fuck?" Oh, Jesus. Yeah. Probably a dozen times I've explained that to him in great detail, but he keeps using it and saying Polaris is 3959 miles high.
Well, like I said, there's ways because I've played around with just like the actual angle that you would get on like a flat Earth or like trigonometry, like the difference between the trigonometry and the globe, and I mean, there's ways to come up with. I mean, you just have to be creative, but there's ways to come up with an excuse for using a function that would just give you that same value.
That's all I did to him like 6 months ago, and he gave me his 10% of the altitude angle, whatever like that. All I did was plug in the tan function into Excel, and then mapped the best fit polynomial, like the 6th order polynomial, to it, and sent it to him. This is a G up.
Yeah, the only problem you'd have after that is the circles. But like I said, that just requires another excuse for using that weird ellipse azimuthal thing I was talking about.
Yeah. I've had a look at MC Toon's the wording of the challenge, like you said, to try and just sort of weasel around it. I don't think you can, because the key is that if you get the correct answer the first time, then you've got to use the same method next time. And like I said, I tried to come up with some brute force algorithm that would work, and I just can't. So
yeah, I kind of did the opposite. Brute force where you would fail.
Okay.
To quickly find instances where it breaks the method.
Yeah.
I mean, honestly, I think he's made it unfair, even from like a flat earther. Because if I was gonna make the rules for a challenge like that, I mean, I wouldn't be I wouldn't say they have to use a flat Earth map, like or like a map that
is not a globe.
I think he said they couldn't even use like a AE map because it's based on a globe.
Well, I think he changed that.
No, you can use the AE map. You can definitely use the AE map.
I remember that you was saying that you cannot get anything that is derived from a globe, and I think in the first, I'm not sure if this is actually something he said or people said he said that the A map is derived from a globe, so you can't use it. It goes against rules. So if you use the A map, you're not. But I think he changed that, like that. There's a version 2 of the challenge, of the same challenge.
Okay.
That is more.
Yeah, you can use the almanac as well, because you can sort of you can get the almanac, like you just have to map the GP, from observation. So I think that's fair enough to use, which I think was in the second version.
There's still something that a lot of people don't get it. A lot of people say that the almanac is built to match a globe. But
no, you can get like I said.
You can get it from observation.
Pondering sort of putting together a little presentation like to do on chains or whatever, to show if you accept that stars move at 15 degrees per hour of longitude, then you must accept that the Earth is a globe, because we can measure over the ground how much distance that is per longitude line. So that could be pretty simple. Yeah.
There's a lot of truths in that. It really just depends on who. Like I said, I mean, I'm not the best person at breaking things down into a digestible way. Even if I have a perfect proof, I can't break it down in a digestible way for some reason. But yeah, if you can easily, because there's so many truths in celestial navigation, including the 15 degrees per hour, the coordinates in general. It's no question. That is
the celestial sphere coordinates. Yes, absolutely.
Like that, it actually doesn't require the Earth to be spherical. It only requires that the verticals align with latitude and longitude. Regardless on, like, it could be a different shape as long as you have verticals going around the center point. And then your latitude would be the angle above a plane, and the longitude would be the rotation of that direction around a certain axis.
Yeah, try to we had a conversation about geodetic latitude, wasn't it? We had this conversation about 6 months ago about what geodetic latitude is.
Yeah, that's why you don't have to worry about the oblateness of the Earth. I mean, it could be even like I don't know, a potato-shaped Earth. You would still get as consistent values as you. You might not just you might not get the 6 nautical miles per degree if you measure the surface. Like the measurements on the surface could disagree with that, but you would still get the same. Like, you could still get consistent coordinates. Using.
Would you need it? Would you need to know the local radius?
No, you don't need any radius.
It's when you project if you project the circle of equal altitude onto any shape, the only place where it's going to be a perfect circle is on a sphere. But if you're slightly oblate, then the circle of equal altitude will be a very slightly different shape.
Yeah, but kind of that doesn't affect it. Like, yeah, because our latitude is based on the tilt of the vertical itself, not
the
based
geodetic,
Yeah, so I don't understand. Maybe you have to break it down for a simple guy. Because you guys, yeah, I know, because I remember you were going over this with me, Bacon, whenever you were talking about the oblateness and the solution, all that kind of stuff for it. But what are you saying? Like, it could be a different shape. Like, you're saying it could be even more extreme of a shape, not just an oblate spheroid, but like an egg.
Could be like let's say American football shape.
And how would that work?
Because what celestial navigation is doing basically is finding your orientation in space. So, like, your latitude is just a tilt, right? Your longitude is just a rotation around that axis of rotation. And if we map latitude and longitude based on those tilts, then we would get lines on that basketball, which the vertical line at that point would match that latitude and longitude of the sky. Like, it's just a mapping of orientation. Like, your latitude and longitude is just an orientation from like local gravity. I'm not sure if I'm trying to summarize.
If you had a really squashed, a really oblate spheroid, and you mapped out the latitude lines, they're not going to be exactly 60 nautical miles per degree, and in fact, they'll be way off. So,
yeah, but you don't have to. Like, if you assume you're on a sphere, you do the same. You'd still get consistent coordinates, because let's think about that, Kosher. Let's say you're on the Earth. Just pick any position on the Earth, and then put a platform to be your ground, right?
Yeah.
And then you have your vertical pointing up, and you take your elevation angles from that, and you can figure out your ground position, etc. Now, take off the Earth, but keep you in that same orientation, same vertical, same down, same up. You're still gonna get the same elevations. Now, if you move yourself around to the left, to the right, but you keep that orientation, none of your elevation angles are going to change. You can be anywhere. That orientation that you have is what gives you your latitude and longitude, not the position on the Earth, but your orientation.
Right.
So if the Earth is like a potato shape or American football shape, that same orientation is going to map to a specific location on that American football surface. And that would be always consistent.
There'll still be 360 degrees unique locations in each.
Exactly, and you'd still you'd be able to trilaterate your position like that, because that would map to a sphere consistently.
And when this would break down, though, I mean, what about like you said, a football? What about like an extreme football, like a football that doesn't exist, like a long football?
Even the longer you are the more sensitive to change some positions become. So, for example, it would be very easy to get your position if you're close to the tips, because there your orientation changes quicker. But if you're in the middle, where the orientation changes very slowly, you need a lot of accuracy to distinguish where you are there. So a sphere is where like you get the same accuracy everywhere. So you could try your coordinates consistently with the same accuracy everywhere. But on that basketball, you some places you'll be more off because of the accuracy. You had to have very precise readings to be able to distinguish between positions where the orientation doesn't change much. Like think of a cube. So if you're in a cube Earth, then the whole face would get the same latitude. Exactly. So it doesn't matter where you are on that face, everywhere will get the same coordinates.
Or orientation, yeah.
Yeah, so because there's no orientation, there's no way you're gonna get a different coordinate. So pretty much it's your orientation that tells you your coordinates.
Yeah, did you discover this yourself, or did you find it somewhere?
No, I discovered this by trying to understand why. Well, actually, I didn't discover it when I was trying to. When I was trying to discover this, I thought a lot about why we don't care about the oblateness and it works the same, and I couldn't. And then you asked me to do this thing with the bridge, take Poncho Train's bridge, and I have the ECF coordinate system there. When I try to plot sorry,
that was very cool as well.
Oh, thanks. So when I try to see, well, let me see if I'm doing this right. So I try to get the latitude and longitude of those ECVF coordinates, and they're all off. They're only off in the south, north, and south direction. And then I went to take a look at how WGS84 deal with latitude and longitude, and then I realized it treats Earth as an ellipsoid, and the latitudes aren't based on the center; they're based on the surface. And then I realized that this would make things work on navigation, and then I also realized that any shape would work. Any shape that has difference in vertical, like a flat surface wouldn't, but because it has no difference in. Before anyone says that then it can work on flat Earth, no, it can't, because all the verticals are the same. If stars are that far, everyone will get the same coordinates.
Hey, you still do those coding challenges, man? So yeah, I bet you're real good at it. Like I like problem solving, man, but I remember thinking about that same problem, and I was like, what the fuck, the oblateness was like, that seems too daunting. I'm gonna fucking ignore it. But it's actually a simpler problem. Well, it's not a simpler problem, but the solution you came up with, it's simple, but it's not like it wouldn't come to your mind right away. But yeah, it makes perfect sense. Yeah, about the orientation. The very unique one for each position.
There's one difference though, which is like to bodies that are too close. It does make a difference because your distance from the center, like the way the distance to the celestial body changes based on how high you are, would make a difference. So if you're if the Earth was like an American football, yeah, and you
if it was a weird shape, I see.
Yeah, you're gonna get a different parallax. So if you're using the moon, for example, on a potato-shaped Earth, that might put you off. But if you're using stars, that wouldn't be an issue.
Yeah, that's a good question. Actually, does the moon parallax, does that care about oblateness?
It does, but it's just very insignificant.
Yeah.
It's
like,
interesting.
So if you like problem solving so much, why are you so bad at it?
I'm not bad at it, asshole.
Well, then why can't you figure out any of these problems with the stakes on the train or which is the shortest distance?
I solved all of them, dude. All I had to do was get off the fucking call with you, take 5 minutes. I came back on, actually less than 5 minutes, 2 minutes, 1 minute. I got the answer. But listen to you and Rakia, you guys in my ear, saying this like fucking goofy stuff, and then I can't think about the fucking answer. So each time I go away for 1 minute, 2 minutes, I'm like, oh wait a minute, no shit, easy answer. 2 different reference frames or whatever the case is. You have 4 problems, they have easy solutions.
Bacon, did you ever figure out the stakes on the train thing? I think I'm gonna start dealing with Bacon from now on. I mean, Bacon, you're turning out to be a hell of a glober.
My real problem is actually to see where the problem is. I don't understand where the problem is.
I don't know. I don't want to bore everyone with the stakes on the train thing again.
I haven't heard it.
Honestly,
come on.
Yeah, if Ruth hasn't heard it, I think it's only right that you bring up. I mean, honestly, one of the questions was actually a novel question. Like, it was a novel way of thinking about it. But go ahead, Jeremy. You're on deck, man.
I mean, you guys are just banging on about celestial navigation and shit or whatever. So
no. Don't just fucking criticize us. Okay.
Do it.
And which scenario are you going to use on him?
With the train?
Yeah, you got 4 different scenarios.
Well, forget about the trains one. All right, that one's might be a little complex for you guys. We got to keep it simple for now.
I gave you the answer for that one too, but go ahead, man. Just go ahead. I'm not going to talk.
I'll tell you what the problem is. So you have
Zanuck told it to you. Zanuck told it to you insanely. I don't even know what he was saying. Zanuck told you crazy when he explained it to you. Like, I don't know if I ever explained it to
me, not Zanuck. What do you mean? I remember you explaining it.
Oh, I explained it to you? Okay, go ahead.
Right, so we have a train that is about to kill 5 people, but you can flip a switch and then it will kill only one person. Just
exactly. Yeah, no, I was like, wait a minute. Jeremy came up with the trolleys. Oh yeah,
it's a trolley problem, right? Yeah, is that it?
Yeah.
Oh, it's not a train.
No, it's not. It's not it at all. Bacon's fucking around.
Here's the thing.
The Vsauce guy did that in real life. Did a real trolley problem experiment.
I saw he had fake video. He was sending the people fake video. Yeah.
Yeah.
People freeze up and shit. Okay, here's the train thing real quick. I'm only saying it once because people are sick of hearing it. You're on a train. You're moving at 1,000 miles an hour. The train's moving at 1,000 miles an hour. There's a vacuum inside the train. You're going to shoot a photon from the back of the train to the front of the train. Okay, there's somebody inside the train with a clock. Now, as soon as you shoot the photon, you have a sensor on the ground and a sensor on the ground of the train and a sensor on the ground outside. And you can get that spot exactly where the photon leaves. It triggers a sensor. It'd basically be like a plumb line. If you could freeze time, the photon would leave and there'd be a plumb line. And now you have a spot on the train and a spot on the ground outside. Okay? And then when the photon lands at the front of the train, you're going to do another plumb line thing with the sensor so you can mark a spot on the train and a spot on the ground outside. You with me so far?
Yeah, but I'm shit at relativity, so keep going.
Well, so is Kosho. That don't stop him, though. Let's see what you got. So according to that guy with his clock on the train, did he experience going through the stakes on the ground?
What?
That was his experience, right? What's up?
I have no idea. Yeah. Did he experience going past the 2 stakes? I guess so.
Yeah, on the ground that are on the ground in the outside the train.
Yeah, okay.
Yeah, he experienced that. That's how we do. That's how when we travel, we have a clock. We're like, oh, we traveled this far in this amount of time.
Yeah, he was completely lucid. He sober, right? Yeah.
So the problem is, though, the problem with this is for you guys is that you say nothing can go faster than C. But if you were to use the spots on the ground of the train, if you were to use the spots on the floor of the train and the guy's clock on the train, you would measure C. But in reality, the photon traveled over the course of the guy's time on the train. The photon actually traveled in between the stakes or the sensors that were in the ground, the 2 spots we made on the ground outside the train. That's how far the photon really traveled.
But the guy inside of the train, experienced the first stick moving towards the back of him, while the photon was moving to the front of him. So of course it's going to get a bigger distance, but that's not going to imply that the light was faster than light. The bullet was faster.
Isn't this like a length contraction problem?
No,
I don't even
there's
think.
not.
I think it's much simpler than that. I don't think you need a relativity for that. Just do something.
I know bacon, but it's not true.
Kosho's excuse for this was you can't use the guy's clock inside the train because he didn't experience in his reference frame going in between the two stakes that were on the ground outside the train, which is ridiculous because we know that the photon actually traveled in between those stakes on the ground outside the train.
Actually travels.
Yeah, that's the way he talks.
That's the distance. Yeah. That's the distance. The distance it actually traveled. Yes. What do you mean? Stop saying actually.
Reference frame.
Oh, they're two different. Yeah.
No, in reference to reality, in reference to reality, the photon.
Reality.
In reference to reality, I know you guys don't like reality, but in reality, the photon traveled the distance of the stakes that are on the ground outside the train, still not moving.
So that would be a different distance from another reference frame. Like it's definitely a length contraction problem, and ask someone that understands relativity well, right?
It's not a length contraction problem. No, it's not.
I'm sure it is.
If just instead of a photon, let's imagine. Let's imagine that I'm shooting a bullet, and it's a Newtonian world, no relativity, right? Same thing would happen. Like for the person inside of the train, the bullet traveled the distance of the train, but the marks on the ground give you a bigger distance. Doesn't mean the bullet traveled two different distances.
Nope, that's right. The bullet actually traveled one distance. The marks on the ground outside the train.
Yeah, but
here's the actual distance the bullet traveled, right?
There's no actual distance. No one's gonna answer your loaded questions, dude.
It's not loaded, dude.
Yeah, because they're gonna have to agree that there's actually preferred reference frames. But here's the real solution.
No, they'd have to actually agree. Hold on, they'd have to actually agree that in reality the photon traveled through the distance of the stakes on the ground.
Yeah, here's what happens: is they give everybody who participates in this stupid test. They say, "Here you go. Here's your clock, and here's your coordinate system. Take your coordinate system with you. Here's your clock. Here's your coordinate system. Don't share with anybody. Don't mix them up, guys." And what they do is they mark, if you're going to use somebody's clock who's on the train, you're going to use the coordinate system that's on the train. And if you use somebody's clock who's on the ground outside the train, you use the coordinate system outside the train. And it turns out that the clock on the train, they're going to have one experience of a second, and the person off the train is going to have a slightly longer experience of that same second.
Bro, there's nobody off the train. Nobody's off the train. There's just one guy with a clock on the train.
And the sticks are moving.
The sticks are off the train.
How are you measuring the distance?
And they're not moving. The sticks are off the train and they're not moving because they're planted in the ground.
All right.
Can you hear me?
What reference frame are you measuring those sticks?
Am I cutting out?
No. In what reference frame are you measuring those distances?
I'm measuring the distance. As soon as the guy does this, he's gonna pull the train over, get out with a tape measure, and see how far the photon traveled through those two stakes. Because the photon did travel through those two stakes, right?
Yeah. But if he's in the train's reference frame, then he'll measure a different distance.
Yeah, but in reality, the photon traveled. In reality, the photon traveled through the stakes in the ground, right?
But then use that clock.
Stop saying in reality.
And the guy on the train's reference frame, he actually traveled through those stakes in that time, right? In his time. It doesn't matter whose clock we use. He has a clock. Did he actually travel that distance in the time on his clock? According to his clock.
Okay, I'm back. What's up, guys? What's going on?
Armbar is going to figure it all out for us. Don't worry,
right.
guys.
I am.
Thank God.
If this problem, the question that Jeremy is raising could still be raised if you're shooting a bullet without any time dilation and any length contraction. Same argument could be made, so I don't think what Jeremy is complaining about is related to relativity.
What is he complaining about?
Okay, let me try to phrase it then with a bullet. So you're in the back of a train, right? And you shoot a bullet to the front of the train. And the bullet travels the distance of the train for you that is inside of the train, right? But if you mark the ground where the train was when you shot the bullet, and you mark on the ground outside of the train, the position where the bullet hits the front of the train, the distance is much bigger than the length of the train, right? You follow that?
Yeah.
Or you trying to follow that?
No, I the thing is,
No one talking to you.
Oh shit! It's like a crazy
shutting
storm
us
over
down.
there. You heard that, right?
Shutting us down, dude.
Never mind.
What's up?
I have something even more damning. I mean, I get what you're saying, Bacon, but it's just I think it's absolutely a and here's the reason why that doesn't apply. Here's the issue, okay? Because the speeds we're talking about, it's negligible anyways. The only time it's ever going to be noticed is if you have a very precise clock, or if you're moving much faster. But when I was thinking about this question the other day, it dawned on me that the way we normally describe travel, like Jeremy was saying, like, you know, if you're in a car and you notice like 2 exit signs or whatever, and the speeds in which like you like the times in which, like, if you notice like 2 exit signs and you notice the clock in your car and you're measuring the distance by using your speed and using the clock in your car, you're not gonna have problems you know, in your car. But technically that's the wrong way to do it. Technically it's not a correct description of the distance you traveled. If that makes sense.
No,
if they're more precise.
Hold on, Coach. So regardless of what your clock is, you can put points on the ground and then measure in between those points. Your distance is not going to change. You have a fixed distance in the ground we can put a tape measure up to and see what that distance actually was in reality.
Yeah, here's the problem though. Like I said, when you get set up at the beginning, they set you up, they give you a clock. They say which reference end you want, which coordinate system you want. Like coordinate system fixed to the car, fixed to the train, fixed to the ground. Whichever coordinate system you pick, you get a corresponding clock that goes with the coordinate system.
No,
you don't get to use somebody else's clock.
Dude, and if you're on the train, I experienced going through the stakes on the ground in my time on that train. Period.
Yes.
Like there's no right, Bacon?
I think.
Using my time on the train, I experienced going that distance.
Yeah,
right?
you have your clock on the train. Yes, your time on the train.
Yes. Okay. Yes. Thank you, Armbar. You are gonna straighten this all out for us, baby.
Listen, just trust me. The only reason you're saying that, or you can say that, is because in the reality that we exist in, when we talk about this kind of stuff outside of physics, we talk in this way and we do things this way.
Outside of
I'm telling you,
reality, bro.
I'm telling you that relativity tells us that that's actually incorrect. But since it gives us approximately the correct answer because of the speeds we're going, it doesn't really matter. But if we were traveling faster, if we were to still do these kind of errors where we're taking the clocks that we're using and we're using the coordinate system of some fixed frame outside of us, then it's just not a valid way to explain distances.
Just listen to me. When you're on the train and you have the clock, did you experience going those distances on the train using your clock? Yes or no?
I'm just going to repeat myself, dude, because the distance that I experience is going to be the coordinate system that's on the train, so it's going to be very different than the coordinate system on the ground, which would be the actual distance you're talking about.
Okay, so you're not going to experience. Okay? Let's pretend we're in a glass train. Okay, and you can see everything. You can see how far you went. You can see the stakes and everything, and then afterwards we can go out and measure the distance of the stake, so we'll know in reality how much distance I experienced when we go measure it. I mean, this ain't hard, dude.
Was that a question?
No, it's just stating a fact, bro. I can be in a moving vehicle and have 2 points on the ground and use my clock to determine how fast I went that distance according to my clock.
I just went over that. That's true. That's true. that's true that we do that at our speeds, and we don't. We
The
don't
train's
register
only
that
going
as
at
an error,
1,000
but
miles an
that's
hour. The train's only going at 1,000 miles an hour, bro. Nothing crazy. We can slow it down if you want.
Wait, so what's the question again? I'm
You want to go
confused.
500 miles an hour?
What's the question
We
again?
could go 1 mile an hour, and you're going to be, and it doesn't work for you. It doesn't matter how fast we make the train go.
go
No,
3
hold
million
on.
miles an hour.
Help me out again. So what's the question?
Uh,
Because I know the whole idea, but like, what's the question now? Are you like what are you questioning again?
Kosho's acting like I can't have a clock on a train and have 2 points on the ground and use my clock to determine how far I've traveled if I get out and measure those points with a tape measure.
You can, but you have to also use your coordinate system,
which is not on the ground. Yeah.
And Bacon's actually got a good point, because that has to be considered as well. That in the coordinate system that's fixed with you on the train, yeah, one of the stakes is flying backwards. While you're going forward, but still, once you go towards like relativistic speeds, there's a more stark difference in the time and the length of traction. Like I said, at 3 million meters per second, like 1% the speed of light, a second is already what is it, like 500 thousandths of a second longer.
To me, we're trying to solve too many confusions at once. That's why
everyone's confused. We got a clock on a train, okay, and we got 2 stakes in the ground. Can I not use the clock on the train and the distances on the ground to determine how long in my reference frame I traveled?
Not in yours. I think in the others, because it's on the ground, right? So you'd be measuring how long you did it in the other reference frame.
No, but for example, let me simplify this. You're just walking from the back of the train to the front of the train, and then when you get to the front of the train, you ask yourself, how long did I walk? How long did I travel? You could use the distance you travel along the train, or you could use the distance you travel along the surface. That would be much bigger. Your question needs a frame. One second. The answer to your question needs a frame. You can't just keep switching them.
Bacon, if I wanted to figure out the distance I traveled through space, what would be more appropriate? The distance on the ground or the distance on the floor of the train?
They're both going to give you distance through space.
No, the actual distance, though. The distance I actually moved through space on Earth, here in the reality frame.
Space is not an objective frame.
Which one would be more closer? Which one would be more closer to a distance for how much distance I traversed? The stakes on the train or the stakes on the ground?
I think neither.
Never mind.
If there was,
just forget it.
Even if there was an objective frame, if the train, for example, is moving against the spin of the Earth, for example, then the answer to what's the best frame would be actually the person in the train's frame.
Do we know the distance? Do we know the distance between New York and LA?
I do.
Is it frame dependent, or do we just know the distance from measuring it? It's frame dependent.
It's frame dependent.
That distance is not moving.
Yeah, no.
The distance
from New York isn't. But yeah, the distance between 2 points in the same time is not frame dependent. What is frame dependent is the distance between a point in different times.
Okay, so we know that the distances with the stakes on the ground is not frame dependent, and that is an actual distance that something went through, right? It's like pulling teeth.
Not the second
guys.
part.
Wow.
That is an actual. The first part is correct. That's an actual distance. But the second part, when you say that's, how do you finish the sentence? As someone went through. That is.
Say I'm on the train. Say I'm on the train, and I'm just walking super slow, and the train goes from New York to LA. I'll know how much distance I traveled, right?
No, because
we have stakes. Because we know the distance between New York and LA.
So you're referencing the ground then?
For our distance, how else would we reference how much distance traveled something through space on Earth?
You could
what
reference
other reference frame would you use? What else would you
reference? You could reference the train. You could reference the train. Like if you ask how much did I walk, you walk the distance of the train. That's a valid answer.
Yes, but if I want to know how far I moved through space, What would be more closer to accurate? What would be more closer to being accurate for how far I actually move through space in reality? The distance of the train or the distance between New York and LA?
Yeah, I don't think space is a like some universal frame. I don't think it changes the answer.
Space, the universal frame for how we know how far New York to LA is. Whatever
There's
frame
no
they use
universal
for that.
frame.
Do we know how far New York and LA is apart?
Yeah, but
that is in the same time.
Bacon. Do we know how? Don't worry about time right now. We're just trying to figure out how far we went. How far we went through space.
Yeah, but you're asking how long we did it after, like, for a certain amount of time. That's what turns. That's what turns.
Listen. Forget the time, Bacon. Bacon. Forget the time. Forget the time. We're just trying to figure out the distance my body traveled through space. And what would be a more accurate distance to use? When I walked the length of the train, should we use the length of the train, or should I use, since we actually went from New York to LA, did my body actually move the distance from New York to LA, or is it the length of the train?
That's still relative to frame.
That's not relative, dude. If I want to know how far I traveled through space, we know how much space is in between New York and LA, right? Is it relative or do we know? Is it relative or do we know? I gotta stop.
We know.
I'm gonna back out.
Jeremy, he's trolling you, bro. You hear him laughing under his voice. He's laughing.
He's not trolling.
Shut up, Arna. You don't know what trolling is. So Jeremy, you must have a good point, man. That's all I gotta say.
Okay,
I've never heard
if you say
so many people talk over, interrupt, and say so many outlanguage things in this actual train topic. Being honest.
Yeah, but that's the distance between two points on Earth. Just what's the distance between 2 points? That has an answer. Now, if you ask how long did I travel?
Oh, you got answers. I grant you that. It's amazing.
I mean,
that's
can't measure curved water.
I mean, it's not relative.
Can't measure a distance
never
of
mind.
train
You're
travel
not even
or
interested
curved water now. Add that to the list of things you can't measure.
And then complain about people interrupting people.
Not complaining, finish. Just stating a fact.
Why I was speaking. Well, anyway.
You mean while you were speaking, you interrupted me, man? You Xanaxing me now?
Me interrupting you is just like I'm not accepting your interruption. That's me interrupting you. It's just me continue speaking when you start interrupting. That's
when I first started talking and you interrupted me. You forgot about that one, all right?
Every time someone's talking and I try to respond and they keep talking, I stop and I wait until the next opportunity. I never continue trying.
I go on mute, so try me with the interruption bullshit, Xanax.
Okay. Anyway, so yeah, I mean, it's not like you're not trolling, Jeremy or anything. It's just that, like, from the, when it comes to like relativity, when it comes to like the speed of light and all that, I mean, we're just following,
Bro, we're not even on all that, dude. We're just trying to figure out how far I'm walking on a train, and the train's going from New York to LA. I walk super slow. So when we leave New York, I start walking one step every hour or whatever. And by the time the trip's over and I'm in LA, I've now traversed the whole train. If I wanted to know how far my body moved through space, would it be more accurate to use the length of the train or the length between New York and LA? What do you think? Let's be real for 1 second here, guys.
The angular size change.
What?
No, okay, that's being trolling. But for real though, hold on. So ask that again to Jeremy.
Hey, what's wrong with the angular size change? You have your height.
Are you serious?
Yeah, your angular size change. Your height would be the unit of measure, and you'll have how many heights you are to the angular size change.
For what?
Yeah, how far you was.
No, we're not. I don't think we're talking about that. We're not talking about that. No.
Yeah.
You want to know something though? I think what's the distance? It's like 3,000 miles about. But let me just do it. I'm gonna do a slightly different scenario, Jeremy. But just go with me, dude.
No,
use Alpha
dude, no, we can't do Kosho. Why would we move to something else when you guys can't even?
Because
you guys can't even realize how far. What would be a more accurate distance to take? The length of the train or the length of New York to LA to figure out how far my body moved through space?
Because it's
how
relative.
far? No, because that's not a valid question.
Can I try to address the question itself? Like, just consider for a moment that the Earth is moving, right? So if we're going from what are the cities you mentioned?
New York City and
LA
LA.
to New York.
Right. So if you're going from New York to LA, but LA is moving towards you, let's say that's the motion of the Earth, then you didn't move at all, right? Even though you're moving in respect to the surface was moving in the opposite direction. If that's the same speed in space, you didn't actually leave the place, right? But that doesn't mean the distance between LA and New York is 0 now, just because the Earth was moving in the opposite direction.
Yeah,
it's not how we tell distance. It's not based on an amount of time it took to get from one position to the other.
Yes.
If I travel on a unicycle, on a train, on a jet, if I travel from New York to LA, how far did my body move through space? Considering Earth's still and we're not moving at 1.3 million miles an hour, that would only make your problem much worse. If Earth is actually moving at the crazy speed you guys say.
that'll make your problem worse but that's besides the point.
I'll use Jeremy's assumptions.
No, it makes your
I'll use Jeremy's
Get out of here.
Let's just follow Jeremy's assumptions. Earth isn't moving. There's a fixed distance between New York and LA. So we travel that amount of distance, all right?
Do you want to use your model? Do you want to use your model where we're moving at 1.3 million miles an hour through space? Because we could do that too.
Let's use flat Earth. No, let's use stationary flat Earth. Let's make it easier.
Okay. So Earth's not moving, and we can actually tell how far we moved through space from New York to LA. Our bodies moved 3,000 miles, let's say.
Right.
Yeah.
Okay.
So not the length of the train. We would use the stakes, the points on the ground where we can put a tape measure to it, measure it.
Yeah, if you're all Jeremy's, then we're always going to use the surface always.
Or if we're in your paradigm, and we've moved 1.3 million miles through space, then we should use that number instead of the 1,000 miles an hour on the train.
No,
so we can do either one. Yours makes it even worse for you, though.
No, but that's why I said it makes it worse for you, though, because the thing is, the 1.3 million, whatever, remember, emotion's all like relative, whatever. So, I mean, for all we know, we could be moving in another direction. The universe could be moving in another direction, but we just can't measure it yet. You know what I'm saying? It's all relative. So it's stupid to be like, oh, like.
So, okay, you can make up any speed. You can say we're stationary or make up any speed you want. We're moving through space. It doesn't change the fact that we know how far it is from New York to LA, and my body actually moved that distance through space.
The actual distance in space or across the surface is 2 different values. One would be
do you want to use your heliocentric model where we're going at 1.3 million miles an hour? We can do that.
No, let's use flat Earth. Let's use flat Earth. Stationary flat Earth.
You're talking about the distance you actually traveled or the distance you actually are apart. They could be 2 different values and still be both true.
This is so silly. Motion is supposed to be.
To me, we should just follow Jeremy, see where we get.
Well, I mean, the distance over a curve can be different than the chord, even though the distance of the chord will be the
flat Earth. Flat Earth.
I'm really not even interested anymore. This is such I don't know what the right word is. Is this? I don't know. I don't know what the word is for what you're doing. I'm good.
Jeremy, because you're trying to make this like universal like frame of reference thingy where like there's only one,
Well, let's use it.
Coordinate system thingy. Like that's. I mean, if motion is relative, then that means you can't have like a defined amount of movement that you actually did because in one frame you're not moving.
That's why we're not contracted. That's why we're not smaller.
Well, why not assume there is?
Lorentz contraction, we can't tell if we're contracted or not. We could be going millions of miles an hour right now. We don't never know it.
That's all gets relativity yet.
I mean, for all we know, well, hold on. For all we know, the 1.3 million miles an hour that moving in one direction, we could also be moving in another vector, like 1 mile an hour outside the universe, because there's another force that we don't know about. But we would never know. It's just 1 mile an hour, but it's moving in another direction, like to the side. So it's like a diagonal thing. I don't know. But
do stationary flat Earth. Let's do stationary flat Earth.
No, I mean we could try, but Jeremy, I think, is done already. All right, we defeated Jeremy. He tried.
Yeah, I think it's sophistry. I don't know what the word is, but I can't deal with it anymore. I'm good.
No, that's not. We're not even trying to be like the sophist thing that you're talking about. That's just how it is.
I don't know if that's the right word or not. I don't even know.
Way to give up, Jeremy. Way to give up.
That's just the model. That's the model, Jimmy.
If I put you on a train and you walked from the back of the train to the front of the train, and the amount of time it took for the train to go from New York to LA, what would be a more accurate distance you traveled, the length of the train or the distance from New York to LA?
You don't want to do that with me because I'm moving in 11 different vectors here on Earth, through the universe, through the galaxy, around the sun, rotating, and also, in the train. So you don't want to do that with me. Okay?
You move further than the train. Jeremy, you move further than the train. Because the train moved 3,000 miles and you moved 3,000 miles and 50 feet.
Okay, so it would be a way more accurate distance to use the distance from New York to LA for how far my body moved through space, right?
As long as you added the distance you walked in the train, because the train has length of it too, and you covered that length as well.
Yes, so a more accurate distance, the most accurate distance for how much my body actually moved through space would be the distance from New York to LA, right?
That's compared to what?
Compared to the distance there's only the distance on the train that I walked, the whole length of the train, and then the distance from New York to LA. So which one's a more accurate distance to say the one I actually traveled, my body actually moved through?
Well, it depends on what frame you're going to compare it to.
I'm done.
Good, Jeremy.
I'm done.
Just be done with this, all right? You're not going to get anywhere with us, all right? Because we're telling you 1,000 times. It depends on the fucking frame.
Bro, I'm laughing so hard, my cheeks hurt.
Well, yeah,
you don't know how good this is.
If you're in a car,
bro, my cheeks are hurting me. I swear.
If you don't move in the car, did you not move 500 miles going from San Francisco to LA? Did you not move 3,000 miles in that car if you sat there?
Yeah, but do I get there faster if I'm in the back of the train and I walk toward the front of the train? Did I get there faster? If I walk into the front of the train, or did I cross the line faster?
I don't think anyone's denying that. We're just saying it depends on what you're talking about because, relative to the surface of the Earth, you've traveled the surface faster.
You traveled a greater distance than the front of the train did.
Yeah.
Right. So I traveled faster than the train, right?
Relative to the surface of the Earth, I mean, sure, but I mean,
your average.
Relative to whatever.
Relative to the train too. Relative to everything.
Yeah, exactly. Relative to the train too.
Your average.
Well, not relative to everything. You wouldn't be faster relative to someone. Let me see. That is going the same direction as you. That for that person, your direction is 0. No, not by any measurement.
Distance, I'm traveling faster by any actual measurement.
No,
I'm traveling
not
faster
really.
than the train.
Yes, your average.
Not really.
Speed,
no.
Your average speed would be faster. Yes.
No, not relative. He said relative to whatever measurement. That's actually not true. If you have someone with a radar gun that is traveling the speed of the train plus your speed, that's where you're slower. The train's faster than you, but it's. Sorry.
If he's shooting me inside the train, then I'm moving faster than the train. If there's
he's not inside
windows,
the train. He's outside the train.
He's out right. He's outside the train. If it's just a platform train, if there's a platform train and he has me walking up it, I'm going to measure faster than
you're on the
train
roof.
itself.
Brian, you're on the roof. You start at the back of the train. The train's going to New York. You measure with a radar gun the entire time. Who's going faster, the train or you walking to the front of the train? It takes you the entire 25 hours to get to the high-speed train to get to New York, and someone will have a faster time than the other, and it would be you walking on the roof of the train.
The roof?
Right.
The roof?
Walking on the roof?
The roof? Okay.
Roof.
Roof?
Just the way your mother likes it.
Roof?
Roof.
Roofie. Your mother roofie. Take her first.
By the way, I have something to deal with Brian here. You guys mind?
Roof is also a fast way of saying roof. Roof.
Roof.
Yeah.
Yeah. Roof. Okay.
So this is where we've gotten now. We can't tell what's more accurate if a train travels from one city to another, or if you measure the distance inside the train. Is this where we've descended to? Really?
We didn't descend to anything. We literally specified what reference, whatever. Like relative to the surface of the Earth, then I guess that's fine. But then like relative to like outside that, then you don't exactly got a point.
Bacon, you want to do it in here, or you want to switch room?
Dude, if we
your call.
You can do it right here, but if we use your heliocentric model, it makes it that much worse.
No, it doesn't. That's what I keep telling you because it's a relative thing. It doesn't make it worse.
Way worse.
No, it's a relative thing. You don't understand that. It's relative.
If we're talking about how much distance we've traveled through space, okay, if that's what we're talking about, if we're talking about how much distance we've traveled through space and we use your heliocentric model, it's going to make your problems way worse.
Jeremy.
It would if space was a coordinate system.
Okay, so real fast, how do you calculate speed?
Distance over time.
Okay, and how do you calculate distance?
Dude, it's a speed, time, distance triangle. We all know how this works.
Okay, right. So
access.
so depending on the reference, depending on where, what relative to whatever it is that, that's moving, whatever, right? Your distance can be different because you have different speeds and,
If we use dude, I can't.
Because relative to the surface of the Earth, you're moving one.
An easier way to do celestial navigation than all this globe math, all the fucking haver-sign bullshit that not many people know how to do, and everything. And I wanted to run this by Bacon. Are y'all interested to hear this or?
From you? No, not at all.
Okay.
Speed and time.
Yeah, if you want to describe it up, all
it's
ears.
like, okay, I'll make it quick then. Okay, so like them arms were, it says a longitude calculator on the AE map. It's a time and a longitude calculator. Okay, and I think there's a reason they rip them arms off and we never see them. Like you see the arm. I think one of them had a swivel, but let's say this. So either way, we're gonna know on the AE map or globe or whatever. We're gonna know our latitude. I don't think that's in question. We're gonna take our angle to Polaris or our co-latitude from the celestial equator, whatever. Okay, so we get our latitude easy enough. A couple different methods. So that marks us a latitude on the A map. So that leaves a big circle. Okay, so where do we go to find our longitude? Okay, so what we got to do. I think I found places where they give the GP in accordance to Greenwich hour angle of but even if we have to go the long route and we get the local hour angle of the
Are you talking about like waiting for a body to reach high noon? I mean, it's just
let's say
what
this
time it reaches.
at the point. Okay, we're not in contention yet as far as getting the GP of the star. Okay, we're just gonna get the latitude or the altitude and give the elevation, whatever. So we got the latitude. Now to get the longitude, we nothing's in contention at this point. We can place it. We can get the GP of a star over whatever point. The question is where we're at in accordance to that star. Okay. And okay, so using the AE map, we can use our co-altitude to figure out the circle. We just use the degrees and measure off the degrees from the co-altitude to get the longitude. It's that simple. We don't have to do any of that math. We already know the latitude, and so we mark that circle, and then we use the co-altitude to get the damn where it's at according to Greenwich, and then we have our angle right there. We have our angle to the star. Therefore, we have our point. We don't have to do all the. What I think so, man. Why wouldn't it?
You and lost mofo, Brian.
Because
the stars go in a circle, right? If the stars are going in a circle and they're measured to go in this circle, then all we have to do is convert the degrees of the circle to the AE map. We don't have to do all the straight. We already have the latitude. We don't have to do a straight line shot. We just have to figure out the longitude.
Right.
But those circles aren't all the same size.
No,
Right.
but I mean,
We're
if
going
you
by the
think
degree.
about it, you already have the correct, like the latitude circles is the same, so that circle is correct. All you need is for the second circle to intersect the first one in the right place. So all you need is the correct distance for the radius of that circle. But that distance can't be the altitude. That's not going to work. If that's what you're thinking, I don't think that's not going to work.
That's why I'm using the co-altitude, because it's going to be a certain height over our head, okay, at a certain time, okay? We don't know that. We don't know what time or what position that is. So we use the co-altitude, the angle of the star, and we can judge that it's going to be, it's going to be in our night sky. According to that latitude, it's going to be in our night sky for a certain amount of time. And then we can judge
that's like several hours.
Right. So it's going to be right overhead, halfway between it setting and it rising. So we take that degree and we mark it on the longitude of how high it is. However high it is above the horizon. We need to know the season, I guess. That's it.
Wait, what are we talking about? Is this a constellation thing?
No. Are you talking about taking a measurement when it's at high noon, or just any time?
No, taking a measurement of the star and comparing it to when it was directly at zenith, its highest point. So that's going to tell us where we're at longitude wise. If we know that the time of year, then we know, and we already know the latitude. Then we're going to know the zenith, right?
I mean,
think about that for a minute. Instead of just
if you're, I'm trying to understand what you're doing. I mean, if you're describing like getting the measurement when the star is at its highest point in the sky, when it's the high noon for that star, then you can get both your latitude and longitude without any math.
Well, no, we already have the latitude, bro. I agree, but we already have the latitude, bro. So think of this: if we already have the latitude, okay,
you don't need for doing what
the sun. If we have the latitude of the sun and ourself, okay, I'm just using the sun as an example, and the sun is 75 degrees. We know we could transfer 15 degrees of longitude to that latitude, bro. We know that it's 15 degrees away from zenith, bro, right?
Do you want to work on it?
We already know the latitude, so all we're looking for is the spot on that circle.
In perfect circles.
Let's do an example. Can we do an example? Maybe that can clear things. Not only it might clear things out, but
I think he thinks the stars are moving in perfect circles, and he's taking.
Yeah, no, they're calculated in perfect circles, Zanik. Yes, they're calculated in perfect circles.
Every.
You think they don't move in perfect circles, Zanik? Do you think they're not calculated in perfect circles, Zanik?
No.
I think he thinks that they're not calculated in perfect circles. Yeah.
They are. I mean, they follow lines of.
Zanik just said. You heard what he said. Shut up, Zanik. You don't have no clue.
Oh yeah, I have a clue.
I think he's talking about something else. He's almost always talking about something else. At least that's my perception. But
so rethink it, Zanik. Now you know that the stars are moving and calculated.
Zanik,
whether they are or they're not, they're calculated in a circle.
Stay on topic, please, Zanik.
Yeah. Okay. So, if you're taking the elevation to the star when the star is not at high noon, so it's still gonna get higher, or it's already going down.
Right.
Then
you know what I'm saying? So
if you do that, you wouldn't need Haversine.
What?
I think you still need the Haversine for that.
No, you don't. You don't need any of that. Think about it. Okay, would you agree?
All right, let's try an example.
Hold on. Let me ask you a question. Would you agree that if I know my latitude, let's say I'm on the equator, okay, and it's equinox or that time of year, okay, if I can get the GP of the sun from the ephemeris, okay, then and I know that the sun is right over my head, then I know my longitude, right? So if it's 75 degrees, like almost right over my head, then I know my longitude. And where them intersect, the longitude and the latitude. Like I said, this is all dependent on getting on knowing your latitude, which is easy.
You need to know if the sun is already in its highest point, right? If you do that before or after, then that doesn't work, right?
No, it's going to be your highest point, bro. Your highest point. No, that's what I'm saying. You calculate it you use the co-altitude. So in other words, degrees off of your highest point. So if we know that if we know the GP of the sun, and we know our latitude, then we know the highest point. Pretty much, we know the degrees from our highest point, the sun's highest point over us. So we know where the sun's over, bro.
That's what I was talking about. The high noon of the sun. It's when the sun reaches its highest elevation angle to that observer. Is that what you're talking about?
Yeah. So if we had them arms that were on the AE map, why would it say it's a horizontal? I mean a longitude calculator, because it calculates the longitude, bro. Them arms would you'd have to measure to get the elevation, and you would agree that getting your latitude's the easiest thing. That's not even challenging for anybody.
I mean,
what are we
it's
talking
the easiest
about?
thing. He's trying to explain about a new way to do celestial navigation. They can use the A map, and it's easier than using a globe.
Yeah, and that's the first thing they teach us is how to get the latitude. With the elevation and your altitude shit. That's using the.
What star?
You don't even need an ephemeris.
But that's for high noon.
You don't even need an ephemeris to get your latitude.
But that's for high noon. Yeah. That's why those coconut sextants could determine latitude. They would have to wait the star when the star was highest.
Right. So what this AE map is a longitude calculator. It says it right here. If you want me to take a picture, it says it's a longitude and a time calculator. Okay. Do you think that that's wrong? I mean, do you think he couldn't back up that claim? Possibly, but I think it's pretty fucking easy, and we don't need all this spherical mathematics and shit. Just use the AE map and you get your longitude.
Yeah, but
simple shit, bro. Anybody could navigate using an AE map.
Yeah, I already described the way, like if you're waiting for a celestial body to reach its highest point in the sky, and you measure the elevation, you can get both your latitude and longitude like that if you know the time in which it reaches the highest point.
Wait a second.
It's always
not without the calculations on a sphere, because I would need to know.
Yeah, without the calculations.
I need to know is the angle to the star. I don't have to wait on it. I know that if it's okay. So let's do this. Let's make a.
Yeah, that's not practical. That's why no one does that.
Not practical. That is the definition of fucking practical, bro.
No, but you have to wait until celestial. 1 second, dude. Because when navigators do the fix, they usually do it during nautical twilight, because they can see the horizon and the stars, and they're not gonna know which stars are in their highest points in the sky, and they can't wait for that. Otherwise, they're gonna lose the horizon.
I don't have to wait. If it's 15 degrees away from my zenith, then I know it's an hour away from being at its zenith.
No, does any of this involve distances,
of course
Bacon?
Sorry?
Does any of this celestial navigation involve distances by any chance?
Not necessarily.
No, distances aren't relevant? Oh, okay, just checking. After the last conversation, they better fucking not be. I feel you.
Oh my goodness, Jeremy.
You guys don't know distances. I don't know what to tell you. You have no idea how much distance we've traveled.
Jeremy, what's the formula for okay, actually, hold on.
Well, we already know the angles of the AE map. That's what they say they're useful for is angles. The azimuths are equidistant. So the angles are tried and true, and that's why the USGS used it. And it's hard information to find now, but I've clipped it out where they use AE map when they're using maps, and the Department of Defense or the military and the DoD use it for like radar propagation because the angles are tried and true.
Yeah, Brian, I think you need to re-explain what you're talking about because Bacon is still thinking that you have to wait for a star to be at its zenith. Can you explain to him?
I understand he said you don't need to, but what he said doesn't work. I understand what he said lastly, but that I know doesn't work.
What do you mean? If I know where the star is at, Bacon, if I know where the star is at, okay, and I know where it's going to be over my head, then that's all I need. What are you missing?
I don't know that. You don't know when it's going to be over your head. Often it won't.
What do you mean you don't know? If it's 15 degrees away, then it's going to be at its highest in freaking an hour.
Of course not. Take for example,
If you know your latitude, bro, you can calculate that. What are you talking about? You know the size of the circle. If you know where the star's at and you know your latitude, you can easily calculate that. You don't have to do all this Habersign bullshit. You're acting like I'm just guessing my latitude and guessing where the star's at.
You can have.
I know
What
the
are you
latitude of
using
the star,
Habersign
bro.
for?
Because
What are you
Okay,
What
let
are you
me.
using Habersign for? What
They're
are
trying
you
to use it.
using Habersign for?
They're trying to use it for the distances on a sphere in the
They don't know.
angle.
They don't know what any distances are. You can never know what distances are because you don't know what reference frame.
Jeremy, that's freaking. Come on, man.
The Earth.
Oh, you don't like it now? Now we want to know what distances are. Now you guys know all of a sudden. I know.
Yeah, we do.
Yeah, we're on the Earth's reference frame.
That's right. Yeah, that's right, Jeremy. All right. I think you're cool, but you're not.
All right with you, dude?
I think he is, man.
Okay.
No, we can't know how much distance we traveled because we're moving. We don't know what reference frame to use. You can never know how much distance you traveled.
We're of course using the Earth's reference frame, since all the coordinates we're using are on Earth.
So now we can tell how much distance we traveled. We know that if we know that we've traveled that distance if we use the Habersign formula. When I need to know a distance for special relativity, there's no way we can fucking ever know how much distance we traveled. I know, guys.
No, nobody said
I
that.
know.
The question you asked then was how far did we travel through space, through actual space? Yeah.
Yeah,
So
actual
there's
space from
there's
New
no
York to
fixed frame.
LA or wherever you were using this Habersign formula, the actual distance.
Here, Jeremy.
The actual distance we traveled.
Hold on, Jeremy. Imagine you're in a void, right? There's nothing, just you. All right. If you can't travel in this void because there's nothing to travel relative to. All right. You have literally zero speed, and in some sense also maybe infinite speed. I don't know. But maybe I'm fucking with that one though. But you're essentially zero speed that you literally can't fucking move. All right. There's nothing to move relative to. All right. Speed is or distance, whatever. The movement is relative. All right. It's relative.
I don't want to derail your whole thing, Brian. Go ahead.
Yeah,
that's right.
I think I got what Brian was trying to say.
Speed up, Orm.
Think you can do it? I don't think it'd be that hard, man. I think I got away because not only can we do that, we can also calculate the angle. Okay, not the angle from like Polaris to the that's worth a try. Calculate the angle from Polaris to the star if you know the GP. I mean, using the ephemeris. But besides that, we could just use the size of the circle that it's taken and how close it is to overhead. We'll know how close it is to overhead based on the star's position. And
okay.
So I'm thinking we could draw an angle between the star's position and where it's directly overhead, and then our position, and then a straight shot from the star to the latitude.
Okay, if I understood what you're trying to do, we're not using the AMAP for anything.
Yeah, we're using the AMAP to make the altitude, the latitude circle. We could just draw it on the portion of the map where we know we're close to. Like you got to have at least an idea of what continent you're in between, right? So you just draw a semicircle, and you know you're somewhere on that semicircle on the AMAP, right?
I don't think you need that.
Well, but you'd agree though. In getting my latitude, I can draw a semicircle if I know what two continents I'm in between. Instead of having just a big ass circle on a globe, I could just have a little semicircle. So I've already narrowed it down. Just knowing my latitude, I'm already doing better than the globe, right?
Oh, maybe. Let's see how where we can get with this. So if I'm thinking correctly, given your latitude, if you know your latitude, the elevation of a certain star is going to go up and down in a sidereal day cycle for that latitude.
Right.
And each longitude is going to be in a different offset of that cycle.
Sure.
So,
that's why we need the latitude of the star.
Right. As you go up and down. Right. As you go up and down, there's going to be a correlation between how high it is and your longitude.
But we can draw a semicircle of where on the latitude where the star's at too. Correct. We could draw a semicircle depending on its longitude and we could from where it rose and to its zenith where it's at currently to where it sets, right?
No, you could be anywhere on the latitude circle. Like you have to do the whole circle.
Wait. So we get the GP of the star, and you don't think that we know its longitude?
No, of course we know. That's not what I'm saying. I'm saying only from the latitude.
Put yourself there then. So now we have the latitude and the longitude of the star. So we could draw a semicircle, of where it rose and where it set. And then we do the angle from there.
I'm trying to think if the elevation of the star is gonna follow a sine function. I'm not completely sure.
It would be a sine. It's just a sideways sine, right? So it's going to follow the sine function of a circle on its, laying down flat instead of which half of the shit line of position, they try and make it look like it's upright, but the haversine is used horizontally any fucking way, which was part of my argument with McToon. Like, bro, this is a circle on the ground. This haversine is doing but then they make it look like it's an elevation haversine, but it's really a circle laid down.
Haversine only has to do with the surface.
It's a surface either way.
I think this might work, but I don't think but the accuracy is going to be very good.
Well, let's check it, man, because if the accuracy is a little bit off, then there'd be a way to adjust for that with the sign.
No, like the problem
is. Let's try it. If it works, let's make it work. Let's make an app and we'll split it.
All right, but here's the thing. What I'm thinking that might work. Okay, we don't need the map to do anything. You only need to do the arc sign of you get the difference.
Oh, that's going to be different, bro.
What?
That's not going to be the same, though, man. Don't try and do a globe switch on me, man. We know what you look like, dog.
No. I'm not trying to use the globe. I don't think we need the globe for this, but I don't think we need any map for this. I think this is simply like an empirical thing we can get.
Bro, how can we not need a map? How can we not need we got to draw. How do we need a map? The whole point in this idea was to make it work on the AE map, bro. Don't expel the map, bro. You can burst in my bubble.
Yeah, but I'm not seeing any need for the map. Like if I'm doing the way I understand you to explain it, we don't need the map. Like the map wouldn't be useful for anything. You can try to draw things on the map to say here's where I am.
You have the map memorized. Is that what you're saying? So you have the map memorized, so you can mark your position. You can mark your position of the star based on memory, or what? What do you mean?
No. Like you can use any if you can use a Mercator or whatever map, just to take a look, have a rough understanding of direction. Any map would work.
Yeah, the math is going to be way more bullshit on a Mercator, bro. I'm not saying it couldn't happen. I think it could happen on any map, but instead of just using the sign for the circle, you're gonna. Yeah.
I think the only reason why a map would help was to you're gonna have two solutions out of this. You're gonna have two results.
Right.
There are going to be two possible longitudes for you to be, and the map is going to be useful for you to just know which one is the likely one without having to think a lot. You can just look at the map.
Yeah, but the angles we know are good on the AE. We know that the angles are tried and true, so that's why I recommend that map. Because to me, more important than distance is your fucking distance. If you're out at sea and you're up under a star and you know the GPS,
you can never tell your distance.
Matthew, you know that you're close, bro. Just by being close up under the star.
You never
right?
know your distance.
I think what they don't mention though, Jeremy, is the angle. But the angle, bro. We need to know which way to fucking go, right? That's way more important at sea than knowing your distance. Who gives a fuck if I'm 3,000 miles away? I need to know what direction to go, and that's been thrown out with the bathwater. When that is way more important than any fucking distance,
Okay, I'll put an example.
I think I've landed back. I'm bringing this back down to earth and what it was originally used for. This is information I feel like they've thrown out, bro. It's very important though. Yeah. But now we use GPS, so nobody's thinking about it.
Brian. I'm gonna do an example, right? So we can see if it works, and you can also see if I'm doing what I should be doing. Is that right?
Yeah, I'm willing to. Yeah, look at it.
All right. So
That's what I was trying to do is get you to put it on a program, maybe make an app or something, man.
Yeah, I'm doing.
Well,
I'm
it'd
just
be
gonna do it by
practical.
hand
It would be very practical, bro. Right?
That's debatable because I think the problem is that your latitude is not very accurate if you do like that. Like if you just get the elevation to Polaris, there's like what, half a degree, plus or minus half a degree.
Well, let's check the angles, bro. That's what's important here, in my opinion. So let's just put it in your program and check the angles.
Okay, yeah, no, already. I'll do it by hand. First example. So I'm on a certain location here. The elevation of Polaris is, let me see, 38. This is already, I'm in stellarium. I turned off the atmosphere so we don't have to correct for refraction or anything.
Yeah, okay.
It should work best. 30 degrees, 29 arc minutes, and 0.01 arc seconds. Okay, that's the elevation of Polaris. And I'm going to use Dubhe as a second star. Which
Can you repeat
is, I'm using Dubhe as my second star.
Okay.
It's the one in the Big Dipper that points to Polaris. It's
Right.
called Dubhe. So the altitude is 57 degrees. 52.
I don't know why you're using one. Well, it doesn't matter, I guess.
Okay. All right. So what I have to do now is to take the difference in the elevation of Dubhe and the elevation of Polaris, right?
Right. So we know the latitude of Dubhe, and I think it might be helpful to get one more, but I don't even know if that's necessary.
I'm not sure how I would do it with one more, without ignoring the first one.
Yeah. Oh yeah.
Okay.
You'd have to know the first one. Yeah. Pick one maybe closer to the equator.
I think I pick one that I can see going up and down.
Well, I think the closer you, I think the easier it's going to be, the closer you find one to match your own latitude. So if you find one, that's my opinion.
Dubhe altitude is 57 degrees, 52 arc minutes, and 47.5 arc seconds. Okay, got both angles converted to decibels. Now, let me think a little bit. So
yeah. You realize on a globe, I wish I could see this, dude. I could help you and put our minds together. But you realize on a globe, if you get your position, okay, you get your. Let me tell you how worthless a globe is for cell nav. Because if I need to know which direction I'm going, okay, that's only accurate for very minimum, bro. It deviates immediately your direction. So if I'm gonna use a compass, which how else could I fucking do it using the stars and a compass? Hold on, if I know that my position that I'm going for is east, and I start heading east, I'm no longer heading east after fucking a few miles. I'm already off track of where I was supposed to be heading.
That takes a while.
Huh?
It's not that fast. No, it's not that fast. It takes a while.
Only straight lines are great circles. It's faster than you would think. I mean, if you're talking if you're 2,000 miles away, which is not that far. I mean, it is that far, but if you're 2,000 miles away, then you can't dead reckon, and you can't follow a compass. You can't do neither on a globe. So I think that's an important factor that needs to be discussed. Like, what's the fucking, where's the practicality if I can't dead reckon? Because the only straight lines are great circles, and I'm limited. That's limiting. I'm just saying. You'd have to check your shit every freaking hour if you were going at a decent speed, in my opinion. Or just keep checking it and just plotting out a million bullshit straight lines and circle your way to your. I don't know. But yeah,
No, I don't
look
think
that
it's that
over.
much.
Look that over. I wish I could see. Can you take a screenshot of what you got and post it in the live?
I'm doing on paper. I'll send a picture.
Yeah, because I want to see if you're executing my idea.
If I'm not executing your idea, I'm executing my idea of what your idea is, which I think
Sure,
might
man.
work.
Look, he's trying to cut me out already, guys. See how this guy is, man? He's trying to cut me out already.
That's exactly how he is.
It might still be your idea. I'm just saying that's what I understood from your idea, which might be wrong. Let's see.
You're gonna be at MC Tune show with your equation.
I'll claim MC Tune's prize and say I did it.
He ain't gonna fucking pay you no matter what you do, bro. Even after showing him that I mean, he's got so many stipulations, bro. How you gonna meet them all? So I showed him a calculation using a flat triangle, and he told me I'm using the radius. Like, motherfucker, I just showed you the math using a baseline and getting the height to the stars of 3959, and you're telling me that I'm using the radius of Earth. It's not my fault that y'all hijacked the radius of Earth from a flat triangle, bro. You know, he's like, I mean, that I would have thought of other reason not to pay me. To use that as a reason is kind of horseshit when I just showed him the fucking flatline triangle.
Hijacking's not legal.
So I got the declination of Doobie, and I got the longitude of the ground position of Doobie. Right. So the declination of Doobie is 61.626805 at the moment when I took the measurement. So that's higher than what I measured.
So we know the latitude though of Doobie now.
Yeah, the latitude is the declination.
So we don't got to measure that right yet. Let's just get the we get a couple of stars or whatever. I would like to, to me, I would use a few different stars just to cross-reference this shit.
Okay, we're gonna use Polaris elevation as our latitude, right?
Sure.
So our latitude, how many decimals do you want?
1. None.
That's 2.
I don't even need decimals yet.
Yes, you need decimal.
Bro, if it's not accurate to like I said, the distance doesn't really matter at this point. I'm going for angles in which direction to go.
Okay.
I'm testing the longitude calculator. I'm testing that claim. That's the importance of being out at sea, in my opinion. That's what's critically fucking important. It's going the right direction. I think it's a given how far you are away from something. If you know the GPS stars and their location, then you know the fucking distance, bro. You don't got to do any calculations to get exact distances. If I go off course, I'm gonna run into rocks. Not if I get there fucking sooner or later. I'm not gonna crash if if I take longer to get there. I'm gonna crash if I go off course.
Okay, so the complement of the declination of a star, it's gonna tell me how up and down that star is gonna move, right? So if the declination is 90, then it's not gonna move because it's pretty much Polaris. And if it's as a smaller declination, so it's away from the celestial north, it's gonna move up and down.
So right, and so let's work the GP of that star based on its LHA or its SHA. It's sidereal angle. It's angle to Greenwich, or it's GHA. What the fuck am I talking about? So we'll get the longitude based on the GHA, and then we know that where we draw that point is its zenith, and we'll go from there. We could draw the point on the A map of where it's at.
Okay.
Then
the difference in altitude between Polaris and Dubhe was 19.3965 degrees, and that divided by
that's the
cold.
azimuthal. That's the difference in azimuth.
No, I have no azimuth. I only have a sextant. Remember?
Oh,
so that's the difference in altitude between Dubhe and Polaris.
Hey, you're skipping steps, bro. But go ahead. I'll hear you out.
Oh, I need to know how close Dubhe is from getting to. I know, right? So if I divide this by the cold declination, is that the word? Cold declination. What is the cold declination? Yeah, so I divide this by the cold declination, and I take the arc sine. That should tell me how many degrees I am from having that star overhead. I think the arc sine or the arc cosine. Oh, it's the arc cosine, not the arc sine. Okay, that's radians. Turn that into degrees. So I should be 46.87 degrees off of the longitude of the star. So if I add that to the longitude of Dubhe.
How are you figuring that? From a God view, you mean? Like from a God view?
Yeah.
Yeah, from a God view.
Hey, you're about 3 degrees off would be about.
Yeah, but
200.
I'm not even at you're just going off doing your own shit, bro. You're not even doing what I've mentioned. And I have no idea why.
Shouldn't I try to use like
bro?
high?
Do you think that do you believe that let me ask you, do you believe that the A map can be used as a longitude calculator?
Like how? I don't know.
I'm trying to tell you how, but I'm asking, do you believe it? When he says it's a time and longitude calculator, do you disagree with that? Just asking. So I know how much friction I'm fucking up against.
Yeah, I don't know what that means. Like, I don't know what
you don't know what longitude means?
I know longitude means, but like.
You know what calculator means?
I know what calculator means. What information are we using to get the longitude?
I'm trying to calculate longitudes.
Without
doing any of the fucking these fucking stupid solutions that most people don't even understand. It's hard to understand. It takes so much time to understand the shit. It's not even worth it unless you're literally doing this shit every day.
Right. Yeah, but from what information are you getting longitude? Depending on what information you have, I can say yes, you can use that.
I gotta go for a minute, man. I'll be right back.
All right. Okay, I'll try to solidify your method. I guess no one was following this, right?
No, okay. So look, if you're trying to follow my method, then do my method, okay? Now, what I'm asking you to do is, okay, you got first get an angle to Polaris and write a semicircle in between the two continents where you're at on that latitude. So let's start with somewhere where we know we're at. We know we're in between these two continents. We know our latitude. So what I want you to do is draw a semicircle. Now we got to narrow down and calculate our longitude on that latitude. It's never going to be off that latitude. If it doesn't wind up on that latitude, then you're doing something wrong to begin with, because that's a given. We already know we're on that latitude because it's a circle around Polaris on either map. It's a circle around Polaris. So all we need to know is what continents we're in between. And so we just draw. I mean, if we're out at sea, we'd know how far we were off the coast. We wouldn't have to draw it completely in between the two continents. But but just for presentation's sake, so we know our latitude. Okay, now we take a star, try and find one east or west. But even if you can't, we could do another one. But I'd recommend it just probably be easier to find one. I mean, if you could find
No
one,
way to know.
A compass, bro. What the fuck are you talking about? We're not on a globe, bro.
Even
Y'all
as a
gotta
compass,
drop y'all's globe thoughts here
even
just for a minute and follow me, please.
Even on a compass though, if it's circling ahead, if it looks east, it's probably not going from east.
There's no way to know. There's no way to know which direction you're looking, what distances are, nothing. We can't tell anything when they need it. It's fucking weird.
All right. Yeah, that's how it is on a globe, bro. It's totally impractical because you wouldn't know which way to go. They just throw out everything and
What do
just
you mean? No,
to show you an accurate distance. Hey, I got the distance. It's a globe. Like, are you fucking kidding me?
we do get the azimuths from spherical math.
Circular math. Yeah, you could call it spherical math and call it and tilt them lines and call them spherical excess. But that's a whole other argument. Okay. But anyway, so tell me, get 2 stars. Try and get one. Fuck it. We don't know if it's east or west yet, as far as the formula goes. I'll give that to Kosher. Okay, but if we're out at sea, we do know roughly east or west. Okay, but so just get a couple stars and get the GHA and subtract the pretty much subtract the LHA to get the GP of 2 stars.
Okay, I'll draw it. Can anyone join live stream with me and Brian?
I'll join it.
I'm not in live stream, bro. What are you talking about? I'm not in live stream.
I was talking. My mic wasn't working the whole time.
I just started.
Oh, I like that, Megan. I like that.
Right.
Got a sky and water. Yeah, look at that. I mean, they're just 2 rectangles. One blue and one lighter, cerulean, but whatever.
Okay. Yeah, Brian. I wasn't live streaming before. I just started now.
Okay, good. Yeah, I'm in live stream now, and draw that blue up a little higher, man. This is a flat Earth, bro.
No, you don't understand. The camera's angled up a bit.
I'm just kidding, dude. I'm just kidding.
Yeah,
that's Polaris. Right.
Can I take a picture of an AE map and send it to you so you could put that up?
Yeah,
I'm not interested in the ocean and all that. I want you to present an AE map.
I'm just trying to explain what is the way I understand can be solved based on the information.
AE maps, I could do it and show you. I know you're quicker, so I figured we could do it live as far as getting the GP. So let's get the GHA from the of Aries and let's get the GP. Let's subtract the LHA and get the GP of 2 stars.
Okay, wait a second. Let me just explain what I was trying to do first, and then you tell me if
great.
Makes sense for you. Okay, so that's Polaris, right? And we're gonna take an elevation angle to Polaris. So I'm gonna represent that with an arrow, yellow arrow. So that is the altitude.
When have you ever cell nabbed like this, Bacon? I'm just asking, bro. In what fucking dimension do you show the ocean and fucking stars over the horizon? Like, bro, we need a map, right? We need a map, and we can just throw out the observations, bro. We can call out what we're seeing. You know what I'm saying? We don't need to illustrate them. You've never ever illustrated this shit, and I don't know why you're doing it now. It's meaningless.
In what realm?
Yeah, I'll explain. Just draw the fall, please. So that's Polaris. Let's say we have Dubhe here. So that's a different star. Hey, Kosho, join that too. So we have more people that might correct if I get something.
Yeah, Kosho, why don't you join? Because I'm gonna be honest,
you're just gonna put Dubhe and measure and you're pretty much gonna freaking measure an angle between the 2 and say, look, it's wrong. Is that what you're trying to do here? Because that's not my method, bro.
No, I'm not gonna measure an angle between them 2.
Okay. Coach, so join the stream. You're Bacon's backup dancer.
Okay, so Dubin makes a circle around Polaris, right? So it's a perfect circle.
That's a nice name, Doobie.
Zenik said it isn't. We're going to ignore him. We all know it is.
Bro, we can get the latitude. We can get the latitude and the longitude of Dubé, bro. All we need to do is look in the ephemeris. Or you can make one up. Just make one up, okay? That knowing the latitude. Okay.
Say
You know that it goes in a circle on a latitude, right? So it doesn't matter where it's sitting. This picture, it's I don't get it, bro. Like why ain't you doing what I'm asking, man? I got a method
Because
here.
I have a hard time following you, and I think I understood a way to like
following. All I'm asking you to do is present a map, bro. To start, present a fucking AE map, and then give me the elevation angle to Polaris. Okay, and then we'll know our latitude and draw. I'm just saying, pick a random spot in between two continents, and we'll start in the north.
Yeah, but what if you don't see Polaris?
Let me just. Can I just make this example?
There's ways around that, bro. There are ways around that. We don't need to see Polaris, bro. We can also just see the star and measure its fucking its get its GP and get the angle from the fucking celestial equator, bro. We don't need Polaris. I'm just trying to make this easy. Why are y'all doing this?
Wait, you saying we can get the latitude from any star?
Yeah, I'd like to see that.
I like to see.
Okay, let's go to the map then.
Yes. No. We could get the latitude of any star because that's the declination, bro. That's the declination. The declination is its measurement.
Yes, of course.
That's not what I said,
equator, bro.
That's not what I said. I didn't say
get the declination. I thought you were denying it, bro. About to say, what the fuck?
No, I didn't say the declination. I said not the latitude of the star. I'm saying getting your latitude from any star. That's what I was
what we're trying to do. I'm trying to position a star over a map, for fuck's sake.
You said we don't need Polaris for that. Are you saying we can get our latitude from all the stars?
Screaming my name, bro. Please don't start screaming my name. Brian, please don't do that.
All right. Anyway, are you saying that we can get your latitude of the observer using any star that is not Polaris? It doesn't have to be Polaris.
No, it doesn't, bro. Kosher said, "What if we can't see Polaris?" He knows what if we can't see Polaris. He's just doing this. I don't know why. To scream my name.
Okay, so explain how you would do that then. You see Sirius. Okay. You see Sirius. Okay. You don't know what time it is.
Then I go to the ephemeris and I get the declination. Okay, what does that mean? Hold on. Where is the declination measured from? The celestial equator, right?
Right. So let's say this. Let's say you have
latitude, right?
Hold on.
No. It's not.
Let's say you see Sirius and you already know the declination. You have it memorized. Okay. Now, how do you find out your latitude?
It's always on a latitude, stupid. Every star
is on
a latitude, and it's in the ephemeris, bro. It doesn't.
How do you find your latitude with this information?
Am I right or wrong? I don't need that.
You are not listening. I don't need to know
where I'm at to know where a star is at. It's in the ephemeris.
I know, Brian, you're not listening. This is the problem: is you talk over people so much that you're not even in. We're not having the same conversation, dude. Bacon is bacon. No, hold on, dude. Bacon. Dude, Brian, you're doing it again, man.
Why are you even talking, dude? Why are you even talking, bro?
I was in the middle of talking to you.
Why?
You would have just brought me up.
Do y'all want to know my
to what I said.
Do you want to know my idea or not?
Brian, right now we're listening to you, and you're saying that you can find your latitude using any star and knowing its declination.
And starting with what? Starting with what, Coach Joe?
Knowing its declination.
I'm trying to present here. I thought Bacon would help me and present a fucking AE map, okay? Because I can't do this shit on a computer. I literally do have a piece of. I literally have a piece of paper with a bunch of AE maps printed up. Okay, I could present it, right? But I figured Bacon's faster at this, and he could put it in a program. Okay, now my idea is not to draw somebody out on the ocean. I'm saying it over and over again. Draw an AE map, and let's get the information from the ephemeris. We don't know where we're at. We're trying to figure out where we're at. We're trying to see if it works on an AE map. I don't need you to throw problems at me like, what if we don't see Polaris like that, bro? I don't need
Nobody's
that.
throwing problems at you, Brian. You don't listen long enough to actually know what anyone's saying.
You're
But
a dick, dude.
that knowing the declination, no, but it's just the truth, Brian. I started talking like 3 minutes ago.
Why are you
Still
still
haven't heard what I
talking? Do
said.
you want to know
You
my
still
idea or
haven't.
not?
You still haven't heard what I said. But just knowing
I
the
asked
declination,
everybody if they wanted to see this,
dude,
and
cut it out,
everybody
man.
said okay.
Dude,
And why are you talking, bro?
dude, just cut it out, man. Just knowing the declination to Sirius isn't going to tell you anything about where it is at any given time. You're like, if you don't know what time it is, if you don't know its actual position, you know what latitude it's on, but it's not going to tell you what latitude you're on.
Kusho, I know that, motherfucker. I said mark it on a map where the star is at, the GP on a map. We don't need my position to know where a star is at on a map, do we, asshole?
Yeah, you didn't say the GP. You said you know
Brian,
its declination.
relax. Yeah,
I'm
relax.
I'm out.
No.
No.
He's gone. Is he gone? Actually, I didn't check. Actually, hold on.
Okay, but he gave me a good idea. Maybe this is not his idea. Because, when I was drawing, he said this is not what he asked, so maybe this is not his idea, but this is my idea from his idea. That might not be his idea. So I don't know whose idea this is. But anyway,
It's an idea from the ether. Yeah, I see it. It's pretty cool.
Right. Okay, so look, think about it. You have Polaris, right? Let's say Polaris is right at the celestial north. So it's exactly where people usually claim it is. Unfortunately, it's not. It would make life a lot easier. But anyway, let's say it is. So here you have Dubhe, right?
Dubhe
is that star that points to Polaris.
Dubhe or not Dubhe?
Dubhe or not Dubhe. Eric Dubhe.
Eric
Right.
Dubhe.
So Polaris makes this circle, like it rises
Scooby
east.
Dooby. Okay, never mind.
Enough with
All right,
Dubhe
go ahead.
jokes. So it's going in that direction, right? And it's making this circle. So this angle here between like the center of celestial sky, celestial north, and the circle that Dubhe circles is the co-declination of Dubhe. Because from this to the equator, there's 90 degrees. So if the declination of Dubhe was 0, if the declination of Dubhe was 90, it would be exactly here, right, at the center. But if it's 85, then there's 5 degrees here, right?
Yeah, but I thought he said that taking it at one time. You said taking it over time?
No, one time.
Yeah, but you can't take that measurement at one time.
No, I'm taking the measurement. Dubhe is here. I don't know where Dubhe is. I'm just taking I'm not taking these measurements. I'm just showing what Dubhe does.
Oh, you're just using that rate. You're using that radius to come up with the
yes.
latitude.
No, I can get it from the almanac too.
Right. But I'm saying, like, if you see its position with Polaris, you could just come up with the rest of the circle, and you could see like the entirety of the latitude, basically.
I guess. Okay, so this is Dubhe's altitude.
Wait, is it actually called Dubhe?
Yeah.
Huh.
It's the star that points to Polaris. That's the altitude of Dubhe, and this is the altitude of Polaris. And I know that this distance here, this angular distance, is the co-declination. It's the complement of the declination of Dubhe. I'll call it the co-declination. I'm not sure this term exists, but it makes sense to me, and I'll use it. So, if I subtract those two elevations, I'm going to end up with the height of this triangle here, right?
I see.
So if I have a hypotenuse and I have a height, I have an angle, right? So I know what is the angle of Dubhe in this circle. And given that the Dubhe makes this path here once every sidereal day, if I know exactly which point of the circle Dubhe is when I took the measurement, I would be able to know exactly what my longitude is. There's only one place where Dubhe would be exactly here. I mean, if I'm only using the difference, it could be in the other side too, but I see that it's to the left of Polaris. So that solves it, right? Does that make sense?
You think this is what Brian was saying?
No, I thought at the beginning that he wanted me to do something like this, and then he started complaining that I wasn't using the AMAP. So I realized that's not what he wanted. So I wanted to explain him what I was going for.
It's pretty clever though. The code declination derived from that is actually pretty clever.
It is pretty clever.
But the problem is polarity is not exactly at the center.
Yeah, but what's your error going to be? It's going to be like
yeah, I did it. I got 3 degrees off. 3 degrees off. First time I did it. 3 degrees is what? 70 miles times 3. 21
miles.
220 miles. Yeah.
Ooh.
Yeah, I mean, but this wouldn't get too big. Like if you do circles on the map, you get thousands of miles. Like if you're in the south or something. But this, I don't think that the error here is too big. This is a more acceptable value.
Yes.
But what he was saying later that you could get your latitude from other stars, and not Polaris.
Right.
Then I would like to know how he wants to do that. But unfortunately, that very question made you leave.
Yes. That's kind of telling.
No, I think he overestimates how well he's explaining things, and when people don't get it, he thinks it's on purpose, and he gets frustrated and angry. I don't think he's dishonest or anything like that.
Yeah, it's kind of like Jeremy.
I didn't say that. Yeah, I was joking around when I said that's telling. I was joking around when I said it.
Okay. Yeah, I think he misunderstood that we were actually misunderstanding it.
Yeah. I was trying to. All I had to do was tell him how it sounded like exactly what he said.
I'm not sure if you can do this math here, because this is like I'm not sure sine and cosine works on spherical coordinates like this. Does it?
Sine and cosine?
Oh wait, no. No, yeah, dude. There's
I think it's not.
Hold on a second. You're a crazy son of a bitch, Bacon. There's actually I remember when we were doing the spherical triangles and you were trying to do the equations for like the area, the trigonometric functions, but they're slightly different. There's different laws. It's not Sakatoa or whatever it's called.
Sakatoa.
Yeah.
You remember that site? I mean, I gave you a site, I think. I don't know, but I read it a couple times, and yeah.
Oh, right. Because this circle here is not 2 pi radius.
Right.
2 pi.
It's a spherical triangle, basically.
Yeah. I mean, no, not a circle triangle, because this side here is a section of a small circle. It's not a great circle round. This is a circle triangle.
Oh yeah.
But we're definitely entering some circle trig.
Kosho out of bacon and out of Kosho and armbar, who makes a better helper?
To be honest, Bacon, it's just say Kosho, right? It's fine. I already know. I am.
I remember next time there's a debate on modern day debates about celestial navigation, you're coming on with me, dude.
I actually don't really know this shit.
Well,
I learned a little bit.
Like formally with me and against Shane and QE.
Yeah, I learned like a little bit, but like not enough to like truly I get the theory, like I get like the idea behind it, like but like I would not be don't trust me with that though. You know what I'm saying? That's no.
Yeah. If you have Blender in the middle of the ocean, that might be.
Exactly.
Bacon, real quick. You know how you're doing the thing with orbits, and we're talking about the centrifugal and centripetal force.
Oh.
You remember that question that I asked, and then you described it in that way. Were you here earlier when we were talking about that? We were talking about orbits and centripetal force and centrifugal force.
Centripetal.
The point is, my thing is, do you think that you can explain it in the same terms you used when you were explaining it then? Remember, we were trying to determine where the thing would land, and you were basically saying like you would basically you calculated it by deriving its orbit, and it explained where the centrifugal and centripetal force came into that.
Right. Yeah, like the centrifugal would only exist if you try to follow the orbit. Like if you're watching the orbit from a stationary position, there's no centrifugal force.
Well, right, yeah, yeah.
And the force isn't that centripetal because the orbit is like elliptical. So it's not like perpendicular to the orbit. Only at 2 points.
Pretend it's use a circular orbit instead and describe the same thing. The point is, we were describing this earlier, and we were talking to a few people, and they were disagreeing with us that like they were saying we didn't understand orbits because we don't include the centrifugal force, how it balances it out and everything. I was trying to explain that, yeah, from an outside frame, that there's not even a centrifugal force. There's not a that only exists in the frame.
Dude, fuck! Oh my god, these frames do not save you for this shit, bro. Stop with the frames, the reference frames.
Jeremy, what are you talking about, man?
No, it's true. Like if you simulate it, it's become pretty clear. Like when you're simulating, you do everything from one frame, which would be like what we call reality.
Yes.
The reality frame?
Yes, you can do that in simulations. You usually have a reality frame.
Oh.
In that frame, there are no centrifugal forces, no Coriolis forces, no anything.
Let's pretend we're not in a simulation and we're just standing here on Earth. What would be our reality frame, do you think?
No idea.
Like, what do we use every day for our reality frame? Like distances traveled?
Yeah, that's our default frame is to use the Earth. Surface of the Earth is our default frame.
It'd be like a reality frame, right? Yeah.
Yeah, if that's all the reality that exists is just the Earth, then yeah. But if there are other stuff, then it's hard to say that that's the reality frame. But anyway, if you're using like a simulation, if you have a Earth orbiting the Sun, and then you want to see how does that look from the surface, then you do see centrifugal forces and stuff like that.
Yeah, it only exists in that frame. It's not. Yeah. It doesn't exist in all frames, let alone the inertial frame. Yeah. I don't remember. I broke up and I had to turn off my thing, so I don't even know the point that was made after that. But they were going on about it like we were. I don't know. They sometimes people go on rants, and it's like it's really too much.
Well, you
were part of it too, Jeremy. You were there too, bagging up.
Bro, you're ranting, Kosho. No ranting, please.
Well, hold on, Jeremy. I mean, all jokes aside, though, but like Jeremy, real fast, you act like we don't know what you're on about. Like, I mean, like, yeah, if I want to like not turn my brain off, but if I want to like forget about like, like relativity and then speed of light, staying the speed of light in all frames of whatever, right? Then yeah, I would agree with you. Like, yeah, that's how it is. But we're trying to argue the whole, like theory thing. Like this is how it. You don't understand. Like, do you understand that?
I feel you. And if we were to use your heliocentric model, it makes it way worse if you have us moving through space at 1.3 million miles per hour. That doesn't help you at all. It makes your case way that much worse.
No, but it doesn't, because in our model things are relative. That's why I keep,
In your model, we're moving through space at 1.3 million miles an hour, right? It's not relative.
No, well, it is, because we're moving 1.3 million relative to, what is it, like the rest of other stuff and whatnot, if I had to guess. Like, we're not getting that speed out of nowhere. You can't really measure absolute speed. That doesn't make any sense.
Okay, so we're either moving through space or we're stationary. Either way, either one of those things.
Or both.
If either one of those are true, it doesn't matter which one's true. It doesn't help your case. Reference frames aren't going to save you from this, because the light has moved through space a certain distance. It's either the stationary Earth distance, which would be the distance from New York to LA, or heliocentric distance of 1.3 million miles an hour. None of them help you. It doesn't save you saying reference frames.
Hold on, usually. You guys, hold on, let me mute myself so you don't hear hear me typing and shit. Hold on.
I want to do a very brief event. It'll just be a very short event. I'm gonna do it right now.
No, I'm canceling Kosho's event. It's canceled. Never mind, guys.
Well, it's not about anything controversial or anything. I'm actually interested in. Yeah, you know what's funny about Galileo? You ever heard about that guy?
Never heard of him.
Well, it's a funny name. It's because he's Italian and he's a goofball because of that. Yeah, most of them.
Shit.
But that aside, that put to the side, he actually the Pope was actually buddies with him. He actually thought he was kind of funny and cool, because he came up with these these out there ideas that people just thought was like kind of whimsical. It's like, oh wow, yeah, he thinks this weird shit. But it wasn't until he wrote this book. I forget which book it was. I think it was the one where he has this dialogue between these two dudes, and one of the dudes is basically like a skeptic to everything that what the other person's saying, and the other person is like a realist. Like they're just saying like what the world seems to be doing, and from the perspective of the so the other person, the guy asking questions, like the opposition guy, he had said things in the book that were exactly what the Pope had said to Galileo. So the Pope was convinced that Galileo was writing that in reference to him, and he made that guy look like an idiot. So
the whole time you've been talking, I've been thinking about this joke with my friend Dave. You ever heard that one where he knows everyone?
Your friend Dave knows everyone. What are you talking about?
You ever heard that joke? You ever heard that joke?
No.
Okay, I got a friend that's his name's Dave. He claims he knows everyone. We go to the diner. He's like, yeah, I know everyone knows him. He's like, I'll take you to Tom. We shoot over to Tom Hanks' house, introduces me. I'm like, wow, this guy Dave knows everyone, right? So I'm like, you don't know the Pope. So he's like, yeah. So we shoot to England, or we shoot to Rome, I mean. He's like, listen, I can't get you in. I'm going to go on the balcony. I'm bringing the Pope out on the balcony, and I'll wave to you. We go to the Vatican. He brings the Pope on the balcony. He's waving to me. I turn to a guy in the crowd. I'm like, holy shit, you see my friend Dave on the balcony there? He's like, and the guy goes, yeah, but who the fuck was he with? Anyways,
was your buddy Dave? Was your buddy Dave the Pope?
No, it was that. Never mind, bro. Just forget it.
Oh, because he knows everybody. Yeah, okay, yeah.
Because the guy in the crowd knew who Dave was, but he didn't know the Pope. Just forget it, bro. Just forget it. You're ruining everything tonight. All right, we don't know the Pope, the distance we traveled, nothing.
I know who the Pope is, man.
No, we don't know. We can't know anything. Are you 99.9% sure you know who the Pope is, or are you 100% sure?
You're just reaching, dude. Yeah, reach down deep.
Are you 100% sure you know who the Pope is? 100%.
No, actually, yeah, it's Francis, isn't it? Is it still that Francis guy?
So you're 100% sure the Pope exists?
I'm like 94%.
You don't even know if he exists, let alone who he is. Yeah. Solipsism.
Spell that for me.
Solipisism.
Okay, it's not Mississippi.
I don't know. That may not be right. I don't know. It doesn't matter if I could spell it or not.
All right. Well, yeah, go ahead. After Bacon says this thing, I'm going to start my event.
No, Kosho's event's canceled. Go ahead, Bacon.
Oh, hold on. Who summoned me?
I summoned you.
Oh, what's up, man?
You know the orbit simulator you wrote?
Yeah.
Apparently, that's wrong.
It's wrong?
Yeah, because you didn't account for inertia.
Oh shit. I mean, okay, well, I guess it is. I mean, if it's wrong, okay, I guess it's wrong then. But what was that?
Did that make any sense to you?
Not really. Wait, hold on. So
to me neither. I don't know. Ask Witsit.
Oh wait. So wait, hold on. What was the criticism about?
Wait,
I get the criticism, but what was it in reference to?
The orbits don't take into account inertia. Don't account for inertia.
Wait, hold on. So is
Well,
it actually wrong, or are
mass.
you just saying that just like so with its words then? So
Yeah, that's what he was arguing. Like the problem,
Okay.
like Newtonian mechanics doesn't even account for orbits because it doesn't like account for inertia or something.
Okay, but what do you what do you say about my little simulator though? Would you say that's correct though? Like your words?
Yeah,
like,
no, it is correct. Yeah.
Okay,
Like,
guys.
if you did
I got scared for a second. I was like, oh shit. I was willing to be like, okay.
If you do that, what's it called? Like the what's it called? The massless or the zero mass in free space or whatever it's called. Basically, determining orbits on a large body with a body that's negligible in comparison, then because of its inertia and because of its mass and its inertia are basically going to be, or no, I'm sorry, the gravitational attraction and its inertia are going to basically make it so that almost every sized mass in relationship to that large mass is going to behave almost identically, depending on the difference between them. So it's in most cases it's not accounted for because there's no need to account for it. I'm sure that made sense. Anyways, my event is starting any minute now, so hold on.
What's your event on?
I'm just gonna read something from a story.
Bro, you gotta tell me what the event's on.
Okay, I guess I'll tell you what the event's on. It's about Galileo, and he wrote something called A Dialogue Concerning the Two Chief World Systems. So I think this is the story that he wrote that the Pope thought was about him.
Is this about the Dave and Pope joke?
It's related to that, yeah. It's related to that. Because when I was describing the Pope and Galileo, during that, you were thinking about that joke. So, that's the relationship between them. But I'm going to read this. This is quite a long paragraph, but my event is only this paragraph. Okay? And then there'll be questions and answers afterwards. Okay. Feel free to interrupt me if you want to. Okay, so I'm going to describe to you what's known as the principle of relativity. Okay? This is before special relativity, before general relativity. Okay? Okay. Here we go. Let me find it.
So this is kinematics or what? What is this?
This is just me reading. I'm going to read this, okay?
What's it about?
It's about Galileo and the principle of relativity.
Before relativity.
No. This is relativity.
How could Galileo
This
write
is
about
relativity.
relativity? So not GR.
No, before GR. GR was like special relativities, like, it's like you got Franklin Roosevelt. He came after Theodore Roosevelt, but both of them came way after George Washington. Okay, and we're talking about George Washington now. Okay.
I don't know. Go ahead. All right, go. Let's go.
All right. So here's Galileo's thought experiment. Okay. He wants you to shut yourself up with some friend in the main cabin below decks on some large ship, and have with you there some flies, some butterflies, and other small flying animals. And have a large bowl of water, some fish in it, hang up a bottle that empties drop by drop into a wide vessel beneath it. With the ship standing still, observe carefully how the little animals fly with equal speed on all sides, how the fish swim indifferently in all directions, how the drop falls in the vessel beneath it. And in throwing something to your friend, you need to throw it no more strongly in one direction than the other, of course. The distance being equal, jumping with your feet together, you pass equal spaces in every direction. Okay? This is because they're still. Does that make sense, right? That's clear?
Dude, there's butterflies and some water droplets falling.
Yeah, he says get with your friend. Your friends probably have plenty of butterflies to go around.
Well, I brought a chick. You probably brought a dude. So my chick's gonna have butterflies. So
it doesn't say specifically whether it's a dude. No, it does. Wait, does it? Either way, it doesn't matter. The point is, he's just saying do these tests with your friend. Throw a ball back and forth. Look at the butterflies. Look at the flying animals, and look at the water dropping. While the boat's still. All right. You're gonna notice that there's nothing. You're gonna notice that it's behaving normally, right? Okay. So, anyways, here I'm gonna continue now. Now that you're done interrupting. When you've observed all these things carefully, though doubtless when the ship is standing still, everything must happen in this way. Have the ship proceed with any speed you like, so long as the motion is uniform, not fluctuating this way or that way. You will discover that not the least change in all the effects named, nor could you tell from any of them whether the ship was moving or standing still. In jumping, you will pass on the floor the same place. You're not going to make larger jumps if you're going forward or back. Anyways, the point is, that's it. It's actually a really long paragraph, and I'm going to cut it short, okay? Because you get the point, right?
Yeah, according to them, if they don't know anything else, if they didn't know the ship was moving, like they couldn't ask the captain or look out a porthole or anything. If they don't know anything and they're stupid fucks and they're just like, duh, I'm jumping in my cabin, then yeah, they don't know how far they moved.
No, the whole point of this
to each other.
The major point that Galileo made, it wasn't just about what happens on a boat. His point is this, that the laws of motion are the same, exactly the same, in all inertial frames of reference. Meaning all inertial frames of reference are equally valid. None of them have precedence over the other. Or
is F equals ma one of the laws of motion?
The second law, yeah.
Yeah, so you definitely need if you have mass accelerating, you definitely need a force, right?
Yes.
You will definitely be under an influence of a force if you have mass accelerating. Yes. Okay, I'm glad we got that clear. So when you're free falling, okay, so when you're free falling, you're definitely under the influence of a force, right? You have mass accelerating.
No.
Mass accelerating.
You're accelerating, but there's no force.
So not under the laws of physics. No. Motion. No.
Einsteinian physics.
So F equals ma is trash. Then that shit don't work.
No, I mean, like I said, that's why Einstein also said, "Hey, by the way, guys, I'm going to tell you that gravitational force, having a gravitational force in that field, gravitational field, is equally, or it's indiscernible from accelerating, or being in a frame that's accelerating. So both two things are equal, and so we're going to use them interchangeably."
Invalid. Yep, invalid. They're both true. You cannot tell the difference between acceleration or an accelerating frame.
We can't know anything now. Now we're back to we can't know anything. I know.
No, we can.
Jeremy,
No, we can't.
Never mind. I was gonna make a joke.
We can't know anything. We can't know anything, Arbar. Don't worry about anything.
Jeremy, you being silly right now, all right? Like freaking
This is what these guys do, bro. Whenever it comes down to it, it's like, oh no, frames of reference, bullshit, blah blah blah. Like you just use every trick in the book. It's ridiculous. It's obnoxious.
But Jeremy, what part of relative don't you get though? It's supposed to be relative, man. Like, that's the whole thing. It's relative.
It's relative. It's all you have relatives, don't you? Your cousins and uncles, they're all relative.
Okay, let's get something straight while I got Kosho and Zanuck here. If I am, write your answers down and be ready to hit enter in the chat. And when I say 3, you type your answer in the chat.
You already know we
when you're both
disagree
ready.
with each other about this, dude. You asked me earlier.
Yeah, you guys suck.
The Coriolis bullshit.
You guys suck. That's funny.
Let's do it.
Nope, Kosho doesn't want to play.
No, I'll play your dumb game, Jeremy. But I told you I said that answer in confidence.
All right, we'll play ball.
You said you're confident?
No, I didn't say I'm confident, you asshole.
I should be asking Bacon. You're right.
I didn't say that, you doofus.
Jeremy, go ahead. Let's hear it.
If you were traveling
flying
from Anchorage,
yeah,
you're traveling from Anchorage, Alaska, to Honolulu, Hawaii. Do you travel? Bacon, don't say anything. Do you travel less of a distance? You're in the plane. Do you travel less of a distance or more of a distance if you fly directly at where Honolulu is going to be instead of adjusting for Coriolis throughout the whole trip?
Are you flying in an atmosphere?
It's irrelevant. Not even relevant. You're out. You're out. Nope, you're out. Forget it. You're out.
Because if you weren't flying in an atmosphere, you'd lead the
not
target.
Relevant. You're out.
Hank, do you remember like a year ago when Jeremy asked us the same question?
Yeah. Okay, I know I do remember. Jeremy, you fly directly on target to that coordinate system, to that point. Through the coordinate system to that point. You do not lead or lag the distance because we're talking about an atmosphere, and if you did that,
even the question, you're already excluded anyways.
I'm not okay. Take mine as a bonus answer then. You'll fly directly.
It's not an answer at all.
It is an answer.
Take it as a comment.
Shorter, longer, or the same distance. If you lead it instead of adjusting for Coriolis the whole way. There's only 3 words you should answer with: shorter, longer, or same.
You're adjusting for Coriolis along the way. Well, that'd be the shortest distance.
No, is it short, dude? See, you forgot the question now. If I were to lead my target and aim for where Honolulu was going to be, according to the Coriolis effect, would I have traveled a longer, shorter, or the same distance?
Jerry.
You're always going to have to. You're going to have to lead it. You're going to have to follow it. It just naturally comes to following directions. You can't not do that.
No, so that's what we do when we take off from an airport. We don't have a heading for where Honolulu is. We have a heading for where Honolulu is going to be.
No, we know where it is, and then we want to stay on that course, and that course will have small adjustments. Part of which is due to Coriolis.
And that's why I'm asking the. You're out, Zanuck.
Go ahead,
you're
Jeremy.
out. Homie's out, Kosho.
Yeah, but Jeremy, now that I'm hearing Zanuck's answer, Zanuck is saying the exact same thing I was saying, and now I have even more of an answer.
Zanuck's not saying
same
anything.
answer.
Hold on, Zanuck's on the
answer.
He's on the he's on the bench now. Right, I'm in now. Right, I'm in.
Hey, go ahead, Armor. I want to hear Armor's.
Tapping out to Armad. Armad, you're in.
Yeah, what's up? What's up, Jeremy?
Jeremy, I gotta tell you, man, I love your questions. I gotta say, at first
I'm done with you, Zanuck.
You kind of bug me, but now I think you're like my favorite flat earther.
Hey, his questions are better and better.
Everyone's favorite. Okay. Go on, Jeremy. What's up?
What's up? What? Were you not paying attention this whole time?
I mean, half. I was half.
I want to see you after class. Okay.
Well, Jeremy, I have in addition to even though my answer was long before, like I was very careful.
The answer
to make sure
is one word, Kosho. The answer is one word. What are you talking about? It's longer, shorter, or the same distance.
Yeah, actually, it's not the complete answer, but I will tell you.
There can't be a third answer. This is a trichotomy.
No, it's
there
it's
can't
it's
be
not
a
it's
fourth
not it's not
answer.
it's not that there's a third answer. There's an additional. There's more information needed.
I gave you all the necessary information that you needed.
It's gonna piss you off, dude. That's
You're already
what
pissing me off.
I can't wait
That's a
for
shocker.
this. I can't wait for the same answer I gave before. Same answer I gave before. That
the same.
No, hold on. Same answer I gave before was that if you were to lead and go to where the place was going to end up, if you like knew the path and you just took that path directly where it was going to be, or if you drew a path on the Earth, and you tried to travel that
Coriolis,
path. No.
There's two things you can do. There's two things you can do. You can fly to where Honolulu is going to be, or you can always fly at Honolulu and adjust for it throughout the course of the flight. Those are the two things.
I know, but I had to be careful to make sure that my point is said as clearly as I did earlier, because it's important that in my stipulation is that if they're to be equal, then the flight path that is taking the path and then correcting for Coriolis or correcting for any error that takes it off that path, it's doing that at a perfect pace. So any deviation that takes it off of it, it corrects for it instantly. This is what I said earlier. Now, yes, they are the same path. If you same path, same distance.
Hold on, man. What the hell did you just said? The plane corrects for Coriolis automatically?
No, it corrects so it draws a path along the Earth. It tries to travel that path. Anything that takes it off of that path, it immediately corrects for it. And then
I know that's the one option. That's the one option. The other one is you fly to where Honolulu's going to be.
Okay, right, yeah. So those two paths are equal. Those two paths are equal. And here's a stipulation. It's gonna piss you off. This is what I'm waiting for.
I'm already pissed off.
Okay, well, get ready to go over the top, because they're equal. They're equal in the case that you're talking about their distance in the reference frame of the Earth. In Earth's reference frame, they are exactly the same distance. They're exactly the same path. The only time it sounds like that question is even a meaningful question is when you're, for some reason or for no reason at all, comparing two totally different reference frames.
Okay. Well, earlier today, Zanuck told me it was shorter distance, and Bacon a year ago made a whole diagram, did the math and everything, and we saw that it was actually a longer distance if you lead it. And now you're saying it's the same thing. Why?
Because in the reference frame of the Earth, if you're traveling this path where you make perfect corrections for any deviation from Coriolis versus leading the taking this leading path.
Okay, well, you got to have it out with Bacon.
The same thing.
So we're doing a new event, Kosho versus Bacon.
Oh shit!
Right now, you guys ready?
I want to see that. Who is the better debater?
I'm starting to remember Bacon's argument from a year ago.
Bacon, you hear? Bacon had a GIF. Bacon had a Blender fucking animation and everything, bro. You're done.
I actually got it's coming back to me now. The animation he had.
Well, Kosher's got a trick up his sleeve, though.
It's funny. No, we debated
Kosho's
this.
Got a dick up his sleeve. Is what he's got.
That's why I keep it.
That's stupid.
It is stupid. But I remember it's just like bringing back like flashbacks, dude. It's like I didn't say this earlier, but it was Bacon. He was the third dude. It was me, Bacon, and Zanuck, and we also disagreed back then.
No, Zanuck's out. Forget Zanuck. He's out.
I think we all came to an agreement though at some point. And Dr. Bob
and today you all disagree with each other once again. I know.
Well, I still stick to what I said, although I'm considering it again. No, yeah, it's the same. That's right.
Oh, okay.
It's exactly the same.
Okay.
Why would leading the plane or leading the Earth or whatever, leading the path, like going to where it's supposed to be, why would that make it longer?
Yeah,
I don't know. That's a good question, Kosho. That is a very good question. I have an animation as soon as Bacon comes back. We have an animation to show you why you're wrong.
Well, you know what? You know what the truth of it is? The truth of it is that question only makes sense. Only makes any sense in a world where you describe an event from two different reference frames, and then act like they're, you mean something like they're two different scenarios. It's the same scenario, just in two reference frames.
I was talking to my earth science teacher today. We were talking about Ray Kurzweil, but if I get time tomorrow, I'm going to ask him this problem. He teaches earth science. Okay.
He probably doesn't. He doesn't. Dude,
It's the same dude I had to
a
tell
high
about the
school teacher.
reference frames. I had him taking notes again today about Ray Kurzweil and shit. He was writing shit down 2 days ago about how I invest and shit. I got this guy fucking notepads filled with this guy.
Dude, he's a goddamn high school teacher, man. He's probably
Okay.
was
He teaches
teaching
earth
second.
science.
He was teaching second grade last year.
No, he wasn't. He was teaching earth science last year. This guy's been in the army. All right, all types of shit.
All types of shit. The Army, Boy Scouts.
All types of shit. Yeah. Yeah.
Backstreet Boys.
I got some wild shit to say, but I'm trying to keep it clean a little bit more than I normally do.
That's your MO, dude. Keeping it clean.
Well, I did just say you had a dick up your sleeve, but other than that, I'm trying to keep it clean.
Hey, man, you're not wrong.
What, the dick up the sleeve?
That's where I keep it.
Oh, well, I mean, he said it, right? Okay.
It's the only way to. Don't worry about it. Anyways, yeah, I'm just thinking again about this problem, leading the Earth, or leading the thing. It's starting to bother
Listen to me.
me.
How about new train scenario? I'm on a train. I shoot a laser beam up in the air. Does the laser beam go straight up, or does it keep does it conserve the momentum from the train and travel laterally with me? So no matter how far I travel with the train, that laser beam will always be above me.
So now you're caught up to Don. This was Don's
Tell me what
question.
happens in that scenario. Tell me what happens in that scenario.
Wait, what?
We're on a train. We shoot a laser beam straight up. The train's traveling.
Oh,
does that laser beam light stay above me the whole time, or does it keep going up in a straight line and then I'm not under it anymore after a little bit? Armbar, this one may be over your pay grade.
Yeah, this one might be over. Yeah, you might be right.
I mean, it's obviously the first one, dude.
What was it?
What was the first one?
Oh, the one you said, like, it's over your head and it just goes up over your head.
It just stays over my head the whole time.
If you shine a pulse, if you shine a pulse, okay, a pulse, that is a laser beam. All right,
You're right.
And the moon is above your head.
Right, yeah.
There's no moon.
You're right, yeah.
There's no moon. Stop saying he's right. He's right. There's no moon.
Well, fine. There's no moon. There's
but
a
he would
rock
have to be
above
right
your
though,
head.
because you would have to treat it as like you as stationary, right? And if you were stationary, then there'd be no reason for the fucking light to fucking move away. That's stupid. So no, you're right. It would have to be the first one.
What is the first one? I forgot.
The light would be above you. It would just stay above you. It's not gonna move away.
So no matter how far I travel, light's just always gonna stay above me. I shoot that one pulse of light. I travel 1,000 miles.
Yeah.
I look back later. The light's still above me.
Yeah.
That's how you think it works?
I mean, it's
not really. That's not what I didn't know that was the first one. I meant the second one.
Wait, the second one?
Oh, okay. That's what I thought. Okay. So
wait, hold on.
I'm traveling in a train. So the light moves independent of the train. I shoot the pulse up. I'm on a 1,000-mile-an-hour train. I shoot the pulse up. The pulse goes straight up, and then I travel. And then after a while, a certain amount of time, it's not above me anymore.
Wait.
Yeah, let's pretend. Hold on for a second. Let's pretend that the moon is exactly 300.
Can we not with the moon yet? We haven't even sorted.
I know.
This one
Fine.
Whoa,
it's not the moon.
Well, if you're not gonna do the moon,
it's a golf.
Okay.
There's a golf ball above your head.
Yeah.
300 million meters above your head, and right So 1 second. Is it 1 second? No, now I'm a little fucked up. Hold on.
1 second. I think so. I think that's the case.
See, here's the problem. Here's what happens. Here's the issue. Yeah, here's the issue. I got it now. Finally understanding Don's question. Okay, so if the ball, let's say you're 1 second before when the ball is going to be directly over your head, and it's exactly 300 million meters above your head. You might think that shooting it 1 second before. Oh man, that's how it's getting fucked up a little bit.
Well, I need to like figure this out. Help me out with this, all right? So if you're, let's say, I don't know, you're just moving, all right, and then you shoot the light, right? Like, can't you treat that as if you're not moving, like you're stationary and you're shooting the light? Like,
I got it now. Yes, you can. So, but it's very specific on what's happening here to make sure, because you don't just see light. You don't shine a light and then just see the tail end of the light or something. That's why I put a golf ball there.
Okay.
Because a second before, yeah. So yeah, I have it exactly right. A second as experienced on that train before you reach the golf ball above your head, you shoot the laser, and from your perspective, the laser hits the golf ball exactly 1 second later, and it keeps traveling that way. But that path is diagonal to somebody who's experiencing it from off the train, so it's a longer path. So their time, as observed, their time is it's longer. Their second, their time is slower, so their seconds are or is faster. I mean, I'm sorry, their time is faster. So yeah, so more time has passed in that same amount of time. So when you shot the laser, and when the laser hit the golf ball, it was way more than a second. It was about 50% more than a second.
I see.
You're assuming you're going at the speed of light too. Forget about what I said about how much more than a second it was, but it was more than a second.
All right, yeah. See that? So that always like kind of like confused me, because once again, I didn't actually study this. I literally just know this based off of like fucking YouTube, whatever. So like I'm literally a fucking like, whatever. I'm as good as some of the flat earthers here, honestly. But anyway, like that whole thing with it taking a diagonal path, I was like, it would kind of have the light would be just shooting off in a different fucking direction, and you would have fucking chaos. Yeah, that's interesting though. That is weird.
Well, that's why it's important when these questions are asked. It's important to identify the scenario and everything. Otherwise, it's like you can't say, "Oh well, in free space, what's it moving in space? What's it doing tomorrow?" You got actually, define exactly what the observers are and where they are and what they're doing in order to really describe what would be experienced. Because, like I said, nobody's a lot. When you shine a light, no one sees the tail end of a light.
Yeah, I mean, I took it like it would be like, I don't know, whatever we're shining the thing on would also be traveling at the same speed as us. That kind of thing,
Well, yeah,
So I get what you're saying though. Yeah, no, you have
so
to.
a person who's observing it from outside would see it travel and hit the same things that it's hitting from our frame, but they would see it like it would just be a longer path. Yeah.
Yeah.
Hold on. Oh, Jace is
Jeremy.
here.
Oh shit, Jace. It's Jace.
We're just talking about relativity. Jeremy's trying to trip us up.
Yeah, Jeremy is trying to trip us up, and someone like me who hasn't even studied it, I feel like is kind of getting it. So
you're saying the light pulse is always above you, no matter how far and how long I keep going on the train?
No, I didn't say that.
Okay, so I leave the laser beam doesn't conserve, the laser pulse doesn't conserve momentum, and it falls behind.
Hey, I'm gonna tell Jace my answer. I'm gonna see, because he can correct me. I'd rather have him correct me than you ridicule me without even knowing if you're right, dude.
Well, Jace is playing chess. You're playing checkers.
Chinese
checkers.
What are you playing? What are you playing? And you're throwing shit, at fucking people watching the monkeys at the at the zoo. Yeah, that's what you're doing. But anyways, well, let's see. Okay, yeah. So yeah, Jeremy's scenario was you're on a train and you shoot the light straight up, and you wanted to know what it does. And so what I did, I gave a scenario. There's a golf ball. There's a golf ball directly. So here's the scenario. There's a train traveling, and at some point in that route, there's a golf ball 300 million meters above the track. Okay, so it's exactly the speed light travels in 1 second. And me on the train, I know where that is above the track, and I shine a laser directly up exactly 1 second before I'm going to be at that exactly 1 second before I'm going to be at that point on the track. Is that laser going to hit the golf ball? Does that make sense, Chase?
Say it one more time.
Okay. There's a golf ball directly overhead there's a golf ball exactly 300 million meters overhead above a track. Okay. And I know exactly where that point on the track is. And since I know that's exactly the speed or the distance light travels in 1 second, I decide to shine a laser at straight up exactly 1 second before the train's going to be at that spot. Right. So as what I'm the way I'm thinking about it, that laser light will hit the golf ball after 1 second, from my perspective. Is that right or is that wrong?
Sounds right to me from the way I'm understanding it.
Yeah. Just Don used to ask a question like this in the past about the horizontal I forget what he called it, like the horizontal conservation of momentum or something like that, a perpendicular conservation of momentum of light. Regardless, I'm not sure what the people in the other frames would experience, but what Jeremy is the scenario he's trying to describe is, I guess, light that you can see continuously traveling. Like, is it going to be traveling with the person on the train forever? Like, if he shoots up in the air, is it going to be traveling, in that with the train? It's going to keep that momentum forward forever, or is it just traveling straight up as the train leaves it? You know what I mean? I might have to draw it out. Or maybe you can repeat it again, Jeremy.
Yeah, I think I get what you're saying. Like, unless the light is like attached, like if you have like a laser pointer, then yeah, that would travel with you. But if you have something that just like pulses, I would think that no. Like if the train keeps moving, the light is gonna just go off in the tangential direction that you pointed it at.
Shot. That's why I first thought about it, but then I was considering that if the train's velocity is linear, then from their perspective, they might as well be stationary. And if that's the case, then let me think. Yeah, if that's the case, then the golf ball passing overhead is going to appear as if the golf ball is coming to them. Hold on. Yeah, this one always tripped me up because my intuition tells me both things. It's weird.
No, I hear you. Trust me, I hear you.
I love how Jeremy fucking thinks he's got something because he asks a question he doesn't even know the answer to. Now he's got me fucked up. But I mean, every time someone's asked me this question, like Madonna asked it to me, that was the first time I ever thought about it. And yeah, I forget somebody's given me the right answer before too, and I just forget.
So the light doesn't conserve momentum, and the train leaves it behind. You're saying it moves independent of the train.
I mean, like I said, for me, I can see it both ways, and I can't be sure which one. I don't want to
What
give
did
a
Jay
fixed
say?
answer
Because
just yet.
isn't this his expertise thing, or no?
He's not a physicist.
So Jace, nobody knows. Okay, that's fine.
I'm just saying, like you just saying it's his expertise. Technically, there's a lot of relativity in what Jace does. I mean, I think he says, but
Yeah, but right, like I'm not doing hypothetical shooting lasers at distant golf ball types of things. It's not my involvement with it.
that was funny. Last night I was asking Chronic a bunch of questions, and he's like, "Yeah, I'm not a cosmologist, dude." I'm like, "What?"
Well, if the
What's the
light doesn't
difference?
go with the train and keep that speed, why would it keep the speed sideways with the train? Like, it only makes sense that you leave it behind.
Yeah, I know, but in the way I was thinking, like I thought that too, but then I was thinking about, like I said, about the Galilean invariance or whatever.
Bro, stop with this Galileo guy. You can't have it both ways, no matter what Galileo said.
No, but the point is that in a inertial frame, in a frame with this constant velocity or just no acceleration or whatever, in that frame, it's almost as if that frame's stationary. So, I would imagine that if I shine a light in a stationary frame, I shine it straight up, the light should go straight up. So I would think that would be valid.
Okay, how about if I'm on a merry-go-round, spinning around in a circle, and I shoot a laser beam out? Right? There's a tree.
That's a different
There's a
situation.
tree.
Then. Yeah, let me see.
There's a tree, and I shoot it right at the laser beam. I shoot the laser beam right at the tree, 1 inch to the side of the tree. Does that laser beam stay with me? So now when I'm 180 degrees from where I shot it, the laser beam's there?
No, that's a different scenario, dude. That's not a.
I know it's a different scenario.
That's not an inertial frame anymore.
I know it's no, it's the same. It's kind of the same scenario, except for now it's
not
angular.
The same scenario,
and now it's angular instead of linear. That's all that's changed.
Okay. Well, it's not an inertial frame anymore.
Okay, it's angular instead of linear. So does the light keep up with you?
I would say no. This does not. The same rule does not apply here. So
The same rule as the train that you didn't know?
First of all, I'm more confident about my answer now.
Okay, what's your answer? I shoot a laser beam pulse up from a train. Does the laser beam pulse stay with me as I'm traveling in the train, or does it fall behind and it's no longer at my zenith?
Yeah, because so the only way that you would be able to determine if it's staying with you or not is by when it hits an object. So let's say it doesn't matter how high the object is, but it's high enough to where from when you shot the laser, it's overhead at the same amount of time it would take the light to reach that same spot.
It sounds like you still don't know.
No, I know. I'm giving you the scenario so I can describe why I'm saying that I would say that it would go with you from your frame, from your perspective.
Okay, cool.
It just doesn't make sense to me because it seems paradoxical once you use two different frames in that scenario.
Cool. New scenario. We're spinning around a merry-go-round. I shoot at a tree. I miss the tree by 1 inch. So the laser beam pulse is still going. But now I'm 180. Did the light conserve the momentum angularly, and now it's in front? Now it's in front of me on the 180 degrees.
No, that's not the same scenario, dude. That's
I know.
Not
I said new
frame,
scenario.
so.
I said new scenario.
Okay.
That's why I started it with new scenario.
Fucking asshole. All right. Let me think about it.
You need to think about this, Kosho. Come on, man. The lengths you guys take this is crazy.
It's obviously
it's crazy,
not,
bro. This is too crazy.
It's obviously not the same, or it's obviously not keeping pace with it or whatever.
Okay.
But then again, isn't it? Doesn't it just change its wavelength or whatever?
Yeah, you guys keep telling me light doesn't conserve momentum in its speed or direction. It just conserves momentum by changing its wavelength, and now it's a different fucking color.
I mean, I'll be honest with you. This is why these
I don't
questions
think
are
you can.
interesting.
I don't think you can be honest with me.
I can be honest with you, dude.
I
First
don't
of all,
know. This seems
let me
very
give you
disingenuous.
let me give you a scenario where you're being asked questions, okay? Questions like this, but you're not. You don't answer questions, dude. You ask questions that no one's ever asked, or that no one's ever thought of the answer to, right?
Well, I mean,
And
that's
you
why
haven't
I'm
even tried to
top
answer it
10
yourself.
flat earther.
Well, actually, not Brummy. Don did ask this exact question not that long ago, or a year or two ago. So you're behind him, but regardless, he's not even a flat earther. Regardless, yeah, you don't know the answer. You're just asking a question. There's no, I don't know.
But I know the answer you need.
You know the answer I need?
Yes, I know the answer you need.
What's the answer I need?
Don't worry about it. I'm not telling. You
Well,
probably know
from
what
the
answer you need too. If you don't know what answer you need now, I don't know what to tell you.
from some of the things that I'm seeing in my little hired cursory search here, it seems that the light travels kind of with you, like it keeps the momentum of the train.
At least from that perspective, it would almost have to seem that way. And that's why, like, to me, like, I'm wondering how that relationship, like, what's the relationship between that frame and the observer. But the other thing is, every time I've seen explanations of this, like, like a light cone, like when they show like light cones, the light cones always they start from. Oh wait, hold on though, because a light cone is a cone, so it's like, even though it starts from that point, it's like it will still go diagonal with them, faster than them. Hold on a second.
Well, I think it's because, right, in all these examples, the big difference here is, like, you're talking about light. So in all these examples, the thing to consider here is that you're talking about light. And so in any inertial reference frame that you're shining light in, you can just transform to the frame of the light, and it's the same in all inertial reference frames. So the momentum doesn't change because you can transform to any frame you like, and the speed of light remains the same. So there's no momentum change.
All right. Okay, so would there? I mean, okay, so is it possible that the reason why this seems like a weird question is because we're talking about a laser that is traveling in a straight line, but technically isn't going to be spreading out as it's going in that straight line? I don't know if that's going to make a difference or not, but it just seems like the person. So for it to be doing what we're saying it does, a person observing it from a stationary frame somewhere away from this train, if they could observe this, they would see the light going diagonally. Like, they would see the person shine the laser diagonally, basically.
Yeah, the person on the train just sees, like, say you're on a train and you have a mirror on the ceiling and right under your feet, and you pulse a laser on the train as it's moving. You would just see the laser just going straight up and down, right? Because you're in an inertial reference frame, and the light would be traveling at the speed of light. Somebody outside the train would see the laser going at a diagonal, but they're still in an inertial reference frame. So the light is still going at the speed of light. The velocity hasn't changed, but it's just the path due to your reference frame is it's different shape, but the velocity and momentum and stuff is remain the same.
Yeah, I think it's something tricky about, like, the way questions asked. It makes you think about it in a in a weird way, but like the more I'm thinking about, like I said, the reference frame where it's a constant velocity, and from that reference frame it's would appear stationary. It would have to be the case that it appears to be going straight up and not lagging or doing anything like that. So, that's why I'm more confident in it. It's just the way you ask your tricky questions, Jeremy. It's in a tricky way, and only when I got time to actually think about it, I realize how malformed your questions are.
You're malformed.
Yeah, my malformed. That's right. And you know what else, dude? Is all the train questions you said that nobody can answer them. I answered all your train. I answered all of them. Dude.
I posted a GIF or GIF, whatever you want to call it, that kind of demonstrates what I was saying about the paths look different, but the velocity is the same in both frames.
Yeah, I made a cool GIF. I could probably find it, but I made a cool GIF of. Did you post it?
Yeah, it wouldn't let me like copy and paste it as a
I see.
It wouldn't let me copy and paste it as a picture, so I had to paste it as a link. But if you click the link, it'll pull up the GIF.
Yeah.
Where did you post it?
It's in the live
it's
stream
just-
on text chat.
Yeah, so I made one like this. This is actually better than the one I made. Even I spent so much time on it because I was timing it out so that the lines were exactly the right length. But yeah, anyways, all mine does is it shows you how many bounces the. Because actually, this one the bounces are almost seem in sync, but they're not. No, actually, no. There's a slight difference. Okay.
Koshu.
Excuse me?
Or is it Kosho?
Yeah, what's up?
Are you a flat earther?
It depends.
He is. He's a flat earther.
Yeah.
I'm just fucking around. He's not a flat earther. No, he's not.
What would it depend on?
Depends on who you are, man. It seems it's kind of a weird. I don't know if you're like an undercover.
Would you looking for some
kidnapper.
action?
Jesus Christ! Look at this fucking whore.
Are you? I mean, okay.
Oh my god. He jumps out of fucking nowhere. He jumps out of nowhere with his dress open.
Welcome to the jungle. We got what you need.
Yeah.
You missed the earlier Kosho. It was a complete mess.
Let's hear for
hey,
a little bit.
Hey, M1240376. You got another name we can call you?
Just M or M12 if you want.
All right, yeah.
Sounds like a galaxy or something.
I'm a flat earther. All right.
Let's hear it. That's it.
Yes.
Yeah, that's
flat
it.
earther.
No, he's not. No, he's not. You don't know any arguments. This is
Yeah, I
basically
do.
your
I'm
first
a
day.
flat earther. See, no, I am.
Okay, is he trolling me?
No, I'm not trolling you.
No.
Jeremy's no joke. Jeremy's trolling you. All right, I'm a legit flat earther.
Regardless of who's flat earther here, Jeremy, the guy who came out like a whore before, and he's not, by the way, he's not actually, but he is a real flat earther, and we can.
Yeah,
this guy's new,
believe
so we
that.
should. Yeah,
Same for me. I'm also a flat earther too.
Yeah, you can't.
Yeah, I know, but we should.
You can't have gas without a container, bro. It's that simple. Your spherical atmosphere is just a religious belief.
Yeah.
Are there any non-trolls here?
Yes, I am.
Like I said, Jeremy's a real flat earther.
What can we do for you today?
No, I am too, though. I'm. What the fuck? You guys are like, you know.
Just the way you talk sounds like you're not a real flat earther.
He's
No,
not.
I am.
He's not.
No, I am.
Armbar, what are you doing? Relax. We got a new guy here. M. How we doing, M?
Hey, I'm doing good.
Are you like Men in Black? You just got one letter. That's your name.
Yeah, I mean, I didn't know what else to put for username, and I like to stay anonymous, so I don't know.
No doubt. Good choice. Good choice.
Well, yeah. Well, I understand because I'm a flat earther. It's because the whole government and whatnot. I get that.
Armbar, stop. Stop.
What is your best globe evidence? Best globe evidence. Give it to us.
I would have
Sorry,
faith in
who are
James to
you
pull this
asking?
off. Definitely not Armbar.
I'm like the best flat earther, so I don't know what you're talking about.
So Kosho, you're not a flat earther, or you're kind of undecided, or something a little bit more
He's a
nuanced?
flat Earth. Kosho's a flat Earth apologist.
I'm on the fence, but Jeremy over here, he's as flat as you can be. So go ahead, just yeah.
Okay.
What do you got? What do you got for us?
I heard Kosho was a Globes sympathizer.
What do you think, Em? What are you thinking about our reality here?
Oh, well, I mean, I don't know if I have too much for you guys. I just heard that this was a flat Earth server and found that interesting and wanted to come.
Yes,
talk.
we are having some of the most interesting talks on Earth.
Yeah, on this flat Earth.
Armbar, settle down.
Just to be clear, there's about equal parts. It's equal parts the globe and flat Earth. But yeah, the topic is typically the flat Earth. It's just you'll find people.
I mean, we've been arguing a lot of relativity, some Coriolis today.
We talk a lot about ether on here.
Yeah, settle down.
That'll do, big.
What do you know? What do you do? Do you work for NASA?
No, I don't work for NASA.
We got some NASA. I know it sounds funny. We have some NASA employees in here. We're big time. We got Jace right now. He's a biological chemist or some shit. What's the title, Jace?
Biological.
Biochemist or
what else? Don't you have some second goofy title?
My work is biochemistry, molecular biology, kind of a crossover of towards.
So Jeremy, what's your confidence in the flat Earth position?
I'm pretty confident.
If you had to quantify that,
yeah, give us a number.
Like maybe a percent, or maybe contrast that with another belief you're pretty confident in.
Hey, I think you got the same name as Elon Musk's kid, bro.
All right, guys,
I don't know. It's really, I would say over 80 or 90, maybe. I don't know. It's not really about what you believe; it's what you can prove. What can be demonstrated, what can be science with experiments, shit like that. That's what I'm into. Measurements.
Yeah, I'm the same way.
Yeah, but that's not the question he asked.
I answered it 80, 90.
Oh, you did. Okay.
So if someone was like, I will give you $1 million if the Earth is flat, but if you're wrong, I kill you right now. Would you take that bet?
No, I wouldn't take that bet.
I love that.
I wouldn't take that bet, no.
As in, like, you're not confident enough, or you just don't like bets like that?
Well, I just don't. I'm not a gambler. I'm just not a gambler. I just wouldn't take that bet.
Gotcha.
Wow.
Yeah, some flat earthers, a lot of flat earthers probably would. Smart move, Jeremy.
Smart move.
What's
Well,
your
I mean,
expertise, M124063? What's your expertise?
I'm a software engineer.
Oh, okay.
Oh, wow.
Do you think our reality is inside of a simulation?
Could be. I think there's good arguments, but
there is good arguments. I got some good arguments for that. Absolutely.
What do you know about crypto?
I just quit my last job was at a crypto startup, like a Web3 thing. So I know a bit.
What do you know about
Were you doing Solidity?
We did a bit. I didn't really touch Solidity in my role. I just did like Python automation, bot like algorithmic trading stuff.
Fair enough. I'm actually working on that right now, actually, but privately.
Cool.
Yeah. I just got into it. So.
What do you think about XRP?
About what?
Ripple, XRP.
Oh, I don't know too much. I mean, I wasn't as interested in crypto as everyone else at my startup. I just wanted to code, and so I mean, I had some secondhand exposure to crypto stuff, so I know more than the average person, but I don't have like a super special interest in it. I don't care about like investing or anything like that.
Well, I didn't want to go on and on about it, like ask you a bunch of questions, but I am curious. Like I said, I am coincidentally like getting into the same thing right now because I code in Python and I know Solidity, but I've been looking into like automating trading bots in both the market and the crypto market. So I'm just curious, like how successful were you with your with bots that you produced?
Our bot was surprisingly successful. I mean, yeah, we were making like $60 profits like every couple hours just with the prototype we had built. So I mean, I don't know. I wasn't paying too much attention to the analytics side. Other people were worrying about that.
Right. Okay.
So I can't really speak confidently. I would say I wouldn't expect, if you're building a trading bot, I would probably have a bit more pessimism, and just that if you're trying to do just basic arbitrage, there's like so many other people doing that are faster than you. You have entire companies pouring millions into that. But you could try it and it could be fun. I think it's a good coding project anyway.
Well, there's a dude here named Ruhif. He's Australian. He made millions doing exactly that. He had a company that did exactly that. And on the stock market though.
Yeah, it could be. I don't know. I'm pretty neutral on if it's something that could work or not. Because we also had to pay for servers, and if you really want to be competitive arbitrage, you have to get an international entity status, so you can access more exchanges like Binance, not the U.S. version. And that, I think that it's like $10,000 or something to get international entity. I don't know, something like that.
Well, you know, like what prop firms, like they have the prop firms, and like they give you somebody else's. You got to take their evaluation, but then they give you an account, somebody else's money. You just get to keep most, like 90% of the profits.
Oh.
But the valuations are pretty difficult. So you have to show that you're consistently a successful trader. But there's no restriction on using bots or not. So if you could produce one that's consistent, then no problem.
Yeah. That'd be cool if you could get that working. It seems my impression is it seems hard to do that competitively because of how many other people do it. But good luck.
Oh, why would that make a difference? Like the other people doing it.
Well, because there's only so many arbitrage opportunities, and so the moment you find one, someone else maybe takes it before you do, or maybe they find it before you do if they have faster computers or they have more sophisticated techniques for finding the opportunities. That's mainly why, is just speed and technique.
Okay, so your team wasn't looking at things that like candlestick patterns or anything like that. Like you were looking specifically at you would have like like sort of formulas that were looking for specific.
Well, we didn't get in we hadn't. When I was there, we hadn't got into anything. The project I was on was just a pretty trivial arbitrage bot, like a pretty standard arbitrage bot, where it scans a bunch of different exchanges, a bunch of different crypto assets, and it just finds arbitrage opportunities, and then it executes trades on that. We weren't trying to do any sort of technical analysis of candle charts or anything. Although that stuff sounds cool too.
Yeah. Because that's more of what I'm looking into. But that dude Ruhif, dude I was talking about, that he did what you, I guess what your company was doing.
Like if you have the world's fastest computer, arbitrage seems really profitable because you can just find everything faster and then execute it faster.
That makes sense. Like the speed thing, like the like that, where you have more people doing it. That makes sense.
Yeah, because there's just so many bots now. I think 80% of executions on exchanges are automated at this point. I remember a statistic saying something like that. So it's a bunch of bots.
Wow.
Anyway, so flat Earth. I want to talk.
Let's get back to it. Yeah, so I said I didn't want to. I didn't want to take too much time.
Yeah, let's do flat Earth.
So Die Slow, the other dude in here. He's also pretty flat.
Gotcha. Well, yeah, if there's anyone who wants to talk about it.
Now, what do we talk about?
Yeah, see, the Jeremy in here and Dyslow specifically, they like to ask questions more than anything. Trip you up.
Yeah.
So be careful.
I'm about to go into my house. No, I'm about to go into my house for the night, so I can't really talk. But I mean, I'll be on here for about 15 hours tomorrow. If you want to come back tomorrow, or
Okay, that's good to know.
like, we do have dope ass conversations here. So I mean,
What'd you say when the dude showed up, dude?
What?
15 hours.
Dude came in. The dude came in. He's like, "You looking for some action?"
Well, I mean, that was 10 minutes.
You're roboting.
Oh no.
But now you guys have been, doing this whole arbitrage thing.
Yeah.
Yeah, we've been doing arbitrage. Sorry, you've roboted. We couldn't hear anything else you said.
He was making some fucking joke, dude. No doubt
Can you
about
hear
it.
me
He was
now?
trying to make some fucking joke. Go ahead, man.
Can you hear me now? Can you hear me now? Can you hear me now?
Well, that sounds like a different person. That's not Jeremy.
Yeah, Armor's had a little bit too much sugar tonight, but
No, that was a
Jeremy-
He's all
reference.
jacked up on Mountain Dew.
No, that's a reference. Isn't that like? Wasn't that like a Verizon? I think.
Yeah,
Like a spider
Verizon,
monkey.
right. Yeah, but Jeremy, you were roboting a second ago, so whatever you said about arbitrage, you had to say again.
I was just saying I was ready to get in it for 10 minutes there, but you were talking about the arbitrage thing. But now I'm at my house.
Oh damn! Yeah, I would have gotten into it. I'm sorry.
And I'll be here for 15 hours tomorrow. Or Dyslow can take it. There's a bunch of flat earthers in here.
Yeah.
Dyslow, Geo.
Keep going. Yep.
Are there any more in the VC right now that are willing to talk?
SC Montreal is a flat earther.
Yeah, the three people he named, they're all in the VC and they're all flat earthers.
Are they just muted?
Sometimes I know Geo, for example, he's often he might have something else going on, and then if he is going to say something, it takes him a minute to get to his mic. I'm always very curious about that.
Did you have a specific topic you had in mind, or like what did you want to like get into?
Well, the topic is flat Earth. Are you wanting me to be more specific than that?
I mean, we cover a lot of shit in here, bro. We just,
I mean, I joined because I just wanted to sort of talk with people about why they believe that and see if they're able to give me persuading arguments.
There's a lot of reasons why. NASA fakery, for one. We've caught NASA faking the funk all over the place. It's not even. I have a 6-hour compilation of NASA fakery videos. That's not even all of it. A lot of this so-called science is sketchy. It sounds more like pseudoscience. We can't measure the curve. I mean, there's a lot of stuff.
Yeah, I mean, I'd be willing to talk about most of those to people.
I said, Dyslow's here. He may be with his family too, far we know. SC, though, he's a prolific flat earther. He comes with the arguments that you never know, you never see coming.
Yeah, Dyslow's top 75 flat earther. So.
Damn.
That's
pretty rude.
He's platinum rank.
I mean, that was pretty generous, if you ask me.
Well, I mean, yes, it depends. Like, if it's like out of all flat earthers, then that's pretty good. But I mean, out of this, server, that's kind of fucked.
That's generous, even out of the server.
Really? How many people are in the server? I don't know. It looks to be like, I don't know, 75. That's.
I mean, do you think the moon landings were real?
I'm not informed on that. I would probably be like 60-40 on that. 60%, yeah.
There's a high chance we didn't go though. Yeah, I'm with you on that. My numbers are a little different than yours, but yeah.
I don't know. I mean, I'm obviously like 90, 95 or something on us currently having the technology to go to the moon.
Well, maybe.
Where are you on that, Jeremy? The currently having technology to go to the moon.
I mean, we know. I'd be shocked if we had the technology right now to go get to the moon. Because I mean, for the last 20 years or however long the ISS has been going, we've been circling the block like a child whose mom told him don't cross the street, and we haven't crossed that street supposedly for 50 years. We've just been circling the block. So I don't know. I'd have to say the chance we get to the moon now is maybe 1%. I guess there's a chance, snowball's chance in hell.
Do you think there's a dome, or what do you think's out there?
Well, there's definitely got to be container walls at the least. As far as when you go straight up, I'm not really certain. I couldn't make any claims on that. I could speculate some things, but you definitely need container walls to have gas pressure. So there's
Do you need a
definitely like some
container
kind
roof?
That's why I said I wouldn't make any presuppositions about if there's a dome or a roof or whatever. I have some thoughts on it, and they'd be all speculation, but definitely container walls. Unless Earth is an infinite plane, then I guess you don't need container walls.
But
do you
need
think
infinite air at that point? I guess, right?
Do you think you need container walls with the globe model, or do you think that they explain that? Like they account for that?
They explain it with gravity somewhat.
Yeah. Like the gas won't fly away if everything just has a gravitational pull towards the Earth.
Yeah, but the gas does fly away in the helio. Would you consider Earth a closed, open, or isolated system thermodynamically?
I don't know enough about what those terms entail, but I would probably say open.
It's open, yeah. It's
I like
pretty
this
clear.
guy,
It's an open. Yeah, he gave a straight answer for once. We can't get a fucking straight answer from none of these guys. Thank you, Em.
Well,
I mean, again, I don't really know what the terms. I'm not a physicist. I don't know a lot about thermodynamics, but I assume open.
You got it right. It's open, yes. They claim to have rockets. Well, in your globe model, it's open. They claim to have rockets leaving, meteors, gases escaping. Yes, open.
Both, yeah, but yeah, Rakia also is here. He's also a flat earther. Just bring that up. Yeah, I mean, Jeremy, you're right. Yeah, he gave a straight answer. I wouldn't have given a straight answer because it technically can be considered one or the other, depending on how it's referenced. But
yeah, I don't know. Mine was a guess. Not confident at all in my answer.
I mean, it was a fair answer. It's a true answer. That was correct answer.
What about celestial bodies?
Celestial bodies.
Like the moon.
The moon?
Planets.
Let Jeremy take that one.
Yeah.
Or are there not any flat earthers here that have opinions about that and are willing to talk about it? Besides Jeremy.
Rakia Life, SE, Snacks also. It just depends on if they want to. Rakia's texting, so he might be with his family or eating or something like that.
No, they're just a little shy. You gotta let them warm up to you.
Well, he's responding. He's responding to you though, but he's just responding.
In text.
Yeah.
Okay. Yeah. I can look in text. Is it in like the Discord integrated voice chat text?
No,
or the channel?
no. Typically we typed it in Livestream 1 text. But if you're on your PC, it's above. It's above this one.
Yeah. If can circle the Earth for 20 years and make it to the moon and slow down and land, what the gas does fly away. Where did gravity go? Gas moves so fast from the surface it escaped into space, I guess, is captured by other masses, gravity. I don't know exactly what that's saying, but I mean, I just think obviously some bodies are light enough that they'll be able to float away, and the gravitational pull won't, because gravity is a function of mass.
What exactly do you think mass is?
Oh, that's a bit of a mystical question. I don't know.
It is, yeah. It's very mystical, I know. I would actually agree with you on that. I don't know either.
These guys are gonna love you, man. You're saying
I like them already.
I know. That's what I'm saying.
Being
Yeah.
honest. It's called intellectual honesty.
Yeah, I'm trying to remember the terms, because some of these, they're not mystical, they're just definitions. Like density is just how many like atoms are in a space or something. Or what's a volume? What does volume refer to?
Space, the amount of space.
The amount of space it takes up?
Yeah, like the amount of it's a specific quantity of it's a statement about the quantity of space.
Wait, how does that? Ooh, wait a minute.
Specifically, density is specifically the amount of mass per volume.
Negative. Density is how compact a substance is. We don't even know what mass is. Mass is too mystical.
Well, okay, so
I love you, dude.
Looks like mass is defined by traditional physics as just the amount of matter in something. So like the amount of atoms, the amount of particles, or something.
Negative. Do you know an electron has mass?
That it does have, or it doesn't?
It does. An electron has mass.
Yeah, so then you'd need to have a recursive definition where mass can mean two different things, where maybe like an electron's mass is just like the mystical intrinsic mass that we don't know what that means. But then higher level composite bodies, their mass is just a bunch of electrons or something. I don't know. Terrakia life. I don't have a number there, but it seems pretty intuitive to me that gas would stop rotating as the altitude gets higher and higher.
What do you know about super rotation?
Nothing. I don't know what that means.
It's this thing that happens on Venus, I think, and they claim it happens on the Earth. That the gas molecules are actually rotating faster than Earth when you get up to a certain altitude or elevation.
That's weird.
It's weird, yeah.
Yeah, I don't know what explanation they have for that.
They don't know what explanation they have for that. Some of them can't even agree if it's happening or not.
Why do you think they would publish that?
They're highly confused. Some of these people are very confused, and they think they know all the answers.
Okay, so you don't think that the actual scientists in the field are intentionally participating in like a conspiracy? You think they're just kind of tricked and the people who are propagating the conspiracy are like higher above them, or do you not think anyone is doing a conspiracy? It's just a lot of confused people.
I think there's a conspiracy at some level. Obviously, there'd have to be something with NASA. There'd have to be some kind of conspiratorial thing going on, right? As far as like an astronomer or a teacher, there's no conspiracy with them, right? Neil deGrasse Tyson probably, Elon Musk probably doesn't even know. This would be like a need to know basis kind of thing, right?
Well, how would Elon Musk? What's happening to his rockets? Because they're like going into space and stuff. So I mean, he'd have to be lying or something, or just not be aware of what's actually happening.
Yeah, that's what I said. It's probably on a need to know basis. I mean, does he really need to know?
Well, so are you saying that like when he's watching footage of his rocket going into space, the footage is just being faked like real time or something? Because I think he goes to the launches and he watches the rockets fly up, and then I'm sure he reviews the footage. So they'd have to like really be like replacing stuff right before he looks at it. Like I would imagine he's pretty intimate with his data. Be like hacking into his machine and planting footage for him.
I mean, he may be. The thing is, they run simulations where ground control can't even tell if it's a simulation or not. So,
yeah.
As far as the video, I mean, you could fake anything these days. No.
Yeah, you would definitely know.
I could put you on a unicorn riding on a rainbow with a leprechaun chasing you right now. Give me your picture.
Yeah, I don't think you could do that 10 years ago feasibly. But I mean, actually, maybe the government has been ahead technologically than where we're at right now for a long time.
The thing is, there's people. That's the good thing about this room. Some of these people in this room claim to know what happens behind every closed door on Earth for all of history, and they know all the technology everyone's ever had ever in the history of humans at any given point. It's awesome.
As in, like, these people are working for NASA, or they're different?
I don't know how they would know that. But they claim that they know.
But Jeremy, hold on. Okay, I'm gonna break. I mean, obviously, I'm not a flat earther, but I'm breaking that right now. But the thing is,
wow, we were confused.
Okay, but Jeremy, hear me out there, right? So if they have this crazy technology, right? Don't you think they would have been doing a better job with their fucking CGI then? Supposedly, if you guys are noticing that it's CGI.
It's gotten better and better. I mean, have you reviewed the moon landing footage from the Apollo missions? It's definitely gotten better.
All I'm saying is that if they're ahead, if they're really, really ahead, I don't think they would have made it where, you just wouldn't be like, oh shit, like this is fake.
The thing is, when you're faking stuff, have you ever seen a continuity error in a movie or something you weren't supposed to see in a movie? When you're faking something, no matter how much money you have on it, you're still going to miss shit when you're faking something. If it's real, then it's real, and you don't even have to worry about it, and there won't be no weird anomalies and shit. They spend millions and hundreds of millions of dollars on these Hollywood blockbusters and still miss shit.
That's a pick from Apollo 12. That is pretty cool. I mean, I'm just trying to think about this because, like, I mean, I guess if the technology isn't that much ahead, like if it's only like 20 years ahead, then yeah, I guess their moon landing CGI, if we're gonna call it CGI. I mean, a lot of flat earthers say it's not CGI; that's a stage or something. Like they actually, use practical shit. But if it was CGI though, then it would be like what 20? No, like it would be like closer to like 40 years or something. I think. I don't know. No. Point is, yeah, okay. I guess that's kind of fair.
Okay, so do you know do you know that the Hubble and Adobe Photoshop, they share the same year anniversary? Is that interesting? That's maybe a coincidence, maybe not. The year we start getting these amazing pictures from space is the same year Adobe Photoshop comes out. I mean, could be a coincidence. There's a lot of fucking coincidences. Stick around.
Yeah, I mean, that's like a quirky coincidence. I mean, there's some small percentage that adds to my confidence in the flat earth theory, but it's nothing significant.
I hear you. No, that's what I mean. Stick around because there's tons of shit just like this, though. Tons of fucking coincidences and anomalies. Just hang out for a while and you'll see. It'll start adding up, maybe.
For flight paths, do you think there's deception going on with the airlines?
With the flight paths? No. I don't know. Maybe. I don't know.
Well, the fact that I can go to Asia with either direction, do you think at some point they are faking the navigational system to make me think I'm going in a continuous direction?
You mean our planes flying in straight lines?
No, I just mean like when I book a flight to Asia, like I could choose to go at it from the east or at it from the west.
Yeah.
And so that would require the Earth
east-west
spherical.
No, east-west circumnavigation is fine. That'll work on a flat Earth. The thing that you would need to have is north-south circumnavigation.
Why
That
doesn't
would- that would blow a hole.
why does east-west circumnavigation work?
Well, I mean, put a piece of paper down and draw a little Earth on it, some land masses and shit, and go east-west.
Wait, if I have a piece of paper, if I continuously go east, I hit the edge of the paper. I don't arrive at the right side of the paper.
I know, but not if the North Pole's at the center, though, and you're always pointing north.
Oh, I see what you're saying.
Yeah. And that brings me to another thing. Do you think if we travel east, do you think we go around a latitude line or we head to the equator?
If we travel east, say that one more time.
If I travel east, am I getting closer to the equator or am I going around a line of latitude?
I'm trying to remember 8th grade geography. Is the equator just like the vertical line in the center, or is that the horizontal line?
The equator is a line of latitude.
Yeah, it's a horizontal line.
So if you're traveling east, I don't know why you would cross that.
Would you know which way the sun rises on an equinox for everyone on Earth, save for the poles?
I don't know about the equinox.